Isn't that funny? And so if you
Yeah.
last year were to say NASA's a military intelligence outfit, always has been. Look at their founding documents. Oh, you are a conspiracy theorist. And now everyone's like, yeah, of course they were. Of course they had to be due to the rivalry with the Russian space program.
Yeah,
Isn't that funny? And so if you
Yeah.
last year were to say NASA's a military intelligence outfit, always has been. Look at their founding documents. Oh, you are a conspiracy theorist. And now everyone's like, yeah, of course they were. Of course they had to be due to the rivalry with the Russian space program, due to all of that.
Man, you haven't. It's like, fuck. That is for me. That is the worst part of being a person that's in the know about things. Is the way
Being right.
the average person just fucking slithers into the new narrative, you know,
Yeah.
and just they get a mind wipe about all their previous statements and ideas, you know.
Right. Right. Happens
Fucking
with
drives
political
me
agendas a
mad.
lot.
Yeah.
guys, are all of you
Yeah.
flat earthers?
I think most of us in here are. Yep, plenty more where we came from too.
Okay. If you don't mind, I'm just gonna like add you to my block list. I never want to talk to you again. Thank you. Yeah.
Oh.
Take care.
Okay, take care.
Right. Not that I would seek out talking to you.
Fucking weirdo, man.
You've got millions and millions of more people to block, dude.
Yeah, he's gonna be busy. That's what we were saying. Yeah, you know, like the oh, we knew it all along. Yeah, you know, I always knew that was what was going on. Blah blah blah.
Yeah. Yeah,
That's the response you get.
very slimy.
I think that attitude, that behavior, is like the de facto crux of the fucking human condition. I think it's everything that holds us back. That little fucking psychological behavior right there, because it's essentially just the refusal to admit you were wrong or completely clowned or totally out of the loop, you know?
Yeah. Yeah, there's a lot wrapped up in this. There's lack of discernment, there's lack of integrity,
Yeah,
there
and
is.
how do you begin your journey of discernment in your life? You first have to admit that you failed in discernment at some point.
Yeah. So now they're coming into the knowledge of things that we had prior for all the wrong reasons, which means they'll just as easily abandon this when something else comes along to grab their attention, when a new narrative resonates with the rest of the world. They look to the world and other people for their moral compass, their guidance and direction in life. You know, what is the government saying is true, so I know what to believe. What are all the people at work thinking are true, so I know what I believe.
Yeah, just consensus-based reality.
Yeah. And
Sometimes I wonder if it has
there's a
to be
certain
that
kind
way.
of self-defense mechanism for that. Well, going with the consensus is kind of like a way to protect yourself. You know, it's a herd-like
Well,
instinct.
it's the least amount of effort, first of all.
Yeah.
So it's energy conservation.
Yeah, if they were free thinkers, maybe they won't be as fat. I mean, could the American obesity condition be somewhat caused by this mentality, this kind of going with the herd?
Well, I mean, you don't just wake up 300 pounds, you know what I mean? So, yeah, it requires some level of zombification. And usually that begins with just following what's going on around you, you know?
Yeah.
It's other aspects, of course, you know, the kind of the work environment of the world. People not, you know, same way people don't have time to research into topics, they don't have time to care for themselves in the right ways. It's all fucking half-assed, you know. Switching on CNN's a half-assed way of getting information, and eating a lettuce once every eating a salad once every 2 weeks is a half-assed way of being healthy.
Right on.
It's something to do with the human spirit as well, right? I mean, when you're pumped, when you're all about life, right, and you see the beauty in it, you know, you see the creation, you see all the wonder of the world, right, and all the potential in it, in yourself, you know, you naturally desire to be healthy, you naturally do healthy things, you know, it just, being healthy just comes as a natural byproduct. But of course, we know we're fighting this epidemic of apathy and nihilism, right? So their bodies reflect that.
Right.
Yeah. Their bodies are just an immediate reflection of their inner mentality / soul. They're ground down. They think they're worthless. They have no position of authority in this world, no say, you know. So their bodies reflect that.
Yeah.
That makes sense.
Is it bad that I kind of want something to come out of this 3 Atlas interstellar visitor to our solar system? Is it bad that I'm desiring some kind of upheaval,
What is that?
some catalyst?
Fill me in. Is that one of these weird fucking objects that they're
Yeah,
going on about? Or
yeah, one of many.
is it a new mission from NASA
Yeah.
or something?
No, it's one of those objects. It's one of many now that people are wondering if are aliens.
Well, we know something will come out of it then.
I mean, but all too often, narratives like this that have such long runway in the media have such a slow gaslighting are usually just nothing burgers. They turn out to be nothing. They serve a purpose to keep people distracted on,
Yeah.
and then they fizzle out.
Yeah. Part of it's just the natural news cycle. You know, they cycle back to some wild fucking space claim, and then they forget about it and go on to North Korea. Yada yada.
I would love for the government to announce it is freaking aliens and they're here. I think that'd be exciting. It'd be exciting for Flat Earth.
I think they like to dance with the idea that they know, but they know very well the population is far too fragile to have, you know, to initiate that. I can only imagine they would do that when they want to push the big red button. You know what I mean?
Yeah.
Can you see it going any other way?
Not really. Not really. There's no coming back from a deception that big. You know, a moon landing hoax, they can admit to, they've got an out, they've got an exit strategy for the moon landing and for a lot of their space missions. Absolutely. They've got an escape hatch, but if they announce that aliens are here, they're coming to visit us, that's pretty.
There's no fixing a cloud.
We might give them far more credit than they're worth on this one, you know? You know, we might be falling into their scare tactics. Because, like, I don't know, what the fuck are they gonna, what's the narrative gonna be? Aliens are here, right, but, you know, they've established their Federation fucking outpost around Jupiter and they'll communicate with us from there. And that's all you're ever going to know about them. You know what I mean?
I think it's Project Bluebeam.
Was that Melvin?
I think it's Project Bluebeam. Have you ever heard about it?
Oh yeah, that's the idea. Yeah.
I think that's a pretty, like, I mean, it could be anything. I don't know. It's either or. But
I was just saying that I almost hope that they do it, that they decide to go forward with this deception. It'd be exciting.
You're a watch the world burn type of guy, aren't you, Amish?
Yeah, well, it's going to happen anyway.
Yeah. I don't know if you know about a TV show called Three Body Problem.
No, a TV show called that? Funny.
Yeah, I know. Yeah, it's based on a book series. It's it's sci-fi. The premise of it is as a distant civilization of a distant solar system, they have a 3-body problem. Like they have like 2 suns or something, and they get very frequent cataclysmic events that wipe out their civilization. So they need to rush between one of these cycles to basically develop themselves, and then, you know, they discovered Earth and then come and take over Earth, basically. But they did this. Oh man, how am I going to go into this? So they did some really trippy, super advanced shit, right? To basically weaponize like protons or something. They were able to send the protons in advance to Earth to basically destroy our science and keep us set back, because like the time it would take them to arrive with their fleet would be like 300 years, but by that time we'd be advanced enough to ward them off, essentially. So they need to get ahead of it. They need to get to us with this fucking shit that can get here quick, fuck up our science, and kind of keep us held back. And it's basically what I'm getting at. So the premise is like the aliens interact with us on a way that we can't tell they're here, basically. And that might be some kind of narrative they might go with, you know? Kind of like the way, you know, you've heard them incidents where they're talking about, oh, fucking ships were flying around and shutting down our nukes, you know? But even more stealthy than that, right? So I don't know. Probably just fucking waffling there on a pointless tangent, but...
So a couple days ago, I don't know if you heard me talk about this, but I was doing some research on the early rocket program in the United States, and also reaching back into Germany and Russia's. And so when they first started putting scientific instrumentation to collect data on these rockets, called sounding rockets, firing them up as high as they could go to study the environment up there, what was taking place up there is freaking weird and mysterious.
Cutting in and out a wee bit, man.
So I'm reading like these reports like, oh, okay. Funny thing. Testing.
Yeah, I'm kind of losing every other word.
All right, is this any better?
Yeah, well, you're louder. So I followed you up to the point.
Right, they're sending these rockets up to study the environment. And weird things were happening, specifically to the electronics. So telemetry data was getting wrecked. Like what the sensors were reporting via telemetry down to the ground stations was different than what was retrieved after the rocket had come back down or sent its payload out for retrieval. Things like this were going on. Electrical systems would experience problems, and they would go like shield it, and it'd send the rocket up again, and then those same systems would experience problems that got through the shielding, so they would shield it again and send it up. And it was almost like they were being screwed with.
Yeah, interesting.
Yeah.
It's like something grabs hold of it, fiddles around the data and the circuitry, and sends it back.
Yeah. Yeah.
But,
I'm telling you,
completely this is stealthy. Yeah.
It's freaking weird, dude.
Certainly is. When you read into this type of stuff, it really feels like it's hard to deny that we're fucking dealing with, you know, something way beyond us, just at these extended heights, you know? I don't know how to say it. You know, we're getting into the realm of metaphysics and fucking
Right.
shit we probably will never comprehend in the physical form, you know, in the three-dimensional mind and all that. I saw a clip of some supposed explorers of the North Pole, and they were talking about decline in mental state, basically, on these expeditions. And you know how you get you've got many kind of shows that show, like, you know, people in groups starving to death, and that slow decline into like cannibalism, and start talking to themselves and shit, and you know, that type of decline.
Yeah.
They're describing something similar, you know, and I'm thinking, like, okay, you're in a really harsh environment. I don't think the North Pole is claimed to be even as remotely close to as harsh as Antarctica, but
Totally.
still, admittedly, a harsh environment, right? But you know, people have done this before. You're well prepared. Surely you're not running out of food. You know, there's different. You know, your I forget what's your sleep cycle called? Circadian.
Circadian.
Your circadian cycle gets all out of whack up there, you know, because of course different lengths of day and night. So, like, admittedly, this is all happening, but they're describing like a mental decline that it doesn't really follow, and it made me think, like, what if it's like a broadcast range, like humans are venturing too far, and our minds start to actually fail us, you know, because we're venturing beyond where we're supposed to.
Yeah, kind of like the movie The Thing in Antarctica, serving as an allegory for this.
Lost you again. Or was that it? Just the movie, The Thing? I haven't seen it, so I don't know of it.
It's good. It's good. And yeah, researchers in Antarctica huddling up for a long winter. It's dark. They lose their minds. Kind of like The Abyss. The explorers take a submarine really deep and they lose their minds.
But I can understand. You've got like Admiral Byrd's testimonies of being in Antarctica for extended times, you know, and he's like, he's in a wood cabin, you know, like fucking snowed in for 6 months. Is like in that type of solitude, and you know, like on the edge of death every moment of every day. I can understand it, you know. But expedition into the North Pole, it's like that's you're constantly on the go. You get there and then you turn back, right? No. But they were describing in their testimony, like, again, one of them was plotting to kill his partner and shit, you know?
Wow.
And I'm like, does it really get that bad so quickly? But then again, it could just be my own personal incredulity. like massive incredulity. I just have no idea what it is to experience these conditions.
Right.
You are from Australia?
I am not. In fact, I'm gonna. Yeah. He sounds like he's from Poland, Czechoslovakia. Just kidding. I'm gonna go check out 24/7 Flat Earth back home base and see what's happening there. There's some folks hanging out.
Yeah, I was going to jump over there. Melvin,
Okay.
I didn't actually hear what you asked.
Well, I was just going to ask if you were Australian or something. Because if you never said you never really experienced like Scottish.
Scottish.
Now you've experienced the cold. Come on, man, the winters in Northern Europe are pretty bad.
Yeah, it gets cold. It gets cold here, but I think people have an exaggerated idea of how cold, And I'm in the more, I'm central east, so definitely not the coldest part. Don't get like Siberian cold here at all.
Oh, no, I can get that up here. Actually, we do get Siberian winds.
Well, then you'll have better experience of it than me. The stuff we're talking about.
I'm a Nord man, of course, Viking. So gotta get used to it, I guess. But it was nice having summer here now, but it's so brief, and now it's October, and
Prediction. There was no prediction.
No. So the prediction is the calculus, like the actual formula to do the thing. You need to go out in the field, actually measure the conditions, and then you plug it into the calculator. Then you take the picture and see if it matches
nobody's done
what
that.
the calculator predicted. Well, you're saying nobody's done it. You can do it yourself and disprove this. Have you done that?
I don't need to disprove it. Y'all need to come up with listen, y'all, you or whoever, I read the literature. Y'all need to come with the actual experimental justification for including this in anything. Because I, despite looking at lots and lots of literature and talking to thousands of freaking Globies, haven't seen any prediction yet. Any. Zero. Zip. Nada. Nothing. I've seen lots of post-dictions.
Okay.
I've seen a lot of cherry picking. I've seen a lot of confirmation bias. I haven't seen anybody, with the exception of FE Core, ironically. So that took meteorological stations out to the environment, made measurements, made a prediction, shot the laser, right? Used the WGS 84 reference ellipsoid. Yeah, laser beam. Laser.
You wouldn't use a laser for this. That doesn't make sense.
Why?
It's not emitting like it's shooting electrons as well as photons.
Lasers don't shoot electrons, bro.
What's it called?
Lasers don't shoot electrons, man.
Have you ever seen
electrons? You're saying lasers shoot electrons?
Yeah, like have you seen the what's it called? It's not diffractive effect, where it actually will spread across the surface instead of just like normal light where it will hit the spot where it's aimed.
What are you talking about?
Like if you aim a light, like have you seen the?
Are you talking about the photoelectric effect?
Sounds like he's talking about Fresnel diffraction.
I don't know what he's talking about.
Yeah, diffraction over like a knife edge.
Yeah, it'll cross across an edge instead of just staying in the one spot that it's aimed at. It'll follow along the edge. Like, why wouldn't you just use a single source of light at your target?
It only does that for a period. It only does that for a distance. It's some fraction of the wavelength. Like, well, yeah, a sixth of the wavelength, and we're talking like fucking 450 nanometer. So it goes 100 nanometers. So what?
But I guess, so would you have an issue with how I described it if you went out, got all the data first, made your prediction, then took your picture, would that be a valid experiment to you at that point?
Yeah, I'd freaking probably die of shock if someone actually did it.
Okay, so what if I provided you one right now?
Yeah, go for it.
Well, I'm driving.
Prediction,
So
not. Yeah,
Sure.
okay. A prediction, you know what a prediction is? We already went over it. Prediction, meaning all the meteorological conditions are measured before the event, and then you do the experiment, meaning you actually write them down. And you don't post it, right? You don't have a refraction slider that you can move around to match any image.
Sure. I just don't see why you're like holding to this idea that it's always a post-diction. I would think that at some point somebody would have done a prediction and then saying, oh no, it's not actually matching the conditions that I'm measuring.
Yeah, you'd think that.
Like essentially you're accusing them of dishonesty, that they're manipulating the data that they're feeding into the model.
this is a common thing in modern science is to do post-dictions.
No, it's always predictions. They understand that it's invalid if it's a post-diction.
Oh, do they? So, where's all the predictions then?
I'm telling you, like surveyors do it all the time. Like you can do this yourself. You don't have to rely on anybody. You can get a theodolite.
You don't know anything about surveying, dude.
What?
You don't know anything about surveying. Okay, what's reduction of the horizontal direction? Why they do that?
Deduction?
Reduction of the horizontal direction.
I have no idea what that even means.
Exactly. Yeah, exactly.
I mean, do you know how a theodolite works?
Yeah, I know exactly. Jesus fucking Christ, dude. Yeah, I know.
Holy shit.
You're in the pros. This is an amateur hour at the Apollo. Okay.
So how does it get?
I know how a theodolite works.
Yep. How does it get the horizontal?
Well, you find plumb.
Yeah, it's 90 degrees from plumb, right?
Yeah. Do you know that plumb lines curve in the globe?
Plumb lines don't curve on a globe. No, that's false.
It's getting better.
Yeah, read your surveying manuals.
Yeah, so in the globe geodetic surveying, plumb lines are curved, dude.
That's entirely false. Why would they curve? They're pointing towards the center.
That's entirely false. Okay, just remember what you're saying. Oh, okay, hold on. It's entirely true.
Sometimes there's deflections in a plumb line, but that doesn't mean the plumb line is actually curved.
No, they say it's curved. They say it's curved.
Why would a line pointing to the center of something deflect or be curved?
You tell me. Lumpy.
You're the one making the claim. Why would I tell you?
It's not my model, dude.
They don't, like, a plumb line can deflect. That's different from it being curved.
No, yeah, it's lumpy spherical harmonics of the gravity field that's contributing to the curve.
There's actually a published paper from. Hold on, let me find it.
Is that what you're talking about, though? The deflection of the vertical vector from like masses proportionate to it?
Well, that would be the measurement. But the plumb line itself, it's not just deflected. That's an indication of the plumb line curving.
Because, I mean, I know that that's a thing that, like mountains, when you're doing surveying, can cause the vertical vector to diverge slightly.
Okay.
Is that what you're trying to say?
This paper was called Evaluation of the Plumb Line Curvature Effect on Deflection of the Vertical, published 1999, 1986, Geodesy and Geomatics. Geodesy and Geomatics Engineering, University of New Brunswick.
Yeah, you're saying it's a deflection of the vertical, yeah.
Yeah, but it's interpreted as curvature of the plumb line.
But clearly you don't believe this paper because you don't think the downward vector shifts at all.
Said who? How do you know what I think?
How would it change on a flat Earth?
Well, what do you mean how would it change? Lumpy gravity.
You believe in gravity?
It depends on what you mean by gravity. But if you
mass attracting
things
mass.
fall, oh, what even is that, dude?
What's mass?
No, I don't believe. Kilograms. What's a mass?
Kilograms.
That's not a definition. That's a unit.
Yeah. That's how you measure mass. It's a number.
It's just a number. So numbers attract numbers?
What? No, mass attracts mass.
Yeah, what's mass? What's attracting what?
Length? And I tell you feet. Mass.
You said feet run up a hill.
Measurable quantity.
You said feet run up a hill. I say what's feet, and you say size 7.
No, I'm saying 10 miles.
Yeah, dude, that's exactly what you did, dude. It's what you gave me the units.
Yeah, I'm naming the unit of measurement. Yeah, I gave you the unit of measurement.
What are you measuring? What are you measuring?
You're asking for the measurement. I'm saying it's
the measurement of what?
Is a unit of measure.
What are you measuring? What are you measuring? Oh, mass is a unit of measure? Mass itself is a unit of measure.
Mass is a unit of measure.
Okay, units of measure attract units of measure.
This particular unit of measure, yes.
Did you just really say that? Think about what you just said.
So, do you believe in gravity or not? Like,
which is
this is all just deflection.
It's not deflection. Things fall.
Do you believe mass attracts mass?
Things fall.
Or are you just pretending like you don't understand what mass is?
Mass is poorly defined.
Okay, so you don't believe in gravity. That's fine.
No.
So you don't believe in gravity.
No, this is a rhetorical. No, depends on what you mean by gravity. If I ask 10 people what they mean by gravity, they mean a whole bunch of different shit.
It means space-time. Yeah, it means space-time.
Well, I mean, it could be.
No.
It's poorly defined.
What do you mean,
known in science itself that gravity is just poorly defined, that the cause is the effect at the same time, and that's what you're trying to do. And I'm trying to differentiate them.
No.
Hey, you don't believe in gravity, which is like implies, oh, you don't believe things fall? No, things fall. That's the effect. You want to call that gravity? That's fine.
Yeah, you have no idea why it falls.
Why does that happen? Why do things fall?
Mass is attracting mass.
How do you know that?
We've measured it.
You measured mass attracting mass between the Earth and some object.
Yeah, you can do that with a scale, like stand on a scale, or you can do it with mass attracting mass directly. You can measure them with a...
None of that determines the cause. None of that determines the cause of why something falls. None of it. Not Cavendish, not a scale, none of that. We want the causal mechanism.
You can do a bunch of experiments on why water boils at a given temperature and pressure. Doesn't mean that you're determining the cause. You're just saying that this is what happens when this happens.
No, we have a phase diagram, okay? We know that a certain excitation energy in the molecules will make the substance change phase, okay? That's what called boiling water is. I mean, you can put it in simplistic
what causes
terms.
That? Why does it change phase?
Because the thermal the kinetic energy imparted, okay, on the molecules, it can no longer maintain a bound structure, okay.
Yeah, but
so
why?
You have a number of degrees. What do you mean why? Because it has energy.
It's not explaining a causal mechanism why these bonds are breaking.
Yeah, it is.
Just stating that it is breaking.
Because it takes so much. Look, it takes so much energy to break them. Okay, and once that threshold is reached, they're broken.
Yeah, but why? Why?
I mean, why? Don't act like a 2-year-old.
That's all you're doing it with gravity.
No, I'm not.
You can measure this thing, mass attracting mass, and you're saying, well, it doesn't explain why.
You can't measure it in relation to a falling object, though.
What?
You cannot measure it in relation to a falling object.
Why does that matter? If you can measure mass attracting mass, why would you think mass would?
Why would you apply it to a falling object?
Well, you're going to say if you don't apply it.
Why? How do you know it isn't some other cause, dude? How do you know it isn't something else?
Because you can try it in a variety of conditions and see if your predictions are coming correct.
Your predictive you can try something else and see whether your predictive predictions are coming correct.
No, just see if your predictions are coming correct.
Okay. That's fantastic, but we don't use the universal law of gravitation to predict how something falls.
Yeah, we do all the time. What are you talking about?
We use little g. We use little g. We use little g. We don't use big G.
You're talking about what? You can use both. You can use either.
Really?
Yeah.
Go ahead, calculate how far a cannonball flies by using big G.
I'm driving.
So that's how Napoleon did it. You need a fiery knowledge of the mass of the Earth. Okay, where would you get that?
Okay, like clearly you don't like the idea of gravity. So what do you think?
No, I know.
Go down?
Like I have no idea. I don't know. Nobody's done it. No one's done the experiment required to do that to determine it.
Well, you're saying
no one has done the experiment. You don't know.
You're saying because I haven't done a particular experiment myself, I can't say that it's been done?
No, not because nobody has.
Well, I mean, that's another assertion. You're saying that nobody's ever done a Cavendish experiment?
Nothing falls in the Cavendish experiment. That doesn't tell us why something falls.
No, it's showing you that mass attracts mass.
Yeah, how did you get to that's the reason something falls?
Because you do it again and again and again, multiple environments, controlling for variables. And if you get correct predictions back, that's a very strong indication that you're...
That's okay to leap logic and apply one thing to another thing, which isn't the same?
You need to go from describing what is happening to why and how.
Works?
No, listen, you can keep doing this again and again.
No, if you have a predictive model,
you can see what is happening, but you don't know why or how it's happening.
Listen, you guys have him down. He doesn't know how anything works now. Listen to him. He's asking a question now. How does science work? How does the letter S work? How do letters get formed? He's getting down to the nitty gritty because he doesn't know shit now.
Okay.
No, I know how science works. It's predictions, novel testable predictions. And if your predictions come true, that's evidence that you are correct about your hypothesis.
All right, dude. Apple cycles forever, brother.
Novel testable predictions are not actually evidence for the claim in the hypothesis.
Homie, you're missing a very key. Yeah, dude, you're missing a very key point about your predictions. You have to manipulate an independent variable to get the prediction you predicted. If you just make a prediction, and, look at today is Taco Tuesday, and you go to the cafeteria, today's Taco Tuesday. Bang, nailed it. That doesn't count. That's just truth seeing.
Did you miss the part about novel testable prediction?
Yeah, you'd have to manipulate variables to get your predicted outcome at your predicted results. It's not just like, I'm making predictions.
Change the mass and the distance. Are you saying that that's not manipulating independent variables?
No, that's not changing any variable.
That's not manipulating a variable, the mass and the distance between the masses?
You can't manipulate the mass directly, right?
You're saying you can't add or subtract mass from something?
Mass itself is what needs to be manipulated. If you were just moderating the amount of mass or moderating the distance between objects, at best you have what's called a moderator variable, which links whatever the independent variable is to the dependent variable.
I'm not understanding what you're saying. If you're changing the mass, you're changing a variable. This sounds like semantics.
It's not the independent variable. It's not semantics. This is part of what goes into scientific experimental design.
How do you identify what the independent variable is?
Sometimes that's the hardest part about setting up an experiment. You don't know, and you go on a hunt for it.
So if I tell you the mass and the distance are the independent variables, what's your issue?
That would be your dependent variables.
No, there's the independent.
Isn't your independent variable, isn't that gravity itself? Or is gravity the dependent variable?
No, the dependent variable would be the force of the attraction.
Which is you're putting a sticker on that, calling it gravity.
I mean, you can call it whatever you want. Sure, yeah, it's the force of attraction between these two objects. That's
okay. So where did you see that happen?
Well, you measure it.
Where did you see it? Where did you see that happen? That happened where? You observed that
experiment.
No, before your experiment, you observed this happening where?
You're saying like your initial observation. You can see things falling down.
Okay, so you saw it's like an apple or something like that fall on your head?
No, that would hit me in the eyeball. I wasn't looking up when it.
Can you see things fall down in Cavendish?
No, mass attracts mass in Cavendish.
Yeah, but can you see things fall down? That's your claim, dude.
No, my claim is mass attracts mass.
Is that the prediction or the evaluation?
The prediction is mass attracts mass.
Prediction was Cavendish was trying to determine the density of the Earth, so that was not the prediction.
It doesn't matter. I mean, it predicts mass attracts mass, and then you measure mass attracts mass, and it measures it.
No, it doesn't, dude.
Predicts mass attracts mass. Okay.
Okay, let me ask you this.
What's wrong with the experiment?
I don't want to. You don't even know what's observed in the experiment. And I'm going to demonstrate that right now. What is observed in the Cavendish experiment exactly? They set up the whole contraption, then what happens?
Track mass.
No, physically, what do you see?
Mass.
Mass. Can't see mass, dude.
Mass.
Hold on, you're breaking up. How lucky for you.
Okay.
Hold on, wait till you're freaking, you got a signal. When you get out from under that bridge or wherever you are. Or is it me? Mic check.
No, it's him. He's all legged out.
Can you hear me any better now?
Yeah, that's good. That's good. So, what do the balls do? Yeah, what do the balls do?
Ask your question again.
Yeah, what do the balls do in the Cavendish experiment? Can you relate to me like exactly what's observed? Where you deduce that mass attracts mass?
Yeah, they're attracting each other.
No.
Yeah, because they move closer towards each other.
And then what?
No.
And then what? That's
you
part
can measure
of it.
That force. You measure the force.
No, that's okay. What do they measure it with, dude? You have no idea what's observed. You don't have no idea what happens in the Cavendish experiment. None of you do. I'll give 100. They're not measuring it with a torsion bar. So what happens
is... What you measure it with, then?
They time a clock. They measure with a telescope.
A clock? You can't measure force with a clock? What are you talking about?
No. So
why would a clock measure force?
Yeah, good question.
How does that work?
Yeah, good question. They don't measure a force.
Can you answer
They infer a force. They infer a force from the force mass equation, right? So what happens is the ball rotates on a thing, right? They measure the rate of rotation and then it oscillates back and forth, back and forth, back and forth. They measure the rate of change of the oscillation and the angular change. And they do the force mass equation, Newton's second law, on how much force it takes to cause that acceleration. That's where they get big G from.
No.
Yeah.
No.
Yeah.
That's not how that works.
I'll post a video of a fucking child in high school doing it, okay? Yeah, that's exactly how it works.
Why would I listen to a child in high school when there's actual scientists who have done this? What's happening is...
Actual scientists, this is how the actual scientists actually do it.
You said it was a kid in high school. The way the experiment is done is you have two sets of masses, each suspended opposite from each other. Then you move the two set fixed masses closer to the opposite two. that can oscillate on the torsion bar. You let them oscillate back and forth until they actually stop moving entirely, and you can use that to measure how much that torsion bar has twisted from introducing the masses, which you can then calculate the force, the attraction.
Okay.
It's not, has nothing to do with time.
That's nonsense, dude. Everything you said is nonsense. How are they measuring the force on the torsion bar? How did they get that?
Yeah, they measure how much force it takes prior to the experiment to bend the torsion bar any given distance.
Good.
Then they place the mass a given distance away, and they see how much that torsion bar has been moved.
Tell us what a torsion bar is.
It's a bar that's incredibly sensitive. It doesn't take very much force to actually twist it. And it's got a very specific given value.
This is amazing. This is absolutely amazing.
Thank you.
I know it is. So it's just a bar that hangs. It's suspended from
I'm not the person who thinks that you measure force with a watch.
That's how it's done. They don't measure it. They don't measure force. They calculate it.
Well, I mean, you do calculate it, but you don't measure it with a watch.
The only measurements done is they measure the weight of the balls. Okay? Yep. And they measure the time it takes for the shit to move. And they do the force math equation to infer a force.
No.
It's really simple.
Because it's on the pendulum, it'll oscillate the same amount of time back and forth every time. Like, you know how pendulums work,
Eventually
right?
it comes to an equilibrium.
What?
Eventually it'll come to an equilibrium point.
Yeah, it'll stop moving, and that's when you measure it. You measure how much it's displaced from initial position A to the secondary position B.
They're making shit up, dude. That's not how it's actually done, though. That's how you imagined it was done, but that's not how it's done.
If I give you a paper, an actual like scientific citation, so I'm going to be done driving in like 5, that states that they measure the force through the torsion bar, will you concede the point? No, he muted himself. I don't even see how this...
Right, sorry, I was talking. No, because how do we get from that to that's why things fall? If you don't understand what we're talking about, how do you get from that, the logical connection between I set up Cavendish and now I'm going to say this is why things fall? How do you get to that? The logic.
Sure, so
the logical steps.
You need to go with my understanding of the Cavendish experiment. Do you agree that...
I want the logic.
Yeah, I'm getting there. I need more than the sentence. So if you agree with my understanding of the Cavendish experiment, would you also agree that if that torsion bar does twist, you can measure the force that's causing that torsion bar to twist?
Yeah, I'll grant you all that. Go ahead.
And calculate the force.
Yeah, great.
Sorry,
there's a force between the balls. Yeah, there's a force between the balls. Great.
Yeah. So if you can demonstrate that consistently using multiple different materials and changing conditions appropriately, then you can demonstrate that there is a force being exerted when you get two masses, you introduce two masses close to each other, that masses do attract each other.
How?
Do you agree with that conclusion?
Yeah, in that setup, let's say, yes, in that setup that happens. Everything you dream of, it all happens. How do you get logically from that to an object falling?
Yeah. So you see mass attracting mass, you can measure it, you can predict it and measure it.
Yeah, in that situation, yes, yes, you do.
Yep.
How do you get to a falling object?
Yeah. So obviously there's a lot more mass in the world than just those two balls. There's a whole lot of mass underneath your feet, and presumably that's causing a similar force.
Presumably, and there we have it.
Yeah. Do you have an experiment that shows otherwise?
I don't need to. You just presume the whole thing.
Well, I mean, all of science is done through induction. You see, gray goose, gray goose, gray goose. You're going to assume the next one's gray goose, not purple goose.
That's all fantastic, but you're saying that this is a universal property, right? That applies to all things.
As far as we can tell, it is. Yeah.
As far as we can tell, it is. I don't think so.
Yeah. Do you have an instance where this doesn't happen?
How come I have to disprove your baseless claims?
Because there's evidence for my claims. They're not baseless.
Yeah, but no, they're baseless. Okay, they're
well,
literally baseless.
You just said that if you do everything in the experiment, it does measure a force.
That was a hypothetical.
A force between. Yeah, in the hypothetical. Okay. Yeah, of course.
Hypothetically, let's say that would happen.
Yeah.
First of all, I'm not even getting into all the problems with Cavendish. How it works when it shouldn't. There's no generated p-value. How you don't know whether the effect is greater than chance. How if you change the orientation of the masses, you'll get different measurements. How things that aren't supposed to attract each other because they don't have enough mass to attract each other. How things that sometimes it just doesn't work at all. Like all the problems with the Cavendish. Tons and tons and tons of them. Okay? In the actual experiment itself. Then there's the problem of you're inferring from a rotation that somehow mass attracts mass, and then you make the gigantic leap of logic that's why things fall. That is a gigantic leap of logic. Okay? The observed natural phenomenon, you're not observing a natural phenomenon. We want to know the natural phenomenon that we observe. I drop something, it falls to the ground.
Yep.
Okay? That was observation. That's your claim, right? And you don't have an experiment, which actually... I don't need one. You haven't demonstrated yours. You haven't demonstrated yours.
Sure. So I think it really
you haven't even shown the association, the logical association, even between Cavendish, in which nothing falls at all.
What?
We want to know why things fall. Fall. Why do they fall? That observation, that natural phenomenon. So to demonstrate why a natural phenomenon happens, you make a man-made contraption and then say, oh, this is why. Just like our man-made contraption, this is what nature is doing over here.
Okay, so are you saying that you have that for like the flat Earth? Because this is like a pretty high standard. I don't see like how you would do this.
Dude, it's well known. It's well known in the science itself that there's a problem. It's well known.
Yeah, I mean,
I can play a video right now of them talking about a bunch of scientists talking about.
But
no, they've known this. This is why Newton repudiated his own theory.
No, he didn't.
No, he didn't.
Warren, block class down.
Do you have a source that states he did?
No, I'll just read it to you.
I'm just ahead of the crew a little bit.
I mean, it doesn't even matter because you can go out yourself, do the calculations, and see if the predictions are correct, and they are.
Which prediction?
His field equations.
Newton's field equations?
I'm sorry, not field equations, but his gravitational attraction equations. Yes.
Okay.
Like you can literally
maybe we will measure through the back door. It might just be easier.
Hold on a second. What's with the verbal diarrhea right now?
What's that?
Hold on a second. Yeah, the people chiming in, do you have something to contribute, or you just chatter? Go chatter somewhere else.
Yeah, someone was home miking.
Oh, okay. Okay, I can make a prediction.
Yeah. You can go out and make a prediction with the gravitational attraction if you calculate the centrifugal force at the equator compared to somewhere else, like the North or South Pole, something like that. And you can actually measure what the delta would be. Go out and measure it, and it's been done hundreds of thousands of times. It's
hundreds of thousands of times. It's getting better, dude.
Yeah. It makes predictions about what the downward acceleration will be.
Yeah, you're full of shit, dude. Okay, I'm going to tell you you're full of shit. So there was
that's a really...
There's a scale company called Kern Scientific.
How that addresses
yeah, I'm going to address what you said. You're full of shit, dude. Your claims are not evidence. You realize that, right? The claims are not evidence.
Is this you refuting my claim? Well, I mean, you can go out and look at the measurements yourself, or just make them yourself.
What can be asserted without evidence can be dismissed without evidence.
Well, I do have evidence. You just refuse to say that it is evidence. Are you saying that people haven't gone out and measured the difference of the downward acceleration at the North Pole compared to the equator? Because it has been done.
Okay, and I'm going to ask you to post it, and you're going to say you can't.
I am driving for another minute. I can post that for you, though. I mean, they did it on the final experiment when they were at what's the place?
They were at the North Pole,
in the southern hemisphere. No, they were at the.
They weren't even at a pole.
Yeah, but there's a difference between the equator and the North and South Pole, and then there's a whole spectrum of difference between those 2 points or 3 points.
Yeah, I know. I know there's a difference.
If those predictions come true, then that's evidence that your claim is correct.
Okay, first of all, they don't match the prediction. Okay, so we know this from the Kern. Kern did a test where they had a scale in a garden gnome, and they sent it to scientists all over the world. 21 data points, CERN, South Pole Station even, they sent them all over the world. And the measurements don't match prediction. They're not even close. In fact, it's just a random frickin' variation. Okay, it's called Kern Scale Precision, a scientific equipment company. They took up one of their precision scales. They sent it to CERN. They sent it to South Pole Station. They sent it to Lawrence Livermore Labs. They sent it to Sandia National Labs. They sent it to different universities all over the world. And scientists there measured this gnome, wrote down the results. They pinned it on a Google frickin' map and generated all this data. Well, this data was taken off, it was put into a spreadsheet, and it was graphed. And that graph does not match the prediction even slightly. So you say people did it all over the world, hundreds of thousands of times. Ridiculous, dude.
And also, too, this guy's like all messed up. I mean, people have done things where they replaced a bar with like a piece of wood, or they replace weights with chicken nuggets in soda. Like what the hell, man?
There's one. I was gonna. If he wasn't driving, I would have posted. There's one where they use like a stack of washers that are metal washers that are all glued together. And they have them so that the holes are vertical, and then they flip it so that the holes are horizontal and do the test 2 different ways and get different results, but depending on the orientation of the washers. So I didn't know that flipping the orientation of a washer changed its mass, so I don't know. Call me crazy. This is the second time in 2 days someone's... Well, when you get on wherever you're going... It's fine.
I did hear a lot of what you had to say, though. So, like, if I gave these...
You heard about the gnome experiment? The gnome experiment.
No, I didn't hear that.
Okay, so there's a scale company that makes scientific grade scales. So they had part of an ad campaign. They took one of their scales and a garden gnome, because garden gnomes were like in fashion back then or something. It was like a meme. And they shipped them to scientists all over the world and had the same one, the exact same one, same garden gnome, shipped them to scientists all over the world. And they measured this garden gnome, and they all got different results, but it doesn't match the prediction, even a little bit. South Pole Station, Lawrence Livermore Labs, Sandia National Labs, CERN, i.e. the Large Hadron Collider. So I think they know how to do measurements there in all those places.
Mm-hmm.
They took the measurements, and it doesn't match the latitude change, the latitude weight adjustment that should be predicted. And he's also
if I gave you... Sorry, go ahead.
I was going to just say these wouldn't even be predictions; they'd be postdictions. By the way,
why would that not be?
Well, I mean, I'm just saying they're not predictions, but it doesn't even match anyway, so it's irrelevant, kind of.
Well, what if I gave you
in chat?
Sure.
You're gonna give me some anti-flat earther and doing some test? Great. Yeah, let's go with that. Sorry, I'll defer to CERN scientists using an actual precision scale company. Okay, a precision scale. So I had somebody, who was it yesterday, saying, yeah, they did this. Wolfie did this, but he didn't calibrate it. That if you calibrate it, you're doing it wrong.
Yeah, that's correct. If you calibrate at the particular place that you're at by putting like 100-gram test mass on it, if you recalibrate it when you're in your new location, it'll know that you have 100 grams and actually change what its output, like it'll change the calculation so that it shows 100 grams. Because it knows that there are variations on the surface of the Earth for the downward acceleration.
Is that why you calibrate a scale?
I mean, there's a good few reasons, because it does get out of true after a while, so you want to calibrate it for more than just that reason. Although, if you do move latitudes significantly, you do want to recalibrate, unless that's explicitly what you're trying to measure.
Digital scale calibration, they get out of calibration in minutes. Minutes, dude. I know, because I weighed a whole bunch of shit. You can weigh the same thing over and over and over and over and over and over and over again.
Mm-hmm.
And you'll get a fucked up result. And any digital scale, triple beam scale, they need to be calibrated or they're not accurate. You're getting a garbage measurement. But then the point, yeah. The point is that they've done this test and it doesn't match prediction. Point blank.
What's that?
They've done this test. Professional experimenters. That's what they do for a living, is they do experiments.
Mm-hmm. Did you post it in chat?
Oh, I will. Yeah, hold on.
I appreciate it.
I didn't know if you were going to be...
Yeah, I parked. I'm waiting for my crew to show up.
Just had to post this last night. This is crazy.
Which, I'm not in here very often. Which one did you post it on?
It's going to be in live stream voice text. There we go. So, this is a Google, this is a spreadsheet with all the data put into it. It's a video going over all the different environmental variables, pressure, temperature, elevation, all that crap. Corrected for all that. Oh,
it's the Google Doc spreadsheet?
Yes, yeah. You don't have to watch the video. I'm just posting that just for ha-has.
Yeah, where do you get the data from?
From their website.
Whose website?
Kern.
Kern or CERN?
Kern Precision Scale Company. KEERN.
All right.
Here's a graph of the data output. So on the right is the data, on the left is the prediction. Variation by latitude. As you can see, they're not even remotely close. There's no correlation there in any way, shape, or form. Other people have done this too. This is Thrive and Survive did this at 3 locations. He's a trained meteorologist. Master's degree in meteorology. He's done this. Saw the fairy tales out there.
Sure. I'm just trying to find the data that he actually pulled from.
The data originally was on. You remember how Google Maps had pins? Like you could pin stuff on a Google Map.
Sure.
Years ago.
Yeah.
That web page is defunct. Okay, that's why I posted the video, because you can watch him go through Google Maps, go through all the data points, and put it into the spreadsheet. Because that website no longer exists. Served its purpose.
The data itself, is it on the Wayback Machine?
The link works on the Wayback Machine, but the Google Maps feature doesn't work.
Wait, so like people just... Sorry, go ahead.
Because they just scrape the page. Google doesn't offer that function anymore.
No, I understand that. My question was, like, so where he got this data from is from pin drops that people left on Google Maps about these scales. Am I understanding that?
That's how Kern. That's how Kern put it on their website. It was Kern's website. So after they did the measurement, they submitted the data to Kern, and Kern added them to the pin onto the Google Maps on their website.
The Google Maps.
So right, they ship the scale. They ship the scale to CERN. CERN does the test. They call Kern and say, "Hey, this is our result." Kern says, "Okay, we're going to put a pin on Google Maps with your results."
Sure. Yeah. And you're saying this is actually Kern and Son? Is that the company that you're talking about?
No, Kern and Son. I don't even know it was in Son.
SOHN. That's got to be it. If that's not it.
Oh, Kern and Son. Oh, yes, it's Son. It's German or Swiss or something.
Mm-hmm. Yes.
Yeah, so they make scientific equipment. This is part of an ad campaign. They actually won an award for the ad part, innovation in advertising or something.
I'm trying to. I just want to validate the data.
Yeah. So, mind you, I don't know if you know who Matthew Ernst is, but I showed him this, and he said, despite the data, what are you going to believe, the model or the data? He said, I'll believe the model. So that kind of tells me everything I need to know. So that don't really apply to you. I just think it's hilarious.
Sure. Yeah. You should always go with the data. I'm with you on that.
But back to this model thing, because I take severe umbrance, like you have a model that makes a prediction, and if the prediction comes true, your hypothesis is correct. What about epicycles?
Are you talking about from the geocentric model?
Yeah. What about those?
Well, we don't use the geocentric model anymore, so there's no more epicycles.
Well, so you can't use it anymore to predict where you're going to see a planet?
Yeah, that's why we don't. Cause I agree with you. That's really bad. Epicycles are a terrible idea. No, because you got to adjust it every year. So it's not. So it's only predicting a very limited amount of time. The further out you can predict, the more accurate your model is likely to be.
How far does Newton's work for?
It depends on what you're measuring. Sorry, what was that?
How often does JPL update their ephemeris?
I don't know. I would think they would update it somewhat often. I have no idea.
Yeah. So what is the bitch exactly?
What's that?
So what is the bitch exactly? What are you bitching about? They have to update epicycles. They have to update Newtonian, Keplerian orbits. They have to update everything.
Well, I mean, you get more accurate information, and you want to update your model with more accurate information, right? You don't want it to just stay static, because a measurement between us and Mars or us and Jupiter, these things they're not exact. There's a for any measurement, there's a margin of error range, and if you can bring that margin of error down, then obviously you're going to have a more accurate description.
These aren't measurements, margins of error. It's model error. There's a residual error. So the point is that why don't we just go with epicycles? Because if it's a model and it works, let's use it, right? The reason we don't use it is philosophical. It has nothing to do with.
No, it's because it can't predict eclipses. It can't. There's a ton of stuff it can't do.
We don't predict eclipses with a Newtonian model.
I mean, I'm not sure if that's actually correct, but I mean, if it is correct, we can definitely predict it now.
Right? No, it doesn't work.
Isn't there supposed to be an eclipse in 2026 in
and they don't predict it. They don't predict it with a Newtonian model. They don't.
Yeah, but they do predict it.
Not with Newtonian gravity or Keplerian freaking orbits.
Yeah, so you use a different model, but if you do predict it and your prediction comes true, that's evidence that your hypothesis is. Do you disagree with that statement that I just made? If you make a prediction and your prediction becomes true,
I don't understand what you mean by hypothesis. Like, what is your definition of hypothesis?
So it's just an idea about the conception of the real world. So I could have a hypothesis that God exists, and if God Bob exists and I pray to Bob, I will get a gold brick in my hands. If a gold brick shows up in my hands, that's evidence for Bob. And if I change the variables a bunch, I tried to pray to Bob in a submarine or secluded on top of a mountain, and every time the gold brick appears, that's evidence that Bob exists. Would you disagree with that?
No, I guess that would be evidence that Bob exists, but I don't know how it applies to this. This is a mathematical model.
Well,
this is an existence or non-existence.
Mathematics is just a language.
Yeah, that's why. How are you getting from? I don't understand how you compared something concrete to something that's abstract.
I mean, you use an abstract model to predict the concrete future. So if you're predicting eclipses 10, 30, 40 years in advance and they're all coming true, that's really good evidence that your model is accurately reflecting or describing reality. Do you disagree with that?
Yes, there we go. Actually describing some future event, right? That you'll see something in reality. Yeah, great. But the underlying model itself isn't true or false or anything. It's just a model. Just data fitting, right? Because we have kinematic versus dynamic models. And the way we predict eclipses is a kinematic model. It's called the solar cycle. So eclipses happen with a regularity.
No, like the difference between kinematics is you're not predicting. Dynamic, you are predicting. You're describing.
No, you predicted kinematics. You just there's no forces.
Well, clearly we're predicting eclipses. You agree with that?
We've been predicting them since at least frickin'
like 100 BC.
Let's just say longer than that.
Oh,
way longer. First eclipse prediction with Thales de Miletus, like in 300 BC.
No, I mean
a flat earther, by the way.
The date, location, the size, the totality of the eclipse. More specific predictions than just an eclipse will happen on this day. We've only been doing that for, let's say, 200 years. Would you be okay with granting that?
I don't know when it started. I know that they used Gazillion projection or something to get the location.
I cannot find where this guy got this data from.
It's in the video. You can watch him do it. Unless you think he faked an entire web page back in 2017.
You can trust, but you always want to validate, of course, right?
No.
Exactly. I mean, the ultimate validation would...
Never trust anything. Validate it. That's how science is built. The power of science is that you immediately distrust it. As soon as you add the variable of trust, you've destroyed science. It's no longer
science. So if you can't validate it, then don't trust it. So if I can't validate these numbers that he's inputting,
then I can't
trust it.
No, you'd have to do it. You'd validate it by doing it.
Yeah, that's my point. You have to there are other experiments where people do it. Well, you don't have to do it personally. I don't subscribe to that. Do you?
Yeah, you'd have to do it.
You're saying you have to do it personally to subscribe to the belief of it.
No, you can believe whatever you want.
Yeah. If you just want to slap a belief sticker on it, you can just believe in Bob. You just said, "Oh, old boy did it. He came down the mountain with a brick in 10 Commandments." Sounds good to me. I don't need to do it myself. Why would I have to do it? Bob did it. You can just throw belief on anything and just go. You'll be fine. The Western culture was built on Bob going up to the mountain and bringing back 2 stone tablets. You'll be just fine. Now, if you want to test it yourself and go up there, and is there a burning bush with a bunch of golden bricks? That would be for you to do, not for someone else.
Sure, but if thousands of people have been to Australia, I can have strong confidence that there is evidence. I know that there is evidence for Australia. I don't need to go myself to prove that Australia or New Zealand exists, right?
Yeah, if that's what you want your worldview to be, that people can say they're from Australia, you've got evidence Australia exists, you no longer believe Australia exists, you know it does. Then follow that logic.
Justification.
Yeah, then follow that logic.
Yeah, so I don't have to personally witness or do a thing. If there's enough independent verification, especially if it's quantified and peer-reviewed, I think that's justification for holding a belief. Do you think it's not justification?
Now you're back to belief again. You can believe whatever you want to believe, whatever framework you want to believe it on. It's not about belief. It's do you know?
Unfortunately, I got to go. It was nice talking to you guys. I appreciate it.
All right. Have a good one, man.
That's really the heart of the issue right there. He doesn't really know things. He only believes things.
Whole shitload of things.
Because even at the beginning, it's so do you know Australia exists based on all the evidence you have? No, I just believe it.
Well, like you said, like I said, he can believe whatever the hell he wants. But that's not what he's doing. He's running around saying, the shit I believe is true. I know it's true. Everybody believes it as with me. So you should believe it too.
Yeah, no thank
you. I was surprised he proved Gary exists. Yeah, so every time you pray to Bob, Gary makes gold bars appear because he wants you to believe Bob exists. And my claim fits the evidence, so I'm correct.
Yeah, there it is.
Now, what about Steve, though? Steve has hypnotically made Gary want to make dude think Bob exists. So he gave Gary the gold bar. So also fits my hypothesis.
Yep.
Were you listening on YouTube, AI?
Yeah.
Did you hear some of the shit he said? It was pretty outlandish. Who was that, though? I recognize that voice. I don't remember who it was. Just alt account.
I didn't recognize his voice.
I've talked to him before. I think he might have been in politics. Yeah, a lot of that was painful.
Oh, what was I thinking? Oh, mass attracts mass isn't a description of the cause. That's a description of the effect. Just said it a different way.
Yeah. It's actually true. Well, I mean, he defined mass. Dude, did you hear what he said about? What was it? He said units of measure. I said, so you're saying units of measure tracks units of measure, and he said, yeah.
Wow.
Yeah, he was. I'm glad he didn't spiral out though. No, because I thought like after he said that, this dude's going. He's about to hit the wall and spiral out of here. But Alpha actually taught me something the other day. Sometimes you can actually reel them back before they completely go off the deep end. I think I succeeded in doing that. Sometimes their ego can't recover from saying something that stupid.
Yeah. Yeah, you got to hit them before their self-preservation thing kicks in. Otherwise, they're just, it's a battle then. I don't know, dude. I feel like I feel like a fresh breeze of intelligence flowed over my mind when I was hearing that guy say, "You don't know the cause," and you say, "Okay, what's the cause?" And he's like, "Mass attracts mass." That's the same thing. So he's saying mass attracts mass because mass attracts mass. He's not saying the cause. He's describing mass moving towards a mass as mass attracting mass, and then saying the cause is mass attracts mass. Even after you told him that people don't know the cause, they just end up with the effect and the cause being confused, and then he just exemplified it. And I'm like, yeah, mass attracts mass that's not a cause. That's what you're claiming is going on. That's the effect.
Didn't he say the attract part is the cause?
I mean, he was trying to say that, but it's like, that's like saying a magnet attracting another magnet is the cause of magnets attracting magnets. Do you see how stupid it sounds now?
Oh, yeah. Yeah.
Like that literally, now that I just said what I just said, it sounds even stupider.
I know. I gotta put that one in my Batman utility belt.
Yeah, what's the cause of a magnet attracting another magnet? Oh, a magnet attract magnet. That's what the cause is.
No, it's magnetism.
It's Bob.
It's a Bob. Yeah.
Speaking of that, I gotta buy a bunch of magnetic levitation devices. Those are awesome.
He's obviously debated this topic before, but he was stuck in his little rhetorical script that probably works on TikTok.
Yeah. Well, yeah, I'm gonna buy a magnetic levitation clock. So it's basically a wall clock where the hand of the clock is a ball floating in front of the clock, locked in a they got a magnet within a magnet, and the poles are reversed or whatever, and so it's attracting and repelling simultaneously. So you put the little ball, and it just like floats about a half inch or an inch away from the surface. and you can turn it sideways and put it on the wall, and then you got a clock.
Does it actually tell time?
Yeah, they have them. You can buy them like legit, where they rotate, tell the time. Yeah. I want it because I want something that I can have a fully mechanical motion that I can pass my hand in between. So hopefully the hand being in between won't disrupt the field in enough so where the ball would fall. So another thing with the gravity thing, someone mentioned in the comments, if you put two balls on a table, and the table's flat and level, and the balls are separated from each other, they won't roll towards each other. Now our intuition is, yeah, but our intuition is of course not because the table's level, so it's not sloped. You know, if it was sloped, the balls would run down the slope. Why would the balls run down the slope? Well, because we know things roll down slopes. So when they do their little space-time demonstration where they take a bed sheet and they put balls in a bed sheet, which depresses the bed sheet and creates a slope, the balls then roll down a slope. And a lot of people don't catch that they're trying to explain to you a mechanism for gravity being the space-time bed sheet when they're appealing to down, separate, as the moving force. So they're already assuming there's going to be a downward vector, and then they're putting the balls on an inclined plane, the downward vector. So this isn't addressing how space-time functions at all. It's definitely not addressing any cause, because the cause of the motion there is something else, which is down, which we all experience. Which is a severe problem with these guys that can't think, is that they don't realize that when you tell them that Newton and Einsteinian versions of gravity are incompatible, it's not because they're not kinematically equivalent in the way that the motion is, right? It's that their causes are different. Nothing in Einstein moves without already being in motion. If it's not already in motion, it can't be affected to travel through a geodesic in space-time because it's not traveling. The geodesic in space-time doesn't move the object that's not already moving. So there's no cause of motion in Einsteinian. So they have to set you up with the mass attracts mass canard to make you think that that's how things work, and then make you think that down isn't down, but it's actually inwards to a giant ball, and then do a bait and switch after you're convinced of all that space-time bed sheets is actually how gravity works. We actually have three competing ideas that can't actually be synergized. They can only be addressed separately. And each example relies on the assumptions that you carried over from the previous example. It's one of the reasons why they can't have a static universe. Everything has to be moving. Otherwise, Einstein's stuff doesn't work.
Well, I mean, his psychological statement was, "It works, therefore it must be true." But he made a lot of crazy freaking claims. Thousands of people, hundreds of thousands of people. There's lots of people that have done it. Like, I can't show you because I'm driving. Oh, now I'm at work. Bye. Yeah, you're never going to show us.
Oh man, thanks for reminding me. I gotta switch out my expensive eyeglasses to my cheap as heck contacts before I ruin them on the job site.
Yeah, I bought an Apple Watch, I don't know, a couple months ago. The face is fucking destroyed, like the glass thing, the bezel thing. Just scratches all over it and shit. And getting fucking trenches with a pickaxe. I've been doing in real life Minecraft.
Nice.
Still no diamond.
Great. I gotta find my contact solution. Good grief. Man, I should just rip my organic eyes out and just go with my red ocular implants. Dang it.
Go with the LASIX. Laser your eyes.
Dude, when I was in the Army, I could have got LASIK. Or whichever one. So they offer you
the PRK,
all of that, but I didn't really know about it. It's the one where they, instead of the standard one was where they kind of like slice your eye like a garbage can lid, and then they flap it over. Then they do their thing, and then they flap the flap back, and then it heals. But you always have a weakness on that plane that they sliced it. And then the other one, oh, sorry, real quick. That one you can go back to work in like a day or two. So the other one is they essentially take a cheese grater and they cheese grate your eye down, right? And then they zap you. But that takes like, I can't remember if it's 3 weeks or 6 weeks. And you're blind for weeks until it heals. But it's super strong and durable and doesn't have the problems that the other one has, like with your eyes hurting, or a trauma can make your scar line sever, so your flap can come loose. So it's way better, but you have to be blind for a while.
Yeah, except it does have more complications too. Like it can have things go wrong with like the way the lens heals, and can kind of create multiple vision and.
Yeah. So there's a third one, which is they scratch your eye around, and then they put a constricting silicone ring in it, right? And so they never actually touch any of the optical parts of your eye. You know, so all that stays good, and they can actually, if they screw it up, they can redo it the same day. So those are like the 3 eye surgeries, and I kind of never really bought into any of them. I was kind of too scared for any of them. And then I didn't know that the Army would have paid for it for free while I was in. Because I probably would have had it done then. But who remembers corrective lenses? Does anybody remember that?
Eyeglasses?
No, not eyeglasses. Corrective lenses.
The glass? Are you talking about the glass contacts that they had before they were plastic?
The gas.
No, what I'm talking about is what I'm talking about is a design philosophy. So there was back in the day. I remember when I was a kid. You go to the eye doctor. They say, "Hey, your eyes suck. Here's corrective lenses. Here's also a list of eye exercises. Do these exercises. Come back. Then we'll alter your corrective lenses, and eventually you'll see normal again." Versus nowadays, where it's you show up to the eye doctor and they're like, "Oh, I'm about to make money on you, buddy, for life." And so every time you go, they're not trying to correct your eyes at all. They're just trying to fix the current symptom that you're dealing with. So every time you go, your prescription gets worse and worse and worse and worse. Whereas in the old philosophy it gets better and better and better till you don't need them.
You know, my ex, I think she did that. I think she had something wrong with her eyes. She had to wear correcting lenses. For like astigmatism or something.
Yeah.
And then, yeah. And she stopped wearing them and they got worse and worse. I was gonna say, now, you said the military was offering eye correction surgery. Now, the first thing I think of, why aren't they offering like eye augmentation surgery? Shouldn't the military be like, oh, dude, we want super soldiers that can see like 40 fucking miles? Why haven't they tried that?
They did try it, and then they all went crazy and essentially turned into zombies. And then they're like, "Oh man, let's just turn this into a plot of a movie instead."
They did try it. Then they realized all their girlfriends are ugly. Now that their eyes are fixed, like they went from being like a 5 to now they're 2. Because now you can see every freaking blemish in their face, every freaking stretch mark in 3D freaking high resolution detail.
Yeah. Dude, you know what? What came across my feed the other day is these girls lauding over Taylor Swift about how immaculate her stage presence is with her gorgeous legs, and her legs are just so smooth, and they don't have any blemishes. They're like, "Oh, wait, she's wearing tights," and I'm like, "You're a girl and you don't know about tights, and it's like you're so dumb that you think Taylor Swift's legs are perfect and she's not wearing tights." It's like, holy crap, dude. Girls don't even know that girls are nowhere near the appearance that they should be. I'm like, what is going on here? When girls don't know that other girls fake their appearance, that's a really turn in culture, man.
Yeah, man. Yeah, I guess. Yeah. Good. We're complaining now, dude. Wait, in 5 years with AI, it's going to be ridiculous.
Yeah, go into a store in the men's grooming section, then go into the women's grooming section. The men's grooming section is a portion of an aisle. The women's grooming section is the rest of the real estate of that corner of the store.
Big money maker.
Yeah, especially since a lot of that stuff you got to use daily. So it's like, you know, you put it on, take it off, put it on, take it off, put it on, take it off. And it's like $15 a jar, you know. Well, some of it's cheap. I guess you can get the cheap junk, but you know how it is.
Jane was talking about that his wife and I think he said his daughter used like an anti-aging cream, and then they wash it off and it clogs his sink.
Oh, that's a good one, dude.
Yeah, and they're putting it on their face, man. Like, come on, man.
I know. I heard they're using AI algorithms to crack the some stem cell code where they inject your cells and reboot them and turn them back into stem cells or something to reverse aging. So I can't wait to see all the test subjects that sign up for that to be done in their face, and then their face ends up like hanging down like Snoopy. Or not Snoopy. Who's that one? You know what I'm talking about, where a bulldog, where all the Droopy the dog.
Well, what if their face turns back to a baby face, and they're like grown adults?
That'd be popular among the Democrats. Be like Darkman, where after 2 hours your face melts off and you have to put the cream on all the
time. Dude, baby-faced human, like adult humans, is like nightmare fuel.
Do you remember the Catwoman movie where the one with the villain? Yeah, the one where the villain was like a makeup conglomerate, and her makeup turns your face into stone, and so she was like had super armor.
As long as it doesn't turn other people into stone.
Hideo, did you see my shoe rock observation?
No. Where'd you post it?
Check 1 second, but I think, you know what, dude? I think I never put my contact in my case. This is gonna suck. Oh, here it is. You ever put in your contacts, and you know they have a left and right, and then you put one in, and then you accidentally turn it around, and then you're like, "Where's my other contact? It's not in here." So the whole reason they have a left and right is because some people have left and right prescriptions, but it's also supposed to be you're not supposed to switch. You're not supposed to switch your contacts, even if they're not different from eye to eye, because you could cross infect. But I'm like,
I just assume people are just dumb, dude, and that they'll put the contact and the two contacts in the same eye.
When I was in Iraq in 2015, I wore my contacts for like, without even taking them out of my eyes, for like a couple of months. Just kept dousing them with a solution all the time. Then they banned them. Some kid had a melt to his eyes because he was stuck in a Humvee that was on fire, and he was close enough to where they like melted to his eye. And they said, no, you can't wear contacts in the field anymore. You got to wear your glasses, which sucks, dude, because your glasses fog and sweat and all that heat.
Yeah, back in the days of yore, it'd be like some of the combat arms. You'd have to have a medical waiver to get in with if you didn't have at least like something like 20/40 or something like that. Like you're expected to be able to function even without glasses on. Oh no, like they,
Yeah, I thought there was an eyesight cut off. I thought you couldn't have.
Yeah, for certain MOSs, like combat, like a clerk or supply, it didn't matter. You qualify for those jobs, or radio operator. Yeah, but if you were some sort of combat arms, that required like you have to be able to see to some sort of standard without corrective lenses on.
Posted it. All right, look at those.
It still proved nothing, lad out there. Yeah, that's good. Shit. Is that Windsor Lake, dude? What clear mirage going on?
Oh man, was I on mute the whole time? Holy crap. Yeah, so who can pass my quiz that I put in the chat there? So there's an image, there's a blue streak in the middle surrounded by green. You got to tell me what object that blue streak is.
Canoe.
What color is it?
Blue.
Wrong. It's yellow. Let me show you. Good guess though. Blue was a good guess, since it clearly looks blue. All right, here it is, bro. Man, did it go through? What the heck? Oh, there we go. Check it out.
Not bad.
Now, somebody guessed that what's occurring there is you may notice that there's a blue barrel in the bottom picture up high there. They said maybe it's the reflection of that barrel on the water. That might be where the blue color is coming from.
Nah. It's too close to the center reflection of the dock, where the dock meets the water. It's on the same line.
So this is about 1,000 feet. Google Maps. Well, actually, not Google Maps. The lake profile, but also Google Maps says it's like 330 to 333 meters to that little pier from the observer location.
How's it going, guys?
Horrible.
Sorry to hear that. What makes your day horrible?
I'm trying to listen to some flat smack and listen, but instead I'm setting up work.
So you can't really.
Set up tools.
Sorry, go on.
I'm just setting up tools.
What do you do?
Build things. Houses. Repairs. Stuff. Objects.
Nouns, even?
What's that?
Even nouns?
Do I
you
build
do verbs
nouns?
to these nouns? Yeah.
Yeah. I verb some nouns. I verb them real good.
Fuck yeah, man. That's what I'm all about. That sounds like a good day. Why is it bad then?
Because all my helpers are on drugs or in jail, bro.
Oh. That does suck.
What's the culture coming to? Yeah, exactly.
You want to discuss the flat Earth at all?
Sure.
Are you busy?
Loosely. Kind of busy. Yeah.
Why? What's your proof of flat Earth?
Oh, I don't have any proof of flat Earth. I think it's a globe.
Prove it.
Sure. Do you agree that you can determine your place on whatever surface this is by local solar noon? You can determine north, south, east, west, and latitude, longitude?
Sure.
Cool. Yeah, if you measure the distances between those measurements past the equator, they get smaller either direction, north or south. And at the equator, they're the longest. The only shape that I know that can do this in the proportions that it does happen is a globe or a sphere.
And so what? Still not curved.
Did you understand my argument, or?
Yeah. But so what? There's still no curve measured.
Well, I mean, if you can measure that the lines of longitude are converging north and south.
I don't care.
That is a compelling argument. I don't know what to say to that.
Well, measure the curve of the Earth, and that is the one that you'll win with.
Well, I mean, I could present that to you. I just don't think you would accept it as evidence. But what's wrong with the idea of converging? Well, I'd rather talk about the thing that I brought up because you wanted to talk about my proof.
Because that doesn't matter. It still doesn't make the Earth drop down away from you anywhere.
Well, I mean, geometrically, if there's two central points where all longitude lines converge, it would have to be some three-dimensional object. It can't be a two-dimensional flat sphere or flat disc or square or any other shape.
Well, it's not curved, so you can throw that out.
So you think it's like a rectangular Earth?
Oh, I don't really care.
The measurements.
Yeah, it doesn't matter to me. It's flat.
It really
though,
doesn't matter to you that there's two.
No, I live in Ohio. I don't go anywhere. If I go anywhere, I'm heading to Vegas or going on cruises.
That sounds terrible. Well, I guess you enjoy it. Sorry, that's my own opinion. But how could it be any other shape if all lines of longitude converge at some kind of northern and central southern points? It can't be a two-dimensional object. Would you agree with that statement?
Nobody says two-dimensional.
Flat earthers do.
No, it's flat and stationary. And contained.
Like there's...
And we have air pressure, so that's another problem for you.
Not really, but what's wrong with my...
How does converging lines make air pressure?
No. Do convergent lines make the Earth flat?
Sure.
No, they're impossible. It's impossible to have two central points on a flat Earth.
Why?
How are the lines of...
So if the ground is flat, when you walk from north to south, when you measure from north to south and it's flat, and you have a point of rotation in the north and one in the south, and that's all done in the sky, what does that have to do with the non-curving ground?
No, I'm talking about measuring the distance between lines of longitude on the ground. You can measure them getting shorter.
Yeah, you use the sky for that.
Equator. No, you don't. You don't use the sky at all.
What do you use?
You measure lines of latitude.
Where are they? Are they drawn on the ground? Are they drawn on the ground somewhere?
Well, you can measure them. Yeah, you measure them on the ground.
Oh, where's mine at?
You said you're in Ohio.
Yeah. So where's my? I want to see the one that's the closest one to me, so I can see where it's drawn on the ground.
No, you can determine these things yourself. You don't have to trust other people. I mean, earlier you agreed with the premise that they're...
No, I want to trust that somebody knows where these markings are at. You said they're done from you do this on the ground. That's how you figure out by measuring your globe. By using your globe, you look at the ground. So you prove it.
Yeah. You use local solar noon to figure out what your longitude and latitude are on. And you can measure the distance between them. South and north of the equator, the lines converge.
Whoa, brother. Whoa. I thought you said it was on the ground, though. So I'm just critiquing from an outside observer in your conversation. No, I'm just saying, like, if you said solar noon, all right, let's just pretend you can't see the sun at all. Okay, what's your latitude?
I mean, I guess you could use the moon. I'm not sure how you do it without the sun. Like, at least in a rudimentary way. Are you saying that the sun isn't a reliable way to figure out what longitude you're on?
No, what I'm saying is the sun is the source of the latitudes and longitudes. The sky, it's not the ground, right? So it's your observer's location where the sun is in the angles where you're at. That's all it is. So the other guy was saying they're not on the ground.
You're saying the ground is dependent on the sky?
No, the opposite. The ground is not dependent on the sky.
Yeah, I agree.
So if you create a matrix of grid lines that you think are coordinated with a celestial object, that's not going to change the shape of the ground. So if you measure the ground and the ground measures flat, then it's flat. It's that simple.
Yeah, but if the ground that you're measuring, that you're saying you measure flat, is converging at two different points, north and south, it can't be a flat thing.
Yeah, but you didn't say that the ground was doing that. You said that lines that you interpret from the celestial positions is doing that.
Yeah, so what's the issue with using the sun to determine the distance between lines of longitude?
Because there's no triangulation of the sun. You can't do any like geometry with it in that sense.
Why would you need to triangulate the sun? All you're doing is at this given time is local solar noon here.
Right. So in order to take interpretation of your data and the other person's data, you have to put them into some kind of matrix or model, right, relative to each other. And then you have to assume geometric locations based on the observer's location relative to where the sun is. So you have to synergize these into one idea. Yeah,
you could say I have no idea. You could say the sun is an infinite distance away, and it would make no difference to what I'm proposing.
Yeah, you're proposing that when people are looking at the sun in their different locations, they're in a specific geometric relationship relative to the angle that they're looking at the sun. That's your claim.
No, my claim is the sun can provide definitive evidence what longitude line you're on. And I thought you agreed with that. Do you disagree with that now?
Dude, that's circular. Your observer's location, the degrees to the sun, that is defined as that. So, like, what does that have to do with the ground, though? All right, sorry, I'm not supposed to be interrupted.
That doesn't make sense. The sun
makes sense.
Well, it was a question. I did want you to answer it. Do you disagree with the idea that you can use local solar noon to figure out what longitude line you're in?
Link up with the satellite computer. We will only have 20 seconds to reprogram the satellite. Beyond that, and then they will be too far apart. Okay. You're reaching 3, 2.
Do you agree with that? I want to know.
So you're using the sky then?
Does that answer my question?
Well, I'm just confirming that you want to use the sky, not the ground, to determine where you're at, right?
I want to confirm that we both agree on the same thing. So do you disagree or agree with my statement? Because if we both agree with it, then it's irrelevant.
I can figure out where I'm at using the stars.
What about the sun, which was my question?
Maybe. What does that have to do with the ground not curving, though?
I mean, it demonstrates my point that there are two central points.
I didn't say there wasn't.
Where lines. Okay, so how is that? That's impossible on a flat Earth. There's no geometry that makes that work.
Right. It's on flat. The Earth is flat. Right. It's in the sky. It's correct. It's impossible on the ground. It's in the sky.
What? I'm talking about the ground. Can you determine your longitude? Are you not tracking the conversation? You can determine your longitude based on the timing of local solar noon. Do you agree or disagree with that statement?
So what?
So that's a yes?
Sure.
Awesome. Then you can figure out, if you go to point A and point B, and you figure out the difference in timing for a local solar noon, and you measure that distance, you can actually measure the distance between for a given length of latitude. Would you agree with that as well?
How are you going to measure it?
There's a ton of different ways. You can use a measuring wheel, car with an odometer, plane.
Is that linear?
You can do linear, sure.
That's a
you
straight
can use
line.
a surveyor.
That's a straight line.
Okay, that doesn't matter at all to my question.
It does. You're trying to. You're not telling me how the Earth is curving, though. Using all these methods.
I mean, that's exactly what I am proposing. Because if they're all converging at north and south...
Then why can't we measure the Earth curve?
You can, you just reject the evidence for it. But
okay, what's the evidence for it? If I just reject the evidence, what's the evidence for it?
surveying.
Those are straight lines and triangles, and you can't have those on the surface of a ball.
No, that's not true. So, do you know what reciprocal zenith angles are?
Do you know what a triangle is?
Yes. Can you answer my question?
Yeah, I do. But we're going to take my test first.
Oh, so you don't like answering questions? I mean, that's been clear.
Oh yeah.
Go ahead.
Now I answered questions. Now it's time for you. So now we'll look in the live stream.
Go ahead.
Look in the live stream and answer this NASA IQ test question. Which of the figures below are not triangles?
I'm driving. I can't see it.
Oh well.
What, you trust NASA or something? Why would you want me to take a NASA IQ test? What does that demonstrate?
See how smart you are.
Dude, the title NASA IQ test is clearly sarcastic, right?
Sure, yes.
They never take the test.
So
yeah, keep in mind, Don Pettit. Hold on, friend. Don Pettit failed the test because when presented with the document, he just started to eat it.
Okay, I don't care. So if lines of longitude are converging at some kind of central point north and south, that demonstrates that they converge, that there's one central point for both set ends, but you can't have that on a flat object.
So you can only have angles. You can only have angles on flat objects. You can't have any angles on curved objects. So you lost again.
Could I throw two balls on the ground and measure the angle between them?
No.
What? No?
What are you going to measure from? What's your point of reference?
You measure from wherever you have your theodolite or whatever instrument that you're using to measure angles to the central point of each sphere or the edge of each sphere that are closest to each other.
So using straight lines then?
You can use straight line. Yeah, of course you use straight lines for that.
You have to use straight lines.
Yeah, but the objects themselves aren't made straight by using straight lines to measure.
If I had two basketballs touching each other, what's the angle they're touching each other at?
That's an incoherent question.
Oh, so you can't have... All right, if I had a basketball sitting on a table, what angle is it sitting on the table at?
That's an incoherent question.
There you go. You can't have angles on a curved surface. So all of your curving measurements that you think are curving are just straight angled measurements. You can't take any of those measurements without it being a flat surface. You can't do it on a ball. So there you go.
Sure. So if I take a ball,
That's the end.
Throw it in front of me.
No,
it in front of me.
No, that the basketball
you don't
surface.
Want me to talk.
No, you were talking about the basketball surface and you sitting it on a table. What's the angle that you measure between the ball and the table?
That's an incoherent question. I already answered this.
That's right.
All right, so let me demonstrate the idiocy of this point. You take a ball and you throw it in front of you. Then you have a theodolite, which measures 90 degrees from the downward vector, right? Do we agree on this so far?
You don't have downward on a ball. You only have in or out.
No, I'm talking about on the physical whatever thing that we live on. A theodolite
down can only be on a flat. Down is only on a flat surface. 90 degrees can only happen to the flat surface, not on a ball.
That's an excellent assertion. So let's say you do this. You throw the ball. You have the theodolite. You measure 90 degrees. That's your.
Why am I throwing the ball? Why am I throwing the ball and then measuring it with a theodolite? Why am I throwing it?
For the sake of the hypothetical. Holy shit, dude!
The basketball's sitting on my table.
Emotional control.
Yeah, the basketball's sitting on my table.
The basketball's sitting at the table. Yes, you have a theodolite out. You measure it.
Or what? Where's the theodolite
Wow,
setting?
holy shit. If I need to finish my sentence before you ask questions about the
Where are you setting up the theodolite?
200 feet away. Does it fucking matter? No, it doesn't.
Why?
What's the goat doing in New Jersey?
You need
There's no relevance
it
to the
needs to be put
hypothetical.
on the surface of the ball so you can make angles to things from the surface of a ball like you would Earth. So you said you can't do that. It's incoherent.
So I'm going to take a ball, I'm going to put it directly below the theodolite. I'm using the center of the ball and the downward vector to position my theodolite. Now I have a second ball.
You don't have a sensor of a ball.
I have a second ball in the hypothetical. Do you really struggle this hard with hypotheticals?
Yeah, I'm not going to let you have this hypothetical because you can't have the center of your Earth ball. You don't have a measured curve.
I can't imagine things. They hurt my balls.
Why would I have to? I used to be a glober like you and imagine those things, but you don't have to anymore because the Earth is flat. You don't know what triangles are. You don't know what triangles are. You freaked out when I asked you what triangles are. You said it's incoherent to make an angle from a curved surface. That's incoherent. And
you know what
so now you're telling us to measure angles to the sun from a ball. That's incoherent.
All right, so are you going to let me finish the hypothetical now, or are you just going to keep interrupting?
Go ahead and finish all you want, but you know it's incoherent.
Sure. Your question was incoherent. Mine is not. There's clearly an answer. You put a ball on the ground, then you set a theodolite directly above it. So you're using a ball to situate your theodolite. You then take a second ball, throw it 10 yards, 20 yards away. It doesn't matter. You use the theodolite to measure the angle to the upwardmost portion of that ball. Can you measure an angle from either the horizon or from directly situated above that ball to get a second angle to the other surface of that ball? It was a question.
So they're both sitting on a basketball court?
It's in a field.
Why does it have to be a field?
It doesn't have to be. That's just my hypothetical.
Is it a flat field?
Sure.
Oh, so they're the same height?
I didn't say that. One's a yoga ball, one's a basketball. It doesn't matter.
I said two basketballs before. Now you change the size of them.
It doesn't matter. It makes that variable doesn't
so from the basketball. So now we need to set your theodolite up onto the basketball and somehow level it to the center of the basketball, right? But you can't do that because you don't have a center to work from on an Earth.
You don't have a center on a basketball?
No, you don't have a center to work from.
On a basketball?
You just can't set it on there and then turn it about 30 degrees and say, now that's centered on a basketball.
You really think you can't use the downward vector to point directly through the center of a basketball?
You can't do what you want to do, no. There's no downward on a ball.
I just said.
It's only inward on a ball.
You can't use the downward vector.
Down is only on a horizontal plane.
That's fascinating. You can't use the downward vector to pass directly through the center of the basketball. Is that your statement?
Where are you getting the horizontal plane from?
The downward vector. It doesn't matter. You can use the downward vector. You don't have to reference the horizontal vector at all. There's clearly the downward vector. You can clearly set it up.
Down is in relation to horizontal.
Through the center of the basketball.
So those are straight lines. You can't have that on a ball. No straight lines on the surface of a ball, remember?
You can do a tangent on a ball.
What's the angle between the tangent line plane and the ball touching it?
What's the taste of blue?
So you can't answer that question, can you?
No, I'm demonstrating that it's a coherent question.
Yeah, so you just said I can measure a tangent, though. So measure a tangent point for me.
No, I didn't say you can measure a tangent. I'm saying you can place a tangent on a ball.
And what does that do for you? What's the angle between the line that's sitting out 1 foot from the tangent point and the ball? What's that angle?
It depends on how far away you're measuring.
Dude, you just said it's incoherent to have any angles when the ball's touching a table.
No, I said your question is incoherent.
Mine's incoherent, but yours is coherent. Yours makes sense, but mine doesn't, right?
Yeah, exactly. Yeah, you're getting there. So you're saying you can't measure from the downward vector through a ball to the topmost part of another ball. You're saying that that's impossible.
You're not going to be able to do that on Earth.
It's a law of identity. It's a law of identity violation. Like, you're already saying that you can do that on a ball. How do you know what you're standing on is a ball?
Where am I saying P and not P at the same time?
Yeah, you're saying you can do this on a ball. Isn't that correct? You stated that over and over again. But how do you know you're standing on one?
Yeah. The converging lines of longitude.
Yeah, what is longitude based on?
Local solar noon.
He said angles, and I told him you can't have angles on the surface of a ball. He said, yes, you can. I said, put a basketball on a table. What's the angle between the ball and the table? That's incoherent. So now he's using something incoherent as his proof.
It's just interesting.
So you don't think you know what longitude you're on from local solar noon? Now you're changing your position?
Yeah, wait a minute. Yeah, but where are you deriving longitude from? What is longitude derived from? See, this is the part you're not understanding. Local solar noon. So when you say that, are you thinking that that's happening on a surface that's curved?
It can be, or it could be on a flat.
No. It's not. It can be.
Data, and then
it either is. No, sir. It either is or is not. It either is or is not a curved surface.
Yeah. So we've done the measurements, and yes, because this particular experiment that I'm talking about has happened.
Wait, stop. You're jumping. You're jumping through. Hold on, sir. You're jumping through too many hoops. Right now you're saying because of solar noon. Yes, you are. Because of solar noon, okay, latitude or longitude is being derived.
Yeah, you can know. Do you disagree that you can know what line of longitude you're on based on local solar noon?
So what we're trying to figure out is what is longitude and latitude derived from? And you keep, it's local like circular. You said local solar noon, right? Is that happening on the surface that's curved or a horizontal plane?
You can make the hypothesis either way. I know that
it's inconclusive. So that's inconclusive then. It's inconclusive.
No, it's not inconclusive once you get the data. The data is how you demonstrate which one is correct.
McFingland, you give two options. It either could be one or the other. It's inconclusive in your worldview.
No.
So you don't know.
So the way that I compare ideas is I take one, see what predictions arise naturally from it, and compare it to predictions made from the second hypothesis. So if the North Pole is the center of flat Earth, all lines of latitude will spread out.
He's making up stories.
Yeah, hold on a second.
Oh, so you don't think the North?
Wait, hold on, McFinland. You just made up what you think flat Earth is. Do you think flat Earth is what you just described? No, hold on a second. You just described what you think. Yeah, well, you didn't give anyone a chance to do that because you've already made up in your mind what you think flat Earth is. I think this is where you're going wrong already. So you strawman.
Yeah, what's your map?
You strawman the position of flat Earth, and then you started kind of wailing on that strawman. So you don't.
So you don't hold to the Gleason's map. What is your map?
There you go. See, this is the issue. So now you don't have a position to argue against if you don't know what we're saying. Isn't that
everybody has a vastly different position in flat Earth. So just stop crying and tell me what your position is.
No. It's not about crying, sir. It's about you being concise in your proposition. So if you're not doing so, it's an injustice to like the argument. So what you're doing right now is you're creating a whole narrative. You're creating a narrative about the argument. So the argument to you is about maybe flat Earth that's like akin to the Gleason's map. or AE.
Yeah, so the Gleason's map is disproved. I'm glad you agree. What's the correct?
Hold on a second. Wait a minute. Wait. But you don't know
if it's
where
more
those
complaining.
maps...
I really don't want to hear it. Just tell me what your idea is.
This is correcting you on your assumption that you think that we're...
I already admitted, if you don't hold to the Gleason's map, that's fine. I'm not trying to force you to take a position that you don't hold.
So we don't...
Just tell me what your position is.
Let's say this. We don't hold to the Gleason's map. What would be your argument then?
That you have no idea what the shape of the Earth is.
So what does that have to do with you trying to rebut our position?
Sure. If you don't have a model, and I have a model that makes very good predictions,
there it is.
Then my model is far more likely to be correct.
There it is.
In fact, yours doesn't even make predictions.
Yeah, because you
have a model that makes predictions.
Yeah, hold on, sir. You need us to have a model in order for you to have a position to argue against. Because we didn't present one, and at least now you're finding out we don't have that position, which would be the Gleasons. Now you can't find a way to combat what we're saying. You need something. You need for us to have a model in order for you to take a stance because you think you have one. And that's the reason why you come in here probably arguing about tangent planes. Because for you, it makes more sense, according to what you're saying. I'm drawing.
Okay, so what's your position on the shape of the Earth? Do you think it's flat?
Yeah, the shape is not what's in contention. This is the whole wrong way to look at what we're talking about here. We're not talking about shape. Flat is not a shape, sir. Do you know that? Or do you not know that?
Sure, it's a two-dimensional description. It's not three-dimensional.
Okay,
but I think we all understand what's being communicated when somebody says flat Earth.
Right,
You're saying you don't have a map? I don't want to misrepresent you. Just tell me what your position is. And stop complaining about my position.
First of all, sir, it's not about a map and it's not about a model. You got to remove that from the position you think you're going to argue against.
If you don't have a model, then you have no evidence for your position.
No, this is a problem for you coming in here thinking that this would be a better way to argue for this, and you don't have a position. Right now, if I was to tell you, how could you verify any model or map? Go ahead and tell me how you verify that.
Makes.
No, okay, predictions. What predictions? Name one.
Reciprocal zenith angles.
From what?
From 90 degrees.
Horizontal.
Yeah.
Not to a ball. Not to a ball, remember? Because that's incoherent.
But we're back to Professor Triangle's point, right? You said 90 degrees. That's what he was saying, right? So we're back to now that you know we don't have the map and model argument, and we're back to what you're talking about, reciprocal zenith angles, and you need a 90 degree. What do you need to have 90 degrees? There's two things.
The downward vector.
Well, what's the other thing you're going to need?
Some kind of instrument to measure the downward vector?
No, I mean, like, what's the intersect? How do you have a 90 degree? What is 90 degrees?
From the downward vector.
Now, I know that, but what is it intersecting with?
It's not intersecting with anything. You're establishing the downward vector, and then you measure 90 degrees up from that.
He won't say it because it's detrimental to his position. This is the reason why he won't say it.
What do you think my position is?
Yeah.
See how you were just describing and saying you can't tell the other person what their position is, and now you're telling me what my position is?
Yeah. No, what you're not. This is important. What you're not saying is what the reason why you. If you're not telling us the full scope of the argument, you're not going to be able to represent your position correctly. So if you're saying 90 degrees, and I'm telling you to go ahead and tell the audience what does that mean, and you're withholding the information.
90 degrees is from the downward vector. That is my honest position. I don't appreciate you telling me that I'm being dishonest. I haven't said that about you.
Yeah. So you need a horizontal plane.
No, you don't.
Yes, you do.
No. You establish horizontal from the downward.
Angle. Bro, listen. If you don't have two intersecting lines that meet at a vertex, then what are you gonna? How do you have an angle if that's not what it is?
Imagine this: you place a plumb bob in a in an area where the air is very still, so it doesn't move at all. Can you measure 90 degrees off of that plumb line?
You need a horizontal plane. If it's 90 degrees,
horizontal plane would be the 90 degrees off of that plumb line.
Yeah.
Are you saying that you can't measure 90 degrees off the line?
So this was Professor Triangle's point. This is the reason why you're not realizing that you don't have a curved surface. Because if you did, then you'd realize that doesn't work on a globe. What you're describing.
So do you disagree that you can? Do you agree that you can do 90 degrees off of a plumb line? Because that's essentially what a theodolite is doing.
Sure.
Yeah, nobody's disagreeing that point.
So you can measure whether it's curved or flat. You can measure that angle.
No, wait. But what I'm trying to tell you is, like, if you're using this information, how does this help the globe in any way? That's what I'm trying to ask you.
I didn't agree that it works on a ball. I just said you can do it because the Earth is flat. That's all.
Everybody knows this. Everybody knows this, McFinlan. But I think you're not getting it for your position. It doesn't help you for the Earth being a globe.
So the reason I brought it up was reciprocal zenith angles. You remember this, correct?
Then you need a flat surface for that.
Yeah, you need a horizontal plane, bro. We're trying to tell you that it doesn't work for a globe.
What you need to do is compare the two hypotheses, right?
You said it was incoherent. You said it was incoherent, and now you're trying to make your incoherent shit actually be coherent. So what are you trying to do here? Is it incoherent or not?
What you were saying is incoherent. What I'm saying is not incoherent, because we both agree that whether the Earth is a globe or the Earth is flat, you have a downward vector.
So you're telling me you can't measure any angles when I put the basketball on the table, but you're telling me there's 90 degrees on that ball.
I'm telling you there's a downward vector, and we can measure 90 degrees off the downward vector. And we all agree with this.
You need a horizontal plane to do that, dude.
Why?
Even in your basketball example, you used a tangent plane. Did I not hear you say that?
No, I'm saying you could use a tangent. You could just measure center.
No, it's not a could.
In this example I posted, where's down on the example I posted? Where's down for that?
I'm driving. I can't look at what you're doing. Down is towards the center on a massive object.
Yeah, but first of all, you have to describe you're begging the question. You're already saying that you're standing on the ball. You're standing on the ball, and the ball, while you're standing on it, the downward vector is when you're standing on the surface of that ball. You're already begging the question. You're on a ball. Like, the problem is you don't know that.
When you compare hypotheses, you take both ideas and you see what both ideas predict.
It's not about an idea.
If you're on a flat Earth, there's going to be a downward vector.
McFinlan, flat Earth is an observation. It's not an idea. It's what the physical world displays itself as. You, on the other hand, do have an idea. But the idea that you have that the Earth is a globe doesn't compare to the physical world. When you go outside and you do field tests, it doesn't appear outside in any form of test, whether long distance observations or laser tests or any other way that we can test and measure. There's nothing you can do to manifest your idea into the physical world. However, flat Earth is.
Nope. You're saying that you're saying simultaneously that we don't have a model, we don't make predictions, and that the globe Earth does make predictions, but it gets some of those, at least some of those, wrong. And it sounds like you're saying all of them are wrong.
What is a prediction useful for? What is a prediction useful for, McFinlan?
It's used for a ton of things, for practical life. Like if you want to know the distance between...
Name one, dude. Stop being ambiguous.
Surveying.
Name one.
Surveying.
In what? What do they use it in surveying for predictions?
Yeah, like, so if you want to try to get two tunnels to meet, you need to be able to predict what angles you need to be...
you can't do angles from the surface of a ball, so you're screwed there. It must be flat then. There you go. Sea level.
Like, I don't understand why is this like a religious chant kind of thing?
No.
Like, let's go from a spot that we all agree on and then move into whether the Earth...
Dude, you said I can't set a basketball on a table and get an angle between the ball and the plane.
Yes,
so somehow now, wherever you stand on a ball, you're able to get an angle from that surface of a ball, but not the opposite.
If the Earth is a globe or flat, there will be a downward vector. Do we all agree on this?
No, if you can't start a statement that is a truth statement with if. It's not logical, sir. A truth statement doesn't start with no. You don't understand logic, number one. And when you're going into it, you're saying if is subjective.
Why do you guys struggle with type like, the example goes forward. If the Earth is flat from the downward vector, that whatever you say, this is an idea. What's that?
Hold on, your internet was wonky. You have to restate the last 30 seconds.
Oh, really?
Yeah.
Looks like it was fine. Whether the Earth is flat or a globe, there's a downward vector. Do we agree?
No. Because something
dude.
is
On a flat Earth, there's not a downward vector? There's things
there has to be. Yes, there has to be because Earth is flat.
You're starting off with either this or that. You have to provide
both
evidence.
of them.
Dude, listen to me when I'm speaking. You have to provide evidence when you're saying it could be this other thing. What evidence do you have to provide that it's this other thing that we're saying it's not? We're saying it's not a globe. You're saying it is. What evidence do you
and
have
it's a
to provide?
multi-step process. I have to explain all the steps. And if we disagree on any particular step, we can discuss it and see if we actually disagree. That's
you
how
haven't produced anything so far. So
how a syllogism works.
I went ahead and posted our flat Earth model, but since he's driving, he'll lose out. But that's our flat Earth model right there.
Is it a map or like a?
No, it's a model. Diagram. It's a diagram showing a guy standing in the middle of a north, south, east, and west cardinal direction with a circular tangent plane, and he's got like an angle to the sun, where it's got vertical, horizontal, and then the angle to the sun. So it's just a diagram showing that.
Yeah.
But you're gonna need it.
But if south converges at all points and north converges,
wait a minute,
all
dude.
northern lines.
No. That's something else. That you're going off something. We're not going there. I was asking you something very specific. Is there any way that you can? Because you said it was either this or that. Okay, so if you're going to produce something that's in the way of evidence, what do you have for it being a globe?
Data, reciprocal zenith angles.
Okay,
these are measured.
Dude, wait a minute. No. What things can you produce as evidence that gives properties of a geometric shape such as a sphere? We need something tangible.
Reciprocal zenith angles are measurements. They're tangible. You can do them yourself.
Plane for that. You need a horizontal plane. So that doesn't describe a curving surface. I've already said that multiple times.
No, it does, because those planes
no, it doesn't, brother.
Don't actually match each other. They actually diverge from each other when you measure them over any kind of notable distance.
What are you talking about?
Do you know what a reciprocal zenith angle is?
Yeah. When you said that the horizontal plane is different than the one where you take it at the other spot, how do you know that's true?
Because you can measure it. You can measure the deflection.
What?
So if
the deflection,
one theodolite is actually going over top of the second theodolite, but the second theodolite is also going over the first theodolite.
Wait a minute.
And obviously those horizontal planes aren't matching. They're diverging.
What is the distance between the theodolites?
Wow, holy shit, man. It's like I'm in the middle of a sentence, and you're like, I can't let him finish this sentence. I don't want to actually engage with what he's thinking and saying. I can't do that. I need to interrupt.
Can you tell us the distance between the theodolites?
I mean, yeah, you can do it yourself because you won't trust anything.
Are the distances between the theodolites, sir?
Are you saying a particular measurement that's been done is like 3.1 mile?
Okay, so one is at 3 miles away from the other?
Yeah. One of them I looked at was 3.1 mile.
Okay, what is the maximum effective range of the theodolite used for that viewing distance?
There's no maximum range. It measures angles, not distance.
What? So it's not going to be inaccurate. Hold on. It's not going to be inaccurate at a certain distance?
No, it measures angles, not distances. Why would a distance affect an angle measurement?
Because if you're going to
very simple.
Go ahead. Yeah.
Very simple. If I'm at gunnery, right, and I'm trying to hit my target on the zero target, and I have a slight deviation in my barrel attitude, it's going to be a major deviation at range. So my gun doesn't actually measure distance between me and the target, but my angle and especially my sight picture, which is how I'm looking through the sight to put the crosshairs on the target, if those aren't aligned, there's going to be a major error at range. So it's not an irrelevant question.
Well, that's for an object that's moving through the two space, like from point A to point B. We're just talking about measuring angles between.
Oh, you mean light? You mean light? So light's not moving between point A and point B?
I mean, it does move, but it's not affected by any of the things that artillery are affected by.
Listen, I didn't say artillery. I said a gunnery range. So if you're looking through a sight, right, you have the forepost and the back post, and they have to be lined up. And then that really attitude has to be lined up. That attitude. Hold on, brother. You didn't, dude. You were wondering why his question was relevant. So I'm letting everybody know why it's relevant.
Oh, so this does have to do with the reciprocal. Okay.
The idea that in a device is going to be the same accuracy at close range versus long range isn't a fair assumption. So it's fair for him to critique you, and maybe the device isn't accurate at those ranges, and the reasons why it would be inaccurate might be relevant, and that is true.
Sure. Do you have any evidence that a theodolite is less accurate at measuring angles at a distance?
Yeah.
Excellent. Could you provide that?
Yeah, it's called everybody who has any sense in their head understands that if I take I have an 8-inch level in my hand right now. Literally picked it up off my table. It's 8 inches long. Now, if I take this level and I level it on the side of my wall here, and then I try to draw from that level across the entire way, it's going to be a different line than if I take my 8-foot level. Now, theodolites don't have 8-foot levels in them. They have very small bubble levels, right? So the idea that that machine is going to be as precise at longer ranges as it is at closer ranges is absurd. Absurd, sir.
You don't think that they can make very accurately calibrated theodolites? That like the downward vector is always going to be correct.
You can make a finely calibrated, yes, you can make a finely calibrated machine within the tolerances for the machine at the ranges which it's intended for, which is why he asked you, this machine that was used, what range is its maximum effective range? That's a fair question.
Well,
I also posted
the issue with that is
why the theodolite doesn't work over.
It's measuring angles. Well, the issue is
listen. Very simple. How does it measure? How does it measure? How does it measure the angles? How does it measure the angles?
From the downward vector.
Wrong.
How does it do it?
You can't complete a measurement of an angle by just saying from the downward vector.
I don't want to hear about how it can't be done. I want to hear how it is done.
No, dude. You haven't told me how it is done. So, for example, if you tell me how do you get the pitch of the roof, I might say, well,
vector. You're saying you make
wrong. I'm wrong. I can get a pitch of a roof without appealing to a downward vector at all. I can measure the horizontal run, which is just assumed, right? And then I can measure the vertical run, and then I can get the pitch from a math equation. I don't need to appeal to a downward vector instrument at all. I can use a carpenter's square to get the pitch of a roof.
Okay, but you're saying...
But in order to do that, and so on my carpenter's square, friend, check this out. Check this out, brother. Yeah, it does. I'll explain. So my square here, which is actually a triangle, it's blue in the shape of a triangle, it has degree measurements on it. So I put one of the degrees on one line, and then I move the edge by rotating the square to where it meets the surface of the board, and then I read the other degree. So one of the marks is on one physical portion of the board. The other mark is on a second physical portion of the board. So to analogize what you're saying, what is the second point of reference when it's doing an angle? How does it tell an angle?
It just does it up and downward.
Okay, so let me help you out since you're clearly struggling. No worries.
You're saying that it is a particular other way.
No. I'll help you since you clearly are struggling.
So what's the issue?
So what you do is you put the reticle. You put the reticle onto.
Let me explain my confusion.
No, dude. No. You had multiple chances. Notice how I could explain my tools immediately and precisely, but you couldn't. Dude, I gave you 2 chances. What, do you want me to give you 3 chances so you're not up to bat anymore? 3 strikes, you're out?
Yeah. That would be...
Okay, fair. Go ahead and take your 3rd crack at telling me how a theodolite obtains an angle. Go ahead.
No, I want you to answer a particular question, because this is my only question that I want to explain. Because
No, dude. No. Okay, so we're gonna bench you. Since you're not answering the question. Since you're not answering the question. Oh no, because you started it with "I want a question answered" rather than saying "I'm about to explain how a theodolite gets an angle." So just explain the theodolite getting the angle. Okay.
Well, I think you're misunderstanding me. That's a sexton, but.
No, the misunderstanding here is why you don't understand. The misunderstanding here, friend, is that you need to drop out.
On the downward.
Friend, you need to drop out. You need to drop out and come right back. Go ahead. Your connection is crap.
McFingley,
your connection
can't
sucks.
hear
So
you.
just try to reset your connection. Man, I gave him a chance to talk about the theodolite making an angle, bro. I don't know.
Once, twice, 3 times a charm. Mike, try again.
Listen, he blew it when when I said this to him, Brett, I'm about to post. When I said that to him, it was over. He knew it.
Hey, hold on. Try again, McFinglin.
Hello?
Ooh.
Can you hear me?
Yeah, you're coming in real rough, man. Like it's choppy and sporadic.
The satellite's not working today.
Wait for the next Starlink to fly over.
That was good. I mean, AI
how about take a break? Take a break. Yeah, take a break and listen for a second since your connection's crap. And when you come back, we'll let you talk. So
he dropped out.
The reason why I was asking you how it happens, dude, was because when you level an instrument, like you said, you're relying on down. But we all know that instruments don't necessarily make a perfect calibration of the down relative to the plane of the instrument. Like anybody who builds anything knows this. There's error. And we also all know that error extrapolates out more and more the further away you get from the device. So when Homeboy asked you how far and was the device capable of being accurate at that distance, you scoffed it off like it doesn't matter. When anybody who has any practical real-world experience knows that level isn't going to transpose itself out indefinitely. Like I can literally demonstrate this with my levels that I own. I could take all my levels and the lines will be different. The bigger I go, the more straight the line will be. The smaller, the less straight it'll be as it gets further away from the device. I mean, this is so obvious. Listen, friends, this is so obvious. The idea that someone would critique you for asking that question is in itself an absurdity. Like it can't even be taken seriously. To even countenance it as a serious retort is silly. That would be like me. This is how it is, friends. That guy just saved me a lot of money. I'll explain. So my levels cost hundreds and hundreds of dollars for the whole kit. Hundreds upon hundreds. What he's telling me is I could have just bought a level from the dollar store that's only 3 inches long, and I would have been good for the rest of my life, no matter what I'm building. Do you see how absurd that is?
I should have done that. Could have saved some money.
That's why they have the different types of theodolites and total stations that are being used that have different ranges that they're effective as. But most of these guys that come into this discussion don't really know that. They just He's repeating. I think it's McToon's argument. I don't know who's actually championing the argument, but I think it's McToon.
Now, there's another factor of this called the sight picture. You have to know how the theodolite acquires the sighting, the target, like how it locks into, this is my initial target, and then it rotates on an axis to the next target, and then assumes that the rotation amount between those two targets is the degrees. Okay? Now, if there's any discrepancies at range, those degrees that the machine is telling you are not going to be the actual degrees, especially if you're assuming they're off a level plane or a horizontal plane that's teeter-tottering on a giant ball. Like, the fact that he doesn't get why these questions are relevant is just, it's mind-boggling. It's like he forgot to do his own thinking or something.
Hey, following a script, that's why.
It's a bit scripted, yep.
Let me ask you this question. If you put listen, if I give you my weapon and you put the reticle onto the target, are you going to hit the target?
What's the distance?
No. It's a very simple question. If I give you my weapon right now that has a scope on it, and you put the reticle on the target, will you hit the target?
Not necessarily.
Yes, or another good answer would be, I don't know. Both would be legitimate answers.
Okay.
Because there's so many factors involved. So, for example,
correct.
What is my sight picture? I'm taller than you. My eye to my cheek is different. Did you maintain a good sight picture? Is the weapon even zeroed? Etc., 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 etc.
Contributing factors, yeah. Was the gun clean? Because, from where the bullet comes out of the chamber, I think that could cause it to spin differently when it's coming out. I don't know. There's many different things that could happen. But you being a weapons expert, I mean, you probably know that.
Right, so the optical device axis would have to be absolutely perfectly parallel to the plane that they're leveling. So if you have a level that's on the theodolite, right? Let's say it's one that has 3 bubble levels, right? And so you have to keep wiggling the thing till it's leveled. Guess what that's relying on? What is that level relying on? Do you know? What's the arbitrational factor of whether that level will be accurate if there's 3 bubble levels that you can see and you have to then level the device? What would be it would be your eyeballs, wouldn't it? Your ability to decide when that bubble is in the middle of the 2 black lines. Good luck with that.
Yep.
Now, maybe you have one that's auto-leveling. Okay, then you have the calibration errors of the auto-leveling plane versus the optical axis plane, and how those two are congruent with each other to how far they're making an accurate reading, which would be in what? The manufacturer's specs for the range of the device. So the idea that, hey, bro, how far was the observation? Was the piece of equipment able to make an accurate reading at that distance? In order for you to say that this thing proves anything, the correct answer to that can only be yes. It is able to make an accurate reading at that distance. And then you demonstrate how. I mean, sometimes the manufacturer is saying, hey, this theodolite is designed to get accurate readings at 10 miles for these reasons. You'd be like, here's some evidence that this device might be able to accomplish that. Because it's a claim by the manufacturer that it's accurate to 10 miles. At least that's something, instead of just dismissing it like your question was irrelevant.
Yeah.
So he's basically saying, oh, theodolites work forever. They never are inaccurate. They just keep going and going and going. It's like you could just buy the cheapest theodolite. Yeah, so instead of buying a $10,000 theodolite, just buy a $10 theodolite. They're all the same.
Yep.
Hey, dude, don't even get a theodolite. Don't even get a theodolite. Just go to Home Depot, buy the budget 8-inch bubble level, tape 2 toothpicks that you put together with super glue on the end as your crosshair, and then just guess what the angle is.
Who was that guy? I haven't heard him around here before. Was he new to the VC?
Don't know.
Yeah, you pretty much had him on the ropes there, Radwin.
Yeah, he's a piece of cake.
I just thought I'd scoop in on some of that light work. He was already struggling with your.
That's fine. I'm working anyway. I don't mind listening to. I just have to laugh at people sometimes, and I really have to just say. I had to go back to say, listen, dude. Now you're saying you can't get an angle if I put a basketball on a table, because he was.
Yeah. I really like that point because he was struggling at that point. He didn't know which way to go. But I already knew that he had something in mind. He had a straw man idea of what flat Earth is, and I kind of coaxed it out of him because that's exactly what I was like. Yeah, I think I know where this guy's going. I just want him to say it because I can't have confirmation unless he's able to tell me exactly what it is, and then I'll be able to say, okay, now I know it's a straw man. Because he went with Gleason's.
Why assume that the North Pole? Let's just assume the North Pole is a point that exists on the ground, and that there are radials that come out from it that you could draw on a piece of paper. So you look at that just on a piece of paper. Now, technically, if you don't know the overall territory of the Earth, you could place that dot anywhere on the Earth, right?
Yeah.
And I don't mean anywhere on the known continents. I mean anywhere on the Earth. So if it's the case, let's just say that the North Pole is in the Arctic perimeter, above Nova Scotia, above Canada, whatever. It's always going to be above Canada. It's like not going to be in the middle of Canada. But how do you know that what's above Canada is the center of the Earth? Well, the only way you even assume that is because you say, oh, well, that's where the North Pole is, because that's where our coordinate reference system is pointing to, because that's where there's sky phenomena that we used as the base for our coordinate reference system. And there's also maybe a magnetic system that is similar. So basically all of you said is, this is the center of the synergy of the magnetic system and the sky map system. Not that it's the center of the Earth.
Yeah. Good point. A good point. That often is not being brought up, but that should be. Yeah, it's a good point. It's ways to think about the argument, like the way you just constructed it, is another reason why I think being let loose from certain argument constraints have given us the ability to like deconstruct the opposition the way that we have. In my opinion, I mean, I've been listening to many people talk about these arguments in the way that you have, and me and Radwin and all the other guys who come forward. And yeah, that's another way to look at it right there, because they're basing it off of, magnetic north and, where the stars are. But then how do they know their geographic position is in reference to like a specific type of map system? Yeah,
a lot of people did that. So they're like, okay, the Earth is flat, but we got the North Pole and we got these splayed out radials from the North Pole. Therefore, the North Pole is the center of the Earth. That doesn't follow.
It doesn't. Yeah, doesn't. A good point, man. Shit. You had a good night's rest at a Holiday Inn or what, bro? Like what the? It's a damn good point. I had to pocket that one.
I had a Red Bull.
Ah, yeah.
I got a joke for you. Why is drinking Red Bulls dangerous for flat earthers?
Shit, I don't know.
Because if he drinks too many, he'll fly so high that he'll see the Earth as a globe.
Oh my god.
Wah, 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 wah.
That's a dad joke, bro. You should slap your thigh when you say that one.
Dude, I got my dad joke shirt, dude. It's got who's that guy? He's got Yogi Bear on it, and it says "Dad jokes. It's how I roll," but I is spelled E-Y-E.
That is so you. That for some reason I don't know why. That's because I've never seen. Have you ever showed a picture? Is that the avatar's not half a picture of you? Is it? I think I've asked you that before. Like maybe in your young military.
I'll let you decide which half. I'll let you decide which half. So I actually listen, dude. Listen, bro. In all seriousness, so dad jokes are actually very important because it creates the synergy between the children and the father with humor, which breaks some of the seriousness of life. You know, like some of these existential angsty questions, and they have this grounding. You know that their dad is kind of just loose and not taking it super serious, and so then they are not afraid. Now, there's fundamental psychological reasons for this. They did this extensive study, and I'll post why in the chat for you so you can see it.
Oh, our boy's back.
Hold on, bro. I'll post why in the chat. Don't worry. Here it is. Look it up. Look right there, bro. There's why.
I'll post why. Oh God, another thigh slapper. I got 1 million of them. You better watch out, man. You're gonna roll off that roof.
McFinglin made it back.
McFinglin.
Hello. How's it going, guys?
You want to pick up
a little bit better?
Off?
Yeah, now we can hear him clear as day.
There we go. Fucking NASA, right?
I'm not sure how far you think you can see on a clear day anyway.
Ooh. Right in the gut. All right, so going back to what you were just talking about, you can pick up where you left off. AI was actually asking you a question, not unless you want to go ahead and finish. I think you were going on the third explanation of how the autolites work. I think that's what it was.
Yeah, whatever. I don't care. We can pick up wherever.
Yeah, well, I mean, we have to.
Sure.
I mean, the base question is really boiled down to this. Should I return all my levels to Home Depot and Lowe's and Menards and whatever other place I bought them from and just go to the dollar store and buy a 1-inch cube level? Because I can level all buildings, all sites, and no matter the size of the foundation, I can just do it with a 1-inch level. I don't need my bigger levels at all. Should I do that?
No, the margin of error on a 1-inch level is terrible.
Okay.
Oh, so for longer ranges, you need more accurate devices. I rest my case.
I'm going to leave the room
now. The theodolite is that purpose-built instrument.
Really?
Yeah.
All right.
Do you disagree that surveyors use it to accurately?
No, I mean, further solidifying the point that I was bringing up to you earlier, which is why it's important to know what they were using. It wasn't an unfair question. It was legitimate, and you just went all over the place because you heard me actually questioning what they were using.
And you said you can't get that from a ball, so you said the Earth has to be flat. I said if you put a ball on a table, remember? You were like, no, that's incoherent. So you can't put a theodolite on an incoherent surface and start shooting angles off of it. There you go.
Well, I mean, you can put a theodolite in a valley surrounded by mountains. Obviously, it's not using the horizon to determine what the horizon is. It's using.
I didn't say use the horizon.
Downward.
I didn't say use the horizon.
You're saying horizontal plane? Is that the correct term that you use?
No, when I set a basketball on a table, I set my basketball on a horizontal plane. So that became my theodolite. Now that I set the basketball in my hand and I'm balancing the table on it, now that's my theodolite balancing on the ball. And you said you can't make angles that way.
Well, I mean, you're making.
But now you can't. No, you said it was incoherent, but now it's not incoherent.
Well, a theodolite isn't measuring the contact point between a circle and a straight line. I don't even get what you're trying to demonstrate with this.
You're right, because the Earth is flat. It's between two straight lines.
So if the Earth was curved, if it was a giant sphere,
it's not.
What would you think? Yeah, sure. I understand you think that. What would be the best way of doing an experiment that would demonstrate the difference between the two measurements that you would get?
We would see curved Earth dropping at 1 mile, 2 miles, 10 miles. We would see that drop, especially over the ocean.
Yeah, and you don't think that like objects being hidden, like the Chicago skyline being hidden.
Oh, that's 52
what seems
miles.
Like flat water.
52 or 58 miles. Yeah, that's not that's not an illusion just flying up in the sky. No, you're seeing it.
Well, yeah, but you can't see the bottom of the buildings. Why can't you see the bottom of the buildings?
Because of your angular resolution, so close to the ground. Waves are in the way.
What?
Waves are in the way. Yeah, all that shit's in the way. Heat waves are in the way. Yes, dude, it's just getting distorted right there. That's all. That's why you don't see your buddy waving to you. It's just too small at that distance.
Well, obviously, angular resolution isn't an issue because you can see the building.
Okay, somebody posted it for you.
But
yeah, so tell me what the guy looks like in the window in that building. What is he waving with one finger? Is he giving you the middle finger, or is he holding up a peace sign in that window from the 52-mile away skyline?
I can't look at.
Or are those buildings just floating in the sky?
I would like to be able to finish my thought. I can't look at it because I'm driving, but if you can clearly, it's not an angular resolution issue because you can see the building.
1,800 feet of curvature should be hiding the tallest building completely.
Do you have Tourette's? Like I was trying to finish like 2 or 3 sentences. I don't want to be like dogging on you if you got a medical condition, but it is very rude.
I have the I'm always right condition.
Okay, so it's not a medical issue, it's just a manners thing.
1,800 feet. Where's it at? The only other choices are floating in the sky, or the Earth is flat, one or the other. Floating in the sky or the Earth is flat. That's why you see them. How come? You brought up the skyline, not me. Wah, 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 wah.
Is that it? You gave up? Earth's flat?
Yeah. He said it's incoherent to get the angle between a ball and a horizontal plane.
Bro. It still hasn't explained how a theodolite gets an angle.
Singleton, how does a theodolite get an angle? I hope he crashed.
He's mad at me.
And you can describe that goes to one direction, and the further it goes in the direction as the angle separations. How do you know what the angle separations? Right, so you got the axis, which is rotation.
I think you're
Canadians, what can you do?
Yes, I am Canadian.
Sorry, guys, I had a work.
How does a theodolite measure?
Do we want to keep talking about?
Yeah, how does it measure an angle?
Yeah, from the downward, from the vertical.
But where's the 90?
How does it measure an angle? It measures it from the downward. The 90 is 90 from the downward. Do you think it measures something else?
Holy crap, dude. You're really struggling with this, aren't you?
Well, I'm struggling to understand what you think it is measuring from. What is it? If it's not the vertical vector that it's measuring
I asked you a question. I said, how does it measure an angle?
What was my answer?
So you said it measures an angle. You said it measures an angle from the downward vector. So notice how you said it measures an angle from, then you explained from, but you didn't explain the it measures an angle, which is the angle measuring part.
Oh, like the mechanics that it uses to measure angles?
Oh my goodness, dude. Dude,
is that what
I have a theodolite. I have a theodolite. I set it up. I want to get an angle of something. How do I do it?
Sure, you set it up, make sure that it's properly leveled, pointing directly down, and then it'll measure up from that downward.
Holy shit. Do you guys see where he's going wrong? Does anybody else see it?
Can you tell me what it is measuring from?
Dude, you are repeating the same thing. Listen, friend, you're repeating the exact same thing over and over. When I parse it out for you, that's not what I'm asking for. And indicating to you, you probably shouldn't repeat the same thing. And then I'm focusing on the measure of an angle part. You still go back to where it's measuring from, not the actual conclusion of measuring an angle at all.
Sure. So are you asking me how it's measuring an angle? Like the mechanism?
Real quick. No, real quick, dude, real quick. You're the equivalent of a guy on a job site where I say, go measure the angle to the roof from the floor. You come back and say, I measured an angle from the floor. And I say, okay, what's the angle? And you're like, I measured from the floor. And then I say, yeah, but what's the angle? And then you say, I measured from the floor. And then you get fired.
No, I'd give you a number of degrees. So that's
okay. Okay. So you go and you go to measure from the floor. Then what happens? Because you can't get that measurement of degrees without other steps happening first, right?
Yeah, you get the downward vector, and then you measure up from the downward vector.
So, to what? To what?
ball in this case? Basketball?
Right, and how do you know you're measuring to anything? You have to see it in the sight picture of the scope, correct?
Yeah.
Right, so you have some kind of reticle that you assume the optical axis of that scope is horizontal, parallel with the surface of the Earth, or parallel with a tangent plane you imagine is teetering on a giant ball. And then from that axis, you assume that that is horizontal, or a baseline of 0, right? And then the instrument rotates as you're attempting, hold on, the instrument rotates as you're attempting to then put the reticle onto another object, right? Or a object as a target object. The amount of rotation is measured in degrees. And so you say, okay, the object is now in the center of my reticle, and the device has moved this many degrees. And so I'm going to say it moved 27 degrees because that's what the reading is. Wow, that was so hard, dude.
Yeah, it's measuring angles. I don't. How does that instantiate? Like, can you explain the first part of what you said? Because yeah, you set it up, and then you immediately said it measures from like a horizontal plane. That horizontal plane is established from the vertical. Do you disagree with that statement?
No, I said you assume it. I said you assume it. You could actually assume anything, but if you're
vertical.
Oh, I'll tell you why you have to assume it, because you didn't perfectly level the device, so you're assuming that it's horizontal.
You think you can perfectly level anything? Think you can perfectly do anything at all? It's all
no. That's why you. No, duh. But you're telling us that theodolites work indefinitely at all ranges.
They all have a margin of error. Like, are you denying that they have a margin of error, whether the thing's close or far?
Dude, it's not
the
just
margin of error is degrees.
Effective range. There's a maximum effective range, dude, for theodolites. You didn't know that?
No, there's not. It's measuring degrees, so the margin of error is in degrees.
Never mind.
Do you disagree with that? We're talking about like arc seconds. It's gonna I think it is like an arc second, or really good theodolites can measure within 1 arc second. Or are you saying that if the object is further away,
so
that arc second?
Right. So tell us the evidence. Tell us the evidence that you were asked, which is the device used in the measurement you presented as your evidence for the reciprocal zenith angles. Was that device capable of being accurate at that distance, or was it beyond its maximum effective range?
No, it's accurate at that distance because the angle that it's measuring was like 3-something degrees. It's been a little while since I read it, but it's multiple degrees second.
You think it's 3 degrees?
Or the margin. I can't remember what exactly it is. So let's just say it's 1 degree.
Dude, there's supposedly only 3 degrees of drop in the horizon when you're in the stratosphere.
Okay, that's fine. I'm saying if it's measuring like a degree or a minute and its margin of error is a second of angle, then it's within its margin of error. Are you saying that it's that 1 second margin of error actually grows to minutes or even full degrees when it's miles out? Is that your position?
Bro, I can't hear you anymore. I'm using power tools. I'm using power tools now, so someone else will have to answer that for you.
Okay. Was nice talking to you.
You're the one who brought up the Chicago skyline, 52 miles away, and 1,800 feet of curve is not there, and you never gave us a reason why.
Oh, I mean, there is curve there because you can clearly not see the bottom of the buildings. It's not an angular resolution issue because you can see the top of the building.
The building should be covered all building, not the bottom. All buildings should be covered.
Yeah, but what's if in that particular, in one of the most all of the photos, they're on top of dunes that are several hundred feet high, like 300-400 feet high. So there's no way that a wave is blocking stories of building. It's mathematically, it doesn't make any sense. The fact that any of it's blocked on a flat Earth, I'm unaware of any mechanism that explains that.
Oh, here, yeah. So you can use your refraction for that. I'll show you what it looks like since you don't understand. You've never seen it. You've never seen this happening before in your life. So, but
yeah, I'd love to see a demonstration.
That explains it. That explains it. See how that.
Brad, when I put it in chat for you. Oh, you got it too.
Yeah, so
I'll be able to
that's
look at
happening.
It in a couple minutes.
In a couple of minutes, fine. That's happening when he snapshotted that one picture.
But you're saying you have a demonstration of a flat surface obstructing the line of sight between two taller points.
Yeah, look in the chat. I know you say you can't, but you need to.
I am driving, so this is very risky.
Well, then you should probably pull over because it's pretty important at this point.
The laser thing?
Both things. The Skunk Bay, the laser. I've got more.
Skunk Bay is good because all you do is blink your eyes and pick one of those spots, and that's what that is when you take a photograph of Chicago across the lake like that. That's a snapshot. And it could be any of those that you see in that time lapse happening to those buildings. It's still flat.
I'm not sure how this demonstrates that a flat, because both of these are talking about in-field measurements. Was anybody able to confirm that the floor of that surface where the laser is actually flat? And it's much better to not use a laser.
Dude, it's like you don't even understand. You were talking about earlier. With Indio upward refraction, which would be called looming. And it's like you're forgetting the opposite of that, which would be called sinking, right? Something that would normally be visible, right, above the horizon apparently sinks beneath it. It's like you forgot about the opposite effect when you have an inverted temperature gradient.
Yeah, I mean, I know that that's
demonstrating here.
That it's downward refraction, that it's upward refraction?
Well, it's not called upward refraction.
Yes, it is. The opposite of downward is upward.
It really isn't. No, it's literally not called that. It's called sinking or looming, which are versions of mirages, right? Inferior and superior mirages, but lesser versions
where the sky is reflected on the ground.
No, dude, right? That would be total internal reflection, which is one of the properties of an inferior or superior mirage, not looming or sinking. Okay, so you're forgetting about sinking. Like, you want me to read you out some citations? Okay.
No, not really.
Not really.
I mean, I understand the concept of downward refraction and upward refraction. You're saying there's a third type of refraction?
No, I didn't say that, right? They're all under the category of deviating light, right? Due to temperature, mostly due to temperature, right? Which will change the refractive index. It's like you haven't really researched this. Really. You haven't really researched this at all. Like, it's like you've listened to some MC Toon videos or something like that, and that's your whole understanding of what refraction is, and you completely butchered it, the entire conversation with Indio earlier, and you're doing it again now.
McFindle, how do you distinguish the refracted surface from the real surface?
You'd measure the atmospheric conditions of the places.
Okay, if you see the real physical water, can you say, I see the physical water, or you will say that's maybe some atmospheric conditions?
I mean, you see the photons, right? So
no, I'm speaking about the ocean. If you see the ocean in a distance, you will say, I see the ocean, or you will say, I see some kind of phenomena happening that's not ocean.
If I'm standing on the beach and I can see the ocean, I'll say I see the ocean. I'm not understanding your question,
okay.
David.
We have observation. It's called black swan. You see the ocean behind the oil rigs. That means no refraction required, there is an ocean.
What? Refraction doesn't require an ocean.
Yeah, there is the physical water behind the oil. That means ocean. There is no light doing anything. You see the surface of the earth.
What?
Anyway, the buildings that we were talking about in the first place, we see them. That's not an illusion. So how do you explain that? Because you said it doesn't make sense. So since it doesn't make sense, how do you explain it?
I mean, obviously, you went out and measured the atmospheric conditions because we all agree that refraction's a thing, right?
Yeah, it has nothing to do with the surface.
Yeah, so it can make it look like the things. Hold on a second, dude. 1 second. Hold on a second, Sasha. 1 second, dude.
Sorry.
1 second, sorry. Look, so it can make it look like things are sinking behind the horizon, right?
That's your claim, sure.
No, that's the claim by the mainstream. I'm just parroting the mainstream right now.
No.
Okay, so let's go. So Andrew Thomas Young, right? Optics of the Atmosphere, Reports in Progress in Physics. Okay, page 307 and 377. Atmospheric refraction can bend light rays such that distant objects are displaced vertically, causing parts of these objects to drop below the apparent horizon or become partially obstructed, even though the line of sight is geometrically unobstructed. Right, I can give you citations and I could go on for days with citations because I got them all right here. So would
you mind sending that to me?
Yeah, I'll pop some in the side chat.
Yeah, I appreciate it. So if I look up your citation and it says the Earth is a globe, would you agree with your citation anymore?
No, because what I was talking about here has nothing to do with a globe, right? This can happen on a small scale or a large scale, on a flat surface or on a bumpy surface. It doesn't really make a difference. It's the mechanism that's at play here. It's got nothing to do with a globe Earth.
Yeah, but if those conditions aren't found in typical atmospheric conditions on the Earth...
They are, though.
They are.
He just said that, and we have countless observations of this happening that actually fit the definition of sinking, which is a type of miraging effect that's common when you have a layer of warm air closer to the surface, and then it gets cooler as you go upward. Okay, the opposite of looming, which you call upward refraction, which is like newspeak or something like that, I'm guessing.
What?
But yeah.
Upward refraction makes things that are high up appear lower. Downward refraction makes things lower appear higher.
No, look, dude, I can post you the actual citations of what these things are really called from the American Meteorological Society. Okay, it's called sinking, looming, which are forms of inferior and superior mirages. Right? They're not called upward refraction or downward refraction. You're not going to be able to find me citations that say those words. Right? But that's kind of what's going on.
Let me ask you this, McMillan.
I do find citations that say exactly that.
Ask you,
do you agree
McMillan.
with me?
No,
sure.
It's called a hostile witness. So let me ask you this, McMillan. Do you understand what sinking is? It has nothing to do with things in the sky. It's things that are literally level with you, and they appear to be sunk into the ground or behind the curve.
What if they're slightly above or below you?
What if there's these are things we're looking at level to a flat surface? I don't understand what you don't understand about that.
Yeah, like if you're in a valley and you see sinking refraction, is that object going to appear higher than it actually is or lower than it actually is?
We're not looking in a valley.
Correct?
We're not looking in a valley.
I know hypotheticals are hard. I'm just asking you to engage.
I know you want to stay in imaginary land. That's the whole point of this whole thing for you is we need to imagine everything, right? We can't go out and do a real world observation.
No, I'm saying imagine the consequences of the thing, make sure that you understand it well, then go out in the real world and actually confirm whether your idea is correct.
We've done that, and this is mainstream. I'm just parroting mainstream stuff right now. So sinking obviously is when something appears to be sinking. Okay, and then looming would be the opposite of that, where it appears to be looming.
Yeah, upward and downward refraction. Yep.
Yeah, it's called sinking or looming, dude.
I mean, you can use whatever words you want. That's fine.
But that's the actual terminology that's used in the mainstream.
But we have example where refraction does not do any.
I'm not a scientist or something, so I don't particularly care.
But yeah, we have observation showing that a refraction, whatever light is doing, does not influence the surface in any case.
It affects how you see the surface.
That thing's what is real. Do you understand me? There is no phenomena. You see what it is.
Yeah, like I can see upward refraction where the sky is apparently.
No, man. If you see the water in a distance, man. Simple question. If you see the ocean in a distance, can you say I see the ocean, or you're saying like this? I see something what is similar to ocean, but it looks because of the sun or the light. It looks that it's ocean.
I would say I see the ocean, because that's a very silly way of talking.
Yeah, that means there is no refraction. You see the ocean, everything is fine. You have that observation, and you say, "I see the ocean."
That doesn't imply. We all agree that there is refraction, so I don't know why you would.
Man, but what if you see the surface of the earth? That means water in a distance. Why are you invoking any word?
Because we know that refraction happens. Like the video that you guys are posting literally show like the horizon moving up and down.
Okay, let's put it like this. You and me never was in the school. We don't know what that word means. We are on the beach, and I'm showing you on 10 miles. Look, there is the ocean. And you're saying, yeah, I see the ocean. Now, it's coming some person and saying, but you didn't account on refraction. And I say, for what?
Yeah, that would be silly.
Yeah.
Why would somebody say that when you're not trying to measure anything?
No, man, you are seeing the ocean, the water in a distance.
Yeah.
And
yeah, the purpose of you looking at the ocean is because you want to look at the ocean. You're not trying to measure anything.
Yeah, but look at the devil.
Fractions only helpful when you're measuring stuff.
Yeah, but you have some marked distances. Like in this case, oil rigs for the Black Swan. That means the platforms are in the water, and behind them you see that water. What is real?
I mean, clearly, you should play the invincible ignorance song.
Man, there is a real water. There is no light doing anything. You see that what you see, that what is real, that is surface.
Well, I mean, you see photons, and photons are real.
No, man, you see the ocean, the platform. Man, the platforms are taking the oil from the sea behind 10 meters behind that platform. It's an ocean, and you see that.
It's like if you had a blue ball in front of you, and I feel like what you're doing is saying you see the ball. I'm saying yeah, but you also see blue, and you're saying no, I just see a ball. It's like. You can see both ththings simultaneously. One doesn't preclude the other.
In this case,
you can see the observable effects of refraction in the ocean.
Because of that, I'm asking you: is that water real water, physical water, or that is something light is doing that you only perceiving it like a water?
I mean, technically, you're only seeing photons, but the photons accurately represent water, just not their position.
Hey, Sasha,
Jesus Christ. Okay, I'm done.
So back to your whole theodolite thing, right? You're on a hill, you're doing a theodolite measurement, you look out over the hill, you've leveled your theodolite, you're looking out over the hill, you're doing this Jesse path of light observation, and the hill that's across from you that should be level with you or higher to you, it appears lower to you. Yeah,
sure.
That's sinking. That's downward or upward refraction. That the path of light deflects upward, sinking the thing off into the distance downward. Yeah, let's go with that.
Sure. Do you know how common that kind of refraction is?
Very common
on the in fairly stable conditions at high altitude.
All you need is a temperature conversion. happens all the time in valleys.
/ pressure inversion, but you're saying on top of a mountain.
It happens all the time in valleys.
They're normally pretty well moderated in temperature. They're not getting a ton of direct sunlight.
Look at the temperature inversion.
Yeah, I know what temperature. You can see it on a hot day when the surface of the pavement is miraging the sun or miraging the sky on the ground.
Most descriptions of temperature inversion happens in between mountains.
Between mountains, not high up
between mountains.
There's not a lot of
right. There's valleys, and what happens is cold air gets trapped under warm air in valleys, and you get your temperature inversions. It creates a lensing effect.
Well, if it's down in the valley, how's that cold air gonna get up to the path of the light reflecting from the mountain that's opposite you?
It doesn't have to be deep down in the valley, bro. It could be sitting right at up to the high level of the valley, kind of like how water sits over the top of a cup and bulges a little bit. Your temperature inversion can do the same thing, bro. Well, Look up temperature inversion. You know nothing about this, and you're arguing against it.
No, I'm saying I do know about this. That if you're on mountain peaks, generally they're a lot higher than the valleys or even the ridge lines between them. So, I don't know why you would think that the temperature differential in a valley would hold up all the way up to the peak and actually interrupt the line of sight between you and that other valley. It's generally those are pretty good conditions for sighting between long distances because there is a large pressure and temperature differential between the two locations.
Right, but that's what happens, right?
That there's a large temperature and pressure differential between the two locations?
Yeah.
No. It's normally not a large pressure and temperature differential between the two locations because there's active airflow at such high altitudes.
Did you measure the airflow between the two mountains? Yeah.
People have done it. Yeah.
Did you?
Did I? Do I have to do everything personally?
Well, I mean, if you're making that observation, right, you're the one making the claim that all these things are going on, and then you hold us to that kind of scrutiny, right? You sit there and say,
"I don't think
you need to measure every inch of air from between you and the object 10 miles away. We need to know the temperature variance all the way across."
No, I'm saying if you want to disprove the idea, then you'd have to do the same rigorous testing that people who have proved it.
They didn't prove it, bro. They didn't do the measurements. They're not accounting for everything.
Well, you say they don't, but when we do these and we make predictions, those predictions come true.
I mean, all it takes is a little bit of refraction, bro. You're asking for a lot of refraction. You're asking all it takes is like a small angle, 1.33 degrees, and that angle over a large distance will push things off in the distance further down.
I mean, I agree that things further in the distance are angled further down, but I don't see how you could instantiate that happens consistently between mountain peaks or high altitude observations.
I'm not saying it happens consistently. I'm saying temperature inversions happen most frequently in between mountains, down in valleys. In between those mountains.
If you believe in a globe, did you know that you believe that you move faster at night than during the day? Did you know that?
Did you know that if you lived on the equator of a globe, that during the nighttime you'd be spinning into the direction of Earth's orbit during the night, and then during the day you'd be slowing down away from Earth's orbit, and there would be 1,000-mile-per-hour difference, constantly cycling and gyrating. Isn't that crazy?
Are you talking to me or to everyone?
I'm addressing the whole room.
Okay.
Yeah, if you believe you live on a globe, you think you're not just moving and you're not just accelerating, but you're constantly accelerating and decelerating over a 24-hour period, getting yanked around and around and around and around. Nobody has ever measured that motion. Nobody.
Damn Grant's trying to throw me to the east.
I know.
I want to.
Did you know that if you thought you lived on a globe, that when you look towards the east at nighttime, that you're looking in the opposite direction of somebody looking east during the daytime? Kind of makes it hard to pray to Mecca, don't you think?
Just goes to show that for that reason, there's no standard cardinal directions on the globe. There can't be, because it's always moving. And also, that problem of the accelerating and decelerating gets more complex as you go through the different vectors. Like if you're talking about an elliptical orbit, that's even compounded even more as far as the acceleration, deceleration. So you would have to add that to the rotation, and then you have to add all of that motion to the motion of the sun going around the great attractor.
Galactic
so
orbit.
That's really, really complex, yeah.
With all that Coriolis going on.
Let's see them adjust for that with their conservation of energy. How do they account for that?
Yeah, do airplanes account for intergalactic Coriolis?
Yeah, exactly. Oh, they don't have to? Because just like the curvature, it's minimal, or it's what do they call that? Negligible.
Yeah, so negligible as if it's not there.
Yeah. So the negligible part of the globe brings it right back to how we actually experience the Earth: flat, stationary, and contained. Thank you very much. So yeah. So why would we use anything else besides what it actually exists as? We don't have to make up these silly stories that the Earth is doing all these crazy things that cannot be measured, have never been measured, and isn't experienced by anybody. Yeah. So the globe's got a real problem. They basically have reverted to like psychopathy, because they've backed away completely from the geometric horizon. And we've even had Globers come in here fairly recently. I haven't been on that much, but fairly recently they say, oh, there is no drop over distance on a sphere. Really? So where do they come up with this shit, man?
Cognitive dissonance.
Yeah, because they have to back off. They have to back off from the geometry because they have no legs to stand on. when we start talking about geometry.
That's right. I'd like to see drag races going from east to the west to compare their times from going west to the east.
Yeah, exactly. And yeah, why wouldn't there be a difference in that travel east to west, let alone, let's say, diagonal travel? Like, that would all have to be accounted for with aircraft landing on runways, like taking off from a runway, like the landing gear geometry would all have to be different. Like, how are they accounting for any of that? It's negligible, and and conservation of energy just is a blanket statement to take care of everything that they cannot show to be objective fact by any true measurement. So it's basically just like Dandelion was saying. These people are lost in an absolutely religious delusion with nothing empirical that they can stand on to say, this is how we know. There is none of that how we know for a fact and can be proven, repeated, observable, measurable, repeatable, and falsifiable, which almost every fact or proof that we talk about in this topic as flat earthers, it is most indeed empirical. It can be repeated, it's measurable, observable, and falsifiable. And if it's not, then it doesn't belong here. So stick that up your equation and smoke it. The equation.
Y'all got to try this one day. Earlier today, I was talking to somebody. Well, India was talking to him. I got to butt in for a second. And I was literally trying to get this guy to answer. Said, how far away is the horizon? What do you mean? That doesn't matter. I'm like, oh, okay. So I'm like, so when the sun's moving across the sky, and I was like, steel man the globe, right? So when the sun's moving across the sky, that means the Earth is spinning. And so when the Earth is facing the sun, that's daytime. And when the Earth is facing away from the sun, that's nighttime. And I was like, is that right? And he goes, I don't know. Let me ask Google.
Very strange indeed.
Because I'm the flat earther, I can't be right.
Yeah, I was thinking, as early as like 4-5 years ago, I was thinking, and I think others of us in this realm were thinking that they wouldn't be able to keep the globe going because, the evidence is just so overwhelming that at some point they'd have to do a new PSYOP, whether it be, getting everybody onto some kind of flat earth model that may or may not be accurate, but at least it would be, keep the white lab coats in charge of determining everyone's reality. But the way things are going now, I don't even think that's going to be necessary. They can just double down. Everybody's just looking to their Google search engine, and their Chat GPT is their new god. Like, as long as they just keep the globe illusion there on the screen, they probably aren't going to have an issue. They can probably keep it going for quite a bit longer. It's just going to be an even scarier. Flat Earth will just become an even scarier discernment test as they just stop even pretending, like you just said. They're not even going to pretend, that they are going to be looking for drop over distance. It's just this whole brain in a jar. I don't have hands. Reality is whatever we determine it is. And you've seen person after person. You mentioned someone earlier. The person who was just talking to Cyclone was like that. We had someone last week who if someone had, Gemsy had a turn of phrase that he couldn't find in Google, so he told him that it didn't exist, it wasn't real, even though it was just a creative expression that he used. They honestly believe that when they're searching something up, yeah, the first Google result, that's reality. Like, it's just getting scary out here. Like, yeah, they won't need to tell the truth about the globe because these people don't even want the truth. They like the comfortable lie and they like it more every day. Seems like it's going in the other direction.
It's even worse than that. Like, have you ever seen the movie Ready Player One? I know some people haven't, but it's an important movie to watch as far as psyops go.
No, I haven't. I think my sons might have seen it. I don't know.
So it's a dystopian future where everybody's wearing VR headsets and they all live in this virtual reality world and play video games all day instead of like going out in the real world and meeting each other and things like that. I was in a group chat. Go ahead, sorry.
Oh, I didn't mean to interrupt. I was going to build off of that, but go ahead.
I was just going to say really quick, and I'll let you build off of that. But so I was talking to a group of people earlier, and they said it's coming down to people making a decision whether or not they like the real world or the internet world. And some people just prefer the internet world over the real world. Like, that's scary.
Right. And augmented reality and virtual reality is going to further immerse people into this delusion. NASA's already been working on some interesting technology where you basically put on these VR goggles, right? And this stuff is going to present you NASA's view of other worlds. So you can go explore Mars. You could see what the rovers are seeing. You can be present virtually on Mars. Isn't that neat? So the two-dimensional projected screen is going to turn into a couple of 2D projected stereoscopic screens and upgrade your immersion into the same fantasy. I mean, can you imagine how many people are going to fall for this crap? Like, hey, I want to go see what's happening on the ISS. Let me put on my Facebook VR goggles.
What are you talking about? There's already flat earthers that fell for it. And what I mean by that is not necessarily that they're going to go along with NASA cosmology, but they're going to go along with a cosmology that they can't access, that somebody tells them is real, beyond the reach of where we can go into the sky, and they're going to live their life as if it's real, simulating the world that they live in their own minds, just like they were doing when they were Globers. Like, for example, stories about celestial entities, which may be angels or demons, floating above us, doing this or that, having certain ways of transporting themselves, having certain lands that they inhabit that are floating above us, all these things that nobody can validate. But of course, they're going to have dreams and visions and use obscure scripture passages to make their claims, and a whole masses of people will believe them. That's not will, that is already happened. As a matter of fact, I would say the majority of flat Earth videos that I've seen outside of our venue, I would give it a 90 to 95% certainty that the majority of those flat Earthers believe in a cosmology that some other flat Earther told them that neither of them have any way to validate. Yet they think it's the truth. And they preach it as if it's the truth. So how are they any different than Globers, really, truly, when you think about it? A territory in an area and a function on the most base unit of reality I'm making claims about. I can't prove any of it, but I'm going to tell somebody else. They're going to believe me because I'm a charismatic speaker, right? And then they're going to live in a world that's a simulated reality based on the not necessarily lies I told them, but on my mistakes and misinterpretations I told them, as if I knew they were true. Like, how is that any different than the Glover syndrome? Isn't it the exact same phenomenon? I mean, correct me if I'm wrong. I could be wrong. That's a possibility.
No, I think it's the same. Yeah, I think it's right. No, I agree.
Yeah.
I'm just agreeing. Yeah, it's outsourcing, to someone else who's going to tell you things are this way and not accepting the basic truth that we are not going to know all things or know all things on that level, and that we can't, and accepting ourselves as having that limited knowledge, which is really the only way to fully embrace the reality that you're living now.
Yeah, a lot of people just got to resign themselves to understanding that they don't know about the extent of the cosmos, and they may never know, and they have to just make peace with that.
So, harm reduction. Which one of these two cosmologies would you least prefer to be taught to your kids in school? It's a tough choice.
I would like them all to be taught.
Well, I mean, you know what I mean, presented as though it was absolute truth.
Well, see, a lot of the globe claims in their quote unquote cosmological and cosmogenical models are just claims. And if they just had a primer before them, hey, this is claims that people made about the nature of the world, and this is how you can model it. Same like some of the guys that were instrumental in the formation of some of these ideas back in the past. In the books that were written about them, in the writings, they themselves said, hey, we're making models. But the underlying truth of the model can't be known because we can't access what we're modeling. So all we can do is do interpretive models. Mine could be accurate, the other person's could be accurate to the appearance of the celestials at particular times of day. However, that not need be the underlying truth of my model be actually reality. Right? So they were humble enough to know that they're not actually telling people what reality actually is. And fast forward to today, and people lost that humbleness. One day you're attacking Glovers for affirming the consequent logic, and specious reasoning, all kinds of appeals to things they can't possibly prove. And then the next day, a flat earther comes along and tells you that, there's an ether vortex that's coming out of God's butt. And then you just believe it. And you think I'm joking with what I just said, but no, I'm not. I was being a little facetious that it's actually coming out of his butt. They just say it's coming out of him, from whatever orifice it's extruding from. Pick one. So a year ago, the person had an entirely critical mind towards worldviews that they're being imposed on by society or the mainstream or whatever you want to call it. And then a year later, they're just lapping up whatever some dumb flat earther tells them. And then you know what? Some of them have the audacity to say, "Oh, well, I trust him. He's a good guy. He's a good flat earther. He's very prominent, has a lot of good arguments. Why would he lie?" The irony. The irony. Yeah, so don't think because you transition from globe to flat that you've reached the pinnacle of critical thinking. You're still on a journey, my friend. All of you listening to the sound of my voice. The battle isn't over yet.
I think you're right. Mostly outside of our group, I think you'll find a lot more cog dissonance than you do with the mainstream cosmology thinkers. People like MC Toon are doing a service going after them.
Yeah, like you were talking just a little while ago about these Glovers receding into the brain in a jar. You know, who knows what's going on? I could be living in a simulation. But see, the problem is they don't go far enough. See, true simulationists understand that you don't need the jar and you don't need the brain. It's not I'm a brain in a jar, quote unquote. It's I'm a mind, right? So that shows me that they're still unintelligent enough to understand the real ramification of their claims, right? And that leads into a philosophy known as idealism, which is essentially all is mind. And the matter, temporal, and energy states that we perceive are, for lack of a better term, quote unquote, constructs, and for a worser term, illusions, which is kind of, silly because illusions are something the mind experiences, right? So if it's the case that the base construct of reality is mind, then that means that mind has to be preordinate to matter, which means that once they realize that, they're basically conceding that the sentient mind is eternal. Not how they used to believe, which is that dead matter, farted out of the Big Bang, and then eventually rocks decided to, get busy and make baby rocks. And then those baby rocks fought and died, and some baby rocks mutated into, Michelle Thaler millions of years later. Like, that's what they believe. Start dead, end up alive, then end up sentient. But actually, it's the other way around. You start sentient, and then you can create matter and stuff. So they're going to be forced to believe that in the end, because that's where all the evidence is leading. But in that worldview, then they can make some kind of weird construct where, the base laws of reality are somehow not permanent in any way. So then a simulation could be operating on a multifaceted instance where every user has their own instance. Plus, there's a hub world which, decides how the instances are displayed at any given time that you are located in the game world. Much like a video game where, you can use mods in your game and the other player isn't using mods in their game. So you're both occupying the same world, but it displays itself entirely different to each of you. So they can retreat into that ad infinitum, just keep kicking the can down the road into new levels of simulation. Just completely deny any kind of base reality. And then you end up with this. It's, well, if sentience is the eternal source of the physical and natural world, which I'm experiencing, and I'm a sentient agent, therefore I am the source of the physical and natural world, which I am experiencing. And therefore, what are you then? If you're the source of it, right, you're creating it. And if you're creating it, you're the creator. What does that make you? Yeah, see how easy that was to self-deify? The oldest trick in the book, right? The creation diluting itself into ascending into the role of creator. Very interesting, isn't it? So why were they hiding the globe? Oh, to hide the creator. That's why they were hiding the globe being a lie and the earth is really flat, because they were trying to hide the creator. You hear that mantra all the time. Well, it turns out in their worldview, yeah, they were hiding the creator themselves.
So they can go down that whole truth route, get the epiphany, and then end up back where they started. Isn't that interesting how that works? They can be played like a fiddle, like a fool, and still end up under the control of the system, even though they think they're free. Because they got their itch. They got their little I'm free itch scratched. So now they can go plug back into the matrix. Rest assured, if you're part of the very few that quote unquote have found the truth, and rather than actually living free and in truth, you just go back to another charismatic set of norms and leadership via somebody else, whatever they believe in, you're back in the matrix. Right? Just like in the movies, what did the architect say? He said, hey guys, guess what? I played you guys like fools. The hero, I designed it to keep you guys in control. The guys who got free and created Zion, I designed that to make you guys think you were free so you could get a chance to exercise freedom for a while before I smash you all into oblivion again. Now, some people think that the people in Zion in the Matrix trilogy actually did get free. But if you pay close attention, nobody ever got out of the Matrix. Nobody. When Neo was jacked out into the quote-unquote real world, why did he have psionic powers over the squids that were coming to kill him? I'll tell you why. Because he was still in the Matrix. That's why. And rest assured, friends, at the sound of my voice, many of you think you're free, but you're still in the Matrix. Many of the people you listen to, you think they're free, but they're still in the Matrix. Part of not being in the Matrix is having the utmost scrutiny for information that comes your way, instead of just allowing it to be spoon-fed to you and taking it on faith. As Reagan said, trust but verify. It's okay if you respect me, or you respect another speaker, or you respect this guy or your friend, that you kind of trust what they say. But they should be freely offering to validate it to you, and you should be freely critiquing and asking for validation, right? If you just join a Flat Earth group and there's like 10 charismatic Flat Earth speakers that you just adopt as your new gurus, and whatever they say is the gospel truth, man, you're just as stupid and retarded as when you were a Glober. I rest my case. Ad infinitum into the future and ex ante into the past, and I yield the floor to any questions. All right, so there's no questions, somebody posted in the chat about the movie The 13th Floor. And what happened in that movie is that a guy was going into a simulation to discover some things that were going on. Then he found out that the simulation he was in a lower simulation, and there was a program in the simulation trying to escape up one level to the real world, but he only made it out of the simulation to the next simulation, which the other guy thought was the real world. And none of them were actually in the real world. Because they got to the end, and when they got to the end, they looked, and all of a sudden, the land just gave way to an unrendered state of vector lines and math. Like this part of the world hadn't been rendered yet. And then they realized, damn, we've been in a simulation thinking we were in the real world, going into a simulation thinking we were coming back to the real world, but the whole time we were in a simulation. We were being played. Very intriguing. If you haven't seen it, definitely watch it. Also, Dark City, that's another must-watch for all Flat Earthers. Matrix, obviously, that's a good one. Existence, yes, good one.
So I have a question for you guys, and it's a genuine question. With the whole Chicago skyline thing, isn't it possibly the case that for an object that is large, so here's the thing, right? For like a light post, I think your argument is valid, like it's cogent. You shouldn't be able to see that object. But if an object is big enough, it'll go over the horizon. Does that kind of make sense? How do you know that's not what's happening with the skyline?
What do you mean by over the horizon?
So, like, okay.
So big enough as in a mountain, you can see the base of it, or tall enough? Which way are you going?
So I'd be like, when you see, when an object starts to disappear over the horizon, it goes bottom up. That's because, well, you don't believe this. That's because the Earth is curving underneath it. What I'm saying is...
That's the claim.
Yeah, that's the claim. Just bear with me. I'm saying, how do you know it's not... So, like, okay, an object disappears over the horizon, right? You're standing still at some observer height, and the object is receding until eventually it can't be seen anymore. Now imagine that object grows by 100 miles, like, of length. You would then be able to see the object.
So it's to do with your angle of resolution, or angular resolution. What is it? 0.02? Once it's below that angle, you'll have trouble resolving it. So if you've got a bigger item, like a mountain, for example, it just means it can get further back until perspective makes it appear small enough to get below that angle of resolution. That's all that's happening. So as things get further away, perspective, they appear to get smaller. So something small, like a tennis ball, for example, wouldn't have to go too far until that angle gets too small and you can't resolve it. Something large like a car, or larger, I should say, like a car or a truck, would go a little bit further. Something very large like a mountain would go a long way further back. Does that make sense?
Yeah, I get that. That is true, but specifically with objects over the horizon, it's more than just angle. It's more than just how far away it is, because if something's over the horizon, there's no amount of magnification that will allow you to see the object. Which is what you're implying.
At least we agree on that simple fact. If something is hiding behind something, it ain't coming back out. So it doesn't matter what you do or what kind of magical lenses you've got. So what you've got... You've got a combination of things happening. So number one is perspective. Things appear to get smaller as they get further away. Another component of this is your elevation in comparison to the object that you're looking at. So say your eye line is 5 foot. I'm just picking a random number. And the item you're looking at is a large container ship. The container ship will appear to shrink uniformly, but where your eye line is, it's only 5 foot up the container ship. So as the ship shrinks from the top down, bottom up, left to the right, right to the left, to converge at your eye line, the bottom will hit your eye line before the top will. And it's an effect called foreshortening. And if you do, probably tech drawing or art classes, you would have a lot more interaction with that. So its appearance is it's shrinking evenly from all sides. But the problem is, because you're so close to the bottom of it, the bottom will hit your eye line before the top or before the sides. That's why it appears to disappear bottom up.
That doesn't make any sense. If it's disappearing bottom up, something's obfuscating it. If the Earth is flat, you should just be able to take a telescope and magnify it.
It's to do with compression. So what happens is, because of your angle of resolution or angular resolution and your ability to resolve that, because the data or information that's below your eye line there's so much of it compressed in such a short space, you can't resolve what it is. So it just blurs into the background. And that's exactly what happens when we watch ships sail away. Because you're so close to the bottom, it's compressing into the water, and you can't differentiate between water and ship because that angle is so narrow, you can't tell what it is. And that's all that's happening. It's really
you actually prove that because I don't agree.
Well, you can agree with whatever you like, but there's some pretty cool pictures in the side chart that AI Overlord 2.0 just chucked up.
Yeah, but you're doing like pictures don't explain a mechanism. You're proposing a mechanism.
Please don't do that on the microphone again.
You don't need a mechanism.
Well, that's what he's giving. He's giving a mechanism. Some kind of compression is happening.
Yeah, but you don't even need to do that. You just need to demonstrate that it occurs in a situation where the alleged claim of something in between point A and B is clearly not occurring. And then if you can demonstrate that, then you've proven that it's not necessarily an obstruction that's causing it.
Yeah, but that's the thing we're trying to prove, right? You want to prove that there's no measured curvature.
No, see, you can't. It's not about measured curvature because you're inferring curvature from a claim that the only reason why I couldn't see something if it was being blocked by an object. So that's your burden to prove.
That's not
the other.
No, I'm not inferring curvature from that. I'm saying that due to the curvature, this is what happens. But curvature is what's in question. That's what we're trying to establish.
Okay, so then you can't. Right. So if you say due to the curvature, this is what happens. Why would you be saying that if you haven't proven it?
Oh, because I mean, I already believe that the Earth is curved. If you don't, then I wouldn't expect you to believe that that's why what you're seeing is happening, right? I would expect for you to question that until curvature is established. That's what I'm saying.
Wait a minute. So you're expecting someone else to question your claim until curvature is established. Shouldn't curvature already be established?
No, that's not what I said. I said I already believe the Earth is curved, so of course I'm going to believe that the reason things disappear
yes, but you're
bottom
trying
up.
to convince us, not yourself.
Yeah, I'm not trying to convince you that things disappear bottom up because of the curvature yet. We have to establish curvature. We're not there yet.
Excellent. So prove curvature, and then we'll talk about the ships disappearing bottom up.
I mean, I've tried to run the Rainy Lake experiment before, but I mean, to be honest, I don't. I actually don't think
pretty junk experiment, if you want to call it that, observation. Look, this is the thing. I lived on the coast my whole life, and in a location where there's it's like a hub for cruise ships. And growing up fishing and surfing at the ocean a lot, we would be sitting there waiting for fish and whatnot, and watching the cruise ships actually sail out into the ocean. Most often, what happens is it just gets smaller and smaller, and it kind of just fades off, right? Because the visibility is not far enough to see the extent of the ship's path. Or if you have really good visibility, the ship will just become too small and you can't resolve it anymore. You can still see the horizon, but you don't see the ship anymore. Now, sometimes you would have waves, okay, like ocean swells. If you have ocean swells, the ship will appear to disappear bottom up, but not if there's not ocean swells generally, right? There are some miraging effects that could happen, but if you have a look at this giant ship in the side chat here, which I'm just uploading now, okay, just think about this one, okay? So he's standing at the shoreline. He's zoomed out completely. You can't see the ship at all. Okay, and when he zooms in, you see the whole ship again. Now, we can see that there's no waves here. If you added ocean swells into this situation, it would look like the bottom of the ship is cut off, because it would be hidden behind the ocean swells, even though the ocean swells, because you're looking over them at a shallow angle, it's going to look kind of flat still with the ocean swells present, but it's going to look like the ship's disappearing bottom up. This is what happens most of the time. So it doesn't always start to disappear bottom up. Now, if it were a globe, it would start to disappear bottom up at a certain distance. So from this height, it would be just 3 miles away, and then it would start to disappear bottom up. Now, we've got tons of observations where we're specifically checking for that geometric horizon distance to see, okay, the object should start to disappear at a certain distance bottom up as it moves away from the object. And it's over and over again confirmed that that doesn't happen. Okay, so we're questioning, how do we know the geometric horizon exists in the first place if there's no evidence of it at all?
Well, because you're not accounting for refraction, that's the issue.
Yeah, but people butcher the word refraction. So even, right, let's just pretend the Earth's a globe. even according to the globe earthers, right, like the subject matter experts in refraction, like Andrew Thomas Young, right, and all of the mainstream explanations, they'll say that there are refraction effects that can happen that would cause something to become obstructed bottom up. Even though it's geometrically unobstructed, it's going to look like it's unobstructed, right, like sinking and whatnot. Okay, so it's the
biggest issue with his refraction. As soon as he makes a claim to it, he loses all claims to geometry.
Yeah, let me clarify. So when I say refraction, I'm not talking about why objects disappear bottom up. I'm talking about you say geometric horizon. That's not actually where the horizon is due to refractive effects. So the actual horizon, the effective horizon, is a little further. That's why you don't see it disappear bottom up.
No. The geometric. Okay, so let's go over a specific observation. Okay, and let's dig into this a little bit. Okay, so I'm gonna test for the geometric horizon here in this test. Okay, so 1 second. I'll just upload a quick GIF. Okay, and a screenshot from the Earth curvature calculator. So have a look in the side chat.
I'm driving.
Oh, okay. Well, that makes it a bit harder.
Hold on.
Well, I'll try to explain it, okay? So in this observation, he's got the camera height at 3.5 foot.
Okay.
It's a crystal clear day. It's a calm ocean. There's no waves at all. Okay, so 3.5 foot camera height. That means the horizon on the globe should be at 2.29 miles away. But he has a wind farm out in the ocean that's a known distance away. Okay, so we can see 6 wind farm towers out in the ocean. Crystal clear. Okay, the furthest one is 11 miles away, and the closest one's 8 miles away. So 8 to 11 miles. We don't see any sign of any horizon before the windmill farms, right? We can actually see the water just completely flat, going up, flat, until beyond 15 miles away.
Right.
Okay, so what we're questioning is that geometric horizon has to be there, right? It's like a physical cutoff point. Okay, it has to be there. Let's say we hypothetically remove the atmosphere. Okay, you would have to agree that there is the horizon line would be visible at 2.29 miles if the Earth were a globe.
Yes.
Okay, and we're just adding the air back in, and now all of a sudden everything's flat, completely flat all the way up to the horizontal horizon at 15 miles. Yes, because there's no obstruction. Hold on a second, let me finish, and then you can respond. Okay, so we don't see any obstruction at all. Okay, so physically, geometrically, actually, the bottom 52 foot of the 11.2 mile windmill tower is hidden behind the curvature of the Earth, right? The physical geometric horizon is at 2.29 miles. Now, we can't find it. It's not there in the observation. Okay, so how do you know such a thing exists? Do you have an observation that's taken specifically, right, the hyperspecific refraction conditions into account that aligns with the globe and that clarifies there is such a thing as Earth curvature and a geometric horizon, which is a byproduct of the Earth curvature? Do you have anything that validates that, right? Or, because otherwise it's just a concept, essentially.
It's a criticism of your measurements. Basically, your measurements don't. So the reason why it's not obfuscated is because the light.
What's wrong with the measurements? What's wrong with the measurements? How about we just break it down one step at a time? You've got an issue with the measurements, Nables. Don't cry on me. You've got an issue with the measurements. So what's the issue with the measurements? From a specific height, the horizon should be at a very specific location. It's not
accounting for the fact that all the light is being shifted upward.
No, that's got nothing to do with it. It's a calculation. We are assuming a radius of 3959 miles. We are given an elevation. From that elevation, we can calculate where the horizon should be.
That's the issue.
Yeah, so how did you validate that the light's bending upward, right? So if the light was bending upward, that would make the object appear to be sinking. So you haven't got that right. You would have to say that the light is bending downward towards the observer. Okay, how did you establish that that's happening?
No, that's a well-known phenomena. Whoever's taking the measurement, they must establish that, like, to what degree it is happening. That's on the burden.
No,
That's the burden of the person taking the measurement.
Well, no, actually, no. That's not how it works.
Why?
Why would it always be bending downward, right? So does light just bend towards the denser medium?
It's continuous, so it would bend continuously. It wouldn't be like a
no. So this is nothing
DJ,
to do with Snell's law.
If we were to grab a laser and shoot it, it would naturally bend down. That's what this gentleman's saying.
Yeah, well, he's trying to invoke Snell's law here. Snell's law has nothing to do with a single medium situation. Nothing at all to do with it. Okay, so even in Snell's law, you're going against what you're saying. Even though you can't use Snell's law here, Snell's law just means the light deviates towards the denser medium. Okay, so this would be atmospheric refraction, according to the mainstream terminology. Okay, and it would be a gradient, not a sharp boundary, but the light would, still the same thing would happen. The light would deviate towards the...
I said it wouldn't be Snell's law.
Section of the medium that's more optically dense. Yeah, that's what would happen. So it doesn't... Okay, so if you have cooler air higher or cooler air lower, the light's going to deviate towards the cooler air.
Hey, hello? Can you hear me?
Yeah. So you have no idea that the light would be bending downward in this situation.
I don't know if you can hear me. I said it wouldn't be Snell's law. I said that 6 times.
You did mention Snell's law.
Yeah, I mentioned it in saying that it wouldn't be an instance of Snell's law. Anyway, the light would still refract since it's moving through a denser medium.
What do you mean a denser medium?
From a less dense medium. So where's this happening at?
Draw
it on that picture there.
Actually, no, denser. Or denser? Is it more? Basically, you go
dude.
from...
Hold on a second. Okay, so when you have atmospheric refraction, it's about the vertical optical density gradient between point A and point B. And then the light will be heading from the object that you're looking at back towards the optic. Okay, so it can bend or it can deviate a little bit towards the denser medium. Okay, so the optical density is primarily controlled by temperature. So if you have an inferior mirage, right, that's the opposite of a superior mirage. The light doesn't always bend down or up. It depends on the temperature gradient or the optical density gradient. Okay, so you have no idea what's going on with the optical density gradient or the refractive index gradient in the observation. You're just trying to reverse engineer it to make it work on a globe. What I'm asking you is how do you know that you have a globe in the first place? How do you know that you have curvature in the first place? Because when we make these observations, it doesn't match up with the globe. It doesn't match up, not by a little bit, but by so much that you would have, like, let's just say we pretend the Earth's a globe and we're using the refractive coefficient, right? Trying to make this work on a globe using the globe version of atmospheric refraction or terrestrial refraction, you would have to have so much refraction that it would essentially make the Earth look flat.
Source?
Even though we have crystal clear conditions, right? We don't see any miraging or anything like that. You're saying that there's such extreme refraction it would make the Earth look flat. That's ridiculous. And what I'm challenging is that how do you know that there is actually curvature in the first place? Rather than trying to reverse engineer it, how do you know it exists in the first place? Do you have one test that's been done that validates that there is actually drop over distance?
So I'm not no, I don't have that. But I'm simply pointing out issues with your methodology. Like, there's issues. You can't conclude what you're concluding. That's the problem.
What's my conclusion?
Your conclusion is that there's no measured curvature.
Yeah, my conclusion is, right, that we can see zero evidence of the geometric horizon, right? And we can see the bottom of objects that should be hidden by a 5-story building. Okay, that doesn't match up with the globe. Okay, that's my conclusion. That's my conclusion here. It checks out with flat. Okay, we don't see any curvature. So if I don't need to.
You keep saying that, and
no, I don't need to. I don't need to account for refraction because I'm not making a specific claim with this. I'm saying that this doesn't match up with the globe. Okay, there's no sign of the geometric horizon. And you're saying it does match up with the globe, but you have no idea what's going on with the refraction.
Actually, DJ, his claim earlier was that the horizon is actually further than what we claim it is.
He did claim that, yeah.
Yeah, that my response was that that's what, if you account for refraction, yeah, that's what you'd observe.
Okay, so just visually, okay, this doesn't match up with the globe, right?
No, false.
So
Really?
you're claiming it
so visually it does match up with the globe?
Yes.
So why is the horizon behind the windmills and it should be quite clearly in front of the windmills?
Because it shouldn't be. You're not accounting for refraction, that's why.
So refraction would also bend the windmills up too?
Yeah.
It's not doing that.
Okay, so how do you know? How do you know? Do you have a single observation where you've accounted for refraction that matches up with the globe?
Well,
anyone throughout all of history, just one observation, right? That validates that. Okay, we've accounted for refraction in this observation, and it matches up with the globe, right? You don't have anything, so you don't even know if it exists in the first place.
It is your burden of proof. You're the one that claimed it. So, Nables, just to pin this down right now, as soon as you blurt the word refraction out, you lose all and every claim to any geometry in regards to that image. You do understand that. So if you're going to make a geometric claim, you are more than welcome to do so, but as soon as you go refraction, game over. No more geometry for you.
Okay.
And look, just quickly. Okay, so if you put this observation into Walter Bislin's Earth curvature calculator, okay, it has a refraction slider, and you have to slide that slider up to the point where the K factor, the refraction coefficient, is set to 1. That means that according to Walter Bislin's write-up on the refraction coefficient, there would be so much refraction that the Earth would just be appearing flat. Extreme refraction. Okay, that's ridiculous because this was done on different days, right? Still the exact same things happening. So in all of these different observations that we go out and take, there's so much refraction that it just makes the Earth look flat. And you don't have a single observation that validates the Earth's a globe.
Did someone post that slider?
Yeah, I can post the slider.
I appreciate it.
I can post. I've already put in all of the details of that particular observation that I'm talking about into the slider.
Yeah, bro.
Screenshot.
Bro, that slider actually slides up to a 60 billion mile effective Earth radius.
Yeah. That's what you have to set it to have no hidden height.
I mean, then you're just saying that the Earth appears to look flat. You just said that earlier. I mean, because basically what you're telling us right now is that the geometry and the measurements that we should have, the geometric horizon that should be physical, and a physical hill edge that's blocking ships. Oh, it doesn't. So the Earth appears to be flat, but I have to Earth refraction. So therefore you're throwing away your geometry plane. You're throwing away your physical Earth edge.
So, like, if there was no atmosphere, yeah, that would be the case. But I'm telling you that the effective horizon gets shifted because of refraction.
How do you know it's there in the first place is the question. How do you know the curvature's there in the first place? That's the question. Because the observations don't match up. So how do you know it's there?
Okay, at this point, I'm not even saying I know it's there. I'm saying that your measurements don't, you're concluding that because you have incomplete measurements.
Okay, so we're not making... one second, Reg, sorry. Look, we're not making a specific claim to the horizon being the physics. Hold on, just let me finish.
Oh, sorry, yeah, my bad.
Right, look, we're not saying that the horizon is at X distance because the Earth's a particular shape. We're saying that our definition of horizon matches up with the actual definition of a horizon, the apparent line where the sky and the ground meet, right? That's what the horizon is. That aligns with what we're seeing, right? It can vary. right? The apparent comes into it because it can vary depending on different weather conditions and whatnot, different observer heights, that kind of thing. You need a geometric horizon, right? That's what you're saying is being manipulated by the medium of the air. How do you know that that thing that's being manipulated and shifted around due to the refraction exists in the first place?
I'm not even saying I know that at this current point, because that's what's in question. I'm saying that for you to conclude what you're concluding about the Earth...
But that is what you said. Don't sidestep.
Don't interrupt. Wait, don't interrupt, please.
No, you are just going to walk straight past your claim and pretend you didn't even make one.
I mean, that is the globe mainstream claim. I mean, whether you say it or not, that is the claim of the globe. That there is a geometric... that the horizon is a geometric physical hill that is blocking things like bolts. That is the mainstream claim of the globe.
That is true.
We even have a measurement that is measured linear with miles and kilometers, right? Which will be usually described as flat measurements because they're linear. But there is a physical claim to it, which is a globe. They have a radius value of 36 or whatever you want to call it. Now, you guys like to change it. You say it's pear-shaped and it's not. But there is a physical claim to it. So for you to sit up here and say, well, I'm not making that claim, well, then you're not basically representing your claim of a... No, hold on. Then you're not representing this claim, which is in the mainstream, which all you guys, so-called scientists and astronauts and government officials actually believe in, which is a globe with a radius value of 3959 and all of this nonsense.
Yeah, but that's what we're already assuming, right? For the sake of argument. Otherwise, you guys wouldn't be using those calculators. Like your argument is by contradiction.
Hold on. It's not an assumption. We have been taught this in school since we were 7 years old.
No, that's not what I'm saying.
As a matter of fact, that we live on a sphere.
Okay. What I'm saying is, what the argument on the table is right now is that assume that the Earth is round. Take some. Hold on. Can you let me finish?
Great. Hold on. No. We're going to establish this first. Are you making the claim that we live on the globe, the mainstream version of it, or not?
Not at this current moment, no.
Okay, so you don't have a globe at this point at all?
Correct.
Great. So you don't have any physical measurements, any physical observations whatsoever at all?
Yeah, that's what you guys have. That's what we're talking about.
Right. So we have all the physical measurements because everything is measured linear and everything is measured with angles, such as elevation angles. All of those are matter of fact a flat Earth measurement because all of those measurements is being measured horizontally.
Yes. So the response measured. That's not how you conclude the Earth is flat. Not because the measurements are wrong.
I'm not concluding nothing. You are, sir. Me. Because you just threw the globe out the window because you say you're not making the claim that 7 years up.
Mm-hmm. Yeah, you guys are the ones making the claim that your measurements allow you to conclude.
You're the one who's making the claim of refraction. So you've got an issue now. Do you stick with your claim of geometry or do you beg for refraction? I'm easy either way, but there's a meat grinder at the end of each of them.
No, it requires refraction. Yeah.
So you lose all claims to geometry. So everything is pure optics. There's nothing to do with physical geometry, and you've just given the flat Earth to the flat earthers. Thank you very much. Welcome to Flat Earth. Please enjoy your stay.
That's a false dichotomy. You're saying it's either. Hold on.
You already told.
1 second.
You already told us that the measurements was flat. You already told us this is how we actually measure it. You already told us that the physical horizon isn't physical. And you already told us that you're not even prescribing to the mainstream version of the globe that we was taught since we were 7.
I didn't say I didn't prescribe. I believe that.
All the window for refraction, right?
Huh?
Threw away the entire globe claim for refraction. I asked you straight up. I said, so you're claiming the mainstream version of the globe. You said no.
Yeah, I'm not making a claim right now. That is what I believe, but we're not even there yet. We're responding to your claim that the measurements allow you to conclude the Earth is flat.
Well, there's zero measured curvature. So what's the problem?
The problem is you're not accounting for refraction.
Look, no, this is the thing. This is the thing.
So it's optical. He just made it quite clear, DJ. I just said there's zero measured curvature, and he said quite clearly you didn't allow for refraction. So in his mindset, it is purely optical. There is no curvature. Everything's refraction. Therefore, flat and it's refracted. The reason you see curvature is because of refraction. So therefore, it is flat by default.
He's already conceded. He's look. Just let me say one thing quickly, right? He's already conceded. Okay, he said that he doesn't have any observations that validate that there is any curvature or a geometric horizon, and then he's mistaking our observation as us saying this observation is proof the Earth is flat. Okay, we don't need to prove that, and we're not trying to prove that with this observation. We're testing for the globe curvature in this. Okay, so everyone already experiences the Earth as flat, even if it were a globe, right? Even from your experience, we all experience the Earth as flat, and we can't detect any curvature.
You have
okay. So once again, in this observation and the observations that we're doing, we don't detect any curvature. So it further validates the primary observation of everyone that there is no curvature. Okay, so that's like the default. That's the axiom that we're beginning with, because that's what we all experience. Okay, so you've already conceded that you don't have any evidence that it is anything other than that. So that's the conversation is over. That's a concession and a W for the flat Earth side.
Are you open to because you're can I respond, or are you guys just gonna keep talking over me?
Just let him respond. Just let him respond to what I just said.
And that you're the one that's making the claim here. We already experienced the Earth is flat. You agree to that. You already agreed that the Earth is being measured flat. You agreed to that, and you already agreed that the horizon.
I never agreed the Earth was measured flat.
Okay. So you didn't agree that the Earth was.
No. Can I respond now? Let me respond.
Or not?
No. Just let me respond. I don't know what you're saying. Let me respond. Here's where we're at in the conversation, and I just request that no one interrupts. Like I let all you talk. Let me talk. Your argument is like logically, like if I were to put this into a deductive first order argument, this would be deductive. Assume that the Earth is a globe. Given this fact,
you weren't taking the globe side.
Wait, hey.
You made it exceptionally clear earlier on that you were not taking the fucking globe side, so you can't insert that. Try again.
I'm not even doing that.
Yes, you just did.
No, I didn't. And
you just said assume it's a globe. No fucking way. You said you're not taking the globe side. So try again, please.
Then he immediately goes to the globe.
This isn't my argument. This is your argument.
If you have
listen. Hey, dude. Navels. I'm the boss here. Okay, so when I want to speak, I get to speak. Now, for the love of God, let Navels finish what he's saying. Thank you. Go ahead, Navels.
Very, very much. What's your name?
Who cares? Just take your time to speak.
Okay. Your argument is assume the Earth is a globe. If it's a globe, we ought to observe this. We do not observe this. Therefore, our assumption must be false. This is called an argument by contradiction, reductio ad absurdum, whatever you want to call it. This is your argument, not mine. What I'm saying is that this is a valid argument, right? If the Earth is a globe, we ought to observe this. We do not observe this. Therefore, the Earth is not a globe. That's valid. But the reason why it is unsound is because you are concluding that we must observe X, Y, and Z based on geometry. And I'm saying physics changes what we observe because the light gets bent downward, and so the object appears more upward. And so, and we have evidence for this. Miraging is we even have a name for it. When there's strong temperature inversion over oceans during the day, we observe objects appear where they're not. Superior, inferior, whatever you want to point out, this is what we observe. And so I'm saying, because this is a known phenomenon, you have to take this known phenomenon into account in order to calculate what we ought to observe. Once this is done, go and retake your measurements, and if they still don't agree with what the globe predicts, then you are right. But I am almost certain.
Okay, excellent.
Okay.
Excellent. So, that being said, a laser transit measurement methodology was done over a body of water 25 miles in length. They accounted for refraction. They had a weather station on both sides. And even if you put in standard refraction, it only alters the observation in the order of feet, but you need hundreds of feet. So that measurement is sufficient to debunk the globe geometry by 2 orders of magnitude. And rest assured, friend, 2 orders of magnitude is sufficient.
So you're saying there's some people out there that measured what the globe would predict and actually took into account refraction and still didn't get what the globe would predict. You're saying that's been done.
I'm saying they debunked the globe by 2 orders of magnitude.
Okay, where do you have a link?
Dude, I got a whole documentary and an associated PDF with the event, and it's actually not just one test; it's 17 tests. They start out small and they work their way up to big. It'll be the greatest 2 hours of your life you ever spent. Half an hour to read the document, and an hour,
with lasers?
a little over an hour. Yeah, bro. Hold on a second. I'll post it for you.
I wonder the laser thing now. Which one is it?
This is just my immediate. This is not me being argumentative, but it kind of is because I'm a contrarian. But I question everything. How do they account? Okay, if you think about what a laser is, it's focused light. The visible light we're seeing normally in the day, it's not focused. How do they they're basically saying they're the same. Like they can conclude the same things. I would be skeptical.
What? No, dude, a laser is better because it's
focused light. It's focused light.
Oh my god.
Yes. So how do you know that it would refract the same? Like just based off of what I know physically, focused light has more energy per square meter, and what refraction is, it's basically microscattering due to the interaction between
right.
light.
So if that's true,
mm-hmm.
then using a laser would be the best way to get rid of all the ambiguity of refraction. So a laser would be more precise.
But by how much?
By a lot.
What's a lot?
Well, 2 orders of magnitude debunking the globe. That's how much.
But give me the specific quantity of step change in the value of refraction between
it's your claim of refraction. You're the one who's begging for it. You supply us with this data.
No. He's the one that's made the claim that a group of people have done this. So the burden's on him.
But he's not made the claim to refraction. You, my friend, have. So you're the one who's got to provide the data for said refraction, not AI.
Refraction's a known phenomenon, right? I don't need to provide
You're
data.
the one who's making the claim to it. You're the one who's got to back this claim, not anyone else.
Yeah. Yeah, because if you're going to make the claim of refraction, and then you're going to make the claim of it has to vary to a certain point, and you want him to give you the specifics of it and say that it needs this specific value of refraction in order to debunk the globe, you're going to have to provide that specific value. You can't ask him for it.
Sorry, what's the specific claim you think I made?
Making a claim of refraction. It's not for me to basically explain it. You have to explain it. You're asking him, wait a minute, You're asking him, right? He said there is something that debunked the globe with a laser test. He said by 2 magnitudes. He gave you a specific value. You're making a claim of, well, I know about refraction, so it have to take account of this specific value. What a value did you guys?
Yeah, I didn't make that claim.
Hold on. As in, he have to overcome a physical condition in the atmosphere, which is an oxymoron. In the atmosphere, you have to make the specific of what he have to overcome to begin with.
Yeah, I didn't claim that, so that's just my.
You said, well, if you know enough about refraction, where there is nothing. So if you don't have anything that he have to overcome in the physical atmosphere, which you're claiming that is refraction, which you haven't described what refraction you're talking about yet. If you're not going to explain any of those things, you can't simply ask him to take account for it, because you're not making that claim, like you said.
Yeah, I just simply called something into question, and that was just my initial response. I haven't even seen the PDF. He has to send it.
Okay, but what you calling into question, you don't know about, it seems like.
Okay, if you want to, like, I don't know how to argue against that. Whatever.
Do you know about it?
Flat Earth core? Yeah, I do. Is this Flat Earth core?
No.
Yeah, I've seen this.
Field engineer core.
Yeah, this is Flat Earth core, FE core. I assumed it stood for Flat Earth. Does it not?
No, it stands for Field Engineer Core.
Oh, okay, Field Engineer Core. Yeah, I've seen this. There's so many problems, but I guess let's just get to the biggest one, the refraction.
Let's just run through them one at a time, my friend.
No, that's not productive. You should always address, whenever you're arguing, you should address the biggest problem first. That's my opinion.
You can't tell nobody how to argue. Just address the problem that you have with it.
Yeah, hold on.
So without watching it, you're going to tell us refraction, because you've already told us that, is the main issue.
Hold on. Let me just pull it up on my...
What you might best watch it first, so you don't poison the well. JJ, in the side chat. Nice and easy.
It actually might be... I might be able to...
So how about not poisoning the well first? How about you watch it, assess it, and then get back to us?
I think he said he's seen...
Yeah, I've read the PDF. I haven't seen the video. Do you want me, is the video, does it add anything to the PDF?
Okay, what is the biggest problem in the PDF?
Yeah, I'm gonna pull it up on my PC. So I'm gonna try and stream it. I feel like that'd be helpful. Hold on.
On top of your head, what's the biggest problem? Name it.
The biggest problem would actually be the lack of proper, how do I put this? Statistical properties of the measurements, but that's like
statistical properties.
Yeah, it's gonna start like.
What are you talking about, dude?
So like for example, well, hold on, don't make fun of me. Like I haven't made fun of you here.
Let him do the example. I want to know about these statistical properties.
Yeah, and I'm pulling up on my PC. Right, this is Flat Earth. Where is it? There it is. Okay, Flat Earth. Is this flat? There. Okay. Here. Okay. Let me share my screen. Actually, let me not do that because that's going to take longer. Go to page 7.
Holy crap.
Well, we don't have to go over it if you don't want to. That's fine. We could just go back. Actually, you know what? Give me a minute. I'm gonna set up everything.
Okay, this is this. Page 7, you say.
Is somebody else giving it to you, sir? I mean, is this your argument or somebody's giving you this? Yes, somebody's giving them this.
Dude, page 7 is still the introduction.
No, somebody's giving him the argument. He said, page 7, he said. Statistical properties. You heard this? Usually what I hear, they always say that mathematics is wrong, it's incorrect, they don't know how to.
Dude, gunnery, statistical properties of gunnery, if you hit the target, is 100%, correct? Am I right or wrong? The answer is if you hit the target, you've hit the target. Therefore, hitting the target is a 100%.
Oh, yeah, you're gay, dude.
Oh, yeah, that's because I hit your target, bro. Man, that was close. Whew.
You fucking.
What statistical properties did you apply to that conclusion?
Oh man.
Oh boy, here it comes.
Wait for it. Wait for it.
Yeah, actually, I have nothing. No, I'm good.
Wise choice.
All right, brother, no worries. You can just listen, hang out. We don't mind.
No, I have nothing to. I mean, dude, I'm not as smart as you. Maybe, actually, I think I am, but like, I don't.
No, you could be, but you're clearly inebriated, and so let's just say I'll leave it to the sober people to talk. You can just listen. How about that?
Well,
I agree. Good decision. Thanks. Anyway, homie Slice, I looked up page 7 here. Hold on, let me go back to it. I gotta open it again. Give me a second.
You're good. I'm taking my time too, man. You're all good. How's your night going, by the way?
Page 7 will land you on the introduction.
I feel like we don't.
I don't like how this thing doesn't open.
Hold on, really quick. I feel like we don't humanize with each other, so I sense some hostility from some people. I'm not even complaining.
No, we're not being hostile. We're just being thorough. So, page 7, the required accuracy depends on the needed deliverable output. Accuracy refers to how closely a measurement or observation compares to a true or established value, since measurements and observations are subject to errors. By analysing the error source models of curvature testing, the optical configuration design of the testing device was optimised.
Yeah.
The precision of the TLC measurement.
Pause. Sorry. So page 7, you read the part that I wanted to go over. In this document, could you read it from there again?
This document.
Second paragraph.
Well, the accuracy refers to how. Actually, you're looking at the next one down. So you're looking at the whole. That'll be page 8.
Oh, my apologies. Yeah, you're absolutely right. Page 8.
Anyways, page 8. The terrestrial laser targeting TLT survey method can be used with sufficient accuracy on large distance curvature measurements. Compared with other curvature test methods, the method used in this paper has proper accuracy and practical advantages. In this document, we are introducing TLT measurements up to 40 kilometres, 25 miles, conducted by our research team as late as the 23rd of April, 2018.
Pause. 40 kilometers, 25 miles. This is the part I wanted to highlight. Plus
so what's the
or
issue
minus,
with 25 miles?
Plus or minus what?
What's the issue with 25 miles?
25 plus or minus.
So you want a range plus or minus, say, 3 foot or...
What are you talking about plus or minus, dude?
Like the range of uncertainty.
With the range, dude, are you kidding?
Yes.
No, I seriously want to know if you're kidding, dude, because what is the 25 miles?
It's a measurement, no?
But what measurement of what?
It's a TLT measurement of like up to like the maximum.
Holy crap!
You said a measurement of what?
Hold on.
It's the
sufficient like large distance curvature measurements.
No, it's not.
That's what it says right there. TLT survey method can be used with sufficient accuracy on large distance curvature measurements. In this document, we're introducing TLT measurements up to 40 kilometers.
Yes, but the
right. So what's the 40 kilometers represent? Did you read the whole document?
It's an upper bound.
No, he saw that one paragraph and thought he could rip it apart.
Okay, I'm going to ask this. No, hold on. I'm going to ask this. I want a straight answer. Did you read the whole document?
No, not the whole, just excerpts.
Okay, then. So the 40 kilometers is the longest range test that they did. So they had the laser on one side of the lake, and 25 miles away, they had the target location.
Uh-huh.
Okay, and they shot the laser over 25 miles to the target.
Yeah, I got that.
Okay, so you want them to write down what the quote-unquote plus or minus is, but if they say it's up to 25 miles, and maybe their plus or minus might be in the actual measurement that they did at Lake Idsil, which was a 25-mile shot. And since you didn't read it, you wouldn't know.
Can I respond?
Sure.
Okay, so this team used TLT measurements up to 40 kilometers.
Right. Now, let me explain real quick why they said up to 40 kilometers. Do you know why? Because they did 17 different tests, some at small range, some at medium range, and some at long range. So I think like some of them were like 8 miles, some were 14 miles, some were 7 miles, one was 25 miles.
Okay, yeah, so they conducted 17 tests from low, medium, long range.
Mm-hmm.
And what? Wait, sorry.
I know you think you have a point, but
no, I'm actually not making a point right now. Wait, I'm not making a point right now. I'm just being. I'm asking a question because I want clarification.
Go ahead.
Can I?
Yeah, go ahead.
It says under the main principles of the experiment, the study effects of terrestrial refraction in the different ambient conditions of very small incident angles close to non-uniform density transition zones above water surfaces. That's where light bends gradually. Like that's the area where it's going to be bending a lot.
Which way? Up or down?
Wait! Don't! I don't want to.
It's a gradient. It goes gradually. That's.
Dude, who cares? Dude,
that's gonna derail, man. Come on, hold on.
Yeah, stop derailing.
Okay. My question is, what apparatus did they use for these 17 tests? You said a laser?
Dude, they used lasers, yes. I'm not sure if they used the same laser for all of them.
How do they measure the distance?
Hey, dummy. Listen,
that's not
bro,
nice.
No offense.
Let's not do that.
No offense. But to be honest,
you guys ask these type of questions all the time and then berate us when we get a quick answer.
That's fair. Exactly. That's fair, dude. But the problem is he already said he looked at this.
I looked at pages 1.
No, but you guys presented it.
Hold on. Yeah, that's true.
And he made it quite clear, Ice JJ, that he had examined it. So please shut up.
Yeah, but it's over 100 pages. Examining it is different from under fully internalizing it.
Ice. Dude. Just get muted, fool. Thanks.
The heck? Okay. Look,
Listen, dude. I'm not competing with Ice JJ for you to get your chance to speak and for me to answer your questions. So you can just stay muted. Okay. So go ahead.
Yeah, I appreciate that, but I would let's just establish a tone of respect. That's all I want to say. My question is, what apparatus did they use? How did they measure the distance?
Mabel. You said you already read this. You already were familiar with this as if you already looked at this before AI even presented it to you.
You know what? Maybe I didn't take a careful enough read. Maybe we can go through some of it together, and you guys can educate me and not be rude. Let's establish a tone of respect.
I think that'd be rude for you to say that you are familiar with something as if you already know what this is.
Sometimes people are mistaken about. Have you never made a mistake in your life about thinking you know something and not knowing something?
I got you.
Are we not human, man? Like I'm just saying, like. Are we not here to have a discussion? Like we're not.
That's not what happened. You said that you'd read it. You directly said that you'd read it, and that there's a whole list of problems that you've already established with it.
Yeah, the biggest problem. The biggest problem. Yeah, bro. You said the biggest problem. The first thing you said was up to 25 miles.
Okay. All right.
What were the error bars on 25 miles? That was the biggest problem, dude.
Listen, man, I embellished. All right, you know what? I'm human. I embellished.
All right, you embellished. I'll accept that. Mea culpa. So let's all move on.
Okay, please, thank you. And if I'm here to be educated, how about this? I've never read this. How about this? Let me be absolutely honest with you guys. I've seen this. I've taken a glance at it. I've never thoroughly read it, and I would love to be educated on the work you guys have done as independent scientists. Cool. Can we call that cool?
What science?
Science is the process of making an observation in the natural world, forming a hypothesis, testing it, and interpreting results.
And testing it with what?
That depends on, like, that's super context dependent.
It depends on. We just taking measurements.
I got you.
Yeah,
I got you. But
right. So speaking of measurements, okay, cool story. Cool story. Let's move on.
Like, yeah. Why do we got to pick over the details anyway? What apparatus?
All right, hold on, brother.
What's up?
Let's just go to one. So I'm trying to find the start of the biggest one. Because why start with the small one when you can just go to the most major measurement they did? So calculation measurement 6, target 4. Okay, so let's just go to page. I want to make sure that the one we're going to talk about has all the things addressed. So it must be measurements. Yeah, let's just go to measurement 7, target 4. So that starts on page 94, I think.
Okay, 94. Let me follow along.
Measurement 7, target 4. Yeah, that's the end that then leads to the conclusions.
By the way, whoever made this, I would label the pages just for people who have.
Yeah, you always label pages.
Yeah.
I hear you on that. I give him an F on that one.
On the 20, my mom's talking in her sleep. Hold on. Huh. She does that sometimes. You know, one time I had a full-blown conversation. She was dreaming that she was talking to her therapist about me, and she was. I mean,
we don't need to know this.
Okay. Okay.
That's not to.
Gotcha.
So we're looking at the 7th measurement. Cool.
You or David?
You
I gotta
too.
mute up. Hold on.
I mean, FE Core is very precise in this documentation. I mean, besides the labeling, I mean, it's not much to really read.
Okay, so page 94 has the photo of the target position. So let me scroll. So the reason is because they actually pan the laser to different targets on the lake.
So we got to go all the way back. Oh my goodness, man. Sorry. Don't want Lake Balaton. Okay, so a second measurement.
Lake Isle 6 and 7.
So laser position at Lake ISO is actually on around pages 42 or 45. That's when it begins. So Lake ISO Netherlands measurements, April 2018. It shows you the laser location, and then it shows you the target locations on the map. So for their distances, it appears they're just using this map. Okay. So they used Google Earth mapping to draw a ray from the laser location to the target location and then get that distance. Okay, so that's how they got it. Now there are 4 targets that they did. So let me zoom in here. Now the reason why they did 4 targets, yeah, what happened? Yeah, bro.
Oh
man, we've been working. What have you been doing? Slacking?
Taking care of my disabled brother and disabled sister.
All right. Fair enough.
Thank God I live in California. I mean, I fucking hate this state, but I'd be cooked without it, ironically. It's a parasitic relationship, almost.
So we were saying on on page 42-ish, there's a map of Lake Eiso presented, and it shows you the locations of the laser and the targets.
Okay, is this from Google? It looks like Google Maps. Is this from Google Maps?
Yeah, Google Earth.
Okay. So then that means Google took these measurements. So, I don't know, it's not like a gotcha. That's just that means that Google either does or doesn't have public data on the statistical properties of their measurements. It may or may not be public, but it exists. When they took these measurements, they also took all of the relevant statistical properties.
That's it. I'm gonna.
I'm gonna be honest. I don't know if it's a complete failure, but I think you're failing to make your point. What do it matter if they referencing Google Maps? That's just a map. I mean, the way it's stated in here, they just presenting the location.
Okay, I'm back. Have you guys spoken amongst yourselves? Hello?
What up?
Yeah, have you guys spoken amongst yourselves about what I said?
No, my headset died. I have no idea what you said.
Yeah, well, he was trying to say that Google Map is the one that took the measurements, but they only referencing Google Maps, right? Basically, the location of where the measurement is being
Okay. They're just using it as a visual.
No, what they're actually using for their underlying test structure is the WGS84.
Yeah.
So what's that? WGS84.
Yeah, if you read the intro, like the first few pages, etc., you would have learned that.
WGS84 model. So you guys do use models.
Yeah, so the WGS84 is one of the reference ellipsoids that geodetic surveying is interpreted through a matrix and laws of formation, as outlined in books such as Higher Geodesy by Helmert, etc., etc. Okay, it's well established. It's considered the standard among many fields. Okay, so we don't need to revisit the error margins or the statistical probabilities.
Oh, okay. Sure.
Right, because their goal was to test the WGS84. Okay.
Against measurements which have statistical properties. Thank you.
Okay. But the WGS484 itself is taken as a given, and then the other parts of the measurements would be what they actually did. Right. So if they're at a particular location, and the WGS84 says that this location and that location are this far away, that's what they're testing. And it also says that there's this much curve in between those 2 points. That's also what they're testing. So the scrutiny that you should mainly be applying to them is things that aren't already the established thing that they're trying to test. It should be their measurements that they're making. So in other words, if I was a judge and we were in a court case, I would say, listen, the WGS84 is not their burden to put on trial. It's already established. They're presenting counter evidence to the WGS84. So if you want to adjudicate the WGS84, go and sue the company that made it. All right, so now that we see how they did it there, they got the Google Earth, they got the WGS84, they got the claimed distances from point A to point B, and also the WGS84 has claimed curvature between point A and point B. If you notice on page about 46, they even put in the scale of the geoid undulations, right? They even put in the tides. Lake tides are known to have amplitudes up to 10 centimeters in larger lakes. In case of Lake Idsil, the average shallow depth of 5.5 meters, 18 feet, and the relatively low water volume of the lake suggests this effect would be even smaller and within our measurement error margin. Right, then it says how they did here. The lake temperature ranges from 7 to 14 degrees Celsius. The ambient conditions along the entire length of the laser beam wasn't available. They used data at the end positions. The data showed there's no significant differences in temperature and humidity between the start and end points of the measurement. So now I'm going back to the 90s to get to measurement 7. Measurement 7, there they show you the readouts of the meteorological station that they had. Temperature and humidity at 2 meters, 6.56 feet, right? Altitude. Then you got the target for observation location, the little photo right there. Then you got the laser beam hidden height calculation measurement. So it shows there the calculations based on a spherical model results in a target hidden height of the measurement 7 at target position 4 of 90.81 meters, 297 feet. Okay. So a straight line laser would pass over the target to the target ground position, 297 feet. Now, obviously, the target has some height to it because it was 2 meters. Then you've got curvature correction, right, from an ideal sphere to the WGS-84. There's the math right there. So the calculated difference of curvature drop on the WGS-84 spherical model for the location in which they were in, right, from the laser to target is plus 2.56 millimeters. So it varies from an ideal sphere by 2.56 millimeters. The height of Lake Eitzel above sea level is 0 meters. All right, then we go into here, measurement 7. So they got the air temperature, the atmospheric pressure, the air humidity. Then they got the, hold on, let me scroll and zoom in here. Then they got historical weather reports there for the days. Look, they even have an uncertainty of the calculated index, the refractive index of air. Right? They got all that right there, Holmes. For all the refraction calculations. Then you see here on page, in about 101 to 103, it starts the refraction calculation. So angle of incidence, right, 0.002 degrees, refractive index calculation based on the modified Edlund equation, N1 equals blibbity blop bloop bloop, nanometers, wavelength of light, blah blah blah, angle of refraction, Snell's law, zibbity zibbity zap, angle of deviation, shabloody shablam. After that, they conclude the ambient conditions refracted the laser beam downward by a maximum of 0.131 millimeters. There you go. All right, positions and height of target 4. Right there, they have the latitude and longitude of the target, right? They have the GPS ellipsoidal height and the geoid height. Target 4, latitude, longitude. Oh, sorry, the first one was the laser position. Second one, the latitude and longitude for the target position. Right? The GPS ellipsoid height, 0 meters. The geoid height, 41.847 meters. So you notice that 41.847 from the 42.409 only gives you less than, let's see, for the 2.4, less than 1 meter of variance, okay? And then they calculate it for you here, 22 inches. So the differential in the geoid height was only 22 inches from target location to laser. Oh man. Did I have you guys on mute? Or is anyone trying to speak?
I can hear you.
Okay, perfect.
Following along.
All right, so next page, experimental results. Experiment results of the 7 tests, because I just read you the longest test. Loosely, you should have been following along in the document. Then you would understand the blah, blah, blah spent. Okay, experiment results of the 7 tests indicates there is no curvature on the lake surfaces. The testing results agree with the analysis of error sources. Feasibility of optimizing optical configuration was verified. In summary, the testing results of the lake surface were plus or minus 0.2 meters. Relative accuracy was in 1%, confidence level 98%. Our experiment results verify the possibility of point-to-point long-range wireless communication system. I'm not sure why they added that. It must have been mentioned earlier. So the TLT measurements meet the accuracy of the experiment design requirements and provide a definitive deliverable output. The surface of Lake Balaton and Lake Itzl is not convex and curvature is not detectable. Right? Through analyzing the error source of the TLT and making the measurements and corrections for the geoid, we determined that results of the experiment definitively prove our hypothesis of non-convex water surfaces. So the conclusion, all large bodies of water should follow the geopotential surface. We proved these lakes are non-uniform with the WGS-84 model. The WGS-84 model is incorrect. Now, why did they say that? Well, because the laser hit the target, and according to what page 99, it would have had, the laser should have been, let's see, 200, should have went over the head of them by 297 feet, but it hit the target, and the target was only 2 meters off the ground. 6 feet, approximately 6 feet. So that means the globe is debunked by 2 orders of magnitude. So then they have the actual things in tables here. So let's find the one of the table for that test. Lake Itzl 7. Okay. Imperial. Let's just use Imperial since that's cool. Let's go. So on Lake Itzl 7, why does it say 357? I don't freaking know. Or is that inches? Why the heck did they do it like that? Oh, inches, yeah. Why would they do it in inches? You little man, man. Well, either way, spherical target hidden height at Lake Itzl is 3,575 inches. Correction to the WGS4 later to target was 0.085 inches. Okay, mean sea level was 0. Refraction was 0.00512 inches. Expected target hidden height 3,575. Variance to the geoid height was 22 inches. Right?
What was the variance to sea level, did you say?
Okay, so the mean sea level at Itzl is supposed to be 0. Let me go back up here to where they actually wrote it to make sure. Curvature correction. Do, 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 do. Hold on, my thing died. It has the GPS ellipsoidal height at 0 meters. That should mean a 0 sea level. But I just read it that they somewhere in this one of these pages real quick here. Give me a second.
Yeah, I heard you say mean sea level at 0. It'd be interesting to see if any other point that they've taken that means sea level would be anything other than 0.
Yeah, but I didn't mean sea level as obviously mean sea level is considered the baseline, so it'd be 0. But so if something is considered at 0, then it's considered at the baseline. So 0 feet above sea level. Dude, they literally had a sentence in there that I read, and now I can't find it. Holy crap. Just gonna real quick reread it.
That's okay. We're recording this, so I can go back, yeah?
Okay, measurement 7, the spherical model, target hidden height, WGS84, laser to target, correction, MSL correction, refraction expected. Oh, the height of Lake Isil above sea level is 0 meters.
Yeah, that's it.
All right, did our homie leave? Guess so.
I'd say he left when he scrolled down and there was one of the pages that mentioned the refraction and how it bent the laser upwards so many millimeters, and that wouldn't have fit the model he required, and he would have looked at that and went, oh dear, that's a problem. Or if he was smart enough, he would have. Yep.
They claim he brings something in, and then now we going over. Set up perform.
I noticed a couple of you in here that I haven't sent a friend request to. Flat Earthers, I mean. So I just sent out a couple.
Yeah, that link you sent is seriously flawed. If you can let me send something in the chat, I can send a short description of
Which link is flawed?
Which link?
The one you were going over, that guy, FE Core experiments, description, and so on.
Well, if it's flawed, you should have been going through it with AI. He would have appreciated some help.
Yep, Mike's back to you, Overlord.
Yeah, AI
actually AI that
points out a bunch of the flaws, but even with later we need AI. I mean, but yeah, I mean, run it through AI immediately.
No, not run it through AI, as in AI Overlord.
Man, just tell us one of the flaws. What, do you got to wait till it premieres in theaters?
Yeah, I mean, very basically, I mean, one of them is that they're measuring refraction, and you even quoted this, only at 2 points, the beginning and the end. But this is in non-continuous zone. I mean, this is in the area where refraction is like the strongest and varies drastically. It's non-continuous. It changes along the path. And there's no measurements for that at all.
So if they've measured it at the strongest points, and it's only out by 0.131 of a millimetre over, how long was the seventh measurement? 25 miles? So we're out by 0.00512 inches at 25 miles, and that's the strongest point of the refraction. I don't think the weakest is really going to do anything.
You misheard me. I know. I did not say the measurements. No, they only took a measurement at the start, the point of observation, and the point where the laser.
JJ, they took the area that they're out by 0.00512 inches at 25 miles.
Yeah, I'm trying to explain something.
Yeah, what part of 0.00512 inches at 25 miles don't you get?
I mean, do you understand? I mean, I'm trying to finish my sentence here.
JJ,
because they're using
at 20 miles, that's 270 feet of drop. At 30 miles, it's 600 feet of drop. Okay, so you're out by not even half of 1 inch. So you've still got to acquire a lot of drop.
And I'm trying to explain to you how they're missing it, which is that their measurement for refraction is only at 2 points when it changes.
So if we take it at 1,000 points, you're going to get more refraction.
It's not working.
Because you make claims that you can't substantiate, my good friend.
I can't finish the claim.
You can't substantiate them, so there's no point letting you. So what you're saying is, if they've made 2 points. They've measured 2 points. So let's say they measure 1,000 points. Are they going to magically get more refraction in order to get a ball? Yes or no?
Yeah.
You're an idiot.
No, that's just facts. If you measure more, you will get more refraction. You get drastic swings in, refraction along the path, especially over water. Like the area, like shooting a beam of light over water and saying, "Look at this." It's not. It's like this doesn't look at like the measurements of the physical properties of the Earth. It's like saying, like waving a thermometer through a steam vent and saying, "Oh, look at this." It's like it's ridiculous.
What you're suggesting is actually ridiculous. So what you're saying is that after the laser leaves, right, from point A, it's perfectly bending around the globe all of these different distances, because they're doing all of these different tests over different distances, where you would have drastically different amounts of curvature. You're saying it's perfectly bending around the globe in all of these different tests and hitting the target within millimeters consistently. That's crazy what you're suggesting right now.
They're using refraction corrections. I'm talking about the things that they're using are methodologically just unsound. So you can hit a beam.
But you're saying
with refraction.
How about us, JJ?
Mean that
how about you make JJ? You've made the claim that they're methodologically unsound. How about you make them sound so we can use your formula when we do these tests in the future?
Well, they would need more measurements. They'd need measurements across the path of the.
So how do you explain the fact that in some of the tests the refraction is going the wrong way?
Because refraction changes drastically along the path. You know, they can go down.
So you're telling me
that's why mirage is
that's your default refraction changes, but it's going the wrong way, JJ. Did you not listen to what I said?
Oh my God.
Did you not listen? If it's bending the wrong way, that means it's leaning towards the globe. And you still don't get enough.
Hey, no worries, no worries. So JJ, all you got to do, bro, it's very simple. Go over to Walter Bislin's, put the observation into his calculator, and then use the refraction.
It's not that simple.
Oh my God, dude. Okay, JJ, let me make it very simple to you.
Yeah, but the point is it's not.
No, JJ, let me make it very simple for you. I get to finish my sentences by acquiescence or force. You pick. Okay.
No, I love it.
All you got to do is go to Walter Bislin's, put it in there, and it'll give you the refraction that's required to make that observation. Once you have that number, then you have something interesting to talk about, which Matrix may be interested in.
Yeah, I'm talking about their own measurements. So if their own measurements don't line up with, if I can't rely on their measurements, then there's no point putting them into something else.
JJ, the laser hit the target. Okay? That's what happened. Okay,
yeah, I'm saying that your claim of refraction along the path doesn't. They don't even
no, you don't even understand. Check this out. It's simpler than that. Okay, if the laser is hitting the target, right, and a straight laser, unrefracted or unaltered in its path, right, would pass over the target approximately 300 feet. That means in order for the Earth to be a globe, the laser had to have curved around and reoriented itself to hit a target below 300 feet. Okay, by 200, well, there was about 10 feet, let's say, so about, I think it was 290, so about 280 feet. So just go into Bislin's and find out how much refraction would be required to curve a laser that much over that distance.
Again, it's not continuous.
Once again, I just did that, and I had to max out the refraction slider to 1. It's in the side chat screenshot.
Right. So it's either going to be continuous, and so over the entire arc there's going to be subtle amounts of change, or it's going to be non-continuous, where there's going to be very little change and then dramatic change, which means that pocket of dramatic change needs even more extreme conditions than the rest of the non-continuous arc that it's supposedly traveling in, JJ. Don't you get that?
What?
I know. Oh, sorry, I forgot. I'm dealing with retarded globers. Let me make it more simple. Maybe I'll draw it in crayon.
Yeah, draw it in a crayon. That'll be easier.
Okay, so if you're traveling 1,000 miles an hour in a hot rod specifically designed to win the land speed record, okay, and there's a brick wall at the end of the track, you have to slow down before you crash into the brick wall. So option A is you start slowing down way before you hit the brick wall, and then you only have to apply a certain amount of slowdown so you don't break your own neck. Now, if you try to stop all at the end of the brick wall, your neck's going to snap in two pieces. So you either make slow, gradual changes over a long period of time, or you make extreme changes that have extreme impacts in a very short amount of time and distance.
Yeah, I mean, they're having an issue of like their calculation of refraction is off. Despite, I mean, according to GPT-5 thinking, 5 to 8 orders of magnitude, or their interpretation of what they're seeing is wrong. Like, for example, do you know what attenuation is? The idea that a beam can scatter. It becomes weaker, and so then you see it creates different dots that go in different paths. What if it's that, especially at that range? That's when attenuation is going to be happening.
What?
That, you know, you don't know if the beam did not start scattering at one point because it starts fading, and then what they're catching as a laser hitting the target is really just one scattered part of an attenuated beam.
No, that's not how it works. See, they actually took a photograph. Check it out. They took a photograph of the beam centroid. Lasers have a Gaussian distribution. You could apply an algorithm. It'll tell you that you're looking at the center of the beam.
An algorithm, okay.
Oh my God, dude! I forgot.
That sounds like assumptions to me.
Do you want me to draw it in finger paints? Crayons may be too highbrow for you.
No, but that's hypocritical. Setting an algorithm.
No, it isn't. No, it isn't, dude. Pay attention. Lasers have a Gaussian distribution profile. So if you're looking straight at a laser, the glow off is going to fade off in a Gaussian distribution. And if you apply an algorithm that could tell you whether it's a Gaussian profile or not, it can tell you the center. Holy crap, dude. Holy frickin' crap, dude.
Yeah, again, if you're dealing with a lot of attenuation, I don't think that's really going to make much of a difference.
Yeah, go get the definition. Go get the definition of attenuation, and then come back and read it, and then tell me how it applies to the situation.
Yeah, it's when it slows down. It has less force, and that causes scattering.
You can see the beam hitting the big target that they created there in the side chat from the PDF.
Yes, that would be one of the scattered beams.
Yeah, what's the circle of uncertainty, dude? Is it 300 feet? Holy frickin' crap. Holy frickin' crap.
So it's sectioning out into separate beams, the scattering sectioning it out into separate laser beams, and one of them happens to be hitting this target.
Sick, bro, sick. Hey, bro.
I mean, they claim relative accuracy within 1% and confidence level of 98%. But I mean, given, I mean,
man, dude, I didn't
uncertainty
know.
Of all this like
JJ, let me apologize to you. JJ, can I apologize? Can I apologize? I didn't realize that you were trying to say that they shoot one laser and then it turns into 17 different laser paths that all just shoot up different shorelines. You know, kind of like in Quake 3 Arena when you get the multi-laser homing missile. Holy crap, bro. You're onto something.
I mean, to some extent, yes, if light scatters, that's something that can happen. And when, and their confidence level is 1% or 98% relative accuracy within 1%, but they don't have any kind of data measurements to back that up. That's ridiculous. These guys are. This is just like. Oh my. I mean, I'm reading through this. If you let me post in the side chat, I'll just post like an AI analysis. I'll give you the prompt.
Why can't you? Why can't you post in the side chat?
Not provoked. I'll give you the prompt too. I just like.
Why do we need an AI run through of this when we've got you to run through it like you've done?
Because it would be a much more efficient way of getting the point across.
So what you're saying is you're not qualified for this conversation.
Hold on, because it's over 100 pages, the document you've sent. I have not seen this before. and it would be much more efficient. Like just simply just.
Oh,
so if you have not seen this before, how are you to judge it?
Well, I have been going through it since you've sent it, but again, that wasn't that long ago. But whatever. I look, if you let me post, I'll send it.
Maybe you should read it a bit more, mate.
If not, then whatever.
You copying Craig rebuttal word for word, bro. You gonna say you didn't look at it?
No, I've been looking at it since it was posted. That's what I'm saying. I have not seen this before. It was posted. I don't know how is this complicated for you?
You definitely see you're copying it word for word, bro.
What am I copying?
You're trying to claim that the lasers is bending with the Earth due to refraction. That's why it's hitting the target. And you also trying to make a claim that the light is scattering. Light is going over the target, which is not. It's not even in the presentation.
Yeah, that's because the presentation is flawed.
So you're saying the presentation is lying.
Yeah, to some extent, yeah. Or it's wrong. I don't know their intentions. They're wrong.
It came wrong because it definitely hit the target. That's the claim in the presentation.
No, but hitting the target. No. But the issue is hitting the target happens with refraction, and it happens with a bunch of things also.
It
happens with attenuation too. But the question is, how do you account for that? And they're accounting for it. It's horrible. It's in fact negative.
Well, maybe you could enlighten us on how to account for it correctly.
Either you're saying the presentation is lying, or you're saying that the physical laser beam is curving with the Earth due to refraction and continuation, which you haven't even described yet.
Yeah, absolutely. Yeah.
So which one is it?
Well, no. Attenuation is just when it gets slower and weaker because it's a laser beam, and then it fades out, and then when it does that, it sometimes will scatter, but it becomes a kind of dim beam. But refraction is the curving because
it was somehow curved and hit the target 25 miles away.
Yeah.
This guy's acting like lasers are like shooting a shotgun into water with flechette rounds, where they just go all over the place and end up, hitting a fish over here and then a fish over there.
Not at all.
That's exactly what I just asked you. You said yes.
They bend slightly down, curve.
You said they scatter out into separate beams.
Well, no, attenuation is when a beam becomes weak enough. So when it goes far enough that it starts losing its strength, it starts dimming. It can cause scattering.
Hit the target. Hit a target 300 feet below the Earth. This Earth tangent. So that means no matter where they set it, it would hit that target.
What?
That means so basically you're making an argument that the globe with these laser tests is unfalsifiable. That's what you're trying to say. You're trying to make like this is confusing.
No. I'm saying that their own description is their measurements are flawed. Their description is flawed.
You didn't even read it. You didn't read it. You just put it into ChatGPT and you're just parroting whatever ChatGPT told you.
Look, I've been
Hold on a second, JJ. Hold on a second. I want you to look at the picture that I put in the side chat, and we can see a section of laser beam on the target. Hold on, just listen. Okay, I just put the picture in the side chat. What is that green beam on the target there that's only in a small section of the target?
That is scattered light.
So you're saying it deviates into separate sections of beam? You're saying that's a small section of the beam, right? And the other bits are scattered elsewhere, and it's separated into separate beams. That's what you're saying.
Potentially.
Well, you just made that up, and that's ridiculous.
No, it's not made up.
Okay, a single laser beam can appear to scatter. A single laser beam can appear to scatter out or spread over distance, but it does not literally split into separate laser beams.
Oh no, it doesn't have to split around. Yeah, but it can scatter in a sense that it directs somewhere else. Like
Okay,
That's
so
not that,
why is
it's not
there,
that. This is not radical.
why is there a concentrated beam on a particular section of the target as if the laser beam is hitting the target?
Oh yeah, well, it's very simple. It's very simple, JJ. Give me one example of a laser having done this at any time in history that's been recorded.
Scattering like that? I don't know.
Yeah.
I'm not an expert in lights, but I can tell you, like,
Now he's not an expert.
No, but this is the point. You're appealing to you're making this logical fallacy.
You're
appealing to who I am, who's saying it. But this is why I'm saying, okay, let me just.
Oh, dude, you're making a claim. You're making a claim that something happens. I said you give me one example of it ever occurring in history, and so now you have no idea what you're talking about, dude.
Can I post something in the chat?
Yeah, why not?
Because I'm not able to post.
Yeah, well, I don't know why you're not able. Why aren't you able? Did you get banned from posting, or you don't have enough rank?
I don't know. I haven't been able to post.
Try now.
There we go. I can post now. Well, there's even this is not that, but there's even with the Rayleigh criteria, there's even Rayleigh scattering. Yeah, Rayleigh scattering.
Yes, but
that's
but
sunset. That's red.
When do lasers do not travel straight and do not hit targets horizontally? That's what we're trying to figure out. Because you're saying that lasers go everywhere, which defeats the purpose of a laser.
No, I'm talking about an optical illusion,
to a
potential
degree.
optical illusion. It wasn't. I'm not saying that's what happened. I'm saying that's a potential optical illusion.
Interesting, this happened. Actually, that you're trying to say that the laser is all over the place, so eventually it will hit its target either way, whether it's focused or not.
Well, to some degree, JJ, listen, to some degree, JJ is correct, and I'll explain. It's very simple to understand. Okay, if you shoot a laser straight in a room, okay? Now, go to the side of the laser in an observation window, so you're looking at the laser perpendicular to its path. Now, fill the room with fog. You're going to see a green line going across the room, right? That's the laser. But that's not the direction the laser main light is traveling. Those are the portions of the light that are being hit on the particles and then being redirected to your eye. So in that manner, you could argue, well, that's the laser being split off into separate quote-unquote beams, but they're not beams at that point. The main beam is the point that's traveling straight ahead. What's being deflected off is no longer part of the beam.
But how do you know that's not a reflection or deflection?
Beam's still hitting the target.
What? Right.
How do you know that is not?
The main beam is still hitting the target, but what you're seeing going off on the side isn't the main beam, dude. And by the way, if you apply the Gaussian profile, listen, if you're looking at a laser on sideways, it's going to look like a straight line going across your field of view, right? If you apply a Gaussian profile to that, you're not going to get a centroid. But if the beam is hitting you, you are. I mean, I don't know why this is so complicated.
I don't know why this is complicated at all.
Well, listen, homie. Listen, Reggie, I don't have anything simpler than finger paints to draw a picture for this kid, so I don't know what to do. Maybe I just need a set of shapes with colors. A red triangle.
Maybe he needs Schoolhouse or Rock. You need to, I don't know, make a jingle or song for him.
You said that they only measured at the beginning of the lake and the end of the lake, and they didn't measure the continuous ambient atmosphere along the entire path of the laser. Okay, let's say that's true that they didn't. Why should they? Justify why they should even bother.
Because that would tell you whether or not whether or not you're hitting a target because light is bending or because it's a straight line.
Well, wouldn't the video footage or photographic footage of the light hitting the target prove that it's doing its thing?
No, but it doesn't prove why it's doing its thing.
Who cares? The result at the end is it hits its target. Ta-da!
Well, if it's because light's refracting, that means it's bending over a curved surface.
So you're making the claim that refraction causes
No, it
lasers
doesn't.
to follow the 8 inches per mile squared average.
No, that's not true. What he said isn't true.
Now, this is
If you prove light is simply refracting, that doesn't prove it's bending over a curved surface, dude.
Right.
correct. But if you prove that
you invoke
measurements that you're seeing, if it's refracting and you're hitting a site at 20-something miles, if there's a bunch of refraction going on and you're hitting what's supposed to be line of sight, then you know it's not a straight line.
Okay, how much refraction would be necessary?
No, but with any refraction, if you're seeing line of sight
Holy
that
crap,
much distance,
dude.
and there's any refraction would mean that you're not on not on a flat surface.
Hey, why every time we ask for this, how much refraction is necessary? I asked this. How much?
He said any refraction. So if there's 6 feet of differential between the laser and the ground, and there's a sufficient amount of refraction to only vary the laser within a circle of uncertainty of 6 feet, he then thinks that means you're not on a flat surface. Are you kidding me, dude?
No. The refraction that you see along this path,
I've heard you.
not any refraction, the refraction that you see along this path is going, and we know there's refraction. And if it's line of sight, then if there's refraction, then it's not a flat surface. Like if things are shifting upwards, like just like that, the ships in the horizon video, like there are times when they are sinking below, and there are times when they are higher. If the time when they are higher is when you think you're line of sight, then you're obviously not on a flat surface. That's when you're seeing mirages.
What? That doesn't follow either, dude. Like you literally can't even make a sentence that results in the surface being necessarily curved. Why is that? You seem to have an issue, brother.
When things are wavy, they're higher than they should be, but it looks line of sight, then line of sight means it's not line of sight because it's wavy.
Holy crap, dude.
So it's
wow. Hey, listen.
That's a very basic
Make an argument that leads to the Earth being a globe necessarily because of refraction. Go ahead.
I mean, that was it.
No, it wasn't, dude. Not even close.
I mean, that's line of sight. I mean, it's not because of refraction is not the best way you're going to, get the measurements of the Earth, because by definition, you're looking at bending of light that is variable along different areas and temperatures and altitudes.
Be asking you,
but the refraction that you would see, like,
Eric, dude, calm down. You the one that said that refraction is obstructing the measurement to begin with. Therefore, you have to take account for refraction. So AI asks you a very valid question is how much refraction is necessary, dude, to cause light to bend to the curvature of this big Earth with this radius value. Because you don't have the radius value at this point. We haven't given you the globe. Listen, we haven't given you the globe. We haven't given you the radius value. You trying to prove that there is a radius value. All measurements are being taken flat at this point. All measurements are being taken to be assumed to be horizontal at this point. Even if the light is bending traveling straight. You don't have a curve yet that you have proven. So you have to somehow convince us or prove to us that the light is actually bending to the point where it's curving. So you're going to have to definitely tell us how much refraction is required for the light to curve over a physical hill you guys call the horizon. Valid question. No, you can't just say, any refraction. You could put a little bit of refraction and it would curve over this 30. No, you have to do some type of math to tell us what refraction that you will have to account for the curve that basically cause light to bend, curving around a surface with a radius value. Answer the question, how much refraction is required for this?
Okay, the exact number, I don't even know which specific observation you're talking about. I don't like the point that I was making was that it's a non-continuous gradient along the path, which means
So the point that you're going to stick to is you can't give us the number.
No, but it's going to be different numbers throughout. It's going to be non-continuous.
Okay, what about this? What about this measurement that we're taking right now?
Like it's like if Earth is like hold on, if you're on a ball and Earth is just a ball and it's bending, and it's curved and light is curved. Yeah, if it's curved, if it is curved, if refraction, if you're on it's on a curved surface and refraction is causing it to bend downwards, and it's non-continuous.
So
what that means
to validate those claims.
Hold on. What we're talking about is whether or not this could be refraction. You asked what refraction could be necessary.
Would have, should have, could have. If you are claiming light is following a ball around, bending downwards, as you pointed out, you can show us either photographic or video evidence of one of these lasers bending downwards, conforming to an 8" per mile squared curvature rate. If you can do that, I will happily listen to you and your quote-unquote proofs of refraction all day long. I won't even interrupt. And I'll smile whilst doing it. Please provide this laser bending downwards.
Yeah, because right now
open air, laser bending down. You can do it.
Yeah, because you're not on the ball yet, and you're saying that this, the thing that AI presented to us, which is the FE core, which is a laser that has been shot and hit its target.
I didn't even get to the AI yet, but we'll go on.
Okay. That hit its target. You're saying that's due to refraction in the laser beam that's actually curving around to hit its target, or actually scattering. So you should be able to show that even in this example. But right now, you don't have a ball. You haven't proven a ball. You haven't proven curvature yet. So you can't assume curvature and say, if curvature, then this. You can't assume that at all. You have to tell us the specific refraction point, actually describe it and define it, and say why is light bending to the point where it appears if the laser beam hits any target is due to the Earth being curved. The laser beam is actually going with the curve of the Earth.
Yeah, and I'm trying to explain to you that there's going to be many different points of along the path where it refracts. So by measuring the first and the end, that's not enough. I can give you one number alone is not going to do it, because if it's refraction that causes it to. We're testing hold on, whether or not refraction can explain the fact that laser hits it. Okay, am I able to speak or not?
So you're lying.
Can I speak or not?
You're saying the exact same thing, and you're giving us the same bullshit.
We're seeing whether or not refraction is the cause of the laser hitting the target.
Great.
And if it's refraction, assuming that the Earth is a completely flat, level surface, is a false assumption to test whether or not it is atmospheric refraction, which is inhibited by a curved Earth.
So Glover, you don't know what refraction is, Glover.
You're not falsifying refraction.
Glover, the more refraction, the less you see,
this
Glover.
Is one of the basic methodological issues, that they're not actually testing refraction.
Glover, you don't understand refraction, Glover.
They just don't understand it.
Glover, you don't understand what refraction is, just so you know, Glover.
Aren't you guys tired of this after 5, 10, 15 years of the same shit all the time?
Yeah.
Oh no, we get new special eds in daily. Example, let's go, Joe.
Shit.
It's actually quite entertaining.
Yeah.
Okay, JJ. So do you have a counterexample that does take these confounding factors into account, that validates that there is such a thing as Earth curvature and a geometric horizon? Do you have that?
Yeah, I've given you stuff before, but because it just freaked out.
But it's got to be analogous. It's got to be like a laser test, right? Because we're talking about laser tests. So do you have one?
Yeah, I'm pointing out the massive methodological flaws in doing
No.
this.
Just answer. You've got to answer my question. Okay, so I understand what you're saying about how you could have, say, a pocket of hot air or a pocket of cold air at, say, 4 miles, and then at 10 miles you could have a different pocket of air, and it could affect the way that the the light's traveling across, right, from point A to point B, but they only took measurements at point A and point B, whereas there's all of these other points in between that could cause deviations. Okay? Valid point. Fair enough. Okay? It's still hitting the target over all of these different tests. That's why they didn't just do one test. They're doing a stack of different tests. So if you're saying the laser's doing all of this crazy shit between point A and point B and still hitting the target at the other side, that's a pretty crazy claim. So maybe you should be the one that has, that shows something that does take all of these different points along from point A to point B into account. Okay, so you've established that you have a very reliable idea of what's going on with the refractive index between point A and point B, and it aligns with the globe, right? But I know that you don't have that, and I just want you to admit that, or show that you do have it, and then we can go over it.
Yeah, but he doesn't even have the globe. He hasn't proven it yet. Nor have he even established that yet. The only thing that he has is refraction. But he has to somehow prove to us and show us, right, something specific about refraction and give us the scale of this refraction where it will cause the light to bend to a point where it will follow a radius value of the globe. That's all I'm asking. I mean, I don't understand on why that's so hard for him to do. You don't need a bunch of numbers for that.
So JJ, do you have what I asked you for, or don't you have it? Don't say that you've tried to give it in the past or something like that. Like, do you have a counter laser test that does take these variables?
Friend. He doesn't have
I know
shit,
that.
friend.
I want them to admit that, though.
No, they won't. No, he doesn't have shit. This guy.
There you go. If you're just going to talk over me.
Listen, I haven't... Sure. Listen, y'all was talking and you started talking over me. Shut the fuck up. So these like always, these globers, what they think is refraction is...
Yeah. Water is the globe killer, really. I mean, it has to be curving at a specific rate. Like any large body of water anywhere on the Earth would have to be curving at pretty much a specific exact rate over distance. Okay, so 10 miles is going to have approximately 66 foot of curvature if the Earth's a globe. And it's just not there. So I get your question when you're talking about they have an explanation for a whole bunch of questions that people have because they're making a specific shape claim. But flat earthers could just make up some shape, right? And that would be more ridiculous than being honest and saying nobody knows that, right? Nobody that we can verify has ever just kept going south to see what happens. You probably know about the Antarctic Treaty as well, right? You can't just keep going south and work out exactly what happens. It's dangerous, and it's also illegal to do it freely. And if you get the permission to do that, then there's a whole bunch of crazy rules that come along with having that permit, which basically make it near impossible. Now, you would think that someone would have just kept going south, right, and circumnavigated the globe and come back around to where they started again, if it was a globe, right? Considering countless people have done east to west circumnavigations, which would work just fine on a flat or a globe Earth. But not knowing the shape of the Earth, it's not saying that it's not a shape or that it's infinite or anything like that, right? It's just being honest and sticking with empirical evidence. Now, we can easily debunk the globe because we've got thousands of long-distance observations, laser tests, and things like that, which you've seen obviously some of. But explanations don't mean anything if you can't back them up with empirical evidence. Surely you agree with that.
Right, and I think the evidence for going around the globe is fairly, inconsistent because there's way less documented going around north to south than there is east to west and stuff,
Yeah, there isn't any. There isn't even any claimed proper like no one's ever done a great circle north to south. The only ones that have been claimed have been ones like One More Orbit in 2018 or 2019, where they went down from the north down to the south, and then they turned around and went back up again. That, and then they got given the, circumnavigation.
If it was so doable, they would do it today. Just since they have thousands of airplanes and stuff, they would just do it to prove it to flat earthers. Why don't they just do it to prove their point and end the argument? They don't do it probably because they can't. Yeah, that makes sense.
Exactly, and also just not being able to find any curvature. There's just so many long distance observations that just completely destroy the globe. They're impossible on a globe. Literally. And they don't have one observation throughout all of history that actually matches up, right, with the curvature of the Earth. And says, oh, look, here's an observation over 20 miles. Here's the curvature. Here's the horizon where it should be, and so on. We've accounted for all of the weather conditions, blah, blah, blah. Here's consistent observations that match the globe. Like, there isn't one. Not that one would do the trick, right? They would need to be repeatable.
Good point. Because I always think, sometimes there's flat Earth calculations of this building is this high and you can see it. Well, if the globe was true, anywhere you go on the globe with any building or any mountain or anything, you should be able to calculate if I'm, 200 miles away, I can only see the 20% at the top. Or if I'm 300 miles, only the 10% at the top. And they would just make photographs with these numbers, but there's like zero of them that I know of and stuff. It seems to show quite obviously that they can't do globe Earth math, even on this planet, which they say is the globe Earth.
Yeah. So they do claim to know the shape of the Earth, right? And that's cool to have an answer, a response, an explanation, but it just falls on its head. Because the pre-requirements to have that globe aren't there, like Earth curvature.
Experiment all the time and prove you can see something that's too far. Shouldn't a globe earther be able to do an experiment that says you see 50% at this distance, 75%? But there's zero examples of people posting that information on the internet.
Yeah, exactly. That's because when you actually go out and test, which is what we encourage people to do, you either become a flat earther or you just kind of bury your head in the sand or don't release the observation to the public because it didn't work out for the globe.
Right. The only pictures of curvature are those that they present from outer space, allegedly.
Yeah. I agree with that. I think that's true. It's always from a satellite. The planes and people on airplanes and mountains, they never see any curvature.
No, they'll show you. Oh, go ahead. Sorry, TG, I didn't mean to take over.
No, you're right. Go ahead.
They'll show you images of inferior mirages on a horizon and try to pass that off as Earth curvature. All the time. And we can prove that those are inferior mirages, which is what you'd expect to see on a flat Earth.
Mm-hmm.
Anything from boats to windmills to mountains to you name it.
Yeah, mirages are everywhere, right? Pretty much.
Yeah, I mean, think about it. Physically, geophysically, you're staring, you're gazing far with a very narrow angular field of view onto the horizon. How much information is packed into that very, very narrow angle? Let's say it's maybe 2 or 3 degrees. How much information is there? You could be staring tens of miles away, which means there are potentially, like thousands of feet squished into that very narrow angular size. What information about the Earth is happening within that narrow band? You've got a warm surface that's heating up air molecules, causing evaporation. You've got water vapor that could be condensing if it's getting cold. You've got a gradient stack of temperature potentially several thousand of feet high, that goes from, I don't know, let's say 80 degrees at the surface to 40 degrees to the tip of the peak. All of that is being compressed into a tiny, narrow field of view. And all of that is affecting the path of light to your eye from that tiny, narrow, angular field of view. And the literature is quite clear on how this affects what we see. You've got a temperature inversion that is happening in a very small angular field of view. You're going to see all kinds of wacky things going on. Turbulence to start, potentially multiple instances of total internal reflection depending on what you're looking at and your angular relationship to it. And all of this is contributing to what is ultimately an image that isn't true. And the very fact that you can see it is killing the globe. The very fact that they can't show you that this is Earth curvature is killing the globe. You know what nobody ever sees? A refracted horizon of a boat going over the curvature of the Earth. Nobody ever sees a mirage. You know, maybe a superior mirage of a boat going over a curve, or an inferior mirage, or Fata Morgana of a boat going over the curve. Nobody's showing that. Within surveying literature, using theodolites to survey the Earth, they tell you, like, listen, these things aren't built to go measure distances, angular relationships on the horizon. The air is just too freaking chaotic to do anything useful with. You're supposed to use incremental steps, leapfrogging.
Try telling Jessica at the live that.
Yeah, I know. Their own manuals. I got this thing from Harvard from their like geophysics department or whatever it's called on surveying techniques that outlines this exact process and says you're supposed to use a graduated scale. You're supposed to basically take surveying rods and survey the distance to each of those rods from each of those rods going out, so that you have an incremental measurement and not this entire measurement without that incremental scale in order to increase your accuracy. So our argument is and always has been that the horizon and the effects that go on is optical and subject to meteorological effects, geophysical effects that cause distortions, and the globers hijack this and say that's proof of Earth curvature. We say, well, okay, if you got Earth curvature, show the Earth curvature plus the known meteorological distortions, optical distortions that we see on the horizon, because both must be present, and they can't do it. And some of my favorite observations are done with infrared, which just cuts through much of this distortion, the vast majority of it. You can see through the haze. You can see light from where it actually originated instead of the altered path that it takes.
Isn't it supposed to be backwards, Yoder? Isn't it supposed to be backwards on infrared? Like you're supposed to see less instead of more? Because of the wavelength of light that...
Yeah, on a globe, you should be able to... It should be limited by the curvature of the Earth. Your distance, right? Because they claim that without infrared, we're seeing a shorter wavelength of light, which is subject to greater optical distortion, which allows us to see further. So if you pop on infrared in the glober's mindset, maybe you should be able to see less. Maybe your vision's now being obstructed by the Earth curvature. But that's not what happens. We see way further in infrared instead of shorter. It's insane. And everybody knows, right? Like, listen, if you're doing a measurement, or if you've got like a military weapon capability, or you're doing some kind of communication with optics, you want to use longer wavelengths. You want to use infrared because it just doesn't give a shit about what's in the way. So yeah, I'm still waiting for Globies to show us infrared long distance observations of beautiful Earth curvature that should be popping out in all of its glory, and it's never been done. Instead, we have hundreds of examples of the opposite.
Okay, you got me. That makes sense.
Yeah.
Infrared seeing further and further. If the normal doesn't see it, infrared should see it. Infrared doesn't see it, there's probably better systems. Where is the curvature of the Earth in any sort of photograph, photography, or video?
Yeah, it's never present. One of my favorite discoveries I found this about 2 years ago.
Good point.
There's NATO. There's a NATO contract called NATO Sapphire. Sapphire contract was funded by the U.S. Department of Navy, and this was for NATO's benefit, where they had two teams of military surveyors come out, one from Germany, one from the Netherlands, to the Chesapeake Bay, which is kind of like outside Baltimore, Washington, D.C. And what they wanted to do is they wanted to examine the optical distortion that takes place just above the surface of the water so that they could develop better models to develop better predictable paths of light that propagates just over the surface of water. I can only imagine what this might be for, like, maybe satellite communications with submarines or something, or who knows what. But anyway, they wanted to study what's called the marine layer. And so these military surveyors went out and they took infrared cameras, infrared theodolites, and infrared flashlights. And on one side of the Chesapeake Bay, they set up a tripod purposefully to be just behind the curvature of the Earth. And they called this their control. And then they had a tower. It almost looks like a ranger tower, like you'd see in an observation tower in a national forest. And they mounted lights going up this at various heights. And they set up their theodolites to measure the distance. And then they set up an infrared camera to record everything, daytime, nighttime, 24/7. They said in their report back to the government that the situation was cursed because the control light that they set behind the curvature of the Earth was visible in conditions that presented no reason for there to be any refractive effects whatsoever. They could see the damn light behind the curvature of the Earth in infrared. And they couldn't make it go away. And this is fucking up all of their mathematical models. They said in their own paper that in order to account for the curvature of the Earth, they had to artificially inflate the difference of temperature between the water and the air just above it by 1 order of magnitude, by a factor of 10. The real measured differential between the air and the water was 0.1 degrees Celsius. It was really cold. It's like the dead of winter. But they had to say it was 1 degree Celsius. They had to move the decimal over one place in order to make the model work. They had to backfit the data, the observation, into a model, dude. And this happens over and over and over again. You can go into our search bar on our server and type in Sapphire, SAPPHIRE, and probably find my posts on this stuff. I've got all the PDFs, I've got screen caps and everything else. And it's just illustrative of what's going on. People say, why would they lie? I don't really know if lying is the right word. These people aren't like secret flat earthers trying to deceive people into the globe when they go out and do this. These are people who just believe in the globe and they're like, what the hell's going on? Well, I guess we don't fully understand the nature of Earth and we can just backfit our data into a model and call it a day. So,
yep.
Yeah, this is a problem, dude. It's almost worse. It's almost worse than a conspiracy theory. What makes it almost worse is the fact that I think it's more of a black pill that the whole world has gone mad with this urban myth of the globe. And to deny what's right before them in their very eyes in reality. I think that's worse than being controlled by a cabal in a back-filled, smoke-filled room.
You're crossing me just a little bit because you say the whole world has gone mad with the urban myth of the globe. And
yeah.
I believe that, except for that, the smartest people in all of science are involved in the lie. Are they smart because they're liars?
What lie?
Involved in the lie?
What lie, dude?
How could they all be mad at the lie of the shape of the Earth?
I don't think it's a lie. That's what I keep trying to say. Like,
well, like, I'm
shift
sorry.
your thinking.
I probably didn't say what I was trying to say just right. So, you think the whole world has gone mad and they believe this urban myth, but
yeah,
surely some people are smart enough to know whether it's true or false and are easily likely passing off the false story as true because it gives them some benefit. Like NASA, for example.
Yeah, well, some people at NASA probably know.
The planets, they'll pay us to go to the other planets.
You know, you're talking to some of those people right now.
Okay.
Yeah, those people you're talking to in this chat right now.
The people who believe.
Took the words right out of my mouth.
People who believe.
The people who realized something was effed up and didn't speak up about it and just took their paycheck and went home.
Okay. I believe that. I think people can just go with the lie, whether or not they know it's a lie, just because they think this is easier. I'm not going to harass people about it. And other people might care about truth and stuff.
Yeah, but so what about those guys? Like, we only care for those who like actually want to come forth and have a discussion about it. Like, I mean, of course the world's filled with those types of people, but you have to be one to stand against that. Like, I mean,
right.
You know, you can't really fault their character too much because they're surrounded. Okay, there's one part of them that feels maybe a little bit scared for speaking up, and another part of them that has tried to be humble, adopt a tone of humility. An entire industry of people who think otherwise. Maybe I'm the one that's wrong. I mean, to me, that is a positive character trait. And it keeps people from speaking out, unfortunately.
Mm-hmm.
Right?
Right. People don't want to speak out and, you know, be questioned about their beliefs and stuff, when it's much, much easier just to pretend that you're like everybody else and believe what you believe.
it's called a sunk cost fallacy. So everybody who's doing that, they can't turn back anymore. Like, there's a gentleman who comes in here every now and again. His name is Josh. I don't know if you heard of him or not, but he works with the Kuiper program on Amazon. And, you know, he challenges what we say in here. But I think the reason why he likes coming back here is because he kind of does deep down inside know that what we're saying is true, because he's been challenged many times. He doesn't know how to prove to himself that, and to any of us, that the Earth is a globe, which is an extreme challenge for him because of where he works, you know. So, like, what else is there to do, like, in somebody in his position, other than just like kind of hope, you know, that some breakthrough happens and, you know, they come out with it and said that the Earth is flat or something. But other than that, like, he just, I don't know, keeps coming back in here, never really has much more other than what he's presented, and it's kind of sad, I think.
It is sad. It is sad. And, you know, people don't really understand what the open, unclassified history of NASA is all about. You know, a lot of flat earthers you'll talk to and you'll hear from almost talk as if NASA's primary mission is to hide the flat Earth. And I don't think that's the case whatsoever. I think that is an outcome of what they're doing, but what they're doing is completely different. What they're meant to do is completely different. I think NASA is full of people who believe in the globe, and at the very top, there are people who know that they never succeeded in orbiting a satellite around the globe before. They don't know that the Earth is flat is the reason. And they're still trying to work on doing that today. And secret little projects, compartmentalized, are still trying to figure the shit out. But they haven't done it in the way that they describe it.
Figure out how to do it, or that they're going to eventually figure out that it's, like, impossible. Because people like us, we are not scientists, we are not mathematicians, not all of us, maybe some of us, but most of us aren't, and we find it unbelievable based on some stuff we read on the internet about the math or about the physics that says it'd be impossible to fly in space and stuff. You know, if we lay people without, you know, any schooling about, you know, rockets and gravity can say it's obviously impossible, shouldn't people who learn a lot be able to tell it's impossible, or are they like tricked because they learned the wrong thing?
Well, let me give you an example, okay? There's a symposium in the 80s, and this is absolutely relevant. A symposium given by a doctor, a professor of astrophysics, not really astrophysics. He's a professor of like a plasma physics, magnetophysics. Dr. Hannes Alfvén was his name. I think he comes from like Sweden or Switzerland or something like that. But he gave this conference called Double Layers in Astrophysics, and there's a PDF called Double Layers in Astrophysics that came out later that captures basically what they talked about. And it shows who, within this document, by the way, is a plasma model of Earth that's flat to simulate the plasmasphere, but that's another topic. He writes here and says this when he spoke to the audience. Dr. Azar, this is just some other guy, has studied how a number of the most used textbooks in astrophysics treat important concepts like double layers. This is the plasmasphere, right? Critical velocity, pinch effects, that has to do with magnetic field lines coming together, and circuits. He has found that students using these textbooks remain essentially ignorant of even the existence of these, in spite of the fact that some of these astrophysics students have all been well known, or all of these that all of these effects have been well known for half a century. Okay, so these astrophysics students come through schools, he says, and they don't understand the basics of like electrical and magnetophysics, magnetohydrodynamics. He writes further, the conclusion is that astrophysics as a field is too important to be left in the hands of the astrophysicists. The billion-dollar telescope data, which space telescope data, right, must be treated by scientists who are familiar with laboratory and magnetospheric physics and circuit theory, and of course with modern plasma theory. At least by volume, the universe consists of more than 99% of plasma, and electromagnetic forces are 10 to the 39th power times stronger than gravitation. He's addressing NASA people right now, telling them that your self-orbiting gravitational satellite bullshit is all a fraud.
Yeah, it is. Why do people fall for that at all? But you know, smart ass people in schools, do the schools teach them to lie, to have the fake version in their heads? Or are people who graduate school really not that smart and just fucking fall for this shit and believe, you know, what the mainstream is putting in their heads for reason of lying about the Earth?
Yeah, it's idealistic. These are idealistic constructs, man. They're mathematical constructs. They don't have no coherence in the physical world. So like that's what Yoder is saying. He's like, basically, if this guy was actually talking to the folks that would realize that, you know, what they're looking into with gravity and that is not real, then they would apply I don't know, how does that even go about, Yoder, that he even proposed that to them and they denied the fact that it had any merit? Like, I don't get that. Like, why would they?
What I've seen is this. Like, you go through school, maybe you take like AP chemistry, AP physics in high school. If you're lucky and want it badly enough, maybe you get into physics in college and take first, like freshman or sophomore courses. What you begin to find out is things start to get really weird and confusing. If you are smart and paying attention, you're going to be bothered by the fact that there are multiple definitions of mass that aren't very clear, that conflict with each other. There are multiple definitions of gravity that conflict with each other and aren't very clear. You move from wanting to learn and critically examine what you're thinking into a mindset of trying to memorize formulas and pass frickin' tests to get through it. And you accept potentially with humility on your part that you don't really understand this stuff. You feel maybe inadequate next to your peers who pretend to. And if you're lucky, you come out of these programs on the back end with a degree. Potentially you move into engineering where things are more practical and more hands-on, and you don't have to revisit these concepts in such a way ever again. That you move more into the applied part of it, and everything starts to make sense a bit better again. But some people stay within that abstraction of physics and maybe become like astronomers and shit.
Willful.
Yeah, that doesn't sound efficient at all, man.
But a lot of people get frustrated and they quit. They wipe out. They're like, maybe I'm just too dumb to understand what the hell mass is.
Yeah.
You know, how come I read in some formulas, it looks like gas molecules are affected by gravity, and in other formulas, it appears that they aren't. Why does it seem that gravity can violate entropy in some cases, but in other cases it doesn't? And so people have these questions, students debate with each other, and some people just get mad frustrated, say, you know what, fuck this, I'll go into computer science or something.
Mm-hmm.
So how many good potential physicists and engineers have been turned away by what this has become?
Yeah, they are almost like people who say, oh, I'll never commit any sins. I'll be a good son or daughter, mother or father, because, sorry to be creepy or weird, but, people who just fucking follow the Bible, or not follow the Bible, but they're just gonna lie and say whatever it takes to appease whoever might, take away their privilege to go out that night, or graduate, or get dinner or food. I don't know. You know what I'm saying?
I know what you mean. Let me read to you two passages, and then I gotta go. I'm already a bit late. Two passages from National Security Council Memo 5814. This was in 1958. It was one of the founding documents for NASA. The scope of this policy. This policy is concerned with U.S. interests in scientific, civil, military, and political activities related to outer space. It deals with sounding rockets, Earth satellites, and other space vehicles, their relationship to the exploration and use of outer space, and their political and psychological significance. Next paragraph goes on. Outer space presents a new and imposing challenge. Although the full potentialities and significance of outer space remain largely to be explored, it is already clear that there are important scientific, civil, military, and political implications for national security, including the psychological impact of outer space activities, which is of broad significance and national prestige. You think it stops there? There's another section that I want to pull up. Further down, there's actually a paragraph titled Psychological Exploitation. The last sentence of this reads, in the near future, while the USSR has superior capability in space technology, judiciously select projects for implementation which, while having scientific or military value, are designed to achieve a favorable worldwide psychological impact. Next, on reconnaissance satellites, further down. In anticipation of the availability of reconnaissance satellites, which had been invented yet, seek urgently a political framework which will place the use of U.S. reconnaissance satellites in a political and psychological context most favorable to the United States.
This is NASA documents?
Yeah, NSC 5814.
Well, it's National Security Council, not NASA, but yeah, close enough.
No, this is before NASA was founded. Includes, I got a suite of other documents where, the first panel that met together was headed by freaking CIA staff officers. This was organized under the President's Psychological Operations Board that was formed after World War II. That's what NASA flowed out of. It's all about projecting power, technology, and capabilities that put the U.S. in the most favorable light. Do whatever it takes. And you can read between the lines. I got to step out, so I'll talk to you later.
Use that word to step back from saying we'll do it for real. If it's psychological, then it just has to be what they believe, not something we really did.
Counterintelligence. Stay blessed, Yoder. We'll see you around, man.
Later, Yoder.
Yeah, just to go back to what you were saying earlier, Shine, about why don't some highly educated people, or the vast majority of so-called highly educated people, know about this? It's because they quite often get their degrees from learning textbooks, right? Repeating, memorizing, regurgitating information that they were taught at university by their professors and from their textbooks. Not necessarily questioning the core fundamentals of their textbooks, right? So they already thought the Earth was a globe, reinforced from a young age, all the way through university. And now all of a sudden they're studying some hyper-specific topic related to a specific subject. They're just going to go deep into that. They're not going to go to their professor and say, oh, how do we really know that the Earth's a globe in the first place? Who actually went and measured that? Right? That's not something that's going to come up. That's probably nothing that they're even going to think about. And when they come in here occasionally, or when we do encounter them, they don't really know these questions any better than most people. They're not that good at answering the specific questions that are related to this topic for the most part. Sometimes they'll be more honest in admitting what they do and they don't know as well, and what scientists do and don't know. Whereas someone that's less educated might think that certain things that haven't been scientifically proven actually have been, right? And they'll argue that to the death, even though a mainstream scientist will actually say, well, this is the best we can come up with. We don't actually know for sure, but this is where we're at, right? This is our current understanding of this.
Yeah, I agree. What do you think is the significance of all that? Do you think that, what do we have to trust? If we can't really trust our schools to be making people smarter and stuff, who do we go to? What do we do? I mean,
No, that's too broad, though. I don't think anybody's saying that. That's a bit much. We're saying that the information concerning the Earth being a globe. So when you say that was a bit too broad for it to be a general statement, why, trusting school, reading, writing, and arithmetic, that's important information that you need to learn while you're going through school. Language skills, that sort of stuff.
Or whatever, because I liked, elementary school subjects that felt useful and they contributed to my knowledge, and stuff beyond that mostly just felt it's a very specific fact that only some people know. Oh, it helps you in this, but not in that. And it just felt kind of man, these things are a waste to teach people in school because it's not even that helpful. Everything I learned earlier on, I've used my whole life long. Stuff in college and stuff, it's, interesting knowledge. Some of it's specific and helpful, but it's not stuff I use every day, unlike stuff I learned very early in my life. Math, history, language. Stuff in college was more philosophy, history, technical style. And just nobody seems to care about it unless they studied the exact same stuff that you studied in college. Most people don't even care. It's the most useless knowledge in the world. Anyway.
Well, yeah, it gives a person a more broad understanding of the world around them, doesn't it? So it's not just specifically those things that I mentioned earlier, but the ones you mentioned. That's helpful in creating a person's character. Because you know a little bit of history, you know who you are. In this country that you live in, or supposedly, right? Because everything that we hear about, we at least have to know like things about our world. So that's what it's doing. It's helping us understand who we are, building our character. So education is not a bad thing. It's certain things about it that are bad, right? So like that's what we would say. So in and of itself, in a general case, I mean, obviously you want somebody to be more learned than not, right? That's everybody should advocate for that. Anyway, I don't like the whole, don't send your kids to school because the school is the devil and that whole thing. I don't know. It doesn't jive with me well.
Where do you live? Like, is where you live somewhere where the government might have conceivably like rigged all schools to discriminate against truthers or something like that? Because I live in California. It feels like, yeah, Democrats run the whole state. They probably also rig your experience in college and stuff, and the teachers are part of it, and the administration.
Yeah, I mean, I hear you. I know what you're saying, but
politics graduate.
I mean, but that's why people that are capable can disagree with that, right? If you
are you from somewhere?
I mean,
else?
this world that we live in the U.S.
University, if it wasn't just California's universities.
Yeah, one thing we shall say though is that there should be a robust environment to have a disagreement with somebody and not just like all be one-sided one way or the other, right? That's not what we want.
Yeah, I also agree, but I don't think college let me do that. I feel like college was super unfair. Did you go to college somewhere where it was super fair?
No, I never went, but I know people who have, and their experience is kind of like what you're saying too. Like I think it's more like the general case that everybody feels like, well, what are you studying for, right? Like, but other subjects, like that they study for, it's like, I don't know. It's not. It's really just like one-sided, one way to think, and like evolution and the cosmos and all that's being taught to you just kind of like a standard model. You don't get to freely think about it for yourself. It's a curriculum.
I don't know if you care to learn what I learned in college, because a lot of it, especially in science, was BS stuff, in my opinion. It wasn't shown through any experiments, was taught through packets and textbooks and stuff, and the students didn't get to ask a lot of questions. When it came to other classes, there was more questions and stuff, but no, not a lot of questions in history and science. I guess you just have to take what they say for it. It was very disappointing, and I thought it was less informative than high school.
You got to treat the education system like the welfare system, okay? It's just because they're giving it to you doesn't mean it's right, doesn't mean it's good for you. You have to, life's not fair. You have to get out there and do it yourself and take care of yourself. And if you just assume that the welfare system is going to teach you the right things and give you the food whenever you need it, then it's not going to work out well for you.
Yeah, I mean, we had to learn about, red shifts, blue shifts, planetary history, elements in space. This was all in a required course. It wasn't one I didn't pass or anything. No, I didn't pass, other courses, but science, labs, I could do it, especially when it was in my first few years of college. But I just felt like the information was kind of BS. It was just all in the packet. We did a couple of experiments to prove a couple things, but it's not like we were about to prove the red shifting of stars or, gravitational pathways of planets in the class. So it's not like it proved astronomy to me or anything. Just a couple of scientific facts, and then a couple of scientific, made up facts, and then they pack it into a course and say everybody has to take this and stuff. And of course, you probably learned the fake scientific facts even earlier in other schools and stuff. I don't know, no one was questioning the system. No one was saying, how could that be true? They all just said, yeah, this is what we're learning. Sounds true enough. Okay, we'll go with it. But in specific classes on specific subjects, people did sort of question the information and say, is this really right? Is this the best way? What if my own interpretation is better? It just didn't happen a lot in science labs or classes about, macro topics like the whole universe or all of history or anything. I don't know. It was disappointing, and for many, many reasons. But one of those was, I've always had stuff to say about everything. And people in high school and elementary school cared. In college, everyone said, shut up, you're ruining it by talking. It was like, we can't do anything we want anymore. We can't take this where we want. I thought this was supposed to be like the land of intellectual freedom or in a university to discuss higher ideals. But it was like worse than high school. It's like, oh, you really got to shut up about this or that. Oh, you can get in real trouble instead of just high school trouble and stuff. It's like they were just threatening us with ruining our lives and trying to ruin our lives. Maybe it's different if you don't go to college in America or California or anything like that. I don't know what college is like for other people, but for me, it felt like a big trap for people who thought they might have important things to contribute to the world. A way to find them early and stop them from becoming all that special or anything. And it takes kids away from their parents and stuff. It's got to be one of the worst things. If kicking out your kid at 18 was good, some parents do this. Their kids, do drugs or drink. They're like, we're not providing for you anymore. Well, college just isn't that different. It's like, you're still our kid, but have fun doing everything on your own for 5 years when you're just out of high school. It wasn't that fun. It was hard. Anyway, what are you guys all thinking about?
I was going to say, I have a different perspective.
Once I left college. Do you think it's unfair because they want people to lie about space and stuff? Do you think it's unfair because they don't accept questions? I mean, look, YouTube and stuff doesn't accept questions. I've been trying to get them to tell the truth about space and stuff, but the way the videos are, it's never telling the truth.
Yeah, that word truth. Yeah, you're going to find out that it means something very different to a lot of people. So to you, it might mean, why don't they just come out and tell people how it is? To them, it's like they want to tell you about the narrative, and that's truth to them. So, that word, for everybody that's using it has a different connotation. It shouldn't have a different connotation, but it does. But what were you going to say, Josh? You were going to tell us about your experience in college?
No, I'm just saying I really enjoyed school, and I found that it was there was definitely tons of opportunities to ask questions and debate with the professors. But I'm also pretty biased. I did 8 years of college, so.
You like school?
What was younger school like? Was it the same? Because for me, it was a downgrade from high school to college.
But I also went to the second best aerospace engineering college in the country. So sorry, what?
Was your elementary school and high school better or worse than your college? You sound like you had a good time in college. You see, I think I had the opposite. I think where I was, college was the thing that was mostly rigged and stuff, and elementary school is and high school where you got to speak your real mind. And then after that, it was the whole culture is just trying to identify individuals who might be hostile to liberalization politics here.
Yeah, I was going to say, I took tech policy courses where it was all Socratic seminar. It wasn't even a lecture. It was just, hey, you need to be prepared on this topic, and we're going to just discuss and debate opinions on the role of the federal government in basic research and development funding, and why is the budget of NASA the way it is? How do we quantify the economic and societal benefits? Like,
you guys talk about that?
Oh yeah, 100%.
Yeah, well, can you enlighten me on that topic? Like, what was the discussion that you remember? Anything about it?
Specifically NASA or the role of federal government?
Yeah, well, NASA and their their funding, their useful their money. Like, what were you guys thinking of?
I mean, on one hand, it's a jobs program. On the other hand, sorry, I'm like trying to wolf down my breakfast. On the other hand, it's a lot of basic R&D and patents and inventions come out of NASA. So it's it's an economic multiplier, like Velcro, memory foam. There's a ton of material science benefits that come out of NASA funding. So it's the combination between those two make up the vast majority of the economic.
Yeah, was that done by engineers like in space flight?
Stuff that Yoder was talking about.
You lagged there for a bit, so I jumped in by accident.
No, you're good.
Most of their funding, was it done to fund like those products that were made by, you said engineers, right?
Yeah. So it's like NASA.
All that stuff.
So there's like the Science Mission Directorate. There's the Space Technology Mission Directorate. Like the way it's organized is they have like their own missions. They do a bunch of ground testing and like figure out if the payload works, and then they work with like the astrophysicists to figure out what type of science they want to do, what questions they want to go answer.
Hey, Josh. No, I mean like the products that were made, like the ones that you just discussed, like foam and all that stuff. Like, was that useful? Was that useful? Right. Was that made because they went to space, or has anything to do with that, or
correct?
Was it just something that they really? Go ahead.
So there's an office within NASA called the Technology Transfer Program, so basically anything that's federally funded. If they come up with something that could be useful in industry or like commercially, there's like a whole program where you're able to like transfer the IP over to the public or to like the inventor who was a civil servant at the time. They like let you keep your patents, etc. But yeah, no, Velcro was made to like stick stuff to the walls of the space station without it floating away. Like it was invented for the ISS.
Really? Who was the inventor of it?
I have absolutely no clue. But the patent is held by I think it's public domain at this point. But the original patent was held by a NASA employee.
I mean, you could use Velcro like on a hunting backpack whenever you're hiking up a mountain to hold your water flask to your backpack. Why is it only designed for the ISS? Like it doesn't make
originally
sense.
Designed. Like it didn't exist before that, right? Like Velcro didn't exist prior to it being invented. Like the concept of having a bunch of little plastic hooks on one side and like fibers on the other. Like it was, I can dig into it later today if you'd like, but it didn't exist prior to it being invented at NASA.
Oh, okay.
But yeah, no, college is great. I dove in head first and really got into the nuts and bolts.
Should have been a professor.
Nah, fuck that. I don't get paid enough for that shit.
Yeah, but you're not doing it for the pay, dude. You're doing it for, the satisfaction of teaching younger generations.
I was going to say, like, if money was no object, like people ask me, like, if you won the lottery, what would you do? I would definitely be like a high school physics teacher. That would be my jam. But no, you have to get a doctorate to get to be a professor at most places, or unless more than an adjunct. But so I have the ability to adjunct at Georgetown and GW here in DC. So I'll go in and guest lecture once or twice a semester for different classes. But no, if I was going to teach a full class, it would either be, I don't know, when I'm empty nesting, the kids are out of the house. At some point, yes. I just don't have the patience to go get a doctorate. Like I just got master like a bunch of different master's degrees. I didn't stick around for a PhD.
So you have a bunch of master's degrees. How many do you have exactly?
Teach the flat Earth in a class, anyways. It would be against the rules.
No, that's not true. We talk about reference frames and projections, and we talk a lot about it. We took there's a class in undergrad at Georgia Tech called Spaceflight Operations, where we covered a lot of that type of stuff about how you get from the model to what you observe on the ground.
They wouldn't let you say flat Earth or talk about flat Earth at all if you had a class.
No, I disagree with that. We fundamentally have those conversations.
How does it end whenever you're trying to find the curvature, by measuring the ocean? Like, how do those arguments end?
From a human perspective, it's flat. I concede that point. But it's three degrees to answer your question.
Okay, nice. But how could it be from a human perspective? Like, is there another perspective that it eventually becomes a ball?
We're too small.
From the astronaut perspective.
You gotta take a step back from the painting.
Oh, so you just have to go higher. So you can't see the curve from sea level, but you can see it whenever you go up in a weather balloon.
No, further than that. Y'all keep asking for the exact height. I really should actually do that research, but it's.
Yeah, you should. Elon Musk, or not Elon Musk.
Hey, so
go ahead, Dan.
I mean, he said he was an aerospace engineer. I mean, I thought that they would know that, like, right off the top of their head. Like, boom, 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 here it is.
Whoopsie.
No, because focusing on the curvature of the Earth is, step 2, right? And we spend most of our time working on, like, step 8.
We can pass their class, but they can't.
Oh, Josh. Go on now.
But
no, I'm just saying, I haven't done the research.
You gotta be a special person to get the job.
Oh, we talked about that in nepotism in here, and like who you know, etc. Like, I told AV I applied for a job in my life.
Look, if I was in John, I would feel the same way, because he spent so much time and money on his education, which is fine, and he probably is going to have a great job and all that. But for somebody to try to crush his all of his investment into this by saying, where is it curving? I mean, I would probably be doing the same thing. I mean, that's why these professors flip out and have like a spasm or a heart attack whenever these kids are like, where's the curve? Because their whole life they've put into this education, into their job and their tenure. I mean, that's the whole thing. That's why the world works the way it is they compartmentalize us. It's all a part of the system.
You can't say it any better than that, Dib. Yep.
Yeah. Go ahead.
I mean, the man's making bread, right? We know that. Josh is making bread, but outside of that, he's got to live with the fact that even if he does know that the Earth is flat, and whatever we present here can't be proven that the Earth is a globe, he still has to go to work in the job that he's doing, no matter what. Like, because he's committed, right? He's given a lot of time and effort into this that he's no turning back now, right? He can't turn this ship around, bro. He's on a one-way direction. That's it. There's no turning back. So he's going to have to do his hardest to keep the same, facade going for as long as he can.
I mean, if I really wanted to do self-preservation, I wouldn't be having this conversation with y'all.
Yeah, well, dude, that's all mental, Josh. That's all mental, bro. Like, yeah, you would. You're doing it right now because you know that if there was some reason that you couldn't be able to do it, like you couldn't live with yourself, bro, because you've invested so much. You're doing everything you can right now to show yourself that there's a reason to believe the Earth is a globe.
Do you find it weird that I don't, crash out nearly as much, or like the other
when you first came in here, you did. I guarantee it, bro.
I gotta establish some boundaries.
Dude, you're a weird one.
Out. Make sure you know what you're doing.
Yeah, and all that jazz. But like, for as long as I've known you, like because you've been here a while, I think you would relish the fact that if somebody would come in here and give us the what's for sure. If some PhD or some other academic came in here and stood like side by side with you, I mean, you would be like eating popcorn, dude, because like you don't have that right now. You're the guy essentially, like, and we're asking the group is like, is there any other satellite engineers in the room except for Phil Bellum? Because that guy's he don't know what he's saying. But
well,
yeah,
I mean, I've seen like NASA's chief scientists get into these rooms. Like I've conceded the point that there's nobody. I don't think there's anybody on planet Earth that could satiate y'all's y'all's questions. So I don't think there is like a person that could pop in here and like, oh man, they're gonna dunk on these people. Like no, I don't think that exists.
Thank you.
Well, that's what I'm waiting for. I'm hoping somebody comes in here and does that one day. Because I want to hear some. I know all the evidence, and we know all the same shit they say every time. But I want to hear some new shit. Where's the new shit at?
Corrupt everybody and make them argue the opposite.
The new shit is you can measure the height of the building by dropping a barometer off of it.
Oh yeah, that was like last week though, bro. What's new this week?
How about this guy saying that he's this teacher and scientist and that it's all fine if the Earth is, a globe, and I don't know, he shouldn't even be in this discussion room. He's against the flat Earth. He doesn't believe it.
I'm against the flat Earth. I'm not against flat Earthers.
Shove it in.
Yeah, he's fine. He can stay in here. I think the reason why we like to have him in here is people need to see what people like him talk about. And he doesn't bother me unless he bothers you.
And we don't push people out because they don't believe in flat Earth. That's not what we do.
Yeah.
So, Josh, you don't think if someone came in here...
You got to be able to know it's true.
What's up, India?
So, Josh, you don't think that if someone came in here with actual, measurements of curvature that we'd be satisfied with that? Think we would just go, nah.
Yeah,
you said you don't think we'd be satisfied by anybody, but what if they
I don't think so.
Really? Why not?
Yeah. Well, I think the goalposts are on ice skates.
Well, the question is, why has nobody? I mean, I remember 6-7 years ago, a guy came in here.
Nobody gives a shit.
He's got to do a simple ass laser test. So we actually had a guy. We had a guy, a go-worker. He's like, one of my professors and one of his associate professors are going to go out, and they were going to do it in somewhere in Oregon or Washington State. And they were going to go do the laser test, and the weekend they did it, well, they've never come back with anything. So we've come over this time and time again where someone says they're going to go do it, and they either did it and didn't get the result they want and disappear and vanish, or they just don't do it. So, talk is cheap, as they say. You can say nothing would satisfy us, and no one's done anything. All they ever do is point to a screen and look, trust the screen. That's it. That's all we ever get.
I mean, they took a whole crew to Antarctica, and y'all are hyper fixated on a vape. So
no, who's you?
The royal you. Apologies.
Okay.
You're freaking y'all. What the hell?
First of all, this dude Duffy was told well before he ever did anything that this type of test is not dispositive of anything. Well, before.
Remember, everybody, it's the ground that we're looking at, not the.
Yeah, I mean, you look at my ex dialogue with him. I said, how would this prove a globe? How would this falsify flat Earth? You know what he said? He said because the Earth has to be symmetrical. What? It doesn't even make sense, dude. Why would it have to be symmetrical?
Like I said, I'd be hard pressed. I would if you wanted to be satiated, I would love a very hard definition of exactly what you want, and then I need this to be assumed away.
How do you not know after all this time?
No, I understand. It's just
How do you not know after all this time you've been in here?
It's
We
gotta be
say it
written
all the
down at
time.
some point, right? And then
Measurements
you're
of
able to
drop.
double talk.
Measurements of drop over distance. Really simple. It's really simple, Josh. It's not
Yeah,
complicated.
but drop over distance assumes Cartesian space, right?
What does that mean?
That
Linear.
X, Y as opposed to R, rho, and phi, or theta,
Hey,
phi.
it's just your human.
Your
it's just your
beef is
human
we're not using
perspective.
polar coordinates. Are you crazy? Like, have you lost
No,
your
it's not my
marbles?
thesis. It's just that drop over distance assumes that quote unquote drop is relative to the local flat plane that you're standing on, right? Whereas, on a globe, it would be an arc length, not a x over y down.
No, we're talking drop from the tangent, dude. The freaking curve that curves down.
Yeah, that's exactly what I'm saying.
Like a ruler on a bowling ball. Right? The bottom of that ruler and the surface of the ball get farther apart. That's what we're talking about. That would prove 100% one way or another.
But it's not possible to have a straight ruler while you're standing on the ball.
Why not?
Is that
y'all claim you measure 1,000th of a proton radius? Why can't you do that?
I'm just saying there's because it's wait repeat. Was that CERN? What are you talking about?
LIGO.
A particle accelerator? LIGO.
LIGO claims they measure 1,000th of a proton radius.
Yeah, it's in a vacuum tube, right? So, a laser test, long distance observation, all that is, light traveling through a medium. So you can't get it perfectly straight. So that's why I say the only way you can measure is by taking a step back and going up.
Well, so check this out. I mean, there's going to be a distance where the curvature of the beam, even if there is some, is going to be so different from what the surface of the ball would be, is that you don't need to be that precise. Unless you're positing that you can have a beam whose ray just goes completely in a circle back around.
No, because then you'd have to understand the conditions of the medium on every step along the length of the beam, right? So I don't. Yeah.
Yeah. So you're trying to make it impossible, unfalsifiable nonsense.
Oh, I'm just saying I don't think it's measurable from the surface.
The globe is copium.
Now,
Indio.
You're really close to what he just said. It's not measurable.
No, he said this before you joined. He said it's the human perspective is where you can't see the curve.
Like
you have to go into outer space.
Giant flat rectangle. All the Earth is flat, like it's a giant flat circle, but that makes sense under your feet and stuff. As you go up, you see in a circle, not a rectangle. The whole Earth is flat.
Josh, you sound like the Pope. Only the Pope knows the true word of God. Only the Pope can interpret the Bible.
Whoa. That's assuming the Catholics are right. Jesus Christ. You're just assuming I'm Catholic?
No,
I'm just saying
to
that, Indio. Come on.
It's an analogous argument where we can't do it. We have to trust some other authority to do it.
I think you're atheist, isn't it?
No. I'm 100% agnostic. I think atheists are dumb.
He's 100% certain that he's uncertain.
100%.
100%.
I'm not uncertain. I'm certain in my uncertainty.
Yeah, we really.
This is
how does that circle jerk work?
I mean, certain.
I'm 100% certain that nobody has the right answer.
Really? How are you certain of that?
I haven't had any first-hand evidence of anything greater than humans. Therefore, all religions must have been creations of humans, and therefore they're infallible because no humans know the context of their.
Yeah, where did the first thought? Let's put it this way. Where did the first thought come from?
A human.
Fly that to NASA.
Yeah. Were they the Were they the originators of the thought?
Yeah, it's infallible. Yeah. But I'm saying prove it.
No, prove it. No, wait a minute. Wait. No. Prove that the first thought was from a human, like that they came from them.
I have no idea. I don't know.
How could you? Yeah, exactly. That's the. Yeah, I mean, your uncertainty, dude. Your uncertainty goes all the way back to the place where you think you were certain on something. You're going to be uncertain. There's no way you can derive certainty from the uncertainty that you're telling us that you believe in.
I disagree.
It's a huge. Well, you can disagree all you like, but it's just true. So if you're saying that you're certain that everything,
you know, the first thought came from a human or didn't come from a human.
So here's the thing, though. You think that things that are thoughts, you can actually say that you're uncertain. You're 100% sure about your uncertainty. You can't be 100% sure in a realm of being uncertain. It's just like a snake eating its own tail. So there's no way you can.
Definition of faith, isn't it? Right, deriving certainty from the uncertain.
Yeah, but how can you be sure, being uncertain, that you're certain?
You just said you can't have a flat ruler on a curved Earth. How do you know the Earth's curved? I mean, it's like a circle jerk.
It's a big circle jerk.
Okay.
Well, hold on.
But I'm trying to get him.
Josh said he's seen no evidence. Right? Do you accept anything other than material world things as evidence?
I don't believe in the metaphysical. No.
So there you go. You will never accept anything that is not material as evidence when we're talking about things that are immaterial. So even if you had something immaterial as evidence, you wouldn't accept it. So you basically set up something impossible to do.
If there is a God,
something impossible.
If there is a God, they are material.
Well, says who?
That's just my perspective.
Yeah, your perspective, and how do you know you're right?
I don't know I'm right.
So
then you're uncertain. You can never be certain about your uncertainty, ever.
Okay.
Are there things that exist, Josh, which are not material? Or the only things that exist in the world are material?
I mean, that could be true. But I'm just okay, cool. I haven't seen anything. I haven't seen any proof of any claim that makes me think, okay, yeah, that's right.
There's things that exist which are not material, which are absolutely true, and this is easy to prove. All abstract ideas, such as math, logic, truth, things like that, those things, those exist, but they're not in the material world. I can prove they exist. I can prove the law of identity exists. It's simple.
Yeah, because
they don't exist in the material world, though. So you just jettison logic, reason, mathematics.
Socially acceptable immaterial things, I can vibe with that, but I understand the social context of their creation, right?
You think the law of identity is a social construct?
Because you're communicating it to other monkey brains that I observe the same laws of logic that you do.
They're independent of human beings. They still exist independent of a human mind.
Have you ever demonstrated to someone who doesn't have a human mind? I don't
What do you
how do you know that's true?
You don't know any of that.
Josh, I didn't say brain, I said mind. And the very fact you're referencing a mind.
You just believe in the higher concept, the spirit, the thing that occupies that idea of belief. But those things aren't proven on any sort of physical level.
Hey, you gotta believe.
No, but they don't exist either. Why would you believe in them if there's literally no physical proof?
Yeah.
Okay.
I'm just here not
everything.
Don't be a dick. Don't be a dick. Lift others up around you, and then you're good. You don't need anything else.
It's physical
yes,
stuff.
That's the question.
It's physical stuff.
Oh, yes, that's the question. How do you know if it exists? It's not in the material world. We can know things purely through reason.
The rules every time. So, and you don't see it. Not.
Hey, man, you're completely talking over Indio. Social cues.
Not reality.
Well, I mean, let's just put the handbrake on this because fuck the metaphysics, right? So.
Oh yeah, no, it's all good.
Back to curvature. I mean, so your claim is that it's immeasurable. That's impossible to measure.
Lord.
No, let's get back to that, dude, because you said that we wouldn't accept anything, and you're claiming that it's not that we wouldn't accept it for some other reasons, simply because it's immeasurable. Or you're saying even if it was measurable, we wouldn't even accept a measurement. Which one?
I mean, you can go look at the Porchart train, power,
Oh my
lines
God.
over and down in Louisiana. Exactly, right? Like,
okay, so, no, hold on. What was measured?
The fact that they're all the same height moving over water and they look like they curve outside of just straight vanishing point perspective.
And Josh, have you looked closely at those images? So at the end of the power line one, it's an inferior mirage. You can clearly see it's an inferior mirage because it splits in half, and there's a mirror image of the tallest tower that's at the end. Okay, and then if you go and look up Lake Pontchartrain data on what the water temperature versus air temperature is, they have 2 temperature inversions a day. So they got buoys in Lake Pontchartrain that measure the wet water and wet air temperature every 6 minutes. So on that day where he took that photo, there is a temperature inversion. You know why I know that? Because I have the data. I have the historical data for that day because I know the exact day he took the image.
And now we can have this discussion because it's putting through a medium. The light's going through a medium. Therefore, I think
that's why we're measuring. We're not just looking at it. That's why we're measuring. We're not just simply looking at it and making it a subjective opinion about it.
Why is this guy just talking? Dude.
Oh, I'm sorry, I'm interrupting. It's just the photograph you chose to use to describe your example is an easily provable fake.
Dude, that's great. That's great, but don't interrupt. Just
water mirage bends the light into nothing.
It's a real photograph. Okay, it's not a fake. Okay, it's a real photograph.
Curve that much in like 1 mile.
Shine. Can you put yourself on mute, please?
Okay.
Okay. So Lake Pontchartrain has 2 temperature inversions a day. The water and air temperature are very close to each other, and they flip back and forth. Because Lake Pontchartrain is very shallow. It's something like 11 feet deep. So people have taken plenty of video and photos of it not looking like this. So why don't you think about it for a second? 30,000 cars go over that bridge every single day. If you could see Earth curve there, right, at that location, they would have set up a tourist shop right at the end of the bridge. Come to Lake Pontchartrain and see Earth curve. No one's ever done that because this is a rare temperature.
I don't think people give a shit about y'all. Like they think that even admitting that there's
people give a shit about money. People give a shit about money. And if you could see the curvature of the Earth at Lake Pontchartrain, there'd be a tourist shop right at the end of the bridge, so you could go there and see the curve of the Earth.
I mean, that's assuming that there's enough, like the social benefit or the economic benefit would be worth the social ostracization of catering to flat earthers.
No, they would have done this years ago, bro. It had nothing to do with flat Earth. People would just do it just because it's a novelty. Okay, that's why they would do it. But the fact of the matter is, Lake Pontchartrain has been thoroughly studied. In fact, on one side of Lake Pontchartrain versus the other side, they have actually different climates. The USGS studied this area. It is literally the worst place in the world to do an observation. The worst. You literally could not pick a worse place.
Okay.
Which is why, like the one of the bridge, that it looks like the hump that's in the middle, that they're coming straight down at like a 80-degree angle. Like they're falling off a cliff. The bridge don't look like that. I don't want to know why you would pick that place. I really don't.
Well, yeah, it's just from a globe perspective, that's an easy win, and obviously there's more nuance there.
It's called grasping at straws.
Do you want me to post all the data? Because I got graphs of all the data of Lake Pontchartrain.
No, I get it. I understand.
Graphed out for 45 days. I got a graph for that day, right? I got a graph specifically for that day showing the temperature inversion. And I have computer simulations of atmospheric refraction from the 80s that show that exact same phenomenon. That a flat surface that they used, and they simulated a temperature inversion, and it makes that flat surface look curved. And I have someone doing it for real with sugar water in a fish tank with a camera at one end and a background on the other end of the fish tank. This is on Action Labs, of it making the exact same visual effect. So this is an Earth curve, okay? Period.
Yeah, exactly. It's traveling through a medium. Like that's what,
you know what's weird?
Like from a human perspective, I don't think there's anything conclusive that could be used to prove. Like, I think there's too many variables to have it discussed unless there's.
Wait a minute. Wait a minute.
We get it on a frozen
Didn't you
lake.
say that it looks flat? Didn't you say it looks flat earlier? You said that earlier.
Yeah, it
You
does.
say, yeah, it looks. Well, why are you showing Indio this picture where it looks like it's curving? That goes against what you said earlier.
You thought we forgot.
I'm saying that it's traveling through a medium.
We didn't forget.
No, I'm
What
saying,
does it look flat or does it look curved? Does it look flat or does it look curved, Josh? You need to pick a lane,
I'm saying it looks curved, but obviously there's more nuances there because the light's traveling through a medium.
Okay,
which leads
so
to this nuanced discussion.
your earlier statement that it looks flat was not true then.
No, I'm saying, yeah, for the vast majority of things, like the human perspective, the Earth is flat. I still stand by that.
So then why are you standing by this?
I'm saying it's saying from a Glober perspective, from someone who says that.
What are you trying to do? What is the difference between a Glober and a human?
What I'm saying it's low.
You said from the human. You said from the human. You said from the human perspective, it looks flat, but from a Glober perspective, it's curved. What the fuck is that?
The human's just out there looking around with no preconceived notions of what they're looking for. A Glober is looking.
Oh, so that's the difference. That's the difference.
Yeah, that's what you asked.
So you would put that Lake Pontchartrain image in front of a human, and a human would be like, "Oh, I'm not looking for a curve, but there it is."
Does this dude just say that Globers aren't humans?
I don't know. He said this. I'm just following his logic right now.
Yeah,
no,
okay. I digress.
I apologize. I'm saying from the royal you, the human race, like you walk around, looking around, and it looks flat.
But you said earlier. Yeah, there you go. See, he said it again. So it looks flat, but then when you look at the Lake Pontchartrain image, you're like, oh, it looks curved. Right?
It does, and that's due to the.
Okay, so are you going to pick a lane?
Indio just pointed towards.
Are you going to pick a lane, whether it looks flat or curved?
One is my own personal opinion, and one is not. Like, I appreciate
God,
that
bro.
There's nuance here, and.
So okay, when you're telling us from the picture that you're looking at, is it from your perspective or someone else's?
From my perspective, it looks curved because I know the Earth is a globe.
Okay, so it looks curved. So now you're choosing curved.
Personal perspective. From my personal perspective, I'm saying from a
you know no such thing, brother.
So when it looks flat, when does that happen? From your perspective, when does that happen? When does that occur?
I mean, almost everywhere else.
Okay,
bro. There's only males and females, and it's either curved or flat. Okay, come on.
I'm gonna hand this back to you, bro. I just wanted to get him on that point because he was double speaking. He's double speaking, as you can clearly hear.
Yeah, I am double speaking. One is me and one's not me.
Oh shit, dude. What are you having an out of body experience? What the fuck, bro?
No, you're allowed to talk about a reference population that's not your own opinion. Like,
no, dude,
we got mixed up there.
So no, we're not mixed up. You're double speaking in the sense of saying, I look at the Lake Pontchartrain. I'm glad that you identified that. Like, that clears up a lot.
You're getting caught up in an aha moment, Josh, and you just don't want to. You don't want to. You
No,
look
it's
like
all good.
you don't know what you're talking
I'm
about.
double speaking. I didn't explain clear enough that I was talking about me in one stance.
No, bro. You didn't have to explain, bro. You didn't have to explain clearly. We understood you when you said it looks flat. We know that that's what you're saying when you look at the Earth. But when you look at the picture of Lake Pontchartrain, your brain wants to make it look like it's a globe from the ground level.
Yes, agreed.
There you go.
That's exactly what we're saying. Okay, that's what we were talking past each other. I apologize.
No, we're not talking past, brother. We're not talking past each other. I hear you very clearly.
Okay.
So does the audience.
Regurgitated back to me what I intended to say. So we are good.
All right. Carry on.
That's all good.
Well, just quickly, because I just wanted to address what Josh said before, like the Lake Pontchartrain's an easy W for the globe, but you kind of like doubles, like you're contradicting yourself when you're saying, well, now you know it's just a miraging effect or an atmospheric effect that's taking place. So how would that make it a W for the globe? Like you said
from y'all's perspective, right? Like if a Glober walks in here off the street and says, go look at Lake Pontchartrain, like that's it looks curved, therefore it's they don't give a shit about quote unquote superior miraging and temperature.
How would that be an easy W?
You're straw manning my position and what I said. I said measure. I didn't say go look at it and see what it looks like.
Oh,
I never said that.
Oh, I'm sorry. I'm talking.
Well, there's a difference, right, between just looking at it and making a subjective evaluation and taking out a fucking tape measure. I think there's a difference between those two activities.
I think that a glober coming in off the street wouldn't understand that. Yes.
Well, none of you guys seem to understand it. You guys think calculations are measurements, think looking at shit is measurements. You think everything is measurement but measurement.
What's a glober coming off the street? There's globers coming off the
they come
universities
all the time.
they come out of
You're one of them.
Where do you come from?
Your level of understanding of the claims when it comes to the bending of light and refraction and whatnot are just as bad as the glober that comes off the street that you're trying to put shit on right now.
I agree.
Yeah,
I agree with that. Like,
Okay, so Josh,
that's why I don't usually talk about long distance observations, because I don't know jack shit about that.
Okay. So Josh,
aren't you like an aerospace school?
Yeah, space. The whole reason I did space is because I didn't want to deal with the medium, right? Like I took thermodynamics and I had to start dealing with like humidity and gas fractions, and I'm just like, fuck that. I want to deal with, vacuum.
Why are you saying fuck that? Because it didn't make sense.
I mean, no, it's more complicated, and I didn't really enjoy chemistry. I'm much more of a mechanics guy.
It's probably complicated because it doesn't make sense in the real world.
I mean, it's just I didn't enjoy it, so I didn't want to do it.
So you enjoy learning about space, which nobody knows anything about, and nobody ever will unless you are Elon Musk.
No, he don't know anything either, and neither does Josh. You're relying on other people.
I still don't get how Pontchartrain is a win for the Globers if we apparently see an apparent curve that's way too pronounced to be Earth curve, and they claim it's Earth curve. That seems to be a big L.
Yeah. Holy smoke is drinks,
it's a
dude.
win
What's up,
for
bro?
the Globers off the streets. We're off the streets, son.
Buckle up.
Oh, geez, come on. Y'all see
Grace is here, buckle up.
Walking in, and they say y'all are stupid.
Grace is here. We're going to have to let him talk to Josh for a little bit, see if he can...
break me, man.
Yeah,
no, I asked you, tell me, how is it a win?
Oh, it's like easily digestible information, right? It's a meme.
You mean it's wrong information being parroted incorrectly, and how is that a win?
Yeah, just saying, it's very similar to the memes and things that y'all post in the side chat.
No, it's not. So do not try to jump away from the actual thing here. You're trying to justify your position, not trying to strawman it with something else. You might have seen a meme that's not indicative of our position as a whole, because we're not a collective like you. We don't have a position like you that is dependent on belief in a greater system. We just have the mechanics of how things actually work, like light refraction.
Okay, I apologize.
So Josh, what it sounds like to me is that you're like, well, we have a meme like Pontchartrain that looks like Earth curve, so it's a W, because even though that's not actually Earth curve, people continue to believe it's Earth curve, and all we want is for people to keep believing the Earth is a goal. Is that your goal? Believe it no matter what, even if it's based. Do you want people to believe it, even if that belief is based upon bullshit?
I mean, you can invert that for many of the memes that are posited by flat Earth.
Don't say what about you, dude.
No,
I'm talking about you.
Yeah, you're also misframing. When we post, for instance, a meme, I posted, for instance, a picture of Lake Pontchartrain with no refraction, so the pylons are completely straight and you can see the shore on the other side. So that is an image that contradicts the other image. So now you have to start to think about your claim, which is that in your first image, that curve you see is Earth's curve. That's all it's meant to do. The difference between the images, or what you call memes, is that the claims that are being presented with them. Do you see the difference?
even the straight picture still has refraction. The light is still moving through a medium and it's refracting.
Yeah,
like
bro, that's not how.
Constant temperature as a function of altitude and distance.
Bro, there's always going to be some slight variations, but refraction is not. If there's no optical density difference in the medium between the targets, or if it's normalized, there's virtually zero refraction.
Yeah, that's not possible. That's not possible.
Yeah, it can be normalized. Yes, it can be.
I disagree.
Yeah, you can, but that doesn't change anything.
Bro, where did you get that idea?
Fluid dynamics, man. Every single molecule in a volume, like there's no such thing as a uniform temperature and pressure in a fluid.
Yeah, I'm not saying it's uniform. It's the atmosphere is anisotropic and inhomogeneous. The problem is when you have the light traveling from one point to another point, and those differences balance out, the light is not going to be refracting up or down by much at all. So it's going to reach the other end.
All is not zero.
Yeah, well, that refraction up and down,
you said zero
the refraction up and down, then balances out. That creates a pretty straight standard.
Pretty straight standard. You're using weasel words here, man. Zero refraction is not possible.
Yeah, you're saying minuscule differences that are undetectable are something that's gonna change anything.
How can you prove that they're undetectable? Do you have a sensor?
Because you cannot detect them.
Square inch. What? I mean, do you have a sensor at every single?
You should listen to Drace explain these things to you, right? Because he has a very good understanding of how this works. And if you just would actually listen to him, you'll actually learn something off him about how this works.
I understand.
You don't understand. You don't understand. You should be listening. You're the student right now. He knows a lot about this.
I just want to make it clear to everybody that zero refraction is not possible. It
is easily.
We're trying to listen to him too.
Let me give you an example. For instance, a very simple example with two mediums like a fish tank. If you look normal to the surface, this is basic Snell's law. You don't have an angle of refraction, so there's zero refraction.
Yeah, but it's not basic Snell's law.
Yeah, but weasel words.
I'm saying you need to deal with differential Snell's law here, not basic Snell's law.
No, it's very much principle, actually. And the thing is, when you try to assume modern ways of dealing with refraction in the air is mostly modeling and assuming those models are consistent. And so you keep switching your models until what you see matches the model. But that does not infer that the paths are like that, but that one model appears to match that vision or view. So the problem here is we've been looking into this very deeply, and so for the globe to be true, you need the light to be refracting down around the globe to allow you to see further. So we have thousands of instances where we can see way too far for the globe, and so in those instances the only excuse the globe has is that light must be bending around the globe to allow us to see further. Okay, so we go and test that. Now, in infrared cameras work on infrared, and infrared refracts less than visible light. And so we should always see the horizon closer in images when we see too far in infrared. So if we see too far in visible light, and we should also see too far in infrared, but just less far because it refracts less, if the conditions of the globe are true and light is refracting. However, when we look in infrared versus visible light, we see further in infrared. So, and when we look at the conditions of the day and we measure, for instance, the temperature, humidity, and pressure on both sides or over a frozen lake, we find pretty normalized conditions at times. And at those times, we can see straight across. When there's more refraction, we see less. So that is contrary to what is required for the globe to be true.
Do you have any documentation I can go read? I appreciate, and I'm following, so I do appreciate the information. But you had to have gone from a layman to knowing what you know now. Is there any good material you could send my way?
There's a ton of material. First of all, where to start? There's of course.
It doesn't have to be now. I'm just saying, like, if you come across something like.
Let's start here. You are aware that refraction is wavelength dependent, right? It has a wavelength dependency.
Correct. Yes.
Okay.
That's why you get the prism, right?
Yeah.
For
yeah. So it has a wavelength dependency, and that is directly related to the absorption. You might not know that. That's kind of a nuanced thing. And it's well known that infrared, that's why we use it for, tracking, planes, missiles, people, etc., because it's absorbed less. So the refractive index, the how much infrared light will be refracted as you go toward that end of the wavelength, right? So it's lesser like ultraviolet and blue, and then it's more for ultraviolet and blue, that end of the spectrum, and less at the redder end of the spectrum. There's an optical window in infrared. In fact, the point is that it's easy to just go, hey, if there's less refraction. So what they claim is the more refraction there is, the more something is lifted up, right? The more the ray curves around the surface of the Earth. So in infrared, right? If it's curving less than the horizon, that was a brilliant argument, Trace. I've never heard that before. The horizon should actually appear closer than what it would be in a more refracted day, when it's actually the opposite. And there's one I actually know about, the San Jacinto infrared, where the horizon is 5 miles too far, at least 5 miles, probably more. And it's easy to know where it is because of where it was taken, the features that the picture was taken of, where the camera was. You just simply know that it's supposed to be the horizon's more than 20 miles, and the horizon, according to the globe map, is supposed to be 5 miles. Well, he also has the same invisible light, and you can't even see the shoreline because of the horizon. Well, the horizon should be farther if it's being refracted more in the visible light than it is in the infrared light. And what Trey said, it's the opposite.
Yeah, the same would also be true with.
It's like how basic do you want it? You know what I mean? Like, that's up to you.
The same would also be true with, like, you look at anything at a distance, and if it's too far to be seen, and you can still see colors, all of those colors should be shifting based on the refractive difference between those wavelengths. And so we don't see any evidence of the light being actually refracted when we see too far. We only see evidence of, like, when the conditions are such that we have a lot of refraction, it lowers how far we see, because when you think about it, if the light is coming from the other side of the lake and the bottom rays are dropping down and hitting the water, of course you're not seeing the bottom rays. Of course the bottom of the boat starts to disappear as a consequence.
That makes sense.
And then there's the other thing.
Yeah, I was going to say, anything in text would love to read.
And then, there's dispersion, right? You mentioned it with the prism, right? The rainbow. You should have dispersion in a camera. They would call it chromatic aberration, right? You should have dispersion if you had a high refractive condition out there in the environment. But no one's ever observed this, where you see a blue mountain peak, and at the bottom of the mountain it's reddish, right? This difference in color because the light rays get spread out. We do observe this astronomically, though. We do observe this with planets. They actually make chromatic correctors, right? Astronomical chromatic correctors that have a mirror in it that you merge the red and blue image together. So we do see this. It's not like it's not there. It's just not there in any terrestrial sense. Ever. Like never. None of the 200 plus mile ones.
And as for documentation, just read about refraction. There's ton of official documentation where you can read about all this. It's not very complicated. And if you want to see people inadvertently testing this, most of the world record long distance photographs are taken in infrared because they see further. And the best part is they generally take a picture in visible light before, so you generally have that differential. So it's just, it doesn't match the physics.
Sorry, I'm reading through the side chat.
You like pictures of the moon I took with my smartphone?
The good question is, what is the evidence for refraction, the way the globe says? And their evidence is that the Earth looks flat, which is fucking crazy. Hey, what's your evidence that light curves around the ball? Oh, the Earth looks flat. You know how cuckoo that is, dude?
Yeah, that's also how they determine how much refraction was that day, is by how flat it looked.
Yeah, the flatter it looks, the more refraction. But Josh, this has to be your position. Well, I mean, your position is, trust me, bro, but I mean, everybody else's position that why these long distance observations and measurements don't mean anything. You guys have to try and take a big dump on them and try to convince everybody that they don't mean anything.
The worse.
Well, the military would like to have a word with you, okay?
Yeah, in their worldview, the worse seeing of the conditions, the better the observation.
Yep. The worst part is the military uses.
Like this, people take away.
Sorry. What I wanted to say was that the worst part is the military, like was slightly mentioned earlier, uses tri-beam different wavelength targeting systems to exclude any possibility of the target being displaced or be able to calculate how much it is displaced by the dispersion of the lasers or through the targeting system. And so we can use the same principles here on Earth, just use the different wavelengths to see how much the dispersion is, if there's any. And so far we have not seen any evidence that the Earth is curved and light is somehow trying to hide it by violating its own basic functionality.
You solve the whole paradox by simply saying it's an optical effect, not a physical effect. The whole thing's solved. That easy.
I appreciate all the content in the side chat.
Here's a little point. Like, I love arguing with ChatGPT all the time, and there's some misconceptions that a lot of people use. Like, ChatGPT there's a lot. For instance, they claim like downward bending is the norm, but that's relative to like if you're like looking at the Earth from outside the Earth in an orthographic view, not relative to you on the surface though, because under normal conditions the ray would still continue to rise up into the air. That's just the physics of it. So they're quite literally screwed.
Yeah, like I said, I appreciate all the content. Feel free to send me stuff to read. More than happy to. Like I said, I'm very dumb on this topic.
So I sent Jay Tolan Media So if you scroll up, I sent the infrared and I just sent the visible light. Now, if you look at the infrared and you zoom in on this, you can see, what the hell is it, the name of it? Can't remember the name. It's something marina, right? And that marina comes up to the ocean, but it has a jetty, a barrier. And you can see all the way into the marina. And the marina is at 20 miles, and you can see into it where they park their boats, right? So we know that that's at 20 miles. Well, the globe curve calculation is the horizon supposed to be 15 miles away. But you can see the water surface 20 miles away. Now you can say, hey, that's refraction or whatever. But then when, like Trey said, like I said, I can't say it enough, man, that was a brilliant deduction, is that the horizon is way closer. Way closer. Right? Some of the buildings are cut off. You can't see them. This is the exact opposite of what it should be. If the globe, the globe mechanism for refraction actually existed, we're seeing the opposite of what it would predict.
Yeah, I was gonna say I need to look into the. I haven't thought of doing long range with either infrared or other wavelengths.
Well, the other thing about infrared is like it penetrates through haze and water vapor, right? Particulates in the air. It isn't affected really by infrared as much. And what I've come to find out, because I've borrowed a multispectral camera and I got an infrared filter, is that consumer cameras, their infrared filter doesn't really have a high activation. So the actual optimal window is something like 1200 nanometer or 1500 nanometer. But your consumer cameras aren't sensitive. Well, it's not that they're not sensitive enough. It's that the material they make the sensor out of has like an upper threshold to like, because the radiation has to activate the electrons on the sensor, and in this particular, the elements they use for consumer sensors, there isn't enough. It's not powerful enough. The sources aren't bright enough. But you can do like 930 nanometer with a long exposure. Or you just buy one specifically made for that purpose. But they also have what they call shortwave infrared. But those cameras are like thousands of dollars, like tens of thousands of dollars. They use a different type of sensor. They're like 1500 nanometer.
I was gonna say I got my phone and that's about it.
Yeah, well, I made a 30-mile observation with an iPhone 4S, which is a piece of garbage. "30 miles from 15 feet above sea level, I watched the ship sail from 6 miles away, tracked with marinetraffic.com, which tracks, well, at this particular location, they use a radar station out of Gloucester, Massachusetts. And I watched the boat for 3.5 hours sail out to sea, never disappearing, never any of that. I mean, it got smaller and smaller, it was tiny. And then to verify I was seeing what I see, I went on top of a parking garage, which is like 100 feet above the sea level, and could obviously see it more clearly. But even from that 100-foot elevation, I should not have seen it. No, I mean, we could sit here and just believe that the light rays are, curving around the surface of the Earth in such a way as to make the Earth just look flat. How that would work in any conceivable way, I do not know. Like I can't even visualize it geometrically. How you would make a curved surface look flat.
Just imagine how uniform the air would need to be for vista, when you look out, like, and you can see 30 miles when you should be at most be able to see 10 miles, let's say, and you look at over that vista, if the horizon is refracting, then the horizon you're seeing shouldn't be the true horizon, and the difference in refraction between you and each point of that horizon should be different, unless you're saying the whole air is uniform to create this uniform refraction. Like it's, or not uniform, it's like uniformly in that, I don't know how to say that in English.
I know what you mean, Grace. Like the structure of the air is such that every path of light has to follow a different arcing path.
Exactly. It somehow would have to match magically to create a perfectly flat line. What should be happening in those cases, if that was happening, is that the whole horizon should fluctuate like a wavy line depending on the conditions between you and that point.
I think that's what we do see, though, right? Like at very, very long distances, like even on days.
No, we don't see. We don't see a massive difference in the horizon. It's not like an S-like curve. When you put a ruler to the horizon is straight.
But if you zoom way in, you see kind of like these miraging effects and waves up and down, and as a function of time, right? Because
you can see waves in the ocean. Yeah.
Yeah, and smearing of distant objects.
It's a medium.
Yeah, there's shimmering effects
in the right geometry.
Yeah, shimmering effects are also a consequence of turbulence.
Oh, and turbulence is exactly what we're talking about here at this point.
Yeah, but that's slight variations in the straightforward, and the propagation's still going to be relatively straightforward. It's not deviations that could allow you to see extra 10 miles. And those extra 10 miles would be variant due to the differences. So you would be able to see 10 miles over there, 5 over there, 3 over there, depending on the conditions. But when we look, we see 10 miles too far there, 10 miles over there, all around us.
Well, no, I think it does change, but it's and this is once again me shooting from the hip, but my gut's telling me that it's 9.98 miles in that direction, 10.02 miles in that direction. Like it does change as a function of azimuth and time, but it's not,
Well, how could the horizon look flat?
Right, the molecular composition of air must be conformal to the curvature of the Earth, such that it flattens it out.
The horizon can't be more than one distance away, because then it wouldn't look like a straight line. Horizon means bounding circle. So a bounding circle is equidistant from the observer, right? So that, because you're
that doesn't take into account the medium, though.
But we're talking about what it would look like, right? So, and what it would look like if the horizon is equidistant, it would look like a line around you. But if it's not equidistant, it would not look like a line. One part of the horizon would be lower or higher than some other part.
A lot lower, farther away. No, it would just be a tiny little bit, and it might be imperceptible to the eye. Is what I'm trying to say. Like, I don't know.
We just went over. You're seeing over 10 miles of what you shouldn't be seeing. So that should be extra 10 miles of extra stuff added on top of the horizon, being bent above the axial horizon to create an illusion. That's what the Globers believe. They believe they're seeing illusions. Okay, and so. Depending on the conditions between them and the illusion. And so that illusion would shift.
Yeah, shift, but like the magnitude of the shift. Like I'm just saying the dynamic portion of this might be...
Yeah, the magnitude of the shift would be dependent on the conditions. And problem is, the Globers do not have the conditions to even create the bending down in the first place.
I can agree with that.
So there's no way to even model this. So this is the funny part, Josh. You know how they actually do model this? They just change the size of the globe.
Oh, I thought you were talking about like computational fluid dynamics. Like,
No, I'm talking about when they model
molecules.
No, that's not even remotely how they model it. What they do is they'll say there's X amount of refraction, right? That means, like, what they'll do is they'll take the curvature of the radius of a right, because they're assuming a spherically symmetrical atmosphere. The standard is like 7.6R. So they multiply 7.6 times the radius, and they make the globe bigger. And then they do all the straight ray calculations. They don't calculate curved rays. There's no way. Like, think about this, Josh. I have a vertical sensor. It's a flat plane inside the camera. That's what I'm trying to project the image onto. Now I have this curved surface, and there's a horizon which I can't see past. And as that curve gets further and further away, it follows an exponential function. Now I need to map all the rays to my vertical sensor, right, off this surface in such a way as to make that curved surface look like a flat surface on the sensor, right? So each point of distance further, it's more and more and more and more curvature that I have to curve the ray. Like, nobody could even, there's no computation that could even do this. You might be able to do it by trial and error or something.
It depends on how granular you want to get, right? Like CFD simulations could do that.
To unfurl the ball. You know how you like unroll a scroll? You know, it's like a scroll. You unroll a rolled up piece of paper. That's kind of what you're doing when you unroll you have to unroll the globe so that it looks flat. How could you do this? Optically. Now we've seen Glovers try to say, yes, it's possible for things to lift up things from beyond the horizon. And what they'll do is they'll take butane or CO2 or something crazy, right, that's super cold. When I say super cold, in the negative digits, right, they do it in regular room temperature air, and they go, look, this thing behind the thing got picked up. Want to know what never happens? You never see the surface. You never see the horizon move. Ever. You might see some stretched object that was partially behind it, right? Stretched out, but it's easy to see that something's happening. Now, the elephant in the room on this particular point is the fact that they're using stuff that is, the refractive index is 1.4 or 1.3, and they're using the super crazy temperature gradient. So that alone demonstrates the fact that they're using unphysical, what we call unnatural conditions, and unnatural not in the sense supernatural, unnatural in the sense that outside in nature, the weather's never, like, doesn't have 70-degree temperature gradients in 1 foot. It also doesn't have like giant fucking CO2 loads or butane floating around, right? So the very fact it takes an extreme special case condition to even demonstrate the possibility should show you that it's not possible, because the refractive index in theirs varies in the 5th decimal place. It isn't in the 1st decimal place. It's in the 5th decimal place. It's in the millionths. So the temperature, like, you know, the 70-degree versus 69-degree temperature difference varies to the refractive index like 0.00024 versus 0.0000237. So it's a slight variation because you have a single medium. Right? So even if you have a 10-degree temperature difference, you could have a 100-degree temperature difference in a foot, and it still isn't going to change as much as what the difference would be in CO2 in air or butane in air. Right? They're just not the same. The point is to even demonstrate that it's even possible, they have to use these extreme experiments. When we can go out and demonstrate that, hey, you can make the horizon appear way shorter than it has to be. We don't need to do any extreme conditions. We can just go out in nature and show that a little RC boat or whatever will appear to disappear over the horizon on something we know has to be a flat surface because it's well shorter than where the horizon should even be. And you have a horizon that's appearing 700 feet away instead of appearing 2,600 feet away. Right? We're observing this in nature. We're not observing it in a lab. under some weird conditions that don't exist in nature. So this is really the position of both sides. One side says, yes, X is happening. Well, can you demonstrate that in the lab? Oh, sure, I can demonstrate in the lab. Give me some butane and some CO2. We'll make the butane negative 40 degrees Celsius, and we'll make the CO2 negative 60 degrees Celsius, right? Something that don't exist in nature. Negative 60 degrees Celsius next to 70 degree air don't exist in nature. I'm sorry. But we can just go out and go, hey, there's a nice freaking smooth lake. There's no ripples on it. Let's just take a camera, set it real low, and sail this RC boat away. And we can observe our contention. We don't need to do anything special.
Yeah, we just test what we're told. Like, we're told to believe all this stuff, and then we go test it. Like, we have hundreds of laser tests over frozen lakes at all conditions of the day. The globe just isn't there, and it's just not enough to just hand wave away all of the data that comes from the world itself and just go with the preconceived notions, because that's what we were all taught. That's the easy way out. It's kind of like when we saw New York City skyline across that water, and people will be like, "Oh, that's an illusion. That's a hologram. That's a mirage." But then Rob Skipa just went on a boat, took his camera out, saw it at one start of the water, and just kept the camera on it the entire time and sailed to the other side. It didn't warp. It didn't change. It wasn't a mirage. We were just told to believe that. No one tested it. I don't really care what shape the Earth is in the end. I just care about the truth. Worst part is I really wanted it to be a globe. And like, this whole thing just it's kind of a litmus test. Like, are you a person who just follows blindly what other people believe, or do you actually go and look into it? And I wanted to have some foundation in my belief in the globe. That's the only reason I'm looking into this. And the more you look into this, the less solid it is, because that's what it is. It's not solid at all. It's in the mind mostly. The little bit that's not is like misconceptions. Like, you measure the ground flat and then you wrap it into a ball afterwards because of the belief. That's not reasonable. You did one thing right, and that was measuring it flat. And that's one of the things what I love about this community, is we go back and look at all of the so-called evidence from the globe side, and we just keep consistently finding that, wait, they did measure it flat. But oh yeah, see, here they divorced reality, are comparing what they're seeing in perspective to this orthographic view to reify into existence the globe, and now they're claiming it's a globe. But in the beginning, they just measured it flat. So that's what we're looking at, the actual data, the foundations that they're building it on, and then looking at why are you adding this? And when there's no reasonable reason for adding it, we can reasonably conclude that this is coming from some preconceived idea that it must be a globe.
Yeah, the thing you ask is, what is the justification? And when we look into what the justification is for adding this refraction thing, there isn't any other than the Earth looks flat. That's their justification. Which to me, it's crazy. I don't know. Call me, like, is that crazy, or is it just me that thinks it's crazy? That, yeah, we know there's globe refraction because of how flat it looks. And the flatter it looks, the more globe refraction there is.
I got a question.
Insane, dude.
Somebody earlier said that You have to see it, then they tell you what kind of refraction is it's that day, but all I hear is Globey saying they can make all the predictions. How come we can't predict what the refraction is going to be before we see what we see? How come it has to be a post-diction, not a prediction?
Yeah, that's a good question. And then they'll say it's too complex. Well, if it's too complex, how do you know your post-diction's correct if you can't make the prediction? How are you matching these up?
And the funny thing about it is it always comes up to where, we have a stance to say the Earth is flat. It's a little bit lower, a little bit higher. No, it's right where a flat earther would say it's at. So, yeah, it's a very troublesome thing here, this predicting refraction thing.
So what's up, Brian? You doing X tonight?
Oh, yeah. I'm going to probably get in there in about an hour. Kind of just tooling around right now, getting some stuff down. I was listening to the conversation.
I don't know. Josh left. Josh is our resident satellite.
Yeah, I'm here.
I think he bailed. Oh, he's here. Josh Ingersoll.
Did you hear my question on predicting the refraction for tomorrow?
Yeah, he's disavowed that. You say that he's not an expert, so.
It's a good question, though, right?
How is globe refraction? And I call it globe refraction because it has to be a globe for it to refract that way. Can't be anything else, right? You have to have a curved atmosphere that curves light.
Yeah, and a globe dropping away from the beam, so that's the problem here is the beam is traveling along the Earth in the same optical density, roughly, because of the temperature gradient, humidity gradient, and the pressure gradient. However, in the globe view, they claim atmospheric refraction exists because the Earth is dropping away from the beam. So the beam is going up into less dense medium, and so it will bend away from the normal. But the problem is, that doesn't actually cause the beam to go back down. It just straightens the beam out a little bit, so it doesn't actually go straight into space in that model. It would just not go as straight. It would just curve a little bit. But it wouldn't go back down, because otherwise at that point you're actually turning the light around. You're not now it's going from less dense medium into a more dense medium, and you have a different based on the angle of incidence, relative to the pseudo boundaries of the different optical densities, you have a different refraction. So they have a real problem getting that beam back to the ground, and so generally what they do is they say, well, it must be super refraction, which has no actual basis for it other than just well, it is must be bending this much because the Earth is a ball and we can see the beam.
And the sad thing is the refraction gets less as the higher you go up, man. I posted in the chat there the world record photo. We got 275 miles looking at Pic Gaspard there from 9,200 feet. That whole mountain range should be under 3 miles of physical curvature. But yeah, you can see the whole mountain range. Pretty devastating for the globe Earth there.
So I just posted one taken from 27,000 feet in an airplane. Those mountains are 500 miles. They're between 450 and 500 miles from the camera. Okay, so they should be 9 miles under the curve of the Earth, under the horizon.
Can you post videos in there?
Yeah.
In the chat?
Yeah.
I think I got one. It's a pilot, an SR-71, talking about how he's in around Tucson, Arizona, and he can see all the way the Rocky Mountains all the way up to Canada. You can see the coastline to LA, which just completely destroys. And this guy's the SR-71. Their max height is like 82,000 feet, 85,000 feet, something like that. I don't know if he was up that high, but he was up pretty high. Let's see if I can find it.
Does anybody have a picture of the weather balloon camera that is showing the sun and how it's making like a hot spot of light on the ocean, and then you can see like the moon far off to the left in the same picture?
Man, I had one. I might still have it. It was a sunset that actually disappeared before the horizon.
Oh yeah, I've seen those. Kind of like turns into like a puddle blob and then poof, disappears right before.
Yeah, it's kind of amazing.
.24/7. Yeah, click on that thing and become a member there. Become a member there and go to the bottom of that server. There's a lot of categories on all the topics that we talk about. And you can look at the research that we've done over the years. Many people have contributed to this research. And if you have any questions about it, you can ask us. You come back later or whatever. But it's far more information there than we could cover in a day talking about the different topics.
Of course, yeah. There's a lot of questions in my mind, and I can't phrase it here. So I think if I have some free time, I will go there and check what is the material.
Sounds good, man. But yeah, don't be afraid to ask those questions. Come in here and have a conversation with us. Sometimes, I'll put it to you like this: you can come into this room when we're having discussions with other people, and it might sound a little bit hostile, and we're trying to work on that so that people can actually feel a little bit easier to ask questions. But yeah, the environment sometimes in here, it gets that way because the nature of the topic. The topic is very provocative. People don't know how to react when it comes to, like, they've been told their whole lives the Earth is a globe, and we're challenging them on that. So you have to understand that this is the place that we're challenging people on.
Yeah, of course.
And then it's flat, definitely.
Yeah, thanks for that.
So yeah, okay.
Yeah, but look into all those topics that we have at the bottom of the server. That's going to really help. If you're going to make some more questions, it'd be.
I'm just thinking that let's say I'm a critical thinker. That I need
good stuff,
the root argument of your beliefs that the Earth is flat. So just I need to read the material to know those roots.
Yeah, you could look over the material, but then you always got to come back and check with us and ask us. There might be. I'm gonna put it to you like this. There might be some arguments or some material there that's a little dated. So you can come back and ask us if we're still using this or not. So it's at some point, I guess people have to comb through what's put in there and stuff. And I'd say.
Okay.
We do try to stay up to date as far as we can with the arguments, so that people can be more inquisitive about what our position is. We differ from other flat Earth rooms that you've ever been in, and the reason that we do is because we don't like to have these arguments that are not beneficial to somebody that's coming into the topic the first time.
Yeah, of course I will see. I will just come back to ask more questions about that.
Sounds good, man. We got some new people. Thank you, Khalid. We got some new people jumping in. If you guys want to ask some questions or perhaps have a discussion with us about the nature of the Earth that you are on right now? If you think it's a globe, please chime in and give us the best position for advocating why it is.
Hello, just want to bring some topic here. I've got
Go
a
ahead.
question. So, if the Earth is flat, so why do pilots fly the curved path instead of straight line?
Well, that's a mistake. They don't fly in a curved path. They're charting their course on a world map that looks like a curved path, but the actual navigation over the surface of the Earth, whether or not they're flying that curve, we don't have a way to determine that. So there's no way that they're going to say that they're flying over a curve, because all they know is that they're utilizing the Earth as a horizontal plane. They're flying over a flat Earth according to how they do their job. So that question, I know what you mean, but you've only seen that in the way they are plotting their course over one of those maps, the world map.
Yeah, because that's what they're saying. Like,
Yeah, I mean,
talked to pilot before.
that's fine. You can say that, but as far as like their navigation across point A to point B, whether or not they know they're flying over a curve, there's no way. They don't know that.
Okay.
But I
So,
get what you're
Nate,
saying.
what you're talking about is projecting the latitude longitude coordinate system on a certain type of map, like the Mercator map. The Mercator map's a square or a rectangular grid. So you're confusing the coordinate system with the actual path the plane is taking. So if we use a polar grid, I can show you a photograph from a pilot inside the cockpit where they use a polar grid. And on the polar grid, the plane's path looks straight. Right? But if you took that and then he projected that onto the Mercator grid, that path is going to look curved. It's not the actual plane path. It's just a projection onto a map. Understand?
Yep.
Don't confuse the map with the actual territory.
In many flights, you have TV screens in front of your seats, like in the back of the seat or whatever. They have a screen in front of you, and they will be projecting the flight path on a globe grid. You'll see like it's like a globe, and you see the airplane flying around the globe, and that's what you see. Oh, I'm on a globe flying on the airplane.
If for those of you who have missed it, there was a special website that a guy named Kin provided us, and this image here was the first photograph ever that was shown lateral curvature of the Earth. I'll post it in the text for you guys to see. This is one of their websites, NASA website. 90 years of our changing views of the Earth. That is 21,000 feet above the Villa Mercedes in Argentina. And then the Andes Mountains, according to what it says here, is 287 miles away. 287.
Yeah, I got you. But why do you think they use the okay, I can't say this spherical trigonometry to calculate the distance, like from Spain to Australia like that?
Nobody ever did that in their life.
Really?
Really.
Okay.
Rohan is the he's following along the
What's the
topic of the
command to
room.
kick people out again? I can't remember off the top of my head.
I don't have it for this one. I don't think I've ever banned anybody from here, to be honest.
No, I can text mute him.
Oh.
Force him to come in here.
That would make him want to come in here. Anybody know how to text me, Rohan?
Yeah, I got it. I got it. Give me a sec. 1 sec. I'm gonna warn him first.
Good morning, everybody.
Good morning, sir. How are you?
I'm good, Indio. How are you, man?
Hey, yo,
good,
I'm
man.
here, I'm here. What up?
Yeah, dude. Nobody said trust us, Rohan.
Okay. But
Let me ask you
just say
this.
something?
Let me ask you a question. Can you figure out what the Earth is yourself, or do you have to just simply trust somebody else?
Well, it depends.
No, it doesn't depend.
It does.
Either you can or you can't.
No, that's just your condition.
No,
Me
that
I
is
can or can't.
can a human being figure out for themselves? Yes or no?
Well, see, I just have one question, right? And
No, answer my question, Rohan. It's rude to
I did
answer a
already. I
question with a
said that it
question. That's
depends.
rude. That's bad manners. Okay, so answer my question.
Yeah, I already answered it. I said that it depends. I can't give a
That's not an
definitive
answer. It's a yes or no question.
Yeah, if somebody doesn't tell me, I would have probably gone on the NASA website and figured it out or looked at research.
That's no. I said figure it out yourself. That's going to somebody else to figure it out.
There's no NASA website. There's no internet.
I don't have the resources. To
You go
figure it out.
outside and figure it out for yourself.
So if you had the resources, theoretically, you could figure it out yourself.
Yeah, I would send a spaceship to space if I had.
Well, how do you know you can do that in the first place?
Because if I had billions of dollars.
How do you know that you can do that in the first place?
How do I know that if I can do that?
Yeah, that you can send a spaceship into space. How do you know any of that?
Because money. What do you mean?
Because money?
Yeah, because money.
That's not an
It's that
answer.
simple.
I said, how do you know that? And you said because money.
The thing is, I'm actually getting to an elaborated version of your question in my answer, but you're not letting me do that.
Well, dude, because money is not a fucking answer, dude. I said, how do you know that you can do that yourself because money? You're going to make some stupid... Listen, Rohan.
If I had $1 billion, I would hire a team.
You're just telling me you believe it even harder.
I would hire a bunch of people to build a spaceship and send it to space if I had the money for it.
No, you can do that in the first place.
I know I can do that because people want money, right? And I would pay them a lot to do it. There we go.
But how do you know they can do it, dude? How do you know anybody can do it at all?
Well, I would look.
If no one had ever done it before, you had never heard of outer space. You just woke up. You're the only person in this world. Nobody else is in this world. Would you have figured it out?
That's hypothetical.
Yeah, no shit.
Yeah, so
yeah, we know you like to use your imagination.
Yeah, but that doesn't.
We know you like to use imagination. It does. Go to imagination
I just have. Okay, wait. I answered.
How do you figure it out?
Questions. Can I ask something?
You want to know, Rohan, what we're doing here? Do you understand what you're doing or what we're doing? See, I'm asking you for evidence. Why did you interrupt me? I'm asking you for evidence for what you believe to be true, and you're just making silly sociological claims about how you believe.
Sociological. Let me Google
that. Yeah,
that
there's
word.
sociological claims. You're making evaluations of what human beings can and can't do. You're not making evaluations of what's in the... Why are you interrupting me again? You rude little shit. Really simply. We're asking you for evidence in the physical and natural world, not what you think other people may or may not have done. We don't care what you think they may or may not have done. So we don't care what you believe other people can do. We don't care what you believe, how much money something costs. We don't believe in any of that. We want the physical evidence that you have, that you know any of that shit's even possible. Because just tell me you believe it doesn't tell me anything. Do you have any physical evidence that you can take a rocket and go to space? Rohan?
Can I ask a question? Or
did I just ask you a question?
Just a sec. What?
I just asked you a question. You obviously weren't listening, so I'm going to ask it again. What evidence do you have, other than what you think other people might know? What evidence do you, personally, you have that you can take a rocket and go to space and look at the Earth?
Because first off, your question was hypothetical, so I answered it hypothetical, right? Because then it wouldn't make sense if I answered your hypothetical
Repeat my question that I just asked you. Repeat my question that I just asked you back to me. Repeat it to me. What did I just ask you?
Oh, it's pretty simple. How do I know whether I can take a rocket to space? If I had money for it.
I didn't ask you how you know. I asked you what evidence you have.
What evidence do I have?
Yes, the evidence.
Before.
What evidence do you have you can take a rocket and go to space and look at the Earth?
Yeah, there was a live stream of the rocket actually going into the orbit. So I don't know what you're talking about.
So your evidence is you watched the screen.
My evidence is I watched.
Yeah, your evidence is you watched the screen. Yeah, you watched the screen and they said, here's an image of a rocket going into orbit. And you were like, I believe that.
Why wouldn't I believe that?
Why would you?
Why would I?
Yeah, why would you? Yeah, why would you believe that?
Why would I believe that? Why wouldn't I believe that? Why would?
Because it's a fantastic. Because it's a fantastic, crazy claim.
Fantastic, crazy claim.
Yeah,
I see.
They're claiming they built a fucking 2-story fucking rocket and went around a giant a giant ball that's sitting in a fucking vacuum that's nearly fucking infinite, and to go to a place where they drop things and things don't fall. Okay. Yeah, that's a crazy claim. That's a crazy claim, Rohan. That's a crazy claim.
Really? That's a crazy claim?
Yeah, that is a crazy claim. Do you have any experience with that?
I mean, this seems like a cult, not gonna lie.
Yeah, so your social commentary, nobody gives a shit. This is what I mean by all you have is sociological bullshit. You have no evidence.
Sociological. Okay.
Yeah, sociological. Comments about what people would do, about what they should do, about what you think they know, about your comments are about people. They're not about the physical and natural world. Is science about people or is it about experiments and observations in the physical and natural world, Rohan?
I'm just talking about my perspective here, and
we don't care. We don't care about your opinion. We literally do not care about your opinion.
I'm talking about perspective.
We do not care. 我不关心啊，能听懂这一句。
We do not care about your subjective opinion, Rohan.
You guys
it's
are
based
making
upon
claims
ignorance.
that Earth is flat. Right, that's cool. I get that. That's a cool
Why?
to make.
Why do we think that, Rohan?
In my eyes.
Yeah, no. Why do we think that, Rohan?
In my eyes.
Why,
just like,
Rohan? Shut up.
These are a bunch of guys making claims.
Yeah, okay, you're going on mute.
Up， 不让他说了 ，shut up 啊。
You're hot micing. Rohan, we're gonna try this again. Okay. You're not getting on your soapbox. You're gonna tell us why we think the Earth is flat. Because we don't care about your evaluation unless you actually know our position. So what is our position, Rohan? Why do we think the Earth is flat?
Are you a rocket scientist? Are you...
Answer my fucking question. Why do we think the Earth is flat?
Why do you guys think the Earth is flat? Maybe because it's a cultist belief.
No, but no. But that's not a reason, dude.
That is a reason. That's why you believe.
Because it's a cultist belief is not a reason to believe the Earth is flat.
Every human needs purpose.
My cult leader told me the Earth was flat. Okay, that would be a reason. I want the reason, dude.
Nah, a cult.
Yeah, so you don't know the reason why we think it. You have no clue, do you?
I do.
What
I do
is
why
it
you
then?
think it.
Then what is
I
it?
think this gives you a purpose.
Okay,
that you
last.
believe that
Oh,
the Earth
so
is flat.
some another psychological, sociological argument.
You can prove me wrong.
This,
I mean,
you,
that's what you're here to do.
Okay, I will prove you wrong. We think the Earth is flat because you observe and use the Earth as flat. We've measured the Earth to be flat using all sorts of devices. Lasers, infrared, long distance observation, radio waves, microwaves, you name it. All different types of technology demonstrate that the Earth is flat. Okay? Do you know how? Because the water that's on the surface of the Earth, it has to be curving for the Earth to be a ball, right? Because the hypothesis is there's gravity, and the surface of the Earth is mostly water, and that gravity forms the Earth into a ball. So that means the water is in the form of a ball, and that the water has to curve on its surface. Well, we can just go measure to see if the water actually is curving on the surface, and it is not. That is why we think the Earth is flat, not for any fucking sociological reason.
But for that, but if the Earth was flat, we would know that it's flat.
Yeah, we do know. That's what you observe. You've never seen the Earth as a ball. You saw a screen.
But at the same time, you tell me that I've seen a screen, and then why would all these media channels lie about Earth not being flat?
Okay.
Like, what are they getting out of it?
So, Rohan, okay, if you go on YouTube right now and type in video from the ISS, you'll get it says live stream of the ISS. That's not actually the live stream. You know that, right?
Okay.
Because the actual live stream is on NASA's HDEV site, and if you go on that, the video they show isn't going to be the one that's on YouTube. This illustrates a perfect point, is that you can't tell the difference between what is actually a live stream and what is not.
No, you can't tell what's a live stream and what
Okay,
is
so
not.
the one on YouTube, you already said that was the live stream when it's not. That's pre-recorded. No, it's pre-recorded HDEV video that they live stream to YouTube. So in that sense, it's live, but it's not live from the ISS. And you can't tell the difference.
Well,
Can
the
you?
Earth's,
And you can't tell the difference, can you?
if a celestial body is massive enough,
Yeah,
its own
cool
gravity
story,
puts it
bro.
into a spherical form, so I don't know what you're talking about.
Okay. Oh, really? Okay. Can you
Yeah.
demonstrate? Okay. What's the experiment that shows that's actually true?
What is the experiment that shows that?
Yeah. You just made a hypothetical. Yeah, a celestial body will be formed into a ball. Yeah. Okay. What's the actual experiment, the observation, or the mathematics which demonstrate that to be true?
I mean, it's literally physics.
Yeah, literally physics is not an answer. Give me the mathematics.
Yeah, walk us through it.
Look, bro,
just
give
walk
us
us
either
through
the
it.
mathematics, the observation in nature, or the experiment in a lab which demonstrates that claim to be true.
Well, what I
Yeah, that's right. You can't do it because no one's ever done it.
No one's ever done it.
It's never been observed. Listen, planets have never been observed to form, or stars never been observed to form at all, much less knowing the cause of why they would form. Okay? Just because they appear to be circles or spheres now doesn't mean they form because of the reason you say, right? No one knows why they form because no one's ever observed
Nah,
it.
this is not my reason. This is Google's reason. I
This
would
is
rather
good.
believe
Oh
Google.
my goodness gracious. It's Google's reason. Did you really say
Wait.
that?
I
You said
mean,
we're in a
the
cult. You're in a
daily-
cult
the
of
things that
Google,
you
dude.
do
You're
on a
not even
day-to-day
ruled by
basis are
people. You're
also
ruled by
backed
a fucking
science. I
goddamn
feel like you're
AI.
contradicting your entire existence on
Dude, you're in a
something
fucking
that you
cult of
think it is,
Google.
'cause
Dude,
if you don't
your
believe in any
worldview came from
institution,
Google
you don't
and
believe in Google, you
YouTube.
don't believe in anything, then
No, I
feel
believe in
like
lots
you
of
shouldn't
things.
shower, you shouldn't brush your teeth,
I believe that you're a
or you
troll.
shouldn't
I
have
believe you have no
6 or 8
argument.
hours
I
either.
believe that you're just coping right now.
Coping
You haven't
I
made a
believe he's
single
in a cult,
argument,
and I can prove
Rohan.
it.
I mean, I wouldn't care if the Earth is flat or round. I'm just like getting your explanation. I feel like there's so many contradictions in what you're saying.
Yeah, I feel like no one cares what you feel like, dude. You
No, I
can't
mean,
point
no,
out a
there are
single
Indio-
contradiction I said, Rohan.
What you're saying.
You
'Cause
can't
one
point out
Can I
a
ask
single
him a quick
contradiction
question?
I
believe
said. So
anything
now,
anybody
this
else
is the thing we
says,
typically deal
which
with, Rohan,
means
is you guys
shouldn't be
resort to
showering, you shouldn't
lying.
be using a toothpaste either, or you shouldn't be doing all these things, right?
What
If
are
you
you
do those, then
talking
you're
about?
contradicting yourself.
Where was it? No, that's an all or nothing fallacy. It's not a. You're making
No,
all
it's
or
not an
nothing.
all
Either you
nothing
accept.
fallacy.
Look,
It's
Rohan.
pretty simple.
No,
You said
you're trying to
you clearly
You're trying to
you
say
clearly said
if you
that
don't do an all or nothing fallacy, that you're contradicting
you
yourself. That's
clearly
horseshit.
just mentioned that
Yeah.
it's all the
Clearly,
claims are
you're
coming from
wrong
other
because you
people,
tried to. No, because
right?
it's a logical
Right?
fallacy, Rohan.
So wait, if you
It's an
didn't
all or
invent showering, you
Rohan.
shouldn't shower either then, right?
No,
Does
that's
that
a
make
logical
sense?
fallacy. Okay, that's called an all or nothing fallacy. That you have to accept everything that someone says or nothing. That's a fallacy.
Everything someone says or nothing.
Yeah, so everything science purports to say, you have to accept all of it. But if you dispute one part, you have to dispute it all. That's horseshit. That's an all or nothing fallacy.
Well, if you
Yeah,
take a
and
small
it's not a
blob of clay
contradiction.
and
Good
shape it
try
into,
though
you
with
know, rough
rhetoric, but
uneven lump,
rhetoric
and
will
like you
not
dip
rule
it
the
into a
day
bowl of
here.
water, that kind of reduces friction. And you know, it's like over time, the clay becomes more rounded. It's because gravity exists. You know, the
Okay, cool
gravity
story,
is
bro.
making that
Yeah, so anyone
thing
observe that?
round,
Yeah, anyone
and there
observe
is
that?
gravity in
Yeah,
space.
has anyone
The Earth would
observed
be
that?
round.
Well, let me ask you, Rohan, is science based upon empirical observation, yes or no?
No.
Okay, you're going on mute. You're an idiot.
Wow.
Yeah, he's created his fantasy world, and he won't allow anyone to take it away from him. And to be into that position, he has to deny the reality and the truth. So obviously, he's on mute. How can you
He
say
just
no?
said science is not based upon observation when science is defined as the systematic study of the natural world and the things in it. Now, if you don't observe nature, which is what science is about, how do you say anything about the thing you're not observing?
Exactly. Yeah. You know, he wasn't listening to what you were saying. He just wanted to talk about his fantasy. That's all he was doing. Just going on like a robot. That's what he was doing.
You just wanted to chant that we're in a cult and, you know, whatever.
Yeah, silly. There are measurements. When you hear the word measurement, when you hear the word measurement, that's integrity right there. Because you're now going to be examining using whatever unit you're going to use to measure, but now you're making a concise observation now, or measurement of your observation, let's say.
Sheepdog, you want to talk sense?
I did want to ask him a question to see if he was in a cult. Should I unmute him for a moment and ask him his question?
Yeah. Feel free. I got what I want. Say something stupid.
Rohan, I got a question for you, man. I want to know if you're in a cult. So, if the surface of the Earth is not curving, then the surface of the Earth must be what?
But the Earth is like 7,000 kilometers wide. How would you know if it's curving or not?
You're in a cult, bro. You're in a cult. You can't even answer the question.
A cult would mean that
your
I have
cult
a
won't
belief
let you
that's
answer the
outside
question.
normal. I feel like you're in a cult though. Think about it, because
You are. You can't even answer the question honestly.
Sticking with it. That's a cultish belief.
You can't even answer the question honestly.
No,
I can prove that I'm not in the cult because I will answer every question from here on out.
I mean, you know,
whatever question you want, I'll answer it honestly. I bet you won't answer my questions honestly.
The Earth does curve. I don't know what you're talking about.
How much?
The Earth does
How
curve.
far away is the horizon?
What?
How far away is the horizon?
How does that matter?
How far away is the curve of the Earth?
None of that matters because the Earth does curve.
It doesn't?
No, it doesn't. Because the Earth does
Well, I mean, if it's curving, then that would matter, right? If it's not curving, then it's what?
But how do you know that it's not curving?
Because the horizon's not where they say it is.
Then know what they say it is, and you have seen this yourself?
Yeah, I've gone out and seen it. Most of us have in this room. We do it on a regular basis. This isn't like a one-off thing. You can go check yourself. How far away is the horizon?
Cult is, right? Now you have a belief in your head
Rohan,
that the Earth is actually flat, and now your brain is just finding reasons for it to be true.
Rohan,
Close your Dorito chute for a second. In fact, as a hobby, I jump out of airplanes. You know the things Globers come in here and claim they see the curvature from? No matter the altitude, no curvature when I jump.
Maybe your field of view doesn't allow it. How do you know that? Maybe the field of view that your eyes perceive, your eyes can only see so far, right?
You don't even know how far the horizon is. You don't know anything.
It doesn't matter because your
it
eyes
does
can only
matter.
see
It
so
does
much.
matter.
So whether I
Because we're
know
talking
that
about
it's
curve
horizon
over
or
distance.
if
We're
it's
talking
not,
about curve over
your eyes
distance,
still
Rohan.
work the
Rohan,
same
we're
way.
talking about
It
curve
doesn't
over
matter
distance.
if I know
Jin, let me ask you, Rohan. If it doesn't
Yeah.
matter, then do boats go over the curve?
Do birds go over the curve?
Boats, ships. When
Well,
ships sail away, do they go behind the curve?
well, the Earth's curve is so big that you won't notice it even if they do. Yeah.
Right. So how far?
Right.
So how far away is the curve when boats start to go behind the curve? Does the sun set behind the curve?
Well, see, the logic is pretty simple here.
Does the sun set
If
behind
the
the curve?
boat is hitting that curve, you wouldn't
Is the
notice that
sun
it's curving because the
is
Earth
the
is so
sun
huge.
Look,
Dude,
is the Earth
you wouldn't
spinning?
notice the curve.
Is the Earth
Yeah, of
spinning?
course. Yeah, of
Okay, and then does the sun set behind the Earth when the Earth spins?
That depends, right?
The Earth is spinning. The sun comes across the sky because the Earth is spinning, and when the sun sets, it's now nighttime because the Earth is facing away from the sun, right?
Wait, let me just Google this for a minute. What?
Oh my God!
No, I mean, I would like believe whatever Google says because it's
You
just
have
like
no
your
knowledge.
opinion.
You have no knowledge. You've got to keep Googling. You've got no experience. Nothing. You're empty here.
Dog, see,
How
it's
dare you
your
tell
word
us
against
we're in a
Google. It's
cult? How
your
dare you?
experiment
No.
against Google. Now
How
the answer
dare
is
you?
so, bro, of course I'm gonna be a little
No,
skeptical.
Rohan. How
Like,
dare
am I
you
not be,
say
am I
to
not
Rohan?
allowed to
Shut
be
up.
skeptical?
Shut up. How dare you tell
Why
us
am I
we're in
not
a
allowed?
cult when you have to Google what you already believe?
Well, because you're in a cult, because one,
Yeah, no,
you're a
you're
very
in a
small
cult.
number of
You have to
population
Google what
claiming
you
something
already
really
believe.
absurd.
You already
And
believed it.
second of all, you genuinely believe this, right? So that's how cults work.
Dude, you
So this is
believe
how
shit
cults
you
work.
don't even
Cults
know. You have
believe
to
something out of
Google.
the ordinary, and they stick with
Rohan,
it.
shut
That's
your
sheer
fucking
doing.
pie hole, dude.
And I'm not
Or I'm
believing
gonna
anything
shut you
out of
up.
the ordinary.
3,
I'm actually looking for
2,
various references.
1. Rohan.
Yeah.
You believe something and you have to Google it.
So?
You already
What does
believe
that
it.
prove?
Without the
Yeah, so?
information required to
So
justify the
why are
belief.
they mutually
Why
exclusive?
did you just
So
interrupt
why is
me?
it mutually
Why did you
exclusive
just
that I
interrupt
believe
me?
something and
Why
it's
did you
false?
just interrupt me? Dude, this is very fucking simple. You believed it and then had to Google for the information to justify the belief. You have to check with your fucking cult to see what you should believe and why you should believe it. You're the one in a cult. You're projecting your own fucking problems on us.
That's not how it works, though. That's not what a cult
It's
is.
exactly how it works.
No, not really. I think you're not understanding meaning of what a cult actually is.
Yeah, there's a dogma, and you have to believe in the dogma. You already believe it. You're
Well, those are
checking
just
what the
fancy
dogma
terms that
is.
mean nothing.
You
Because a
had to
cult
check
is a
what
relatively small.
Rohan, you had to check what your dogma was. You had to check with the frickin' high priest to see what you actually believe.
He literally said, I literally told him exactly how the globe Earth works, that the Earth is spinning, and because it's spinning, the sun moves across the sky, and when the sun goes away and it becomes nighttime, it's because the Earth is facing the opposite way from the sun. Hold on, let me go check Google.
He had to check. He had to check to make sure you had the correct dogma. Literally. Does Sheepdog have the correct dogma, Rohan?
There's no way a flat earther could get.
Does Sheepdog have the correct dogma? So when you Google to check Sheepdog, is he saying the right thing?
Depends on what he's saying.
as the Earth is traveling around the sun, the Earth is spinning on its axis. When it's daytime, the Earth is facing the sun, and when it's nighttime, the Earth is facing away from the sun. Because the Earth is spinning, the sun moves across the sky, and when the sun sets behind the curve of the Earth, it's now dark time because the Earth is facing away from the sun. That's what you believe, right?
I believe that there are different times in the day wherein in some parts it's night and in the other part of the earth it's day. So of course the earth.
Why is it nighttime in some places? Why isn't the sun shining on those places?
The sun isn't shining on those places because one, the earth is spinning and the sun, I mean it's spinning around the sun, and when the earth is spinning within the 24-hour cycle, in some places it's day because the it just changes. You know what I mean?
No, I don't know what you mean.
It's because the earth is spinning. That's why it's round and it's spinning. That's why that happens. The 24-hour cycle.
I think you should Google it again to find out. You should Google it again to find out what you believe.
This guy, bro. It's not that hard to understand, dude.
I mean, look at this point. It's your
when the Earth is facing towards outer space.
I would believe them over you guys. I don't get what is so like confusing
We don't want you to
about
believe
that.
us.
Yeah, it's not about believing, right?
It's not about believing us.
Technical, strong.
But here's the thing, Rohan. I used to believe in the globe for 39 years.
Know what I mean?
I now know the globe better than most globe earther believers. There's a reason why I'm a flat earther. I know the globe better than you.
I mean, the Earth. I just googled why the Earth is not flat. The Earth is not flat because gravity pulls matter together into the most efficient shape.
Okay, great. We already covered that. I said let's check that hypothesis. What was the experiment, observation, or mathematics
The
which
experiment
demonstrate
was
that?
if you dip a mushy round of clay into water, after some time, that
What does that have to do
ball
with
of
gravity
clay
forming
becomes
things into a
round,
ball?
and that's gravity doing its thing. So why wouldn't that
What are
happen
you
on a much
talking
larger
about?
scale,
So
like the
putting
Earth?
water into clay is gravity?
Putting water into
Clay into water?
but the clay
What
which
did
is
you
lumpy,
say? Say that again.
which has lumps, it becomes
Yeah.
round eventually, and that is because of gravity.
Okay, that's your claim. I want the evidence for the claim.
Evidence for the claim?
Yeah, the
The
evidence for the
claim
claim.
would be you dipping clay into water and seeing it.
What?
That's yeah. If you
No, the
dip
evidence
water
that
into
gravity
clay,
forms things into
I mean
balls,
clay into
Rohan.
water,
Try to
you
try
make
to
it
keep
a
up,
mushy
bro.
thing, and
The evidence that
eventually after
gravity.
sometimes it becomes round.
Okay,
Because of
is that caused
gravity.
by gravity? Is gravity the
Yeah,
cause
it's
of
because
that?
gravity. Yeah,
Okay.
gravity is the cause.
We
of that.
want the evidence, right? The observation of gravity forming something into a ball.
The observation. Let me look it up. Let's see if there are any experiments on that.
This is getting better.
Gravity making things round. Way.
Yeah. The actual
Gravity makes
observational evidence.
Gravity makes a large celestial bodies round because it pulls all matter equally towards the center of mass. And the sphere is the most efficient shape for this.
Is that a claim or is that evidence?
That's not a claim. Wait, there has
That's
to
not a
be.
claim.
You want evidence? Okay.
Yeah,
Let's look
evidence
up
would be
evidence.
you actually make the observation in nature with some type of instrument, telescope, your eyes,
Oh, there's a
freaking
YouTube
microscope.
video.
So shut
I'm
up.
gonna.
Shut up. Why are you interrupting me? So you make the observation in nature, right? And you record the data. That's what we want.
That is nice.
Well, there's a YouTube video on it.
Of it being observed in nature?
Have you watched it? Have you watched it?
Yeah.
दिमाग खराब
Yeah,
कर
I've
देंगे
seen
इनको।
it.
Hey, Rudy, you're hot micing.
Yeah, I'm so sorry. Hello there.
Wait,
Hi.
how do I send this video to you all? Wait, it's called.
It better not be a
Gravity
simulation.
Visualize.
No simulations. I said nature.
Yeah, but then that's
nature.
a wild claim to
We
make,
can
though,
simulate Superman
isn't it?
flying around. We
Now
can
you
simulate
want,
frickin' cars
now you
jumping
want
buildings in
something
GTA.
That is so
coming out of
true.
your terms and conditions, and that's a cultist belief.
That
That's a cult belief.
science, you know, that science is based upon empirical observation.
Nah, it's based on simulation as well. Nowhere
No,
it
it's
says
not.
that simulations are wrong.
No, even if you have a simulation, that simulation has to be verified with a natural observation. Otherwise, how do you know your
No, not
simulation's right?
really.
How do
That's
you know
not
your
how it works.
simulation's right, Rohan?
Simulation
I
shows
saw,
us
I
how
saw
it works
simulation.
Answer this
naturally.
question. How would you know your simulation is correct if you don't compare it to the natural world?
I saw a simulation that the Ninja Turtles were real.
One sec, wait.
Answer my question, dude. How do you check your simulation if it's correct?
By using science, logic, and math.
By using science? No. Science is...
Yeah, but gravity is literally...
Rohan, you said
gravity
science.
makes large
What is science?
objects around in real life by
Y-
pulling
no,
of the
in real life
masses
they
towards
get
a central
no.
point. So I
That's
don't
the
know what you're on about. I mean,
yeah. You
the
can
statement is so simple. Even a
yeah.
10-year-old
I
could
understand the
understand this.
idea.
And
Okay,
I feel like
I
you're in a
understand
cult.
that. Rohan,
I feel
shut
like this
up.
thing is a cult.
I understand the idea. I understand the hypothesis.
Yeah, so
I
if you
want the
understand the idea, if you
scientific
understand the
evidence for
hypothesis,
it.
then you already have your
Why are
answer.
you
That's what
over
makes it a
talking me?
crown.
You fucking utter clown, dude. I want the scientific evidence for the hypothesis being true.
Bro, the scientific evidence
Is the
is
observation.
a simulation that you create because gravity universally already
So you just say
exists. So
you're just saying the hypothesis
that
again.
correlates with gravity is
You're just
real.
saying the hypothesis again.
So
I
if
want the
you reject
experimental
that,
result.
you probably are in a cult.
No, I want that. You just state you're in a cult, just chanting the hypothesis over and over again. I want the experiment that confirm the
not a
hypothesis.
It's real.
Okay, your hypothesis is gravity forms things into balls. Okay, we've heard you 50,000 times say the same thing over and over again. We want the experiment which confirm the hypothesis is true. Go.
State of denial.
Go. You were talking the whole time that you were muted? You know you just been muted for like 30 seconds, right?
Oh no,
You're
I was on
psycho.
a different tab.
No, you're a
I
psycho.
didn't see.
Yeah, you're a psycho.
Oh yeah, I'm totally a psycho for being on a different tab. Yeah, man.
No, you're a psycho
that's
because you're just chanting. You don't even realize you're muted because you're not listening or paying attention. So for the last time, I'm going to ask you
I'm
one
not
more
paying
time.
attention because this is a cult.
What do I want? What did I ask you for?
And I told you, gravity makes celestial
No, what I asked you for, I want you to
because it pulls
repeat to me what
equally
I
from all
asked you so
sides
that you
towards the center
understand.
of Mars, and you can look up the mathematics for this as well if you're that curious.
Mathematics is still the hypothesis.
You know what I mean?
Yeah, mathematics is still the hypothesis. We want the experiment which confirmed the
Well,
hypothesis.
if everything according to you is a hypothesis, then that is a cult, right?
No.
Everything
That's
according to you is
that's a non
hypothesis,
sequitur.
Everybody's lying.
If everything is
For
a
some
hypothesis,
reason,
you're in a
people are lying
cult.
that the Earth
You're
is
a
flat,
retard,
and
dude.
that is a
Okay,
cultist
I'm done,
belief.
dude. Yeah, dude, you stop making sense. You're in full fucking cult mode. Okay. Scientific claims, scientific hypotheses require experimental validation of the hypothesis. This is called the scientific method. Okay. So, one more time, you need to do two things when I unmute you. You need to tell me what I asked you for, and then provide it. What did I ask you for, Rohan?
Hey, give me a minute.
What did I ask you for, Rohan?
You asked me. Wait, how would you see that though? You would need to go to space for that.
Okay. What did I ask you for?
But you would have to go to space.
3 times I've asked you now.
Yeah, but
4 times. This is the last time I'm asking you, and then I'm kicking you out of this chat. Okay. What did I ask you for? What did I ask you for?
Just a sec.
I asked you for evidence of the hypothesis is true. So this, that might have been frustrating, but I wanted to do an exposition on a fucking cultist accusing us of being cultists, which is frickin' batshit crazy.
Just prove it to you with the YouTube, though.
Yeah, watch the simulation. There's my evidence. I made a video game.
So you think it's a globe? What would be the best way for me to understand a method that I can know that the Earth is a globe? Give me like a method I could test.
I'm not here to prove nothing. I'm just listening.
Oh man, come on, bro.
It's all
Hey,
right.
I'm just listening.
We don't
man.
bite.
Billcat, honestly, don't even try. These are just mental retards. Don't even.
Oh, come on. No. We're here actually demonstrating that nobody can prove it, and nobody ever has.
Shut up.
So it's all fun and games, right? You think we're joking? It's all fun and games until like you hear us talk to satellite engineers and surveyors, and they can't prove it either.
This is my point of view. Is even if flat earthers are correct, that it doesn't really matter because it's like, well, everybody agrees otherwise, and so if I start saying flat Earth stuff, then people are gonna think I'm a fucking quacko.
Yeah. Okay. So guess what?
I'd
That's
rather
what makes
not
this
be a
so much fun.
So, yeah, I don't like being a quacko. I like being like part of
Well,
society.
no, I mean you're not quack. You're correct, right? I mean there's a difference.
Plus, I love NASA as a kid, so fuck that. You know,
I still love NASA. Okay, I love NASA as a flat earther.
Santa?
I can name the solar system from heart. You know, I love NASA.
You still believe in Santa too?
The fact we're flat earthers because we study the globe more than you do.
I'm sure.
Right.
All right, so like me just telling you that, and you just deferred to like, well, there's no way that you can prove it. So doesn't that show you that most people are like you? They just believe that it's a globe. And well, like you're saying,
what it tells me is that this is like a topic that you like obviously talk about over and over. So you've like some prepared arguments and stuff. And for me, this is something where if I put an equal amount of preparation into, I absolutely could prove my position. I guarantee it to you.
Well,
But
I like that.
It's just me going from voice chat to voice chat, casually listening. You know, so it's like
But no, but check this out, man. I like that you're actually saying that. So it's like you say, we have something prepared. Well, we do. But the other side of it too is like we're telling you, and I am, is that people don't know that the Earth is a globe. We've spoken to the people whom you might think know, and even those guys defer to other people. So nobody actually knows. We just get
for
like
example, imagine we had like an like a 24/7 no oxygen channel, right? Where they're saying that when you breathe, like hear me out on this. When you breathe, there's no such thing as oxygen. You're just breathing like something else. I don't know. Let's say there's pretend that's like a thing, and I join the channel, and I'm like a person who thinks, okay, when we breathe, one of the things we breathe in is oxygen, along with like nitrogen and other things. But you know, so I'm a person who thinks that, and I join the channel. I'm just listening. I don't have like a scientific dissertation prepared in my head to explain that. Oh, we breathe oxygen. That's what I've been taught.
Bro, we just need a measurement.
Shit, you know.
Yeah, but the surface of the Earth is something that you encounter every day of your life, and not only that, you have the same experience that we do when we talk about the Earth. So it's not unlike you to say, well, I'm not an academic, so I can't speak of the matter, because you experience the same Earth that we do. So we're not. Let's put it this way, Billcat. Billcat, hold on. What I'm saying is, yeah, I get your point, right? You can't deep dive into it, like the quantification of the like math or whatever. I get it, but what I am saying is that you can like what we say, what we see, our experience, and what we observe is the same thing that you would. It's not any different. So it's not like we're talking about two different kinds of Earths, if that makes any sense. We're not doing that. We're just saying what we see.
What I'm trying to tell you is, if we're going off of just purely our firsthand observations, right? I have flown several times.
No, we're not.
And in the course of flying, well, he just said experiences. So he's telling me what we.
That's the foundation, dude.
So can I get a sense out? Like, you're asking me questions, you want a response, you have to allow the other person to respond like a mature adult.
But you're mischaracterizing what we're claiming.
You have to let the other person respond if you want to have a mature conversation.
I'm going to stop you from mischaracterizing what we're saying, though.
Yeah.
What is being mischaracterized? Please.
Yeah, our experience is the foundation only. What we've come to the conclusion of flat Earth based off of measurements. Okay, this goes beyond just looking at it. This goes beyond just what's in your visual space.
So what I'm responding to is the person who was previously talking, not you, but the one before them. I didn't say I've flown many times. I've flown a couple times. So I'm specifically.
Okay, so
you said okay.
Hey, previous
what do you
person,
mean-
do you
what do
agree with what I said or
okay?
no?
What is the point of having a conversation here if you're just going to talk over me every time?
Well, if you're just going to mischaracterize what our position is, right?
What are you like
then
a
what's the point of a conversation?
What are you a collective consciousness? Our position. I'm responding to one person's statement, not yours, and I don't even remember.
Well, you're mischaracterizing what that person said. Now, maybe
totally
the previous
correct.
person would like to weigh in.
What did that person say? And who
Yeah.
was it?
Well, I couldn't finish because you jumped right in after I finished saying that we
I
observe the earth.
listened to you for 5 minutes
Like
talking.
you're doing, you're doing now, like you just did.
Go
now.
ahead. Go ahead.
All right. So when we make our observation, the common human experience is that we see a flat Earth. So that's what we're all seeing, a horizontal plane. But then when we start to actually take it to the next step, which is the point of measurement, we're going to do tests to actually verify that it's not just that what we see, but we can also measure across the surface of it, like in the case of measuring over large bodies of water, which is going to give us the information needed to make the statement that the Earth is not just observably flat, but it's also measurably flat. And we're going to take distances that are going to equal to above and beyond the expected amount of Earth curvature that should obstruct the line of sight distance or a targeting distance, which would be like laser targeting or mirror flash targeting. Anything that we use from point of observation to a target distance, and we can say over a safe distance, right, 15, maybe 20 miles, we're going to be able to tell you that it's not just observed as that, but it's also measured as such. So it's far beyond that too. We navigate across the surface of the Earth as if we're traveling over a horizontal plane. So there's a lot to it, man. Like, and for us to get into it, you're going to have to allow it for the conversation to unfold and not mischaracterize us like the gentleman was saying.
I don't even know what point you're arguing at this point because, truthfully, you just I don't know. It's gone on so long and long. I understand. Yeah, you believe I've mischaracterized you. I'm not trying to mischaracterize you. Yes, you believe you have measurements. That's very interesting. The only point I was making is you had mentioned that oh well, yeah, you're not an academic and I'm not an academic and I don't have to have some academic thing prepared and you're happy that I'm honest about that and you were honest about that, etc. And my point was that okay, well, if you want to talk about like a firsthand experience, I've flown like 3 times in my life, right? I don't know why this guy's like yapping inside chat and lying and saying I've flown many times. Never said that. Said I've flown a few times. I've flown 3 times in my life, and of those times I flew, 2 times I had a window seat and you could see curvature of the Earth, right? That pretty much cemented it in my brain. You could see the curved outline of the Earth. So
okay, I didn't want to interrupt you. Did anybody else want to jump in before I start? Okay.
No, take it away. Thanks.
So basically, you made an observation, is what you're saying, right? What you were telling me, you were actually mischaracterizing, or you were starting to, but then Yoder jumped in, and now I made my point clear. So the very thing that you said, you didn't want to, or you were saying that you were going to mischaracterize my position for just making an observation, is exactly what you've done. And so you're saying you saw the Earth looking curved, so therefore it is curved. Is that what you're saying? Just based on an observation?
Saying I, from a first-hand observation, have seen the curvature of the Earth.
Right, that's fine. Would you make the declaration that would solidify that the Earth is a globe based on that observation?
I would say that I have made the observation the Earth is curved, and from that I can conclude that if it continues to curve and curve, it would be circular and then globular because we're in a 3D reality. So
okay, so based on your observation, though, right?
Yeah, based off just seeing the curvature.
Okay, see, the thing that you were trying to tell me, because I see a flat Earth, then I'm declaring that it's flat. You were saying that's just incorrect. You can't do that. So now you're doing it. You're basically a hypocrite. You're now doing the thing that you said that I was doing.
You got to be like a little more cohesive on what you're actually trying to say, because I'm not tracking here. I'm listening very.
So you're looking outside of your airplane window, and you see the Earth looking like a globe, right? It's curvature.
I see the curvature of it, yeah.
Right. So now you're making the declaration that I see this curvature, and I've been told all my life that it is a globe. Therefore, now I know it's a globe because I've seen it with my own eyes. Right?
Yeah, I can Google that, yeah.
Okay.
It's pretty
all right.
sound.
Well, it's not. So we're going to have to actually figure out, okay, so you saw the curve of the Earth from an airplane window. But I'm here on the ground, and I'm saying it looks flat to me, man. I'm making my observation, and it looks flat. So we're going to now compare. How do we know who's right? You saw curvature up there. I'm seeing a flat Earth down here. And even some people listen to this. Listen to this. Even some people next to you on their plane could say they see a flat Earth. I don't see a curve. I see a flat Earth out there. And you're like, no, I see a curve. Look, it's right there. And they're like, I don't see a curve. I see flat Earth. So how would we find the deciding factor?
Made pudding. You just kind of created this hypothetical.
Yeah, we just wait until I'm done, and then you'll just wait till I'm done. You're very rude by interrupting me. Wait till I'm done.
You've done several times.
Wait till I'm done.
You had Master Yoda cut me off when he was mischaracterized.
Yeah, but wait till I'm done.
Your position according to you, and you cut me off during that.
Oh, because I wasn't done yet.
I'm going to cut you off right now and say you're mischaracterizing. I don't know what this is right now.
No, I'm not mischaracterizing you. I'm not mischaracterizing you. I'm not mischaracterizing you.
Well, what if your fellow passenger said the Earth was flat? It never happened though. So what do you?
Yeah, it does, because there's people in this room that have flown in a plane.
It didn't happen on the flight that I was on. So what are you talking about?
It doesn't matter. People have flown in planes and said that the Earth looks flat. All right, so people have done that. There's people that exist, and they're in this room right now that have flown in a plane and said that the Earth is flat. That has happened. So okay, let me just tell you this. I want to get to my point. So if you're saying that the Earth looks curved from an airplane window, and somebody says it looks flat, what would be the deciding factor that gets us to understand whether it's one way or the other? How would we know?
I'm not going to engage in a hypothetical, which hasn't happened.
No, this isn't a hypothetical. People actually fly every single day.
I was in an airplane. Nobody on the flight said it. You said, "What if your fellow
passenger
said it?"
You're not the only person. Listen, brother, you're not the only person who's ever flown in the plane. So you can't just make it like only you and the passengers in your plane. Because anybody who's flown in a plane at the altitude that you've been at, they could see the Earth for themselves, and they can make the declaration like you did, whether it's a globe or flat based on what they see. And there's a lot of people that say that the Earth is flat from an airplane window. I know that because I've heard of it. People always say it.
When have I ever said they can't do that?
Well, right now you said, well, not in my plane. Well, it doesn't. I'm not talking about just your plane.
You said your quote, exact quote, my fellow passengers. Exact words.
So if your fellow passenger, one person would be arguing with you, would be like, dude, how would you find? It doesn't matter. What I'm saying.
They're not my fellow. Just say other people.
Listen to this. Listen to this. Yeah, it's a hypothetical and it's practical because you didn't ask every passenger either. You didn't do that either, so you don't know. So what I'm saying is, though, if somebody was to say that to you, how would you find out what the real meaning of what you see is? How would you be able to know whether or not it's curved? So you'd have to be able to measure it, wouldn't you? Go back down to the ground and see if you can measure the curve. Because if you've seen it, it's there. Therefore, when you go back down to the ground, it would still be there. It wouldn't go away. It would still be there. And so the guy who thinks the guy who thinks he saw the Earth as flat in the airplane window would be proven or disproven based upon a measurement on the surface. Then at the surface level, you could say, okay, let's do this. Let's test to see if we have this drop over distance because we have a curving surface. The surface of the Earth being a geometric shape like a globe, it would have the property of the surface having that curved path, along the line of sight. So if you have a line of sight and you say, okay, at a far distance away, we can't see anymore, and that's because the Earth is cutting it off because it's dropping away. We can't see further past the curve. That's fine. If you're able to prove that, then the guy who's sitting next to you, hypothetically, like I said, would be able to say, okay, you've proved your case. The Earth is curved because you measured it. There's at a certain distance away, it's predictable to say that we can't see anything farther past that because the Earth's curve would be in the way. So therefore, you would be able to prove to him that not only did you see it up there when you were in a high altitude, but you proved it because it was measured as such on the surface.
Such as this, for example, right here. Here you go.
Such as what?
You said you wanted measurements on the ground.
You gotta be kidding me. The Netflix special?
All right. Yeah, but dude, they didn't measure the surface of the Earth to be curving. Okay, so if that's your evidence that
you're disagreeing with their methodology,
no, I'm disagreeing that the fact that you use somebody from the internet, like a YouTube video, instead of pulling from academia. I'm disappointed that you didn't pull from academia and you actually pulled from YouTube video of some guy. You said,
hold on, you said you were giving me. No, you mischaracterized me again. I'm going to talk over you for a moment.
No, I'm going to have to hold you to this, dude. You're using a guy who's a no. Who said he was a flat earther? Yeah, dude, no one's going to be able to hear us because you're just over talking me.
I think we need a different tact with this, guys. I think our friend
talking down to me.
I think our friend should
quiet.
Billcat, why don't you walk us through the details of what they did?
What do you mean?
Please walk us through the details of what they did in the link you provided. Okay, the audience wants to hear you explain it, especially for those listening.
So what they did, right, is they had two different people at like two different positions, and they had them like talking on radios and shit, right? And they had one person like really fucking far this direction, and then one person really fucking far the other direction, right? Far enough where if there was no curvature of the Earth, they would be able to point a laser through a hole, and it would be able to go straight and then reach the other people, right? It would be able to reach the other piece of, like, I guess they're using like a piece of wood or something like that, and it would be you'd be able to see the laser, right? But because of the way they do it, and when they do the curvature of the Earth and they try to adjust for it, you can still see the laser, even though you shouldn't be able to see it.
Just quickly, just a question, because you keep saying laser. Would a flashlight count as a laser, do you think?
I don't think that's concentrated enough, is it?
Like a regular flashlight, would you call that a laser? Like, would that be comparable to a laser, do you think?
Close enough, yeah. Like for the purpose of the experiment.
You did a lot of things incorrect. Like, you didn't state for the audience what the distance was away. You were very ambiguous. It's too far. It was far away, far enough. That's not an actual numeric value. You have to give a known distance to actually get an
explanation. You just asked for like a general what's going on in the video.
Yeah.
Well, they have this.
Yeah, how they determine how high up they were?
I gave
from what?
I gave you like a layman's explanation of it.
Yeah, okay, so how'd they determine how high up they were? And how high up from what?
I don't remember. I just had a layman's explanation of it. They just had like one.
So you don't know how they measured their own heights?
Dude, you got to calm down. I'm just having a
No, I'm just pointing out that you have no idea what you're fucking talking about, because I know you didn't watch it. Want to know how I know you know? I know that you didn't watch it. It's because they didn't use a fucking laser. That's how I know you don't. You never watched it.
English not my first language.
Obviously not. So why are you presenting something beyond your ability to? Why are you presenting something beyond your ability to detail for the audience?
Flashlight, you're criticizing me now because it's not my first language. Like what are you, dude?
Well, hold on. The other guy, DJ, just asked if you knew the difference between a laser and a flashlight. You clearly did.
Beyond my comprehension.
So now you're lying.
Now you're just making shit up.
No, you're fucking lying.
Now you're just making shit up.
No, it's because the previous guy, DJ, basically had you clarify the difference between a flashlight and a laser, and now you're telling us that you didn't really know the difference between a flashlight and a laser.
What is the difference?
So you don't even know the difference between a flashlight and a laser? It sounded like I thought from DJ you told him you knew the difference.
I don't know this language. Well, clarify for me.
Sorry, I mean, I'm not going to teach you the difference.
I'm not either.
They know it all. Can't explain very basic thing to me.
Collimated light. All right, now go Google that shit.
Collimated light? Can you be more specific?
Collimated. Yeah, there's a collimator. Do you know what a collimator is?
No, he doesn't.
Yeah, you don't know anything about the claim that you presented to us as proof of a globe.
Huh?
So you're going to have to go back to the fishing hole and find something else, because we threw this fish back in the water. It was fucking lame.
What are you talking about, man? I just posted some YouTube video and I was like, hey, here's like a layman's explanation of it.
You didn't know. You don't know anything about it, dude. It's not a layman's explanation. A layman would be able to tell it in some kind of way, make sense of it. You couldn't even do that.
Yeah, that's what layman's are good
You
for.
asked for like a layman's explanation. I just gave you like
Yeah, layman should be able to break it down in clear terms for the average man.
Yeah, they have
You're not doing a layman's explanation, dude. I'm sorry, but you're not doing a layman's explanation. You're not doing that.
Yeah, you were bullshitting, dude. That's what you were doing.
You're bullshitting. That's
a layman's explanation, man. I don't know what.
No, you're not.
What am I
not
bullshitting about? What am I bullshitting about?
You don't know anything about this.
We should rename Billcat Bullshit.
Yeah, you don't know anything about this. You presented something. You presented something confidently, like you knew what you were going to do, and then at the end, you had nothing about it.
I didn't present anything confidently. I just presented a clip, and you said we need measurements on the ground. I'm like, well, here's a measurement on the ground.
Yeah, what's your native language, Billcat?
I'm very unhappy, bro. I understand why. I just posted a video.
What's your native language?
And that was it.
Yeah. What's your native language, Billcat?
Hey, I'm not doxing myself. Fuck that.
Doxing yourself? What? You speak a language of what? Like, I'm the only one who speaks Klingon.
Only 55,000 speak this language. Yeah.
Oh my god, dude. Or whatever. All right. So we found out that you don't even know anything about what you just presented. Not even a layman's explanation, as you said. You didn't even do it as a layman.
I just gave like a layman's
No, you
explanation.
didn't. Absolutely not. No, you didn't. That's an absolute lie. You're bullshitting your way through something you thought was evidence
I
of
just
the
gave
Earth
like a
being a globe.
layman's explanation of it, man. That's all I did.
It's bullshit, dude. Admit it. You're just bullshitting your way through. You're not giving a layman's explanation. That's a bunch of shit.
You just asked for some measurements on the ground, so I'm like,
And
oh,
you
hey,
didn't prove it. You did not prove it.
Did I make any claim to prove? I just said,
Yeah, you said I got here are the measurements right here. Here's a video. There's a video. There's a
I think
measurement.
you're assigning a lot of like emotional, like ego language to this that didn't really happen. You know, I just like
Emotional
make the
ego
video in
language.
the side chat. You know,
Yeah, which you didn't know anything about. That was clear.
I gave a pretty good layman's explanation.
No, you didn't. You're bullshitting your way through. Thought you were going to get away with it. But then now we're pointing the fact that you didn't know anything about it is showing you're just bullshitting your way through
I
it.
think I gave a pretty good layman's explanation of it.
No, yeah, in your own head. But what we listened to was somebody bullshitting their way through something.
Please calm down. Take a breather. Whatever
Shut up, dude.
whatever
Shut up.
disagreement we're having here, we can talk about civilly, okay? We can talk about
What we're talking about civilly is your inability to be able to articulate any point that you have to offer.
in the side chat for you, okay? I think this is going to help you out here. Let me take a look at that. What do you think of that, man? Can you give me like your explanation on that generation lead right there? How do you feel about that?
Yeah, so you're not going to talk about the subject matter at hand. You're going to talk about something else.
Well, for a while,
you
we've
eat
kind of
paint
been
chips,
ranting about
why
my
don't you? Tell us how many
language and
paint
where
chips
I'm
you like to
from
eat.
and things like that. I mean, Yoder was going
We
on.
really don't. He was trying to ask you to be honest, but we really don't give a shit what language you speak, dude. Honestly, I don't give a fuck.
Why would you? I'm just some guy on the internet.
Yeah, who's randomly coming in here thinking he knows what he's talking about, and he doesn't. Just like every other Glober that comes in.
Dude, I literally came in here to be quiet. What are you talking about? You engaged me over and over and over. I just sat here and I was like listening quietly for like a good 30 minutes, just quietly.
Your accent's so unique, I can hardly place it.
But it's very clear you don't know.
Feel like every time you try
It's
to
very
like
clear.
add some emotional language, I just kind of push it back. I
Yeah,
don't think you're
whatever, dude. It doesn't matter. Like right now,
Whatever.
all we need to
Doesn't
know is if you're able to tell us how you know the Earth is a globe or not, and just admit, hey, I don't know. I'm just a belief.
I just
And
went up in the plane and I saw it. I fucking saw the curvature of the Earth. That's like my solid.
Yeah,
cement.
you
Beyond that is
somebody
like,
listen, brother.
Listen, you asked me how I knew from personally me, right? I don't know the scientific explanation for it. I just looked out the window and I saw it, and I was like, okay, that's cool. That's cool.
Yeah, what's
shit.
funny? What's funny is you were ragging on me when I was telling you I observed the Earth is flat. Oh, you observed the Earth is flat. How do you know it's flat? You seeing it's flat?
Well, I said,
You
why
were
don't
telling
you
me a lot of shit, dude, and
Why
then
don't you
you
go
go and do an observation, and it's just fucking
Why
hunky
don't you-
dory.
If you don't like airplanes, you can go up in a hot air balloon.
No. We're talking about an observation. You make an observation, and it's the bee's knees. But when I make my observation of flat Earth, you're like, oh, well, it can't be. It's no flat Earth. Like,
Please calm down again. Calm down. I've tried to extend the olive branch.
dude.
I've tried to extend the olive branch to you several times and said maybe we just have different perspectives, literally in physical reality, based off.
So
of
how
where
can we determine that the Earth is one way or the other? Is what I was getting you to realize. What's the
Well, I was trying to
determining
answer
factor?
you, but you started talking about measurements on the ground. I said, "Well, I think
That's how you determine.
You just
That's
shoot
exactly
a
how you
satellite straight up into the air. Well, we'd be able to get like a perfect perspective of everything, right?
No. Listen, brother. Listen to me when I say this. You don't leave the Earth to measure the Earth. You don't leave it. You stay on it. You're on the Earth. The Earth's surface. Listen to me when I say this to you, man. The Earth's surface should follow a curvilinear path because it's curving. It's a globe.
A whole lot of scientific mumbo jumbo, but let me tell you,
No, it's not, dude. You're being a dumbass right now. No, it's not.
You ever go hunting before? Let me answer that. You ever go hunting?
No. You're not answering my question, brother.
Ever in your life, have you?
I'm not going to answer your bullshit question right now.
If you can't engage with a simple hypothetical, then you
listen to me. Listen to me.
Take a breather and look at yourself.
Shut up.
I'm just trying to engage you calmly.
No, you're not. No, you're not. You're being a weasel. You're being a weasel. Nope.
Anyone here gone hunting before? Anyone at all gone hunting?
I'm going to count to 3, dude. You better let me finish what I'm saying.
You're going to count.
What you need to do. Shut up, dude. Shut up. What you need to do is measure the surface of the Earth to determine whether or not what it is. You're not going to be able to do it, but you're not going to be able to do it going farther away from the surface like you want to with your satellite. You can't do it with that. You have to do it on the surface.
Baseless assertion that you have to measure in the particular way you demand.
It's the way that the surface would be conforming to if you're on it.
I'm trying to engage with you, right, in a conversation, but you just continue to insist that
so
you're.
will you?
Did you just say a satellite measures the Earth?
Yeah, he's trying to get away from the surface. I'm like,
Oh,
dude,
great. Can you provide the deets?
This is a lot of emotional and angry conversation. I'm trying to engage with you all, honestly. This is like
shut your dumb ass up, dude, with your bullshit ass. I'm just calm. Yeah, you're not calm. Shut up.
This is the lead brain aggression is what happens with these older Gen Xers, probably about 40 years old, is the amount
Skip
of lead.
the meta, skip the meta, and get to the
lead
meta.
aggression. The lead aggression.
Skip the meta. Yeah, I don't give a shit. Skip the meta.
So basically, Bowcat, you're accusing people in here of eating lead chips. And meanwhile, you're the one that is presenting evidence for a globe and basically stepping on garden rakes and smacking yourself in the face every which way you go.
Were alive during that time period. You were Gen X and you were in a car.
Yeah. So okay. So can you generalize and paint with a broad brush your prejudices anymore?
Prejudices towards Gen Xers.
Yeah.
The lead brain.
Yeah, you seem to have an axe to grind against Gen Xers. Not that I'm one, but maybe I am. Maybe some of the others are. Who knows? But you have no idea who we are.
I don't mind millennials when they're not so lead-brained. Some of them are like, we're living in
well, okay, so you just believe that you can see curvature of the Earth from an airplane.
Yeah.
Which is the dumbest fucking thing I've ever heard. That's how I also know you're a liar.
I personally saw it on 2 flights that I was on.
Okay, so how much curvature should you see if Earth is a globe from an airplane?
I don't fucking know, dude. A couple
degrees. So what makes you think you're seeing curvature then, fucking retard?
I fucking saw it with my eyeballs? Like, what?
Idiot. You're an idiot, bro.
Like,
I know how much you should see. Honestly, I did the math to test it.
Let me give you an example. You could very honestly engage and say, well, hey, actually, no, that's not what you saw. You saw this, or there's an explanation, or it's an optical illusion, or this. But instead, you're
How about this? Check the side chat.
Instead of
the construction of airplane windows are curved.
That is one argument. That's one argument. But instead of just saying that to me, you're both.
Dude, shut your yapper, man. He's telling you something. Shut up.
The structure of airplane windows are curved. Number one. Number two, let's do a geometric test. I'll pop open the details.
Let me cite what I said to you. I said if the window is making it curved, then why in the original photo of the outside of plane that you sent and other people have sent several others is it flat? If it's the windows, and why is that? Like you can't if it's always the window.
Well, I'll tell you why you can't see curve. It's because from even like 31,000 feet, you should be seeing 0.07% of the Earth's surface, and you think you're seeing curvature. Yeah, bullshit. It looks flat. Even if it's a globe, it looks flat from up there.
You can just look out and you can see it. Like, I don't understand why. Like, you're just telling me my eyes are wrong, but you're basically just lying.
This guy.
Yeah, so I'll go further. Want to see an infrared hyperzoom of the horizon?
I can just look at a satellite picture.
I can give you a method that you can actually test for yourself.
I can just go to the ISS live feed right now if I want.
Oh yeah, I can go to CloudSat and I can show you a flat horizon from CloudSat. Why is that?
Just go to the ISS feed. I don't know.
Yeah, did you know that CloudSat actually has a camera that faces sideways and looks at the horizon of Earth? It's fucking flat.
But all I have to do
post that. I want to see that, Master.
Oh, okay, yeah, hold on. Let me go dig that up.
Let me get you a link. Sure.
No, you don't need to show me the ISS footage, okay? Because from the ISS, it shouldn't look curved either. Geometrically.
I don't think you really have any idea what you're talking about.
Oh, no, I've done the math, okay? And I've tested it. You haven't. You just accept that what you're seeing is globe curvature, when if that's the case, then you must think Earth is a very tiny ball.
Oh, what the fuck? Oh, and you got to rewind. Okay.
Yeah, that's right. It doesn't hold up to the geometric constraints of what the globe ought to be.
You just said I went to go to the live feed and it's been down for an hour. It's got to go back up. But if they do that every day for me.
All right, let me post CloudSat.
I just don't understand why you're so upset about me saying I went in the plane, I saw a couple degrees of curvature. I was like, wow, that's pretty cool.
Yeah, because you wouldn't see a couple degrees of curvature. Nobody has, and nobody can.
And in commercial flights, you can Google right now, can you see the curvature of the Earth on commercial flights? Yes, you can. You literally
it violates physics.
Right, you can Google it.
Even from your own side, right? Astrophysicist Neil deGrasse Tyson, who hates flat earthers, by the way. Okay, even he said from 10 times the height of a plane, which would be the height of the Richard Branson Virgin Galactic flight, he said that he did the calculations and you wouldn't even see the curvature of the Earth from that height.
An argument of authority. That's all that is. Oh, Neil deGrasse
No,
Tyson.
no, that's someone from your own side who's an astrophysicist.
I have no side. I don't know what side
The
you're
globe side. You're on the globe Earth
That's
side.
just reality, bro. I don't have a side.
No. The reality is that you wouldn't see a couple of degrees of curvature from the height of a plane. You would only
Reality
see 0.1% of the surface of the Earth from that height. Even if it was a globe, you wouldn't see it.
From the perspective of an airplane. You can literally Google it right now, look it up, see the curvature. Like, it's not that hard.
All right, I'm about to post some electro-optical infrared and LiDAR scans of the horizon from CloudSat.
This again for you. Here we are in the plane, looking over.
Oh, okay,
Right,
well, I'll post a photo
1,120
from my flight.
kilometers. Here's 1,120 kilometers of a swath of the horizon taken from CloudSat using LiDAR.
We can settle this debate very interestingly by just getting the highest perspective,
Louise.
the most we can of the Earth. So that's the simplest explanation we should do.
I'm posting
the highest perspective we possibly.
satellite images of a flat horizon, Bill Cap.
Why would we? What possible loss could we have then, if that's the case? Why don't we just send a satellite up and see?
He's muted everybody. He's on a platform on his own.
I haven't muted anybody at all. I'm sitting right here.
All right, then listen to what he's saying when he's talking. You over talk him.
What I'm telling him is I'm telling him.
You're over talking me now.
Satellite up. Okay, I can't even say a word edgewise. It's sad.
Yeah, well, why are you getting upset, bro? Relax, calm down.
No one's upset, man.
You are. Just relax, dude. Just calm down.
Hear you with your bag of chips, man.
Yeah, just calm down, bro. Just relax. Just calm down. Relax.
It's okay.
It's gonna be all right.
So the active infrared of CloudSat's really cool because you can actually see condensation and evaporation lines from the surface to form clouds, and from the clouds when they condense and start to rain. So in some of these images that you see in the hyperspectral colors, you can see that the evaporation and condensation lines are parallel to each other and perpendicular to the flat ground. Again, this viewing angle presents about a 1,100 kilometer swath.
So why don't
There's
we
no
just
curvature.
send something up into the sky to look down to see the curvature of the Earth, if it is there or not, like a satellite, for example?
Well, that's what I'm presenting. I'm presenting what's called a limb view. It's a sideways view, looking out at the horizon, not straight down like you might be accustomed to.
Why aren't you just directly answering my question?
I am, actually. I'm presenting you exactly what you claim to have evidence of, and it contradicts your claim.
Posit the Earth is flat. Okay. So why don't we just send a satellite straight up? And see
This is a satellite.
Not like why don't we just send a satellite? No, what? Send me what you're looking at. I actually
This is called CloudSat, okay? And this is from the Calypso
I'm actually curious
platform using what's called the Calliope sensor. And I've got all the documentation you could ever dig into if you want to verify this claim.
I mean, give me a link to what you're looking at, please. I just like charts.
Okay, hold on. I'll give you a link to the whole library of images from the website run by the National Oceanographic and Aeronautic Administration.
Curious to new information. This is something I'm interested in. Let me see.
Yoda out here doing God's work.
All right, here are multiple daily scans of the horizon, flat, going back for years.
So standard part of a training satellite. Well, let's take a look here. This is very interesting stuff. You see. Let's look at the 30th.
Oh, it gets even more interesting because CloudSat is actually claimed to be a self-orbiting satellite. You can read about the launch using a Delta Heavy rocket to lift everything into orbit. But here's the funny thing. Let me post you an image I found from a slide deck.
Let me take a look here. I'm looking at the Calypso satellite. It's interesting. Let me see.
All right, here's where it gets interesting. Next image. All right, so this next image shows in red is the track of the satellite as it goes back and forth between, it looks like Palestine, Texas, and parts of North Africa and Europe. You know what's in Palestine, Texas? It's called the Columbia Scientific Ballooning Facility.
So the Calypso mission, cloud aerosol lidar, and infrared pathfinder satellite observations represents a collaboration between NASA and the French space agency CNES. Launched on April 28, 2006, the satellite was conceived to enhance the understanding of the role clouds and aerosols play in Earth's climate system and air quality. Aerosols, tiny particles. Like, yeah, I'm not going to read the whole thing out loud, but I'm going to read it. I don't want to, unless you want me to, but I'm just going to.
No, it's okay. I know what it is already. But what I'm presenting to you now in chat is from their own slide deck showing in red. Those are balloon tracks. Why is this a balloon track when this is also supposed to be a satellite orbit?
So please hear me. So before I can respond to specific things, I'm trying to get some context here, right? Just like some basic information on what the satellite is, what it does, how it scans things. So that's what I I have to figure that stuff out before I can answer why is it doing this or that. Well, I don't know. I have to figure out like how this works. So please give me a moment.
Okay. Well, happy reading. Also interesting that they're using a projection of Earth that puts the latitude and longitude at equidistant of each other. So that's equidistant meridians. Yeah, that's pretty cool.
So how fast is this thing moving?
Well, I mean, if it's in orbit where they say it is, it's supposed to be going like 18,000 miles per hour.
So that's apparently how it works right there. So it measures a vertical line of clouds and aerosolized particles completing a near polar sun synchronous orbit.
That's not true. That depiction isn't true.
Completing approximately 14.
I've got the schematics. It's sideways.
Orbit ensures consistent daylight conditions for measurements, enabling global data collection. This is just that's what you're looking at.
Your artistic rendition, whoever was the artist that drew that, is wrong. That's not the satellite's looking sideways.
I'm just looking at what like NASA.
Yeah, and I've also presented you
is NASA like
countervailing data.
How their satellite works, or I'm just trying to get like a basic understanding of this here. It seems to me very confusing to use data from a satellite that you're claiming that they're lying about. Like, I don't understand. I'm just looking at the basic explanation.
Well, there's a point. It's called invoking a hostile witness if this is a courtroom. It's because basically the other side, your side, actually provides information that contradicts your own side. And we're just calling that out.
Like,
so this is basically a blow to your credibility.
It says Calypso uses... Oh, let me read the full paragraph. The combination of these advanced instruments allows Calypso to provide detailed vertical profiles, capturing not just the horizontal spread, but also the height and aerosols of aerosols and clouds. So the point of it isn't to measure what you're claiming. It's not measuring that axis that you're claiming it is. It's measuring this line because it's trying to measure, like if you're looking at
showing
side slice, think
horizontal.
Of like it's not true.
Showing the horizon, and it's showing evaporation lines that are parallel to each other. That's a geometric Euclidean reality that you can't escape.
This just simply does not do what you're claiming it does. Like,
what did I claim that you said it's not doing?
It doesn't measure the horizon.
I'm showing you that it shows you the horizon.
No, you've taken charts here, right? And you're just simply misunderstanding what it's showing you.
Oh, where's the curvature of the Earth then?
It's in the fucking graph. Do you not understand what it's measuring?
I do understand what it's measuring.
So think of like a human body, right? When it's like
it's measuring condensation and evaporation.
Okay, what does that mean?
Rain and evaporation. So like when the oceans get warm and all the little water molecules start to jump around and get excited and they go wee and they go straight up into the air.
What do you call those?
It's showing that. And when the clouds get really cold and start to shiver and they shake all the water and the water condenses and falls back down to Earth as rain, that's what it's also showing. And it's got such a wide view, it can actually show you polar stratospheric clouds. What is a polar stratospheric cloud? Like, holy shit, what's the altitude of that thing?
That was a layman's explanation right there. You got to learn what a layman's explanation is, okay? That was one.
See,
right, so what it shows is these evaporation and condensation lines, like I said for the 50th time, are parallel to each other and perpendicular to the surface.
Right. So what you're not understanding, once again, I'm trying to explain this to you, is it is not measuring the horizon of the Earth.
On a globe, those are going to be radial with a common center of mass. Because you think gravity is pulling everything inward like spokes on a bicycle wheel. Which means the spokes can't be parallel to each other on a bicycle wheel. Right? Just like the condensation evaporation lines can't be parallel to each other on a globe.
Ask you a simple question. Is a spoke on a bicycle wheel curved or straight?
They're straight and they're not parallel to each other.
They're straight.
Just jumping around now.
No fucking shit, they're straight.
So then why would this fucking satellite...
Actually, hold on a second. If we want to take this to a higher technical level, you don't have straight plums. It's called deflection of the vertical in surveying.
Point. The reason this fucking satellite's not going to show you the curvature of the Earth is the same reason that if you have the bicycle spoke is straight from one spot to the other, even though a bicycle wheel is circular, the fucking spoke is straight, because from the perspective of it, from where it's going, it's straight down. That's why.
It's a sideways camera view of the horizon, okay? Why is there no curve?
It's literally a vertical camera.
No, it's not. I told you that your artist depiction is wrong. And I can present to you. Let me just show you. Okay, I'm going to go dig through the schematic.
So NASA is lying then. It's fucking a vertical camera.
No, they're not. I don't know what fucking source you're reading from when I pulled the actual design documents of this thing that are public. Let me go retrieve them. It'll be a minute.
CalOp has a high vertical resolution of 30 meters in the low troposphere and 60 meters above that.
Yeah, vertical. It's looking sideways so it can scan vertically.
You said vertical and you disagreed with it. You said
you tried to present this as vertical, like looking straight down, dumbass. It's looking sideways to get the vertical datum. Yeah, I'm still here. So for the audience wondering what it's called the Microwave Limb Sounder. It's part of the CloudSat constellation flying behind some of the main platforms, and its job is to look sideways.
Let me size this here for you. Here you go.
You realize CloudSat's not one platform, right? It's a program involving multiple platforms, multiple satellites with multiple capabilities.
Honestly, I just find it very amusing that you...
And they find a constellation they call an A-train configuration.
I just personally find it very amusing. You cite NASA, but then when I'm just sitting there reading about this thing from NASA, you're like, nope, that's
okay.
Hostile witness.
It's because you're trying to mischaracterize what it is. You've been trying to mischaracterize everything everybody here's been saying since you first started yapping.
Hostile witness.
Yeah, you are.
No, you said that NASA was a hostile witness.
Oh, you're a hostile witness to NASA.
I'm a hostile witness to NASA.
Yeah, NASA's providing evidence of a flat horizon. And you're contradicting that.
I think you're just a little bit incorrect, and I think I've...
No, I'm actually precisely correct.
You can't autocorrect this, Zoomer. You can't autocorrect this. It's just the way it is.
Well, I'm pretty sure
Would you like to play again?
Vertical resolution. So, what are you arguing?
Insert coin to continue.
He wants to get closer to his mic as if you didn't hear him. I'm telling you, as a child, he got so ignored. He got so ignored that he had to do with interrupt people, and his parents were talking, and they probably gave him negative attention. They probably did. Go back to your room, Tommy. And he's just like, dude, I'm telling you. Every time someone speaks, you like to interrupt. That's what you do. That's your deal.
I think maybe because it makes you a little unhappy.
I don't care what it makes me. It just shows that you're an idiot.
I don't care what it makes me. Oh, you don't?
No, I don't. Yeah, he crashed out. He's just waiting to respond to you, Yoder. Even though you showed him that he's using some information, he can't even tell you how he understands it to be true. You showed him this is what NASA's actually showing us, the flat horizon.
Yep, and he's confirming what we're saying is true and trying to mischaracterize it as if it disagrees with what we're saying. So yeah, I mean he's actually now the hostile witness to NASA's claim. Isn't that funny?
Yeah.
I mean NASA's also a hostile witness to NASA, which is also funny.
And I like the fact that he's triggered and he gets close to his mic and doing the thing that's antithetical to the thing he said he was trying to do onto me, calm me down. He's all uptight about it. Bro, relax. You're not right. Oh, you're muted because you don't know how to like let other people speak, bro. You're like a squirrel on crack. I said that earlier. You're just like bouncing all over the place. What do you think you guys' generation is called? Zoomers. Duh. The ADHD generation, brother. Yeah, but funny enough, you're on this platform not speaking and you're listening to me. How ironic is that? Yeah, that's all you have in your brain of those memes. A layman's explanation. That's funny, dude.
Like what's funny is I find in this this presentation deck these red ground tracks going from Palestine, Texas, quite clearly out to the east, and then actually looping and coming back. So like southern jet stream or northern jet stream, southern jet stream, I guess. And it's a ton of squiggly lines going around. Like this is not a satellite orbit in the traditional sense of a globe. So what I was saying earlier is you can read about like the launch of CloudSat satellite. Multiple launches. Big heavy rockets to boost these things really high up into orbit. And it's like, okay, if these things are doing the loop-de-loop around a ball, how come we see this loop-de-loop back and forth between America and Europe? Doing like a hard U-turn, hairpin turn around Texas and another hairpin turn around Greece. I find that fascinating. Not sure what's going on or how they're controlling that. I've got some ideas, though. Oh, maybe we should believe that they're augmenting the orbiting space junk with scientific balloons for the same program, the CloudSat program. Maybe that's it, guys. They totally have self-orbiting satellites, but they also use the balloons.
All their orbital pods are meant to be natural.
Oh, thanks, Morvis. Palestine. Yeah. Well, I mean, AV pretty much exposed this guy. Like, he was telling us his debate bro tactic to try and just remain calm because it only works when one of the other party is spurting out of control.
Yeah.
Like, that's all he was here for. Just tossing shit at the wall. Here's Jaren's freaking laser test. Didn't know a thing about it. I see curvature from airplanes. Didn't know a thing about that. Well, satellites prove the Earth is curved. ISS footage. I mean, this is just basic, like tier 1, level 1 Glober shit.
Yeah, bless his heart, he tried. Well, I mean, tried in his own way, not that he met any standard of like actually accomplishing his goal. Yeah, you were like, I'm your Huckleberry. That's just my game team. He took him to NASA and he's like, he lost his shit. Oh,
So
you're
my
showing
next
me
stop.
NASA. You can't show me NASA. You guys don't like NASA. I'm like, well, could have used this as a hostile witness.
Yep. Oh, dude, I already had the next step ready. Like, oh, you like satellites, bitch? All right. Let's go to the Goddard Space Flight Center, satellite tracking query. Go
Guys,
read that magnetic flux tube of force thing and go explain that to me.
I was telling in the text chat, I was like, Yoder's the soy whisperer.
I said that.
That shit was funny.
Yeah.
Cause, bro, they come in here nothing but gimmicks, man. Like, I'm tired of that shit. Like, I can at least attempt to listen to what the person say. He was like not even listening, bro. It's like, oh
No.
man.
No. Like, you crave substantive conversations.
Yeah,
you might
dude.
be lucky if you get one a week.
Fucking something, bro. Like, I would give it to him if he just at least repeated back or what you're like something, dude. Just give me something to work with.
Yeah, like honesty.
Ugh.
I mean, there's something to be said for our tenacity in this space. Like the staying power we have, the duration we have, we can outlast and deter any troll that comes in here. We've been forged through the fires and flames of the worst ridicule, the craziest targeting. I mean, it's pretty insane what this topic does to people and the kind of abuse you endure over it. It's only made us better at what we do.
Yeah, I like it. Yep. And then we got the homies to share it with, like Anti-Globalist, Necros, 20 Cups.
Shout out.
I appreciate you guys. Sometimes you do just want to sit back and listen to somebody else take it, you know? You love frustrating the plans of the wicked, though, don't you, Yoder?
Yeah, that's my main shtick, if you're gonna call it that. I love that. I love to frustrate their plans.
Oh my goodness.
You got to kind of match their energy and tone. You give them a chance or two.
Good luck matching that tone.
Yeah. And when you can't do it, that's when you turn on the juice,
That was comedic timing on that, though, Globalist. Yeah, because he's a soy boy, right? So it's like, how are you going to match that tone? Unless he becomes soy-like.
Yeah, you got to kind of lead them on so that they unknowingly strap themselves to their own electric chair.
Hey,
And
Matthew,
then
are
give
you
you
there?
the honors.
Uh-oh.
Yeah, I'm here. So,
hey, do you think if a flat earther came in here and made a really ridiculous argument, we'd call them out?
yes.
Okay, thank you. All right. Did you notice that when the last globe earther came in here and made a bunch of ridiculous arguments, you didn't call him out?
Right, because this is your forum, not mine.
Okay. Just wanted to point that out.
Ah, okay.
Yeah, got to close your ranks, huh?
appreciate the admission. Thank you, Matthew. Matthew agrees his arguments were bogus.
Yeah, stronger together, right?
But I didn't hear all of his arguments. But in general, I don't think you can prove that the Earth is a globe.
A torch and a laser are the same thing. You can see the curvature from an airplane.
Why did we? I don't know. Imagine taking elevation scans, but you're looking straight down.
Yeah, like if that's straight down, like what's that horizontal line supposed to even be? If it's not the horizon. All right. Any more globe earthers in here? Who's next? I think they're all done.
Hey, yeah, insert coin to continue.
How do you know the Earth is a ball?
Ships disappearing over the horizon, reciprocal zenith angles, tides, moon phases, plethora of other evidences.
Okay, so let's go with that one by one. Have you ever observed yourself a ship go over the horizon?
Yes, numerous times.
Numerous times. Where were you?
Sorrento, Portsea.
And which area?
Melbourne, Victoria, where I live.
You know what kind of boat it was?
Spend my life at the beach, mate.
Yeah, that's fine. You know what kind of boat it was? You remember?
An internationally travelling ship, a very large cargo ship. Cargo ships don't have oil arrive here in Victoria, but we have extremely large ships come into the port.
Yeah, great. So I live in Boston. I live in Cambridge, which is next to Boston, like where Harvard and MIT is. I've been to Boston Harbor, and I watched a ship sail 30 miles away, and it never went over the horizon. So, and I've actually never seen a ship go over the horizon, ever. Not even one time. So I have photographs, images, radar tracking of the ship, cargo ship.
Radar tracking.
Pardon me?
No, sorry, I didn't mean to interrupt at all. Keep going.
Yeah, so Gloucester, which is north of, it's at the northernmost point of Boston Harbor. They track the position of ships using marine radar, and marinetraffic.com posted positions of the ships. So I watched the ship for 3.5 hours sail from 6 miles away from me out to 30 miles away from me, and it never vanished under the horizon or did anything like that. Now, according to the globe map, that ship should have been 420 feet under the horizon. So you have your observation, which doesn't seem very well detailed. And my observation, where I have compass headings, positioning of the ship, my elevation, which is 15 feet, right? I all the particulars. So if we have, let's just take it at face value that you saw what you saw, because obviously this is observed sometimes. It's a question of whether that's the geometry of the Earth. If the horizon is the geometric edge of a ball, but that's blocking ships, it's blocking the sun, that's blocking all these things, right? So the horizon will have to be physical, right? It have to be a physical location.
Well, the horizon is a physical location. Where we see it isn't necessarily the physical location. And just going back to you saying that you've...
That's impossible. What you just said is impossible.
Hang on. You've sped out a whole lot of details and facts and stuff there. So let's just go back over what you said.
Okay.
You said you've seen ships numerous times. You've never seen one go over the horizon and disappear. So you just sort of go away and get smaller and smaller and smaller until the entire thing disappears.
Then the air becomes too opaque for the see through it, right? Because we have visibility in the ocean, right? If you go look on your weather,
but you don't have a photo of it, do you? You don't have any footage of that happening, do you?
What do you mean? I don't have any footage of what?
Pretty straightforward sentence. You don't have any footage of this happening. It's just your word that you saw it get so far away that it got smaller and smaller and disappeared.
I just said I got to. I'll post the pics, dude.
Sure, let's see them.
Hold on a second.
Great, thanks.
So, you said that the horizon's geometric. You just can't see it. That's impossible because horizon is defined as the apparent location where the sky appears to meet the Earth, right? You have to see it. Otherwise, it's not a horizon. Appears.
Right.
Appears is not a mental construct. It's vision. It means you see it.
Okay. I'm not really...
Okay.
Yeah, I'm not really getting your point here, but...
The point is that the horizon that you think exists, if it moves around and is just a product of the meteorological conditions, then that's not the curvature of the Earth that ships disappear behind. For instance, if I see the horizon at 10 miles one day and the ship disappears behind it, and then the next day it's 20 miles away and the ship disappears behind it, which one's the curvature of the Earth?
I don't follow what you're talking about, to be honest.
How can you have a bunch of different curves of the Earth if the horizon, ship going behind the horizon is going beyond the curve of the Earth, right, curving down, okay? It does it at 20 miles one day and does it at 30 miles another day and does it at 6 miles another day. How can that be the curve of the Earth?
Well, we know what refraction is, right?
So not the curve of the Earth.
So do you know what refraction is and how it works?
You don't.
That's not answering the question.
Yes, I know it very well, okay?
Right. So then why do you not mention that when you're talking about ships disappearing one day at 20 miles and disappearing another day at 30 miles, whatever number you use, it doesn't really matter.
Because if I mention refraction, that proves my point that it's not the curve of the Earth, that it's a meteorological condition.
It's not a meteorological condition. Refraction bends light downwards.
Is that caused by meteorological conditions?
Dude, I'd really, really appreciate it if you wouldn't start talking when I'm in the middle of a sentence. Can we just keep it?
Well, is that caused by meteorological conditions?
If you don't get to finish a thought, if you don't get to get the entire thing out, people don't get to hear the conclusion of what it is, the point you're trying to make. So just wait till everyone's finished talking.
Well, you said it's not a meteorological condition, and then you described light bending down by a meteorological condition. Told you, dude. You bit off more than you can chew, bro.
No.
Back to amateur hour. You
gotta stay honest, dude. Okay, you're talking nonsense.
You bit off more than you can chew. You have no idea what your fuck you're doing. This is amateur hour.
Yeah, amateur hour, right? You can't stick to the subject.
Tell me.
You're turning to insults immediately. We haven't even been going 10 minutes yet, and you're turning to insults
dude,
already.
You're wasting my time.
This is not a debate. You're wasting your time.
Yeah, because you don't know anything.
I don't know anything.
Okay, tell me what causes light to bend down.
Changing the medium. It's like
changing the medium.
Dude, if you're going to keep interrupting me, right, when I'm trying to answer your question, then we have no business here. Are you capable of destroying me like you claim you're going to do, or do you have to interrupt me? Right? And eventually you'll go, I'm sick of this. You're wasting my time. I'm too big for you, and you'll freaking leave.
I'm wasting my time.
Okay, show some nuts. Nut up. Be quiet when I'm speaking.
No, you talk too much shit, dude. For respect.
So you're gonna
insult flat earthers out. You insult flat earthers in the timelines like a crazy person, and you don't know shit.
Sure thing, right? So where's this footage? Have you posted the pictures of this ship going away?
I'm posting it right now. Give me a second.
Oh, you're getting
it's almost up.
Okay,
it's almost up.
Okay, so while you're doing that, you explain to us how a local moon, how we see the exact same face, right, of the moon. Everyone on the Earth sees the exact same face on any given day. How is that possible? Right, on a moon that is
God, this is so amateur. Look, if the moon is sufficiently far away, the angle's going to be the same. That's the reason for in the fucking globe, and that's the reason in the flat Earth. Okay,
no, I'm going to need something.
There's no parallax, brother. If there's no parallax, then everybody's going to see the same face of the moon. Whether you see parallax or not depends on the distance of the object away from you.
No. So this is where you just blurt out freaking numbers. The only time we won't see parallax, right, is when the distance is extraordinarily far. Right?
Okay. Is there any parallax right now at 300,000 miles?
If your position is moving, right, you will see parallax. Okay.
Do we see parallax with the moon now?
Yes.
We do. Okay.
From one side of the Earth to the other, yes, there is.
Oh, really?
That's why we can take elevation angles of the moon.
That data. Yeah, post that data, bro.
We can take elevation angles of the moon. This is why flat earthers will never do this experiment. Okay, why don't three of you go out right at the same time from different places on the planet? You know, you're all around America. That's a big enough area.
We don't have a planet.
Take an elevation angle of the moon, right, and plot where the moon is from that. Right, and tell me it's a local moon then. But you won't do that. I guarantee none of you will do that and publish the results.
Okay.
Why is that, India? Why have you never done that, India? You could prove the moon is local. You've never thought to take elevation and direction angles.
Because it's irrelevant to the shape of the Earth.
It's not irrelevant. You claim it's a local moon.
So check this out.
It's not irrelevant to the shape of the Earth because you say we're in a dome. You're going to change the subject again. You're going to move on and change the subject again.
No, I'm addressing what you said. You're trying to move on by bringing up a fucking dome. I'm trying to talk about the moon. Okay? Okay, really simple. Can I figure out what my house is made out of by looking at something that's not my house?
No, it depends. But yeah.
No, the answer is no. So looking at the moon can't tell you what the shape of the Earth is.
That's a baby fluff comment, okay? Because you can't look at the floor. You can't look at the ceiling to work out what the floor is. Is that the flat Earth saying something along those lines?
Okay. No, this is logic, right? Okay. Anything you do to listen. If you look at something else other than the thing that's in question, the only conclusions you can draw are inductive inferences. Okay? Inductive inferences all contain the logical fallacy of affirming the consequent. Okay? They can't prove anything.
No, science doesn't prove things. Neither can you.
Congratulations.
Yeah, no, but I can
prove the Earth is flat by measuring directly the surface of the Earth. Really simple.
Well, why don't you show us those flat measurements then? But you won't. Because it doesn't.
Well, I posted a boat in there. Now, if you want flat measurements, I'll post those too.
So where did you post it? In the pill?
Yeah, I posted it in the thread that this thing is in.
What are these? A red line pointing to some blurry pixel. What the fuck?
A red line pointing to some blurry pixel.
This is your evidence that the Earth is flat. You got to be kidding me. You are kidding me, right?
This is my evidence that ships disappear over the horizon. Why are you straw manning me? Why are you straw manning me? This is my evidence ships don't disappear over the horizon.
I can't even
tell more. Hold on a second.
I can't even tell.
Hold on, I got more.
Cannot see what that is.
Well, I got more. That's okay. I got more, dude. It only lets you post 4 images. Here, I also got it taken from 100 feet from the top of a parking garage. in the mass per 100 feet.
Well,
still 30 miles away, and it's sitting on the horizon, which is supposed to be 12 miles away. So, compass headings. I got a whole bunch of shit, bro.
Tangents, Earth radius, what? Feet 400, obscured 425, and then you're claiming that that's how far away the boat is. I'm not seeing any proof here at all. I'm seeing a blurry picture and then some Earth calculated numbers.
Earth calculated numbers. It's your globes, right? So the horizon from 15 feet is only supposed to be 6 miles away. Well, according to this, 4 miles away.
Right? Did you add in?
I just posted the marine traffic graphic. Okay. I also posted where you can clearly see it from 100 feet. Okay. And the map from 100 feet, which it puts the horizon 12 miles away, and the boat's on the horizon, but it's 30 miles away, which makes the horizon 30 miles away.
From 100 feet.
100 feet at the top of a parking garage. This is Revere Beach. There's a train station there, and the train station has a parking garage for cars. You can get on top of it. It's 100 feet up to sea level. Now, the whole point of this isn't to prove the Earth is flat. The point is that ships don't disappear over the horizon, and when you do see that, they're caused by an inferior mirage in some meteorological condition. And we know this because we can replicate this on shorter surfaces where we can eliminate curvature as a variable. So we can replicate the same observation, a little teeny boat disappearing, bottom up, over a horizon which shouldn't even exist, on something we know can't be the curve of the Earth because it's too short of a distance.
But doesn't the curve start at your feet? How could it be too short a distance to show any curve at all?
Because the horizon, like if you have a low enough camera height, the horizon is a certain distance away. From 1.5 inches, the horizon is supposed to be 2,400 feet away. If you have a lake that's 1,000 feet long, obviously you can't have our globe horizon on it. The lake's not long enough. Right? So if you take a little boat, sail across, and then freaking see it disappear behind the horizon, that can't be the curve of the Earth horizon.
Where's this footage? Have you got that available? Is this a little remote control boat?
Hold on a second. Hello? Yeah? Oh, thank you. Sorry, I'm talking to somebody.
No problem.
Thank you very much. Sorry, someone knocked on my door. Anyway, where was I? Oh, the RC boats. Yeah, hold on. I got that too. Still there?
Yeah, I'm here.
Oh, okay. I dropped or something. Yeah, give me a second for that too. Okay, so I posted, this is RC World, but this is just one of many. I can post bunches. There's people have also done this on Twitter. In fact, I think Overlord's done some of these. So you just get a short lake, which is not long, which is shorter than the predicted distance to the horizon. Just watch your freaking little boat sail away. Now, key point about this image is there should be no horizon at all. According to you guys, if the Earth is flat, you should be able to see all the way to the other side, the shore, because this is only a 1,000-foot long lake.
Great, thanks. So the Earth is not flat. Because if it was flat, you should be able to see to the other side of the lake. Thank you.
According to you guys.
And the picture.
This lake isn't long enough.
That you've just shown.
Yeah, this lake isn't long enough to block the boat, according to the globe.
What do you mean, according to the globe?
Oh, yeah, that's right. This is happening on a flat surface, bro. The globe, this is a 1.5, hold on, this is a 1.5-inch camera height. This lake is 1,000 feet long. You go in the curve calculator, it says the horizon from this camera height is 2,400 feet from the camera. Now, how can this boat disappear behind a globe Earth horizon it can't reach? Because the horizon's at the edge of a ball. Because the horizon is an optical effect. It's really simple.
How long is a mile? I'm not familiar with miles. How long is a mile?
5,280 feet.
Right. So 6 foot observer sees 3 miles, and you reckon a 1 inch observer sees
1.5 inch. I can post. I posted the video. Even if you load this in the Walter Business Calculator, shows that the object would be visible, which they do in the video. She loads it up. She takes all the measurements. I mean, they've replicated this multiple times. This is what I'm going to do. I'm going to post a screenshot from Bislin. This thing like crazy person. So what I just posted is the globe Earth prediction. You can clearly see that would be in front of the horizon. So that's the problem. We can replicate this on a flat surface. It doesn't matter why it happens. We know. So the point of the test is to eliminate the variable of curvature. We eliminate it as a variable by using a distance where curvature can't be the reason. Can't be the cause. That's the point of the test. It's been replicated many, many times. You can replicate it yourself.
So I'm not seeing any numbers here. In the 2 pictures you posted, can you step me through the numbers here? Angular size, drop, angle, distance on surface, horizon dip, drop from high level, drop from surface, top right, apparent radius, target left to horizon, target lift absolute, horizon, gradient. There's no elevation of the observer here. Oh, whoops. Come on.
No, it's there. Sorry. I'll crop the whole thing. Observer height is 0.03 meters. I posted the video where all this is at. Told you how high the camera height is. In the video, it shows for measuring the camera height. So, hold on.
Because
you can just go on Walter Business Calculator and do this yourself, man. Like, you don't have to trust me or the screenshots.
No, I don't trust you because I want to see target 1 visible, 0.076 meters. Hidden, 0.
Yeah, 0. 0 should be hidden. That's the point.
0 is hidden. There's nothing hidden.
0's hidden. Where's the right bottom of the boat then?
Is it not pretty much the whole boat? Have you got a picture of the boat? I don't know how big it is. That looks like pretty much a boat except for what would be in the water. Maybe a tiny little bit missing. Could be a little bit.
Yeah, I got a picture of the whole boat.
Disturbance on the water.
It's like painful. You know what I find out? You've never, ever in your entire life applied any scrutiny to the globe at this level. Ever. Not even once. You never have.
Yeah.
I guarantee it.
Sure. So we'll get on to
Tell me one thing you ever questioned about the globe. One thing.
We'll get on to
said, hey, this don't make
personal
sense.
stuff again straight away.
It's not a personal attack. I'm just saying that you've never questioned it.
Yeah, I know. I noticed that we just
Can you give an example?
Did a U-turn and drove right away from the face of the moon. When I ask you a question, we're sitting here.
Because it's irrelevant.
Dominate the live. And ask me all these questions.
It's irrelevant.
It's not irrelevant. It's not irrelevant. I've posted a picture.
Okay, how is it relevant?
Because you claim it's a local moon.
Who? When did I say that?
You. It's part of the flat Earth.
Really?
So
is it a club? Where's the fucking notes, dude?
How far away is the moon then?
I don't know. There's no parallax. There's no way to tell.
That's just factually incorrect. So
it is. It is correct.
No. One wrong for Indio.
Okay, so show me some parallax measurements of the moon. Post them.
Why do I have to show you parallax measurements of the moon?
Because it's your claim that it exists,
it's
dude.
It's not my claim. It's how it is. You have to show me.
Dude, it's how it is. Okay, post the evidence that that's how it is.
Oh my God! Post your
evidence. Oh my God!
Post your evidence. There is no
brother.
You cannot be serious that you think from one side of the Earth to the other, the moon isn't going to be in a different position in the sky. Are you serious? If you say yes, you're not qualified for this.
When I say parallax, I mean a shift, right? You know what a parallax shift is, right?
Oh, really? So if I hold my thumb out in front of my face and close one eye, right, and then swap and close to the other eye, is the tree that one eye blocking, did that just move? No, it didn't just move. Okay. My perspective moved, okay? The object doesn't move. That's what parallax is. Okay?
We know, but you can...
how things actually work, right? Rather than trying to confuse people and give them a different perspective.
No one's confusing.
Right, of what the truth is.
You're confused.
You are. You just made out.
You're confused. Yeah, listen, a parallax shift...
Not talk over the middle of a sentence. You're utterly incapable of it.
Okay, what is a parallax shift as far as the moon? What would that look like? What would the observation be?
It would be in a different position in the sky as
relative to what?
The observer.
Relative to the observer?
Correct.
Okay. Say you're on the North Pole, South Pole, looking at the moon at the same time. What's the amount of the parallax shift?
Can you have a look at the picture I posted in the pill?
Okay.
I just got to get a drink. I'll be 1 second.
Yeah, no problem. Actually, can't see the freaking pill. Fine, but I feel like I might pollen. What the flying fuck, bro? Do you guys see that fucking diagram? Jesus H. Christ.
All right. So did you have a look at the photo I have in the...
It's hard for me to take that fucking seriously. Okay?
Just stick to the facts, mate.
What facts? Your diagram isn't facts.
So
you know what facts are? Well, you know what a fact is? It's when you make an actual observation in the physical and natural world and record the result. I am.
Yeah. Okay.
I'm sticking to what you think a fact is. Observations are facts. Diagrams are not facts.
Okay.
Now,
so,
according...
No. Don't just keep talking, all right? Okay?
Yeah, show observations, dude. That's what I want. I'm about evidence. I'm not about claims, dude. I'm about evidence. Data.
Right. Well, you claim that your boat was at this height. We got no proof of that. No proof that it was a 1-inch observer showing your little boat.
Watch the video. She measures the camera height on camera with a tape measure.
That's great. Not very,
Measures the
not
height
very
of the
hard
boat
to then
with a tape
substitute
measure.
the footage later on and show you a different.
Oh, is that what they did? Did they do that 20 more times?
Sure, that's what you do every time I present you with evidence. Okay, I'm showing you
what evidence.
I'm showing you a diagram of observations. I'm trying to explain it.
A diagram. Which observation? What date? What instrument?
Every single day that people can see the moon. You haven't
What
even heard what
instrument?
I'm trying to explain about it yet, because you will not.
Dude, because this is silly, dude.
It's silly.
Because I want the evidence. I don't want your narration.
Guy who thinks there's no equator. So please, just look.
I know there's no equator.
Sure.
How did I prove there was no equator?
diagram, and can I explain it to you, or not? Do you just want to?
Yeah, go for it. Explain it to me.
So the diagram is a diagram of observations. Okay? On the top one, that's the flat Earth with a local moon. The two people, the top guy would see a different face of the moon to what the guy on the bottom would see. Whereas on the globe at the bottom, of course, it's not the scale, right? They both see the same moon, even though they're on opposite sides of the world.
So if it's an observation, how did they make a not to scale observation?
What? Do you not understand?
This is not an observation. It's nothing like an observation. The moon is supposed to be 30 times the diameter of the Earth away. Okay?
Right.
This local moon shit, nobody believes in this. Why did you put the moon there?
To show you that if it wasn't at 230,
why don't you just put it on top of the flat Earth and debunk that?
Ask me a question. Do not start talking over me when I'm in the middle of answering it, okay? You ask me what this diagram is about. In the bottom one, if the moon isn't 238,000 miles away, you won't see the same face. If it's closer than that, we will see slightly different faces of the moon, and we don't.
Okay. I don't know how far the moon is away. We don't see this. We see one face of the moon, which necessitates that the moon must be far away. I don't claim that there's a local moon. And as far as, do you really want to go over the angles to the moon? You really want to go over that? Because you're gonna get fucked up. I'm gonna tell you right now.
Yeah, sure.
Yeah, because if you do the calculation, the moon's only 1,600 miles away.
That's complete nonsense. You've done your calculation.
Okay, I'm going to post it. I'm going to post it based upon observation data
Whose observation
of moonrise
data?
and moonset, where it triangulates in 3D space that the moon's only 1,600 miles away. You ready? Hold on.
Yeah, so whose observations are these?
What do you mean whose observations? They come right off of Time and Date, bro. TimeandDate.com?
Yep, okay.
And it's a globe earther that found this, not me. Not no flat earther. This ain't flat earth shit. Let me post it.
So while you're looking for it.
Yeah, hold on. No, I found it.
Cool. So then why do we see the same face of the moon then if it's only 1,600 miles away?
Good question.
A damning question.
Well, I mean, how can it... Listen, you don't get it. It's like you're missing the forest through the trees. We see the same face of the moon, but if the Earth is a globe, right, that's spinning, and we see the moonrise and moonset, and we draw the angles to it, then it's only 1,600 miles away.
No, that's
right?
Right.
So that's a problem. Okay, hold on. I'm going to post everything. Hold on, dude.
Yeah, okay.
I didn't make this up, dude. It didn't come from me.
Oh, so we can use other people's data.
This is from timeanddate.com. It's not data. It's a model.
It's not data. Okay.
Time and date is not data, dude. Data you take with an instrument.
Information.
Well, it's a model. It's an observer-centric model.
What is data?
Data is a record of observations or measurements or something like that.
And data is a single piece of information without relevance to anything. 16, that's data, right? How old is the person? They're 16.
I think that's a number.
How old is the person? They are 16 years old. That's information.
Okay. Listen, you need at least a relationship between one thing and another to call it data.
No. Data
just the number 16 isn't data. What does it contain for data? Where's the information?
It's not information until it's collated into information. Data is raw stuff.
Okay, so I posted in the chat. Now this comes from timeanddate.com. So you draw the tangents from that ball to where they intersect, then the moon is 1,862.6365 miles from Earth.
All right, what am I looking at here?
So you understand that she used moon set and moon rise, right? So that would be a tangent, your line of sight, going through the horizon to the moon. And on the other side, right, when moon set, to the moon. Well, those lines of sight should intersect at the moon. So you can draw that triangle, calculate your baseline, the chord of the arc between your points, and then calculate how far the moon is away. Now, this is a globe earther. This isn't a flat earther. And actually, I'm pretty sure she's at the time she did this, she was getting her master's in physics. What is any of this evidence of? Not a damn thing. We can talk about the moon all day. It doesn't matter.
Yeah, it does. It absolutely matters. Can you step me through the picture of the globe where it's got the last sight and the moon thing? Can you step me through that picture? Because I'm not seeing enough information on there to be able to make this calculation.
Okay, so I posted two. Right?
I've got it open on my screen. The big one with the circle, and it's got the two lines intersecting where the moon would be. Can you step me through that picture?
Which the diagram?
Yes, the drawing that the person did.
The tangents are the line of sight to the moon.
Yeah, can you step me through all the numbers?
They position the tangents based upon the latitude and longitude of the observer.
Right.
Okay, and that's in the preceding info. That's in the other document. That's in the other screenshot. There's two screenshots there.
Why aren't they on this picture?
These are moonrise moonset times from Greenwich Borough, UK, August 2021, 551:48 north latitude. These are moonrise moonset times from Stanley Falkland Islands, August 2021 at 51:69 north latitude. So for these times, this moonset, moonrise, those lines of sight should intersect at the moon. That would put the moon 1,600 miles away.
So
now, and the reason it doesn't make sense to you is because you have a presupposition. You presuppose that looking in the sky is identical to observations we make on Earth, and there's no evidence for that. In fact, the evidence is against it.
No, it's not.
No, okay. It is because there's no parallax to any celestial object, including the moon. Okay, you just think there is. But if I went on the North Pole and South Pole and looked to see if there was any shift against background stars, there wouldn't be one. Okay. Nobody in astronomy even claims there is one. They admit there's no parallax to the sun. They think they calculated parallax to the stars based upon a theory, not because it's actually observed.
That's just wrong.
Okay, then what's stellar aberration?
I don't know what the.
Yeah. Okay. You're just saying it's wrong. You're just not eyeing me left and right.
Because it's not true that there's no parallax to the sun.
It's not. Yeah, because you said so.
Well, you said so.
Yeah, I did say so. Okay. I said it's theory. I said it's calculated. It's not naively observed. It's based upon calculation.
What?
Based upon an orbit.
No, it's not. The calculation comes from the observation. We see it happen, and we try and work out what it is. We don't just make shit up.
What do you see? What do you see happen? What's the observation?
That the sun is in a different position if you're on one side of the planet to the other. If I'm at sunset and you're at sunrise, right? So we're 180 degrees, we're on opposite sides of the planet. You see the sun in a different position of the sky to what I see it.
And?
Yeah, so you can calculate its distance from that difference.
No, you can't. It's well known.
Right. So
you can't.
So I'm going to post
drawing
a line from you.
Just me.
Hang on.
I'm going to post from the Astronomical Journal. Okay.
Drawing a line from you.
I'm going to post from the Astronomical Journal. Okay.
You can just keep talking through me. That's fine. Okay. It's what you do.
Yeah, I'm going to post from the Astronomical Journal. You're talking out your ass.
Yeah, sure. Okay.
You tell me what you believe to be true, but you don't know it to be true.
That's all you do. You say what you want to be true, but you don't ever provide
this
any
is from the solar. This is Harold Weaver.
You tell people they're
lying.
lying.
The solar parallax research of the National Society of the Pacific. Okay. This is a post from Harvard.edu. They cannot measure distance to the sun using parallax.
Yeah, it cannot measure distance to the sun using parallax.
Yeah,
so there's parallax.
Yeah, parallax. How we want to measure the distance to something on Earth.
Okay, so
yeah, there's no parallax to measure.
Oh, is that what you meant? Oh, you misspoke. Right. Okay.
I didn't misspeak. Okay, there's no parallax to measure. Any parallax that astronomy says exists comes from theory and calculation. It doesn't come from observation, and it comes from two things: theory of an orbit and theory of stellar aberration, which also comes from a theory of an orbit. So all the stars are in apparent positions. They're not in their true positions. They're in apparent positions.
Well, could you not say that?
Same with the sun, same with the moon, all that shit. Everything in the sky is an illusion. You've never seen a sunset in your life, according to the globe. When you see a sunset, it's already over the horizon. Yeah, didn't you know that?
What does that matter?
What is that? Because the entire sky is an optical illusion to you.
It's not an optical illusion. So we see it going over the horizon, a few seconds after it actually goes over the horizon. It's still going over the horizon. Minutes, fine. Minutes. It's still going over the horizon.
Look, when you see the sunset, it's almost 2 solar diameters under the horizon physically, according to the globe.
So what?
So what?
Yeah,
So you're seeing a refracted holographic image of the sun.
Holographic? Well, hang on, what? The sun's up. All right, okay.
Look, if the stars have apparent positions because of stellar aberration, and the sun has apparent positions based upon refraction, and the planets have apparent positions because of proper motion, everything that is in the sky is an optical fucking illusion. And according to you guys, you think the looking flat is also an optical illusion.
Sorry? What was that?
The Earth looking flat is also an optical illusion.
No, not so much an optical illusion. It's because it's so big. To us, it looks flat. I mean, if you stood in the middle of a hula hoop, okay, and you look down at it, right, it looks like a ring. Okay, now pick that up and hold it up at eye level. Okay, it's flat. That's what you're actually seeing. When you look out at the horizon, you're seeing the radius of how far the horizon is. It looks flat. And on the Earth, the size that it is, that's what is predicted.
That's what is predicted?
Yes.
That it looks flat from sea level?
Yes.
Want to know what also looks flat?
The horizon looks flat. From left to right, the horizon.
Want to know what also looks flat? Flat things look flat.
Yeah, but we can't.
You know that? Flat things look flat?
Yeah. Flat things look flat.
Yeah. So You think the flat thing that looks flat is not a flat thing that is flat. It's actually a curved thing.
Through other things, through other means. We don't just go.
Yeah, but
it looks flat, so it's curved. And simplifying it to that is, I don't know.
It's what? That's not the situation.
Disingenuous, because we didn't just go, oh, it looks flat, so it's curved. That's what you make it sound like.
Okay, so they measured the curve.
Yeah,
and that's how they figured it out.
Yeah, it gets measured daily.
Oh yeah, really?
Yeah,
tell me about it.
Yeah.
Yeah, tell me about it, bro.
Yeah, have you ever watched Barron?
God. Barron's a dope, just like the rest of the fucking surveyors. They don't even know it.
Because he shows you.
No, he's a dope.
Because he shows you to be completely wrong. That's why he's a dope.
Oh, yeah. Yeah, no, he doesn't know how his own fucking profession works. Just like all the fucking other surveyors.
But you do.
Ask him. Oh, yeah, I do.
Right. So, have you got
ask him what reduction of the vertical? Ask him what the reduction of the horizontal direction is.
The guy doesn't.
Watch him freaking go. Huh?
Right. Sure.
Okay. So there's something called reduction of the horizontal direction. After you take a measurement, this is what you're supposed to do. This changes the azimuth, meaning the direction you're pointed. Because according to the globe,
don't really care about all this nonsense, okay?
Of course, because you don't know. I'm going to tell you. I'm showing you why they don't actually measure. Well, we can just cut it like really short. If they measure the Earth as a curvature, what's the reference ellipsoid for?
No idea.
They wouldn't need it if they're just measuring an ellipsoid. Why do they have a reference ellipsoid? What's that for?
What's that got to do with anything?
Because they're not measuring anything. They're making measurements and projecting them onto a reference ellipsoid, the same way you map a texture onto a 3D model in a video game.
So would that not be so... I've never even heard of a reference ellipsoid, but at a guess, I'm saying...
So WGS84, reference ellipsoid?
Right, so is that so there is a static place that it can be measured against?
No, it's a reference ellipsoid. It's created to project measurements onto its surface. It could make the reference frickin' dolphin. Project measurements onto that surface. Project any surface onto any other surface, or map any surface onto any other surface. The way they map the measurements onto the globe surface is they curve plumb lines. Which
they what?
Mr. Barron that you talked about, they curve the plumb line.
Sure they do.
You don't believe me?
How do you curve a plumb line?
Yeah, you tell me. They do in geodetic surveying. And that's funny, you're Barron, and none of these other geodetic surveys know anything about it.
But
it's in the literature.
You seriously?
Yeah, it's in the literature.
It's in the literature. Hang on.
Yeah, it's in the geodetic surveying literature.
Hang on. So 1 minute, right? My diagram is a diagram. That's not relevant when it's of observations. But now you're saying it's in the literature. Have you ever watched a surveyor doing their work?
Dude, my friend, when he was 17 years old and still in high school, sir.
Heads of YouTube and Google, they certainly care because they censor it. Right? They hide it when people search for it online.
Wait. I have another question. Let's go for another example. I'm trying to put you in the line because really want you to convince me because it's hard to convince the globe is flat surface. So I'm going on a plane, plane flying between countries, and the plane goes a lot of kilometers above the sea level. Mm-hmm. And at a certain point, it's you can see the globe curving.
No. You don't see the globe curving. You might think you see globe curving if you're looking through.
So you're saying my eye lying to me?
No.
So how do you explain that?
Lying to you.
I flew a lot of time, about 20 times in the last 2 years.
Well, because the windows that you're looking through, those can flex and bend, right, with the pressure, right? They're designed.
Let's go nuts. Without windows, I don't have windows.
Okay, well now you're just imagining it. So now we don't have a real example. Now you're just saying, imagine if I saw curve. Now what?
So we do have windows, all right.
You do have windows, and they might
have windows,
they
and I'm
might,
looking
they might,
through the
they
windows,
might
and the
curve
glass
the horizon
through the glass,
with
and the horizon is curved.
glass
How do you
of the
explain
lens.
this? So you call my eyes liars? Is my eye lying to me?
No. You don't see curvature. You might see a distorted horizon due to the window curving, but you don't see curvature. And actually,
I'm like Dennis right now.
The fact that you bring up pilots is good, because did you know pilots, when they fly, they treat the Earth as flat and motionless. They don't account for any curvature. They don't
Because they
account for
need to stay in one shape. If they like change the shape, if they change the shape a bit too high, a bit too low, they're gonna crash.
No. Think about it. If you're traveling over the surface of a ball in a plane,
yes,
you're gonna have to your nose of that plane is gonna have to dip around, down and around the ball, right?
No, you're right.
Right. Well, pilots aren't doing that. They're just flying flat, level, straight.
They're flying flat. They're flying flat because they need to save the plane in the same like level. Because if they
they were
go too
flying
down,
level straight on a ball, they'd be flying off into space.
All right. Let me open Paint. Painter on my PC real quick. I want to paint something, and I'll send it on the VC chat. All right.
Great. We love a paint.
Okay.
We love a paint argument.
On PC, so I have a painting program they can paint on.
Very good. Well, I'm glad you understand, though, because if you fly in a straight line on top of a ball, you're going to leave the ball, right? Pilots fly in a straight line. They don't leave Earth because the Earth is a plane. The airplanes fly in the air over the plane. There you go. Makes sense, right?
Kind of. Wait a second.
Yeah. They fly flat and level.
I just sent a picture. It's a bit like crampy, but don't judge. I'm not a great painter, so.
Give me a second. I'm not looking at the chat.
I can send images on the VC chat.
And also, you can't see the curve from that height. You can't even see the curve from the ISS.
I can see the curve. I flew a lot of times for the last 2 years, and I.
Yeah, but dude, what you need to understand is mathematically, they give us a claimed size of the globe. Yeah, do you know what size they claim it is?
I send you a picture. You need to accept me. I send you the paint.
I'm not at the chat at the moment. Can you just post it in the general text chat?
I tried. All right, I'll try.
And one of the flat earthers here.
I said it on the media. Where someone can take me on the media chat?
Yeah, no, it's just the text channel associated with this VC.
I can. I have no idea why, but I can send messages. Not messages. Pics on the screenshots.
You maybe don't have the roles. Are you new to the server?
What do you mean by new? I joined December 2. This is the.
Well, because you need to rank up. You need to have a certain role to post the images and stuff. So maybe you've not reached that level.
How do I get a role like this?
Well, you need to. It's activity based.
Okay.
So the more you talk, the more you chat, the more you understand the Earth is flat. You get terms.
T-Dub sent me a friend request to send him the paint.
Okay.
Yes.
Yep. Send it to me.
Oh. All right. I said you can open the share screen. Maybe send it on the VC chat for me.
Yep.
All right. Thank you.
Look at that. How helpful.
It looks a bit weird. I tried to paint another one. For a second. Let me try to paint another one. Oh, perfect one.
Don't worry, it's not an art channel.
Yeah, I know, but for the example,
it's nice to have good images. You're right. Oh, yeah. Let's see. It's like an Among Us character.
Yeah, it's kind of if you like,
or
take the plane, take off. Come again?
It looks like a big toe.
Like I said, I'm not phenomenal at painting. Just
no, that's all right.
My imagination. So like the plane line, where I wrote the plane. This one where the plane is taken off. All right.
Yeah.
If it keeps consistent with the line that I draw, if it's going to be too down, if it's the plane is gonna go down a bit, it's eventually gonna crash. But if it's going to be consistent with the line that I'm trying to paint, it's gonna land safely and smoothly on the landing side. So this
You're
is
saying
explained.
the plane is gonna. If the plane was going around the ball, it would.
Yeah.
Let's say it's going from like the UK to Australia. You're saying it would curve around a ball, and then it would be upside down from where it started.
Kind of, yeah.
Yeah, that doesn't happen.
So what happened? Explain to me.
They fly level. They go up. They fly level. They come down.
Okay.
Guys,
I didn't know this, to be honest.
the Earth is not
No, they don't
flat,
teach you.
nor round.
They don't teach you that in
Diamond.
school. They don't teach you that in school.
Just think about it for a second. Do you have any evidence that you end up upside down? If you look at mechanical gyroscopes work on the gyroscopic effect or rigidity in space. They don't move, so if you move them across a curved surface, the housing would twist, but the gyroscope would remain upright. That's how we create artificial horizons for the planes. If the gyroscopes were moving across the curved surface, we wouldn't be able to use them as artificial horizons because they would constantly drift as a consequence.
All right.
And think about this, to put it simply, right? So they've told us that from UK to Australia, you're doing like a 180 around the ball and you'll be upside down. Yeah. But what we're saying is we're all on the same level, right? So if someone in Australia is looking up, that's the same as our up. We don't have a different up. We don't have a different down. People are not playing football upside down in Australia, and the snow is not falling upwards towards our feet. It's just we're on the same level. They're just they're just at a different part. They're further away from us on the same surface, a level topographical surface. You understand?
Yeah, but there's a footage that proves wrong from your eyes view, from your view.
No, there's no footage that proves us wrong.
There does.
What footage?
Let me send. I try to send the GIF. A second.
This isn't going to be that spy agency again, is it?
Why do you call it a spy agency? Because
remember, you looked it up and it's a spy
because
agency.
it's the only agencies that give proofs and give you
No, but they're a propaganda agency, remember? They do counterintelligence. That's propaganda. Like the CIA.
I see. So why don't you like that? I'm going to go nuts. All right. Why don't you're like a normal person in Earth, right? Why don't you save up, go to work, and do something that's going to prove all the world that it's actually an agency that is spying on people, on the government?
Because they already admit it. We don't need to prove it. You just Googled it, right? And it told you. It's a spy agency. It's an intelligence agency. We don't have to prove that. They admit it.
Yeah, but we
No,
need.
it's
what
called.
we can do, and just
It's
like
called.
you
It's
can
called.
do-
No. It's called Intelligence and Security Function Agency. The
Yeah,
spy
it's an
agency
intelligence
is a
agency,
made up. It's a
yes.
made up name.
Bro, you can
That's what
go out.
intelligence agency is.
Bro,
Sorry,
you
go
can see in these pictures that they show you that the Earth appears curved and the water appears curved, okay? So you
Okay.
can go out and test if that is true. You have access to the Earth. You don't need to take their belief. You don't need to take it on faith. You can just go test it.
Yeah, remember we discussed the water earlier? So they're showing you pictures of curved water, but you know the water lies flat when it's at rest. In reality, when you go outside onto the earth, a lake, a shoreline, a beach, that's what you experience, right? And then this intelligence agency has told you, no, your senses are wrong. Trust us, the spy agency. But
I asked ChatGPT if NASA. I just sent NASA spy agency explain, and he said NASA is not a spy agency. Here's the clear breakdown. NASA National Aeronautic and Space Administration, a civilian space agency focused on space exploring science, styles, technology, and research. Example: moon mission, Mars
Ask it if
rovers,
it's not
space
designated as an
helicopters,
intelligence
Salome
agency.
studies.
So you
Come
believe
again?
everything the AI tells you?
Not everything, but most
But
of the
didn't you just
time it's
Google
correct.
it? Didn't you just Google it and you saw the
What?
article saying NASA is an intelligence agency now?
I asked, and he says NASA is a primary civil and space agency, but recent activate orders relaxate. It's having a national intelligence dash security function, leading to it's being called a spy agency.
Oh, so it's being called a spy agency because it's now
But
being
it's not
classed
formally a spy
because
agency.
it's being classed as an intelligence agency by the government, right?
Okay, so you're saying the government is also a spy agency?
The government has classed NASA as a spy agency, an intelligence agency. Intelligence and security.
The government has separate divisions, right? Like the British government isn't a spy agency, but MI5 and MI6 are, right?
For example, like ChatGPT says, CIA, spy intelligence agencies in the US. I goes for the US. The CIA, human intelligence and foreign intelligence. NSA, single intelligence in cybersecurity. NRO, all books
so NASA's
and
like
operates
that.
spy satellites. DIA, military intelligence.
Yeah,
But
and
NASA is not on the line.
Yeah, that's what it is classed as. Just Google it. You'll find the articles in the
I
press.
googled it. Tell me what to Google, and I want to find it. So you tell me what to Google.
Yeah, I already gave you the link. If you look in the text chat, there's
Let me see.
Politico.
Politician,
We're talking
NASA, the
about it
spy
being a
agency. My question. Question
spy
mark.
agency now, and then I have here a recording of an ex-CIA official who became a judge, and in this court proceeding talked about NASA and how internally the CIA did not consider them a space agency and referred to them as not a space agency, to abbreviate NASA. And he also claims that the bulk of the mind control happened over there.
Yeah, it's just that agency is there to propagandize and control your mind. That's it.
Wait, you don't think they pay them, like pay them off, like bribe them to sell?
What this ex-CIA head and soon-to-be judge, he paid him off. It was you need to watch it, dude. You need to watch the proceedings themselves and dictate for yourself whether he's being paid off or not.
If they're like, I don't know, he's a former CIA agent, right? If they want,
he's a judge
right now, but he's a former CIA
he's
agent.
a judge, or he was. I think he's dead now. He was a judge proceeding over a sex trafficking case. Okay.
All right. So
they killed him.
He became the judge. They killed. Like I want to say, they killed him because he's probably they bribed him.
Because
the people want.
Hey, we used to in the CIA. We called NASA not a space agency because we knew they were just a propaganda agency.
Okay, let me ask you this. All right, there's not a slight. Let's take it's 100%, 90%, 80% cases. All right, if you go with what you are saying, all right, 95% is true. NASA is really a case scenario of spy agency, like you were saying.
That's 100%.
There's not a slight 5%. All right, I'm going with my mind. There's not those 5%, slight 5%. That the people who want this guy to say what they want them to say and go public, bribe them, pay them off. And when they did, NASA found out about this one and they killed them.
What weird scenario are you making up in your head to make this plausible, dude?
Yeah, I'm not really following this.
What? Who would have justification to pay him to out NASA?
Yeah, why would they tell him to call them not a space agency and blow up their whole
Not
gig?
NASA. They killed them off. The people who don't want.
Yeah, he's been killed off. President Trump 2 months ago has reclassified NASA's role. Let's say, okay, cool. So do we trust what NASA says? Well, we can go out and verify what NASA says, and when we go out and verify the surface of the Earth, that measures to be flat. So they're lying about that. We can demonstrate that to be true. Anything else, we don't fucking know.
So let's say the Earth is really like flat. how does it
Correct.
affect me?
How does it affect you?
Yes.
Well, you thought that I'll tell you. You thought
Alright,
that
I
you
th-
lived on a
okay.
ball. I'll tell you. You
Okay.
thought that you lived on a ball that rotated around the sun that came into existence by some kind of big bang. That big bang exploded all the physical matter into existence. Then they tell you a story of evolution and how your consciousness was devolved over millions of years, so me and you can sit here and have this conversation. They get to tell you where you come from and who you are and your possibilities and limitations. The Earth is not the ball that was created by a big bang. So go back and ask the question how the Earth was created then and your purpose on it. That will lead you down a different path.
Yeah, it
Alright.
basically makes it so that you, instead of believing that your rights are endowed by some sort of creative force, whatever the religion may be, you now think that the government endows all of your rights, and you have given up those rights freely, and so have your ancestors, through this globe belief. It has taken your freedom away from you. That is what it has done.
Okay, but why does I care about it? Okay, they're taking my freedom. I'm good. I have money. I have life. I have a family.
Well done. Your
I have
prison,
babies. I
your
have
prison's
brothers.
got nice things. But your prison is deeper than that. It's a prison of the mind, my friend.
So let's say
Well, hold on. Let me cut through this. Because the answer is because we care about what's true, right? We want to know what's true. So if you're not interested,
let's say it's true.
Hold on.
Go on.
If you are not interested in truth, then it might not matter to you. But we are interested in truth, and that's why it matters. Because we want to know the truth about reality, where we live, what our situation is. And we didn't get here by a random explosion and then evolving from a bunch of monkeys. This is the story that they're teaching all the children in school. This is the story they told us, presumably you as well. And it forms your whole worldview, how you think, how you behave.
All right.
It's control.
So let's say there's big people, like big power and financial people who call the governments. And NASA is really a spy agency. All right. After we said, how does it affect me? All right. Let's say I believe you. Genuinely believe you. What can I do? What could you do? What could everyone do that believes the Earth is actually flat?
Just take control of your mind. Just take control of your mind.
Okay, you take control over my mind. Those are
not your mind. You take control of your own mind. This is what you do. Now you realize that the story you've been told about where you think you live is wrong. You now take control. You figure out where you live. That's what you do. Okay, and then what you do with that is entirely up to you. We're not passing out recommendations. We're just pointing out the facts. Okay?
Okay, but
we're not
after
a replacement belief system.
Wait a second. After all the knowledge that I have in my mind right now, I'm gonna like live my life, like going outside.
Yeah, you still have to live your life. Yes, you still have to live your life. You still have to go to work.
So I'm going to suicide after knowing this
the human being is deeper than that. The human being is deeper than that. The human being asks the question, why am I here? What is this place? What's the point of all this? What is this experience we call life?
Yeah,
right?
I also want to give him
does that.
I also want to give him the answer that he wants. What does he gain from this? And that's what you gain from this is a critical mind. What you gain from this is the ability to detect fallacies, because we're not here to give you a replacement cosmology for the cult belief system that we were all raised in. We're here to give you logic, reasoning, evidence, so that you can see through the deception that you have been fooled by. And so you won't buy into more deception because you can identify it when you hear it.
Yeah, that's helpful.
All right.
Because when you make decisions in your life, you want to be making your decisions based on the best available information. That's how you inform your decisions. And this is exactly that.
This is an interesting thing that I really need to investigate, to be honest.
Yes, you need to investigate. I was going to say earlier, we have resources on a server which are not easy to find just by Googling and YouTubing because they censor the topic. So if you want access, we've got terabytes of articles, videos, PDFs, all kinds of stuff. Someone will post you the link, DM you a link, or you can look at the YouTube bots and you can find it there. Discord.gg/Flat Earth. 24/7 Flat Earth Discord. You can find us here on the politics server and in that 24/7 home server.
I'll check
and
it
we're
out.
live. We're live on YouTube, by the way.
All right.
You're on YouTube, so we've got a couple of channels streaming, and we stream 24/7, 365 days a year. It's Christmas today. It might even be Boxing Day now. We've just given you.
You can send me the link to the YouTube channel.
We've just given you the YouTube channel 247 Flat Earth Discord.
All right.
Right, just type that in and you'll find us. And we've just given you the best Christmas present that can be given. Right, a wake up call about your reality. So Merry Christmas.
Merry Christmas, man.
Merry Christmas, people. Happy holidays.
Yeah. So there you go.
All right.
So there you go. You just became dumber. For Christmas.
Nice.
Nice. Pretty good.
Well, if not rejecting reality because a spy agency told you so is considered dumber, then yeah, I guess so. But we would consider that to be of a critical mind, to challenge claims made to us. That's not dumb. That's exactly what an intelligent mind would do. Question these stories. Hey, you experience a flat, motionless Earth every day. Every human being has in history. And yet, a 0.0000000 continuum 1% of some elite intelligentsia in the militaries of the world have told us, your senses are wrong. You cannot trust your senses. Trust us, the government, with your entire worldview and creation narrative. And you've lapped it up and said, okay. See, this makes you weaker as a person.
I got it. All right.
That's more to the other guy who's trying to jump in. But no, you've been chill. Welcome to the channel. Good to speak to you.
Thank you.
Good luck. Good luck in your research. We're here all the time. So when you've got questions, come here and ask us.
Okay. All right. Thank you very much. Have a nice one.
You're welcome.
Bye-bye.
You too, bro. So who's that other guy? You think it's dumb to observe flat water?
Yeah, pretty much.
Wow. So you think it's dumb to go to the beach?
No, sorry, Cyclone. You think it's dumb to observe flat water, even though we use water as a horizontal reference tool? We use water for horizontal, don't we?
Yeah, what's dumb about that?
You said it was dumb. I pointed out it's actually used practically as something, that being horizontal. Do you still think it's dumb?
Pretty much.
Wow. Okay, I don't understand why you're here. I'll mute myself.
I understand. He thinks practical reality is dumb, so he's a globe believer.
Well, how come, because he's probably a brain in a jar kind of person. How come in his brain in a jar world, the earth is still flat?
Did you understand that you experienced the earth to be flat? Or have you not noticed? Is that it? You're dumb. That's the culmination of the globe argument in 2025. Nearly 2026. Boys, it's been a hell of a year. We need to do a roundup show. Top of the bill. Flat Earthers turned NASA into a spy agency. That's pretty good, no? It's pretty good going. 10 years in, the only globe primary evidence has essentially conceded that they're just liars. And now legally so. That's pretty good. Anyway, good talk, boys. I'm going to go on mute for a bit and then dip off. Good to hear you all as usual. Merry Christmas.
Merry Christmas, man. You have a good evening.
Yep. Peace, brothers.
You ready, Rusty P? I'll let you hear it. Here you go. I made a song about this.
I'm not gonna listen to the fucking song, man.
That question already missed the point. Why would they lie? Wrong place to start. Most people don't. That's the easy part. Belief doesn't need a paycheck signed, it just needs a lens
Bro,
to frame.
shut the fuck.
The crowd repeats what fits the view. Interpretation doesn't work for you. No conspiracy, no secret call, just inherited models filtering it all. You don't need liars in every seat when belief already edits what people see. The majority doesn't fabricate or scheme. They interpret through what they think it means. Why would they lie? Who said they did? Belief does the work, the model does the spin. You don't need fraud when faith is enough. The lens makes sense of the visible stuff. Now ask the real question, who does lie? Same answer always, no need to divine. Money, power, leverage, control, that pattern's old, it never gets old. Institution guard their frame, carries grants, rank and name. You don't get paid to break the mold, you get paid to repeat what's already sold. That's not paranoia, that's how systems run. You don't bite the hand that signs the funds, but none of that touches the evidence base. It doesn't rise or fall with intent you can't trace. Intent is in evidence. Comfort isn't true. You don't test reality by guessing motives for proof. Appeal to incredulity dressed as debate. I can't imagine it, therefore false, you say. Asking me why someone would do a thing doesn't undo what the measurements bring. We don't divine minds, we test claims. We don't read hearts, we read terrain. The ground doesn't care what you're okay believing. It measures the same with or without agreement. Flat where it measures, still where it stands. Not curved by consensus or comforted plans. Truth isn't democratic, polite or kind. It just remains when belief resigns. Why would they lie? It doesn't apply. The data stands where the motives pass by. Believe what you want, sleep just fine. Reality stays planar, still and unaligned.
There you go, Rusty. I know you muted yourself, put your fingers in your ears, and screamed la 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 because you didn't want to hear the answer. But there's your answer. People don't all need to lie. People believe this, just like you do. And so you got none of that, Rusty? So why
I
ask
didn't.
the question when you don't want to hear the answer?
You pause the fucking music, then you mute me.
Yeah, it answered your
then
question. What's
didn't
wrong
do
with
shit.
it being in the form of music? Do you hate music or something?
No, I don't.
So what's wrong with
fucking
getting the information, all of the answers to your question in song form?
Because it's fucking dumb?
Because you're fucking dumb and can't understand the answers, or you have your fingers in your ears and you can't listen? What's the problem?
Yeah, if I ask a question and then someone answers it.
You're watching 24/7 Flat Earth Discord live.